So I have just one word for you, or maybe it's 2 words, I don't know, doesn't matter. Anyway, that word is microservices. Well, hello, wherever you are, whenever you are. Where am I? Melbourne, Australia, as usual. And when is it? It's August 2021. Now I hope wherever I find you, and whenever I find you, that I find you happy, safe and well. So yes, this is the big one. This is microservices. This is the course that I have been wanting to make for such a long time. And now it's finally here, free on YouTube. It was a lot of hard work, it was a lot of fun, but I'm glad it's done. Now, you will see from the timestamp that it's a long video, so I wouldn't expect anybody to go through it in one sitting. So with that being said, I have put the time codes in the description below. So that means you can jump to the sections that you want to go straight to, or you can come back and pick up where you left off. That being said, I do suggest you go through it start to finish for the best experience. Now, I have tried to put in the right balance of content for an introduction to microservices, but if you do have any feedback on how I can improve, please put that in the description section below. I always love getting your feedback. One last thing, just a big thank you. Thank you for joining me here on YouTube. And if you do like the video, please think about giving it a like. That just helps me out. And if you've not done so already, maybe think about subscribing, ding the little bell, and that way you'll get notified when I make new content. And finally, to my Patreon supporters who go that little bit extra and support me on Patreon, thank you so much to you. I cannot tell you how much I really do appreciate it. And as usual, as a way of thank you, your names are coming up at the end of the video. That's enough for me. We have got plenty to get through, so I don't think we should delay any further. And I think we get started. All right, so yes, welcome to this step-by-step course on .NET Microservices, and we will also be using Kubernetes, RabbitMQ and gRPC. So up front, I just want to, this isn't the course outline, we go through that in a second, but what I want to be very upfront about is just the approach we take in this course and the type of approach I've taken, which may or may not suit some people. So I want to be very clear about that up front before you invest too much time going forward. So this course will focus on the technical aspects of building .NET Microservices, which shouldn't be too much of a surprise, so hopefully that's why most people are here. We'll cover the theory as we go, but I wanted it to be as practical and as technical as possible. And so we do theory, but I didn't want to do so much theory up front that it becomes maybe a bit tedious. So we cover it as we go, but there is a bit of a theory block up front as well. Take a pragmatic, balanced approach, but always try to follow best practices. But again, you do have to balance that. When you are developing in the real world, it's not a highly theoretical place, and you sometimes have to make tough decisions, pragmatic decisions on how best to go forward. So again, I've taken that approach in this course as well. It's fully step-by-step. So the code is available on GitHub, but I don't point you to a repository and just tell you to download code and point at it as part of the video. We actually go through every single bit of code step by step, line by line, and that goes for doing our Kubernetes stuff as well. So that might not suit some people. I'm just calling it out, but that's the way I've approached it here. It is fully step by step, and that's why it's pretty long. Already covered this, be as practical, as interesting as possible, but also acknowledge that microservices are hard and they don't solve every problem in the world. So we do have to go into the course acknowledging that that is the case, and I certainly try and acknowledge that. Some things this course doesn't do, so I don't focus on things like domain-driven design, bounded context, a lot more of the kind of highly theoretical stuff about how you would design your business-focused microservices. I don't really focus on that. We touch on it slightly, and I make the point about, services should be bounded, for sure, but I don't go into lots and lots of slideware or theory about that. We don't build out too much redundant business logic in our example. Our example is incredibly simple. Well, it appears incredibly simple. There are only 2 services, and you might think that's not enough to learn anything. Believe me, it is more than enough to learn the basics and the introduction introduction material to microservices, more than enough. And I felt if I introduced more services and tried to build out something like an e-com app, it would detract focus on really what I was wanting to try and get across. So we don't focus on redundant business logic about building carts and category pages and all that kind of stuff. Don't demonize the monolith or bandwagon jump. There are reasons and scenarios when you would definitely use a monolith and reasons where you would definitely not use microservices, which is probably the same thing. And I call that out and I give some examples of why we do that. So what I'm saying here, what I'm not trying to say here is that microservices don't cure everything. They're not the best approach in all circumstances, definitely not. And we don't cover everything. There is a balance to be struck, of course. You're never going to cover everything, and I certainly haven't covered everything here, but what I do feel I've done is given enough material that's going to give you a really good introductory foundation to building microservices with .NET technologies and all the associated stuff around that. I feel this course is going to give you that really good introduction foundation that you'll need to move forward. Okay, let's go through the course overview. So just FYI, there are 9 sections, 9 parts to the course. So we're just going to go through those now. So the first part is our introduction in theory. So we go through course overview, which we're doing now. Some prerequisites, which aren't mandatory, but kind of nice to have. The ingredients and the tooling that you'll need if you want to follow along. We then move on to some theory. So what are microservices, why you would choose to use them. We look at monoliths and why you would and would not use them as well. We then look at our services that we're going to build out. We do an overview of our solution architecture, and then we look at our service architecture, so how we're actually going to build our services out. We then start the practical build, and the rest of the course is fully practical from this point on, so it's all coding, config. So we start the platform service, which is our first service. So a bit of an overview of what it is. We scaffold it out, build out the data layer, and then we work on our controllers and actions. Part 3, we look at Docker and Kubernetes, so a review of Docker. We containerize our platform service, so we build it as an image and push it up to Docker Hub. We then go into Kubernetes, what it is, why you would use it. We look at the architectural overview of our application in Kubernetes, so that's the Kubernetes architecture section. And then we deploy our platform service into our Kubernetes cluster. And then finally in that section, we set up some external networking so we can actually use our platform service inside of Kubernetes. Part 4, we start with our commands service, but really this section is focused on synchronous messaging actually. So we scaffold up our command service to start with, we set up a controller and action, and then we look at messaging, synchronous and asynchronous messaging. And as part of the synchronous messaging, we set up HTTP communications between both our services, our platforms and command services. So as part of that, we add a HTTP client to our platforms service. We obviously have to deploy our command service into Kubernetes. We do some internal networking, and we also stand up an API gateway. So it's a really big section where we cover an awful lot of material. Part 5, we move on to SQL Server. Every service has its own database, so this is the SQL Server for our platform service. As part of setting up SQL Server, we talk about something called persistent volume claims. We look at Kubernetes secrets. We deploy SQL Server to Kubernetes, obviously, and we revisit our platform service. And just a quick call out, if some of this stuff you don't know what it is, that's fine, we cover it all in the course. So if you don't know what a persistent volume claim is, do not worry about that, we obviously cover it in the course. Part 6, we revisit our command service and we talk about multi-resource REST-based APIs. So we review all our endpoints for our command service, we build out our data layer, and then we finish off our controllers and actions. That looks like a short section, but it's actually quite a long section. Part 7, we then look at our message bus, which is RabbitMQ in this case. So we do a review of our solution architecture. We give an overview of what RabbitMQ is. We deploy RabbitMQ to Kubernetes and we test it. Part 8, we then start to really build out our asynchronous messaging using RabbitMQ. So that involves adding a message bus publisher to our platform service. We look at event processing, and then we add an event listener to the commands service. And then to round out the course, we look at gRPC, so an overview of what gRPC is, why you would use it, all that kind of stuff. We'll do some final networking configuration inside Kubernetes. We'll then add a gRPC server to our platform service. we create a proto file or a protobuf file, and then we add gRPC client to the commands service. And to round it off, we deploy all that and we test it all end to end. All right, so let's move on to the course prerequisites. Now again, these are just suggestions. We do everything, as it says, they are fully step-by-step, but some of the stuff is quite complex. And if you've not touched it ever before, you might find some of the concepts a little bit heavy going. So I do have courses for all this stuff pretty much on the channel. So if you're a bit rusty, maybe you want to brush up on the following. So experience with building .NET Core REST APIs. So I have a full course on my channel that covers that in detail, although we do it again here step by step as well, but I do spend more time on bits and pieces in that video. Understanding of Docker and associated concepts. Again, if you've never touched Docker before and you don't even know what it is, we do cover it here, but again, doing a more detailed course might help you out. Dependency injection in C# would be useful. Again, we do cover it here, but some of my other courses go into it in a lot more detail, the more sort of basic theoretical concepts. And if you've used async and await before in the C# language, that would definitely be useful. But again, that's probably not super critical. So all of this stuff would be useful. We do cover it all step by step. But again, if you've not ever built an API before using .NET, C#, you might find some of the stuff a bit challenging. All right. So these are the ingredients that you're going to need if you want to follow along practically, which I think most of you probably will want to do. So I'm using VS Code text editor. You can use Visual Studio if you want, but again, I'm deciding to use VS Code. I just find it lighter and more adaptable than Visual Studio, but you can use Visual Studio if you want. .NET 5 is sort of mandatory. There's some concepts in here. If you decide to use an earlier version of the framework, you may run into some little niggly problems, so I highly recommend you run with .NET 5. You'll need Docker Desktop running Kubernetes, again, which is free. An account on Docker Hub, again, which is free. So when we push images up to Docker Hub, you obviously need to have an account to do that. And you'll need either Insomnia or Postman, which are basically API test clients, which we will be using throughout the course to test our services. And in this video, I'm running everything on my local hardware. I did have a decision to make on whether to go with this approach, running everything locally, or whether to go with a cloud provider like Google Cloud or Azure. I decided that this course would be using just your local machine, so you don't have to sign up for cloud services, which I know doesn't suit everybody. But the downside of that is, yes, we will be running up quite a number of services, so you do need a decent level of local hardware. So I'll just show you my PC spec, just out of interest. Now this is probably a higher spec than you need, but I'll just go through what I've got anyway. So yeah, we'll be spinning up a lot of containers in Kubernetes, which obviously has an impact on your local hardware, most especially memory, really. So I've got an Intel i7, I've got 32 gig of memory, which is probably way more than you need. In fact, it is definitely way more than you need. It's just what I happen to be running. 16 gig will be absolutely fine. So 16 gig, you should be totally fine. Anything less than 8, I mean really 8 is probably the minimum, the absolute bare minimum, and I think even if you're running 8 gig, you're probably going to struggle a bit with that. So between 8 and 16, I'd recommend 16 to be honest with you. And the hard drive is sort of irrelevant, but I just happen to have a 1 terabyte solid state disk drive. But it's really the memory. Memory is the main thing that you will need. So yes, 16 gig, you should be fine. Now, the other thing I want to call out is we are doing a lot of Kubernetes stuff in this course, so I have produced a free cheat sheet that you can download. It's a nice one-pager that you can refer to, so either on screen or you can print it off, and it has all the Docker and Kubernetes commands that we're going to be using in this course. So it's a nice little one-pager reference guide. It has our Kubernetes application architecture reference on there, so again, you can kind of tick off what we complete as we move through the course, and we also have a Kubernetes object glossary. So again, if you're new to Kubernetes, we cover it all in the course, but again, everything that you see on screen here is on a nice little one-page summary for you to download. So all you have to do is go to .netplaybook.com, that's my blog website, and just register for our mailing list, and we will subscribe to our mailing list, and we'll email you with a download link. And I do want to call out that we never, ever, ever pass on your email address to anybody else. In fact, I hardly even use the mailing list at all. I probably send out an email maybe once a year or something, and I definitely do not pass it on. So just be assured, if you do give us that, it's totally secure and we don't ever pass it on to marketeers or anything like that. Other course resources, the code is available on GitHub for you to download and follow along. There is a lot of code here, there's a lot of scope to make errors, and I've made a few errors as I've made the video, which you will see if you follow along. Don't worry, I do correct them, but it's always nice to have that backup of a code repository so you can refer back to and compare what you've done. In the description of the video, I have put timestamps to all the sections, all the main sections in the course, so it's a very long video, so I don't expect anybody to go through it in one sitting. So the course outline description, in the description, you can jump to each section and come back and revisit at your leisure. And then finally, the course slides, the stuff that we're going through. There's quite a few slides that we're going to go through. I'm not making those available publicly, but they are available to my Patreon supporters. The $5 supporters and above can download the course slideware through my private GitHub repository. So if you're interested in that, maybe check out my Patreon site at the following address. All right, so let's come on to talking about microservices now. We've done enough introductory stuff. So what are they? And rather facetiously, I'm saying, how are they saving the world? Not being totally serious when I say that. So let's look at this idea of a single responsibility principle, which was coined by this chap, Robert C. Martin. And what he's saying is, gather together those things that change for the same reason and separate out those things that change for different reasons. So what did he mean by that? Or what do we mean by that? Well, that really is a nice way to kind of, at a high level, think about microservices. So what are they? They are small, okay? They are built, let's say, by a team that would consume 2 pizzas. That's a way that we often measure team size. So imagine, at the end of the sprint, end of the week, you want to treat your team to pizza. You only need to buy 2 pizzas to satisfy this team. So small team. Or if you want to think about it and how long it would take to build a typical microservice, you're looking at maybe 2 weeks to build. That's what we mean by small, although that is quite a subjective term. They are responsible for doing one thing well. So you kind of have this idea of a microservices application, which will include many, many different services. Each of those services will do one thing and do it really well. Okay, so again, go back to that single responsibility principle. If something's doing one thing, does it really well, it doesn't need to rely too much on the other parts of the system. Although paradoxically, in order for it to be a microservices application, services typically will talk to each other because they need to share data between themselves. But you don't want it doing so much sharing that they're chatting to each other all the time. So that's why breaking down your services into doing one thing and doing it well is really important. They're organizationally aligned. So think of a large organization. The parts of that organization will typically be responsible for running and managing a set of different services, and they have almost exclusive control over those services. So they can change them when they want to, and they can make additions to them and take them down when they need to. And other parts of the organization, they will have their own set of microservices that are aligned to their part of the business. And again, they will need to, or most usually, they do talk to each other. This is really important. So again, we will talk a lot about decoupling and the fact that you don't want services talking huge amounts to each other, but at the same time, again, paradoxically, in order for it to be a full microservices solution, the services typically form part of a distributed whole. So one service doing one thing by itself, never talking to anything else, is that a microservice? Possibly it's not, okay? It really is a true microservice when it does form part of this larger distributed system. And again, this is we've already kind of covered this, self-contained, autonomous. So again, they are responsible for doing one thing. They can stand on their own without being too reliant on other things. All right, so just to help position what microservices are, let's look at the contrasting side of things and look at monoliths for a bit. Now, you might be wondering what a monolith is. So probably the best way to describe it is by reference to an actual system. Now, the system I'm going to describe here is actually an amalgamation of a number of systems that I've worked with or been across at various points in my career. But one thing is definitely, for sure, if you work in a large organization, there's a very, very strong chance that you have a system like this in that organization, in your organization. So this is a sort of example of something that I have come across on my travels. So a large monolithic CRM system that services millions of customers. So it's a really, really super important system. Evolved over many years. So again, it's not something that's been stood up within the last 6 months. It's been around for many, many years in an organization that itself is many, many years old. Built on a single proprietary technology stack. So obviously there'll be different technologies that make up the monolith, but for the most part, it will be built on one platform, one tech stack. And in this case, and in most cases, it will typically be managed by an outsourced partner. So it won't even be managed by the organization itself directly. Most usually, or a lot of the time, systems like this are managed by third parties. So what's wrong with that? Well, this system is very, very difficult to change. It's a huge code base. Making changes even to a small part of it, you have to make sure that it hasn't impacted any other part of the code base. So change cycles are months in duration, and even for big migration projects, if you're maybe migrating from one monolith to another, they can be years and years in duration. But for this particular one I'm thinking about, the change cycle was at least 3 months. Lots of testing, often frequently manual testing to make sure that nothing has broken when you make changes to these systems. So difficult to change and therefore very slow to change. Difficult to scale. Now, what I mean by that is, the CRM platform is a huge system. And let's say, for example, you are going to experience increased orders at certain points of the year, say, near holiday periods or something like that, or, Black Friday sales or something like that. You may want to try and scale the part of the system that just deals with ordering, and all the other parts of that system don't need to necessarily scale as much. But with a monolith, you can't do that. You have to scale the entire system. So quite difficult to scale specific bits of the system. You can scale it, but it means you have to scale absolutely the whole system, which makes it quite inefficient to scale. And then finally, you're locked in. You've got one big, huge platform. It's locked into the technology stack, pretty much. Very, very difficult to change the technology stack. And also, if you're using an outsourcing partner, you're locked in from an intellectual property perspective as well. So this one party knows everything about that platform, which is fine, but you can't then choose another party to manage that system. Well, you can do, but it'd be very, very difficult to do so. So you're kind of locked into that vendor managing this platform. It's not a great situation. So this brings us on to the benefits of microservices when you kind of contrast that with that example monolith. Definitely easier to change and deploy, basically because they're smaller and they are more decoupled. Can be built using different technologies, so you're not locked into the one technology stack. Typically, different teams will build different microservices, and it's really up to them to choose what technology they want to use to build those microservices. As long as they can talk to each other, the services, it doesn't really matter what they're built with. You have increased organizational ownership and alignment. So the CRM system, there'll be many different parts of the business that are relying on that system. And if one part of the business wants to change it, another part of the organization may not want to change it, or they may have their changes that they want to prioritize over the other part of the business. So it becomes this headache of managing priority, managing change, whereas with microservices, typically each part of the business owns their own services, and so they can change them and prioritize their own changes till the heart's content, really. Resilience. So we'll see this with an example in a minute. One service can break, that's fine. The other services will continue to run. Whereas with a monolith, if the monolith goes down, typically the whole thing will go down. So you'll end up with this situation with microservices where parts of the system may be down, but other parts will continue to run. And I've got an example coming up. And scalable. So coming back to this issue of scalability, with a monolith, you can scale it, but you have to scale the entire thing. So it's rather inefficient to do so. With microservices, you can focus and scale out just the services that you need to scale. You don't need to scale everything. So it's much more adaptive to different demand patterns. And they're built to be highly replaceable and swappable. So that's the whole point of them. If you are not happy with a particular service, you can replace it with another service built by the same team or possibly built by a different team. But the whole point is that they can be swapped out. You're not locked in. All right, so let's come on to an example of a relatively simple microservices application that kind of talks to some of the concepts that we've just mentioned. So let's say we have an airline and an airline has decided to go with a microservices architecture. You could split your application up as follows. So you would have could have a flight catalog service. So that's the service that contains all the flights that people can book. And let's say, for example, in this example, it's written in .NET with a SQL Server database. And we have, in this case, one running instance of that service. And it's built by a team, let's say, based in Scotland. We then have a second service. This is the booking service. So let's say, for example, it's built using Ruby on Rails. It has a different type of database, PostgreSQL database. We have one running instance and it's built by a team in the USA. And what you'll see here, which is quite obvious, is that each service has its own data store. So the flight catalog will use its own data store and the booking app will have its own data store. Now, these services will more than likely share information, and that's really what the whole of this course is based around, is how do these services share information that the other one relies upon. But one takeaway is that they do not share the same database. They may share data, they will not share the same database. And it comes back to this whole point that one of these instances can go down, the other one will continue to run pretty much uninterrupted, possibly with some limitations. And then to round out our airline example, we'll have a check-in service. So somebody uses the flight catalog service to browse flights. They will then use the booking service to book a flight. And then finally, at the airport, they will check in, or they can check in online. So they all have different domains. They may be run by different parts of the business. Our check-in service in this case is written in Node. We have one instance and it's using a MongoDB. So again, to labour the point, it has its own data store and it's written by a team in India. So the takeaway from this slide is that separate services written by different teams, they have their own database and they will be somewhat reliant on each other. So for example, you won't be able to check in unless you have access to booking details. And again, the whole point of this course is to understand how we can move data between services, but they are independent. So for example, if the booking service went down, people can still browse and look at the flight catalog. So they can still go online, they can still see what flights are available, they just can't book. And likewise with check-in, people can still go to the airport or they can still check into their flight online. They might not be able to book a new flight, but they can still check in. Or let's say the check-in service goes down, people can still browse flights and they can book flights. They just can't check in. So the point of this is that even though one of the services may go down, the others remain up and certain parts of those operations that they are responsible for will continue to run. Unlike a monolith, where the whole thing goes down, everything goes down. And of course, what we're going to explore in this course is the fact that even if a service does go down, we'll be able to recover them much, much quicker. The other thing is to talk about scaling. So let's say this example airline has a sale on and we have lots of people coming to the website to look at flights and book flights. You can scale out additional instances of those services. And the check-in service, you leave untouched because the number of check-ins probably isn't going to change unless you maybe increase the number of flights. But let's say in this example, the number of flights remain the same, but we have a run on cheap flights that this airline is running. And you can scale up and scale down your instances very, very easily. So that brings us on finally to say, so does that mean everything about microservices is awesome and everything about monoliths is completely terrible? Absolutely not. And on this slide, we have some disadvantages of microservices, or certainly some things to consider when you use microservices versus using a monolith. So microservices are difficult to implement. There's no getting around it, they are difficult to implement. Writing an individual service might be somewhat okay, but designing and building an entire microservices architecture is difficult. When you're starting out, especially with a greenfield site, microservices may not be the best approach because if you don't understand the problem domain, you may spend most of your time just analysing the best way to break down and compose your services, and you may end up just in this analysis paralysis where you end up not building anything and you just keep going round in circles trying to determine what microservices you should be building. So yes, you need strong domain knowledge, and so in a greenfield site that may be difficult. Microservices are distributed, so that's something that people tend to forget about, and when you're running in a development environment, you're not really taking into account the fact that these things necessarily are running over a network. So you can have services running in different geographies that rely on the network, and of course the network can fail or it can slow down, and so that's something you really need to take into consideration when building microservices. And paradoxically, we keep going on about this concept of, microservices are totally decoupled. Well, as a paradox, they still need to be coupled to something. A microservice that doesn't talk to anything else is probably not actually a microservice. It's maybe a mini monolith or something like that. So yes, you want to reduce lots of chatty messaging between services, but ultimately, in order for them to function as a microservice architecture, they need to be coupled to something, even if it's just a message bus or the database, or more than likely other services. So the good things about monoliths: simpler to implement, no doubt simpler to implement, at least initially. You still can use CI/CD, daily deploys, you can do small changes. So the example I gave of a monolith, it was a huge beast of a system, and you were unable, just given the history of that application, to have a CI/CD type pipeline, do daily deploys, all that kind of stuff. But you can absolutely do that with a monolithic system, assuming that you build it in the right way to begin with. So one of the advantages of microservices is, you can use an agile approach to deliver them, and that's absolutely true, but it's also true of monoliths. So just because it's a monolith doesn't mean to say that you cannot deploy changes daily for a monolith. You absolutely can, but you have to make some considerations and build that application in a particular way, but it is still absolutely possible. Building a monolith is also a great exercise in familiarizing yourself with the domain. So again, especially if you're like a startup or something like that and you don't really know your domain that well, and you don't even know if your organization is going to be around next year, spending thousands and thousands of dollars building a microservices application where you don't really know the domain may be absolutely a terrible idea, and you may end up spending half your time just trying to analyze the problem. Whereas if you just go about and start building a monolith, number one, it's a bit simpler to implement, at least initially, and it also is a great exercise in familiarizing yourself with the problem domain. And so if you're one of the lucky startups that actually does start making money, then that's fine. You can then possibly move to a microservices architecture at that point. But at least if you've taken this approach and gone with a monolith to begin with, you're probably going to get up and running much, much quicker. And also you're going to start to understand your domain. So when you do come to actually implementing microservices, you'll probably compose them in a much more efficient way. And you can still have 2 or 3 big services. So this is kind of like a hybrid type approach, I suppose. You might not have microservices where you've got tens or even hundreds of services. You may end up just having 2 or 3 big, maybe not services, but 2 or 3 big applications that each don't do just one thing, but kind of take care of a bunch of stuff that's kind of similar. So it's a kind of halfway house sort of approach, and that may work well for some people. And generally speaking, monoliths won't be as reliant on the network as a microservices application. They're typically not considered distributed applications, so you do not have the same considerations around network latency or even network being unreliable as you would with a microservices application. All right, so let's come on and take a look at the services that we're going to build in this course. And we have 2 services that we're going to build. Now, our first one is the platform service, and that's what we will refer to as throughout the rest of the course. And it's basically going to function as an asset register for our fictional company. So it'll be used to track all the platforms and systems in our company. Now, we're not building out a full asset register system, just to be upfront with you, but we are going to build our platform service to operate in that way. But that is the idea behind it. And most importantly, it's built by the infrastructure team. So this particular team, they have a strong interest in maintaining a running asset register of all the systems in the organization. All right, so let's come on and take a look at the 2 services that we're going to spend our time building as part of this course. And we have two services that we're going to build. So let's move on to the first one. And this is our platform service. Now, what is the platform service? Well, the idea is that it's basically going to function as a sort of asset register. So it's going to contain all the systems, all the platforms that our fictional company is running. So yes, as it says, they're used to track all the platforms and systems in our company. And it's built, in this case, by one team, the infrastructure team. So may not be called infrastructure team in your organization, but maybe you might call it the operational team or the ops team or even the DevOps team. So that's the team that build it. That's the team that's owning it, and they will more than likely prioritize their changes against it. But it's not just to say that they're the only team that will use it. Yes, of course, they will use it, but it may be used by the technical support team systems. So again, faults are raised. You may want to know what system you are raising a fault against, and the technical support team will more than likely consume data from this service. Engineering team may want access to it for similar reasons. The accounting team, they may need access to it just to understand the assets that we have in the organization and what we need to write down each financial year, all that kind of horrible stuff. And even procurement. The procurement team may be interested in data that this platform service provides when it comes to renewing licensing agreements or signing new contracts, all that kind of stuff. So yes, owned by the one team, built by the one team, but will be used potentially by many other teams. So our second service is the commands service. And what is this? The command service basically is acting as a repository of command line arguments for given platforms. So the idea is it's going to aid in the automation of support processes. So imagine the concept where you may need to restart systems in a particular way, or you may need to understand how to back up databases in a particular way, rather than memorizing reams and reams of different command line snippets for different types of platform. This service is going to contain a repository of all those command line snippets. And so built by the technical support team. So this is the team that's going to build this repository. They're going to run it and support it, and they are going to be the principal users of it. So used by, the technical support team. May also be used by the infrastructure team, may be used by the engineering or development team. They may have an interest in getting access to this as well. Now, one thing that's going to kind of recur through the course is the fact that I have the word platforms on this slide, and that's no accident. The command line service is somewhat reliant on the platform service, and getting that platform's data into the command service is one of the things we're going to focus on as part of this course. But takeaway, two separate services can theoretically or should be able to run completely in isolation of each other, even though there is somewhat of a dependency between the two of them. All right, so let's come on and take a look at our overall solution architecture. So this is kind of the 50,000 foot view of what we're going to build. Now, this does not reference Kubernetes or any Kubernetes type objects just yet. When we come on to doing Kubernetes, I kind of overlay all the kind of Kubernetes concepts on top of this view here. So this one is abstracted away from that, and it's really just the components that we're going to build or use. So with that being said, first service we're going to have is our platform service. It will have its own SQL Server database, and together that kind of forms the entire microservice. It's basically going to be a REST-based API. So the public interface, the interface that our consumers are going to use, is a REST-based API. And yes, this service sits within what we're calling our internal microservices domain. Now we can theoretically access that API directly from externally into our internal microservices domain, and we will do that just while we're developing. But ultimately, we're going to use this concept of an API gateway, which is really going to front up all our services. And so any external requests coming in are going to then get routed internally to our relevant services. And so in this case, you can see our API gateway is routing through to our platform service using its REST API. Then our command service, it's going to have its own unique database just for it. Just for quickness, we're not going to stand up another SQL Server. We're just going to continue to use the in-memory database. But the important point to note is that it's absolutely got its own database. It does not share a database with the platform service or any other services for that matter. And it too is a REST-based API, and it too will make use of the API gateway will route through to our command service. So taking a look at this now, it's all great and everything, but Is this really a microservices architecture? To be honest with you, I would argue and say that at this point, looking at the screen at the moment, I would say this isn't really a microservices architecture. Mainly because the platform service and the command service are completely and utterly, totally unaware of each other, which you might say is a good thing, but there's no data sharing between the two in any way at all. They're really just totally separate apps that happen to go through an API gateway. So again, there is a paradox here. You do want to have services decoupled. You do want to have them independent, but at the same time, you don't want them so independent that they don't talk to anything else. That is the paradox. So in order for it to be a microservices application, in my view anyway, there needs to be some degree of data sharing between the two. And that brings us on very nicely to looking a bit more at our command service. So what you can see here is a snippet of what the database may look like. And you can see that we have a list of command line snippets, how to do a particular thing, such as stop a service or restart services or generate migrations. And you'll see that we have those command line snippets. But most importantly, you'll see that our command service does rely on the fact that it needs platform information. So for the majority of this course, what we're really going to be concerned about is trying to understand the best way of getting platform data from our platform service down into our command service. Now, as we've said before, the command service cannot reach into the platform service database. Absolutely cannot do that. One approach possible would be that we kind of couple quite tightly the platform service to the command service. And what I mean by that is, once we create a platform in the platform service, we could theoretically get the platform service to post using HTTP to the API of the command service and say, here's a new platform that I have created. This does create quite a tight coupling between these services though, because the platform service absolutely has to know where the command service sits. And that does kind of create this concept of a coupling. So really what we're going to focus most of our attention on in this course is the idea of using asynchronous messaging via an event bus or a message bus. And so what we're going to do, similar sort of scenario, when we create a new platform in the platform service, we're going to publish an event onto our message bus. Now, all the platform service is aware of at this point is the fact that there is a message bus. It is not aware of the command service, nor does it care that there is one. And in this case, what we're then going to do is we're going to get the command service to subscribe to the message bus and receive those platform published events, and then it will add those platforms to its own database. So this idea of creating data in one service, in this case a platform, and it subsequently making its way down to other services is something that we call eventual consistency. Again, services don't share the same database, but they do need to share the same data. And so the main problem that we're really looking at here is how do we make sure that all these services have all the data that they need and data that may come from other services. So in this case, we're going to use a publisher-subscriber model, synchronous messaging, to get that information down into our command service. And again, to labour the point, the platform service does not even know that the command service exists. And again, we're only going to do 2 services as part of this video, but as you can see here, you may have other services that publish other events onto the event bus and subscribe to other events or similar events. And you can see again that the XYZ service has its own database, the ABC service has its own database, so on and so forth. So you have this decoupled architecture, event-driven architecture, which is really what microservices are about. So to round out our solution architecture, we are going to make use of gRPC, and gRPC is used quite a lot in microservices, so for that reason I've included it. And what we're going to use gRPC to do is allow our command service to reach out to our platform service and pull down any platforms that it doesn't already have. But a point to note about gRPC is that it is synchronous, it's not event-driven, and so we are coupling our command service to some extent to our platform service. Okay, so let's move on to taking a look at our service architecture. So again, we'll look at the main components that make up both our services. So we'll start with our models, our internal data representations. We'll have a DB context, which mediates those models down to our persistent layer, in this case SQL Server. We're going to make quite extensive use of data transfer objects, DTOs, which are external representations of our model data, and they're mapped, as you can see there, to our models. And we're also going to make use of a repository pattern, which just abstracts away our DB context implementation. We're going to have our API REST controller, which is I'm calling Synchronous in, so HTTP requests coming in, we'll say externally, reach into a repository, pull back any data, and then send back the HTTP response using a DTO. So that's really our external contract going out to our external consumers. We're also going to have a HTTP client, which is, I'm calling here Synchronous out, and it's going to make HTTP requests to our, in this case, command service and receive back a response. Now, I'm including this just for completeness, just as an example. We're not making extensive use of this, but we are going to build it out just to demonstrate that particular approach. We're then coming on to the main event, which is to use a message publisher, which is asynchronous out. And so our platform service, yes, is going to publish events onto our event bus, onto our message bus. And then finally, we're going to use gRPC within our platform service as a synchronous in service. And so clients, in this case our commands service, can use gRPC to request platforms back from our platform service. And we're using gRPC to do that. Now, an important point to note, the only external interface here is our controller, our HTTP Web API controller. Everything else that is not denoted by a green line is internal within our microservices domain. And as you can see from the darker coloring on the publisher, it's asynchronous, the other ones are synchronous. So command service architecture, I'll just go through these quickly, it's exactly the same. Again, this is exactly the same. We're going to have a controller, synchronous in, responding to HTTP requests and giving HTTP responses. We're going to have a message subscriber. So this is asynchronous in, so it's going to receive messages from the message bus. And we're going to have a gRPC client, synchronous out. So this command service is going to make requests to our gRPC service in our platforms service. And again, the only external interface here really is our Web API controller, REST API controller. And with that, I think we start coding. All right, so I'm going to come over and we're going to start to build our platform service. So I'm just going to start a new Visual Studio Code window, and I think it's probably started it on my other screen. Indeed it has, so let me just pull that over. Rather annoying. Now I've got my screen running at 150% magnification, so hopefully that's large enough for everybody to read clearly what's happening on screen, but at the same time balance that it's not too cramped for writing code. So I might change it if it's not, if it's a bit too cramped, but I think this is going to be okay. So I'm going to bring up the integrated command terminal by doing Control and back quote, and then change into my working directory. Now this will be, chances are something different for you, but for me it's on my D drive and it's season 4 and then it's episode 3. Do a quick directory listing and it's empty. Now we're going to create a few projects in here as our main sort of solution folder, but for the moment let's just work with individual projects. So the first one we are going to set up. Now actually before we do that, let's just do a .NET version, -- version, just to check the version of .NET that we have installed, and it's version 5. I would strongly suggest you use version 5 and not 3.1, which probably will work, but you might have to make some tweaks here and there to get it working, so go with version 5. All right, so I just did a CLS to clear the screen, and we're going to do a .NET new. Web API is the template type that we want, and then we give it a name of platform service. And I'll just make sure I've spelt platform and service correctly. Looks like I have, so hit enter. And that will go away and scaffold that up for us. So quick directory listing will confirm that that is the case. So I'm just going to do a code, open this recursively, and I'm going to open this folder up. So platform service. And that will open our project up for us in Visual Studio Code. Now, I'm assuming that you are somewhat familiar with web APIs in .NET. As I say, if you're not, then I would suggest you check out one of my other videos that I've put links in the description below to. We'll just click yes to this, and this will just create a .vs code folder, just so it remembers our settings and so on and so forth. So I'm going to delete the weather forecast class. It's just like a class that's used by the templated project. And I'm also going to come into controllers, and I'm just going to delete the weather forecast controller. Fantastic. And then you should be familiar with the regular anatomy of a web API project. And we've really only got a controllers folder now empty, but don't worry, we will be populating that relatively soon. But the first thing I want to do is really just start to add in our dependencies, our package dependencies that this service will require. So again, I opened up my start menu there. So control and back tick to get the integrated terminal up and running. And I like to leave the platform service CS proj file up and running. So as we add packages, you'll see them being added to this file, just to make sure that we've not made any typographical mistakes. So the first thing I want to add is .NET add package, and the first one is AutoMapper. And I'm actually just going to copy the package name from my notes over here because it's a little bit long-winded. There you go. So it's automapper.extensions.microsoft.dependency injection. I'll hit enter. I'm sure you don't want to see me typing that in. And you can see it's been added as a package reference to our CS proj file. And then the next one, .NET add package. And again, I will save you from my typing because I'm sure you don't want to see me type out some rather long package names. This one's a bit shorter though. Microsoft Entity Framework Core, which of course our database context class will be using to communicate to initially our in-memory database and then subsequently our SQL Server database. But we do need a few more packages in that space. So I just did upkey, so .NET add package Microsoft Entity Framework Core design. You need that one as well, and that's just at design time. This does not get included at runtime. And then the last one in the, well, actually, no, it's not the last one. We've got two more to go. So Microsoft Entity Framework Core. We are initially going to use an in-memory database because it's just a lot simpler than connecting it into SQL Server, but we will of course use SQL Server eventually. But yeah, we do need Microsoft Entity Framework Core .in-memory. And then the last one in this kind of Entity Framework Core is of course SQL Server. So Microsoft .entity framework core .SQL Server. And I think that's us good for now. So you can see that there was one other package in there, this swashbuckle, that just gives us an open API spec out the box, which is quite nice. We might take a look at that later if I remember, but for now, we're going to leave it at that. Now we are going to add other packages, but I'm not going to put those in just yet. I'm going to wait till we come to the relevant section and then we'll add those in. I'll just have to make sure that I do remember to do that. So for now, that's good. Our application is scaffolded up. We've included our packages, so now we are going to move on to adding in our model. All right, so back over in our project, we're going to create our first model. Well, in fact, our only model for this service. So in the root of our project, I'm just going to right click and do new folder. And I'm going to call the folder models. Although we're only going to have one of them, doesn't matter. Use that naming convention anyway. So right click on the models folder and new file. And the model is going to be called platform.cs. So it's just a plain old C# class. And this is really our internal representation, our application's internal representation of our data. Why am I saying that? Well, we go on to use data transfer objects in a bit, which are basically our external view of our data going out. So models internal, DTOs external. All right, so namespace, which should be platform service. And then we'll do models. All right, and then the name of our class is just a public class is platform. And this is probably going to attempt to autocorrect. No, it didn't. Great. That's it. So it's public class, and then we're going to add some properties to it. So to sort of shortcut writing properties, if you type prop and then tab, and then you can tab through the property that it's created. So yes, this instance, we do want an integer, so tab over, capital ID to give us our model ID, and that will eventually become our primary key down in our database. Next prop, so again prop, tab is this time is string, and it's just going to be called name. I'm only going to do a few properties here. Next property will be another string, and I'm going to call this publisher. Okay. And then the final property, and we're not really going to use this, but I just want to labour the point. I'm going to create another property, just make it a string for simplicity, but I'm going to call it cost. Now, while that's a bit of an ambiguous property name, the point here is that for this service, you might want lots of properties that describe the platform. So cost might be how much it costs, or it might be its annual subscription, or it might be a support cost, or it might be the cost to run. And you could add all these in, as well as lots and lots of other properties very specific to this domain, to this microservice. It's a platform service, it's an asset register. You might have loads of attributes in your platform model that you might want to have there. Spoiler alert, we're going to have like platform representations elsewhere in our microservices ecosystem, in our commands service specifically, and it's just not going to be interested in that type of data. So the point I'm making here is, yes, you're going to have this concept of a platform that permeates throughout our system, but different services will have different views on what that actually means for them in terms of the context of what they're trying to achieve. Okay, so a bit of a long-winded way to say that you could have loads of stuff in here that other services just may not be interested in when they come to modeling or representing this type of data. Cool, so let's just save that off. And then the only other thing we want to do, just to help Entity Framework along a little bit, is just decorate these with some annotations. Now, the first one I'm going to use is the key annotation, just to say that this ID is going to be a key in our database. So make sure your cursor is in the offending article. It's got the little red squiggle under it. Make sure your cursor's somewhere in there, and Control and period to get Visual Studio Code to give you some code suggestions. And I'm going to select the first one here using System Component Model Data Annotations, and we'll add that in the top for us. Now, we're going to be doing that control period about 1,000,000 times, well, not 1,000,000 times, but a lot throughout this course. I'm not going to say it again, although I'll probably mention it again, but that's how you get those code suggestions up. Now, just a word of interest. By default, Entity Framework Core would interpret this property as a key. You don't really technically need to specify that it is a key, but I just like to do it just to be a bit more complete. And it also acts as kind of in code documentation, although it's not really documentation. This is similar. This is not actually required because a primary key is of course mandatory, so you don't really need to have the required attribute, but I just like to put that in because, well, I'm maybe a bit weird. And then I'm going to make all these other properties required as well, so they cannot be null. All right. So that's it. It's a very simple class, and you might be going, that's a bit too simple. Believe you and me, you don't want it to be any more complex because there's a load of other complexity coming down the line, so we want to keep it relatively straightforward and relatively easy to understand. Cool, so that's our model created. We'll move on to the next section, which is looking at our DB context. All right, so the next thing we want to do is create our DB context. So again, just we'll pay a quick visit to our architecture. So we've created our model, just a platform model. We're now creating our DB context, which effectively maps our models down to our persistent data store. Now, to begin with, we're just using an in-memory database, but we will move to SQL Server eventually. So this is the next thing that we're going to tackle. So back in our project, new folder in the root, and I'm just going to call this data. I'll put a few data related things in here and right click and new file, and we'll call this app.db context.cs. And then namespace is just platform service.data. And it's just a public class called app.db context. And we're going to inherit from the base DB context class. And it's probably going to try and autocorrect here, but let's see how we go. Yeah, it did. So just go back and take that back out and just say we're inheriting from DB context. So we want to bring in that namespace, so control period, using Microsoft Entity Framework Core. Fantastic. And then we just want to create a constructor that we can, if we need, pass in additional options if and when we need them. So constructor, actually short code for constructor is ctor tab, and then you can just tab through, and we're going to pass in one parameter, which is db context options of type oh, well, whatever our class happens to be, so DB context. And we'll just call that OPT. And we can get that from base. Okay. And we don't need to put anything in there just yet, but that's our constructor, that we'll use for this. And then most important, well, it's as important, we need to define a database set, or DB set, and which relates to our model. So that's really what's telling our DB context to mediate or mirror our internal model down to the database. So we just specify a property, prop, tab. This time it's of type DB set. And the type of DB set is platform. And we'll complain, so control period, bring in the namespace for our models. And we just want to call that platforms, plural, okay? So that's our DB context class set up. Then what we need to do is we need to kind of register it over in startup. So let's do that now. And in our configure services method, we want to add that in here. I'm just going to take these comments out because the code looks busy enough at this level of magnification without additional redundant commentary. So yeah, we're going to put that in configure services, which is where we register all our services. No surprises there. So I'm just going to add that here, services, add DB context. What type of DB context are we going to add? Just the class that was added in the last section. And it probably won't find that, so we'll need to bring that namespace in. Control period using platform service data. Fantastic. And then we'll just specify some options. And we're going to tell it what type of database we are wanting to use. So we're wanting to use in mem database, and I don't think it's finding this. I think we've probably got to bring back, yeah, using Microsoft Entity Framework. Well, let's bring that back, and let me take a new line on this just so you can see that a bit clearer. And then you just give the database a name. It can be anything, it doesn't really matter. I'm just going to call it in-mem. So we are using our DB context with an in-memory database. And again, we will move to SQL Server and we'll make some determination in here, a bit of a check to see whether we're using a development environment, which I'll still use the in-memory database, or when we move to production to Kubernetes, then we will use SQL Server. But we can leave that for the moment. We just want to get up and running with our DB context. And that's it for our DB context. So in the next section, what we're going to come on to doing is we are actually going to work with a repository. So we're going to start to set that up in the next section. And really what I want to try and do is get all this blue stuff kind of set up, this data stuff set up before we move on to the more interesting stuff. Not that this isn't interesting, but we get all this wired up and then we can move forward. So repository next. All right, so back over in our project, what I'm going to do is I'm just going to get rid of this terminal for the moment, gives us a bit more space in our on our screen. And yeah, we're going to create a repository now, and we're going to use the interface concrete class pattern because we will inject our repository through dependency injection in our startup class. But if you don't quite follow that, don't worry, we'll do it step by step anyway. So the first thing we want to do in our data folder yet again is create an interface, and an interface basically just it specifies what type of things, the method signatures effectively that our repository will support, and then any concrete class can come along and implement those interfaces. So yes, over in our data folder, right click, new file, and because we're defining our interface first, we will specify a capital I, and I'm just going to call this platform. There we go. You're just going to do it eventually, platform repo for repository.cs. Not repi. That sounds like it's Latin there. I did it again. Repo. All right. I platform repo.cs. Okay. And namespace of platform service and data. And it's just a public interface called I platform repo. And then all we do in here is specify this method signatures effectively. So the first one, and if you've done any Entity Framework core stuff before, you'll realize what this one is for. But basically, we need to save any changes that we make. So whenever we add stuff to our DB through our DB context, adding it or deleting it is not enough. You actually have to save those changes. So we'll need to put something like that in here, which is what that is. And you'll see how that works when we come on to doing the concrete class. And then the first kind of proper signature that I want to define is getting all our platforms. We want to be able to use our API, use our service to retrieve all platforms. So specify it as an enumerable, which we don't have the namespace for. So enumerable of platform, a platform class, or platform service. And we'll just call that get all platforms. We're not going to pass anything in. So quite a simple operation. So bring in using system collections generic for the IEnumerable, and then we'll bring in the, try that one more time. Using platform service models, there we go. Okay, so this interface should allow us to get all platforms, specifying it as an IEnumerable. Next one we want to do is just return an individual platform. So not an enumerable this time, just returning a platform. And we'll call this get platform by ID. And this time we will pass something in, which will be the identifier of the platform, the ID of the platform, the unique ID. And then the last one is we want to be able to create a platform. So just make that void, call it create platform, and we will pass in a platform object into that method. And then we'll have to call save as well when we come on to doing that. But that's basically our interface done. These are the three, or really four, but these are the three things that this interface should provide somebody that's choosing to use this interface. And now what we need to do is we need to build out an implementation class of this interface. So we'll do that now. So again, in data, right click, new file, and we'll just call this platform repo.cs. So over here in namespace, create namespace, and call platform service, data, fantastic. And then we just specify it's a public class called platform repo, and it's going to implement iPlatform repo there. Okay, and straight away it will complain because we've not actually implemented any of these methods here. So again, our best friend, put your cursor in there, control and period, and click implement interface. Now it's not clever enough to actually fully implement it. All it does is create these placeholder method definitions, and then you can just see it's just throwing a not implemented exception. So yeah, it doesn't fully implement it, but yeah, it gives us the placeholders that we need, which is good enough. And actually you wouldn't want it to implement it anyway, because generated code is not that great, but this is fine. All right, now before we come on to doing that though, we want to actually create a class constructor. And this is our first use of our first proper use of seeing how dependency injection works. So again, ctor to create a shell constructor. And what it's going to expect to be injected in is an instance of app db context. And we'll just call that context. Okay, so whenever we use platform repo via our interface, when it gets constructed, it's going to expect an appdb context to get passed in. And because we have registered our appdb context here in our configure services method, that will occur. Okay, so I'm not going to go too much more about that. I would expect you to be somewhat familiar with dependency injection, so I'm not going to explain it further than that. But we'll use it so much throughout the rest of this course that it will definitely become second nature to you. And then to finalize, we actually need to make use of this context that's injected in. So we do that via a private field. And the convention is to typically start these with an underscore. Well, I do anyway, and you'll see it used a lot like that. So basically, whatever's injected in here will get assigned to this. And again, this doesn't exist, so control period. And what you want is this one here, generate read-only field. And I'll put it up here for us, private read-only appdb context. And you'll see this pattern used time and time and time and time and time again throughout the rest of this course. And that's really dependency injection in a nutshell. So we can come on to working with our methods down here. So I'm going to start with the simplest one and we'll do save changes. So let's just get rid of that for the moment. And all we want to do is return, and we're going to make use of our DB context, and we're going to say save changes on that context. And then this little bit here is really just saying if the result of save changes is greater than 0, then we basically return true back. So we had something that changed. So that's all that is. And we'll call this after any create, update, or delete operation. Any unsafe operation that we have on our data source, we will have to call that to make sure those changes are flushed down to our database. All right, so let's start with this next one, which is getting all platforms. We'll do that one next. And it's really quite simple. Return, again, we'll make use of our injected context. And then on this, you can see that we have our platforms object available, and that is just coming from, that's just this property here. We're just referring to that now. So we're going to return platforms to list. And I think we'll probably have to bring in the link namespace here. Yep. So control period using system link. It puts that in at the top for us. Fantastic. And that's all we need to do for that. We'll come on and do our get platforms by ID, and it's slightly more complex, but not much so. So return context platforms, but this time we're going to use this first or default method to say give us the first instance of a platform or the default one, and then we're going to specify some criteria using a lambda expression. So we'll say P goes to P, and we're wanting to find the ID of the platform where it's equal to, I'll get rid of that prompt, where it's equal to the ID that we pass in. So quite straightforward. We're basically saying, yeah, return everything from platforms, what the first or default item, from platforms where the platform ID equals the ID that we passed in. So it's conceivable that we get nothing. It's conceivable we get a null return there, but nonetheless, that's okay. And then finally, we've done that one already. And then the final one is creating a platform. So first thing we want to do is check to see that we've had some sort of valid object passed in. So we'll just do a fairly simple if plat equals null. Then we don't want to do anything. So actually I probably shouldn't have deleted that throw statement, but we'll just type it in again, throw new argument. Actually puts a slightly different exception, argument null exception, name of plat. Okay, so that just gives us a more descriptive exception, and we'll just bring in that namespace using system. So if platform is null, if it's not been defined and we're trying to create one, then we'll just throw this exception. Otherwise, quite straightforward. Context, platforms, add, and then we just add the platform object that we've been passed in. Fantastic. Now when we come to use this, as I've said before, we'll then need to call save changes to flush that down to the database. And that's it. That's it for our repository, and that's actually it. We're not going to change this now. That's our finalized repository, and that's our finalized app.db context. So the next thing that I want to do, and just before we do our DTOs, is kind of create a little class that's going to prepare our database. So when our app starts up, I want to actually put some data, some mock data into our database, just so that we have some there to work with. And when we come on to using SQL Server, I want to also run what's called migrations to actually create the data structure in the database. With the in-memory database, you don't actually need to run migrations, which is kind of good, but kind of bad. The other thing I will say about the in-memory database that we're using now is that it really is only used for test purposes. It's not a production type database. And of course, because it's in memory, if the service restarts, you'll lose all your data. So it's really, can't stress it enough. Probably should have mentioned it when we were setting up our DB context. It's really just for, it's really not even used much in development environments. It's really just used for testing, really. But we're making use of it here just because it's going to get us up and running much quicker than setting up databases. So we will eventually move to SQL Server though. So yes, anyway, what we want to do next is prepare our database, put some data into it. So we're going to create another little class to do that, and then we'll come on and finish off with our DTOs before we move on to writing up our controller. All right, now actually just before we go on with creating our database preparation, one thing I forgot to do, having created our repository interface and our concrete instance of a repository, one thing I didn't do is actually come over and register that for dependency injection, so that when somebody asks for an interface, a repository interface, we give them whatever concrete class we specify. So the way we do that is just over in Configure Services, and we'll just make use of services again, and we're going to add a scoped service, and we will just say if somebody asks for iPlatform repo, we're going to give them platform repo. Cool. So yes, obviously very important when it comes to using dependency injection, we register our interface and the concrete implementation of it in Configure Services. So somebody asks for this, we give them this. Fantastic. So let's just save that off. The one thing we've not done so far is build. So let's just bring up our command line and let's just do a .NET build. There's not much to run yet, so we'll just do a build. I mean, it should be okay. We'll run it once we've kind of come to the end of this sort of section of data stuff. So that's all good. So I just want to do that, make sure we're okay to go. So yes, next what we're going to move on to is creating a class to kind of prepare a database with some example data. Okay, so just back over in our project, I'll just close down our startup class and give us a bit more space. And yes, we're going to create our database preparation class. So over in data, just right click, new file, and we're going to call this prepdb.cs. And then we'll begin with a namespace as usual, platform service.data. And this is a public static class with the name of prepdb. Get that round the right way. And yeah, static class, we don't need to create instances of it. And this class is going to have two methods, one public and one private. And the public method is going to set up a database context for us that we can use. Now, this isn't a constructor, this is just a public method. So you might be going, wait a minute, got a couple of questions here. Why aren't we using constructor dependency injection? Great question. Well, we can't because it's a static class, so we can't use constructor dependency injection. And the second question you might have is, why are we using a DB context? Why don't we use the repository that we just created? And that's another great question. So the reason I'm using a DB context in this case is that eventually I'm wanting to use this class to generate migrations in our SQL Server database. And it's just much easier to do that directly on a DB context. All right, and there's a couple of other methods that we're going to use here that I don't really want to build into my repository anyway. This class here is really more for testing. This is not something I would probably push into production. It's really just for us and for this video to help us set up things in our database environment. So that's the two reasons. We can't use constructor dependency injection, and I'm using a DB context mainly because I want to use it eventually to create some migrations. All right. So with that being said, let's create our first, let's create the signature for our first public method. So it's public static void, and I'm going to call this prep population. Now, before we define what we're going to pass into it, if we come over to our startup class, we're going to call this method, this prep population method on this class from startup. So once we've run configure services and then configure starts to get run, we're going to call it in and around here. And what we're going to pass in order for us to be able to use a DB context is this iApplication Builder instance here. We're actually going to pass this through into it, and then we're going to use this to create something called a service scope, which we can then use to create a DB context. So it's a little bit heavy at this stage in the course, and it's slightly off topic, but we have to do it, and I'm just trying to explain it as best I can. So hopefully you'll follow the code. It's not that bad, but let's get on with it. So yeah, we need to pass in an instance of this to this method over here. So let me just code that up now. So iApplication Builder. And we won't have the namespace for this, obviously, and we'll just call that app. So what I'll do is I'll just bring in the namespace for that, and I think I probably spelled it wrong. Yeah, there we go. My application builder. Let's try that again. There we go. Using Microsoft ASP.NET Core Builder. So that's a good tip. You know, if you're doing the control period thing and you don't really see what you want, chances are you've spelt whatever it is wrong. Okay, fantastic. Now, just before we continue with this, what I'm going to do is I'm going to pop over to our startup class, and I'm going to just call this method because we've got everything we need now that startup needs in order to know about it, and call it, just so I don't forget. So prepDB, we can access the class directly because it's a static class, and then prep population, and we're just going to pass over app. All right, and that's all we need to do in our startup class, so I'm going to save that off. So back over into prepDB, we will carry on with this. So yeah, as I was saying, we need to create like a service scope in order to derive a DB context. So I'm going to do that via a using statement. So I'm going to create, first of all, a variable called service scope. I'll make that equal to using our app, application services, and then create scope, which I don't think will be available to me just yet, so I'll have to bring in that namespace. So control period, that's the one we want. Microsoft extensions, dependency injection. Fantastic. Now in here, we're actually going to call our next method, our private method, which is the method that's going to do all the seeding of our data and eventually run our migrations. So let's just create the method signature for that. It's a private static void method called seed data, and this is going to expect an app DB context, and we'll just call that context. Okay, fantastic. So where is seed data going to get an app DB context from? Typically, if this was a normal class, it would be via constructor dependency injection. You can't do that, as I've said, so we're going to have to create an instance or call this method, this private method, with an instance of appdb context from within our first method. So let's do that now. So let's call seed data, and then let's give it the DB context it so desperately desires. And we do that by making reference to the service scope we've just created upstairs, using service provider, and then get service. And any ideas what service we want to get? Of course, appdb context is what we want to push in there. And don't forget the round brackets at the end. We can close that off with a semicolon. So this public method, that's it, it's basically complete. So now for the remainder of this little section, we're just going to fill out the seed data method that we're going to use to, in this instance, just pass in some data. As we're still using the in-memory database, we don't need to worry about migrations. We just need to pass in some data. We will come back and update this though when we move to SQL Server. All right, fantastic. So let's move into here. Just, make sure I'm indented in the right place. So the first thing I want to check to see if we have any data in our database relating to platforms at all. So we'll make use of our context, and we will just look at our platforms instance, and that's, if you come back over to appdb context, we're just referencing this here basically. And then we can use this, probably have to bring in link here, but we can use this any syntax to see. There we go, we're getting autocorrect because we don't have link reference, so let's do that now using system link. Yep. So if the context platforms has anything or doesn't have anything, so make sure you put in the exclamation mark, so it's a not operator. If we don't have anything, then we want to push data in. Okay, otherwise you do nothing. Now I'm just putting this else statement in really just to help us with a bit of output, a bit of debugging output. So I'm going to do a console, and I'll bring in the system namespace, so control period using system, console write line, and I'm just going to say we already have data. And that'll come in useful when we actually use SQL Server and data will be persisted. At the moment, most of the time, we're always going to be seeding data at startup because we're using in-memory. And if once we shut something down and restart it, all the data's gone anyway. So for the moment, we're never going to see this. We're only going to see that when we move to using SQL Server, but we'll put it in for the moment. And then likewise up here, I'm just going to put in a console write line, and we'll just say something like seeding data. just so we know it's kind of working. All right, so now we'll come on to actually putting some data in, and there's another nice method we can call on our platforms object, on our context, so we'll use that now. So context, platforms, and then we can use this method called add range. And it's quite nice because it allows you to add a number of objects at once, which is quite nice. All right, so we're going to create a few new platform objects to pass in and create. And remember, DB context works off of the model, the platform model, nothing to do with DTOs. This is all internal to our platform. So new platform, I'm just going to bring in the namespace. I think I brought in used the fully distinguished path, which I don't like. I'd rather bring the namespace in up at the top. So we're going to create, a new platform, and then we simply just specify a new platform. So name equals, first one, let's do .NET, why not? Put a space in there. We'll specify the publisher, which in this case would be Microsoft. And we will then specify the kind of rather ambiguous cost attribute. I'll just say it's free. All right, now I want to create a few more. Now, rather than watching me type those out, I'll just go over to my notes, and I'm just going to copy in a couple more. And you can, of course, put in as many as you like here. You don't just need to put in 3 like I'm doing. There we go. In fact, let me get rid of this thing at the side. So Control B to take away the panel gives us a bit more space. So nothing too controversial. We're just creating a couple other platforms, SQL Server Express and Kubernetes. Don't forget the commas at the end of each line, except for the last one. All right, so that's cool. We've added our products to the database effectively. Do not forget, and I always forget this, do not forget to context save changes. Because yes, that add range will add stuff to the database, but unless you save the changes, it's not going to go in there. Right. So that's it for the moment. I think that's it for the moment anyway. PrepDB is done. It's going to start up, give us a database context, and add that to our database. So why don't we give that a go now? We did add the call to this method here in startup, so it should be good to go. So Control / to get a command line up. Let's do .NET build, just to build it first. Although when you run it, it builds it, but I like to do the build before the run. I don't know why. .NET run now. So what we should see is this seeding data message. There we go. I think it flashed up on screen. Quite quick though. Yeah, seeding data. So cool. It's realized we don't have any data in our in-memory database, and it's seeded the data. Now we can't do anything with that now. We can't access it yet. That's when we come on to our controller. Fantastic. But what we're going to move on to now, just to kind of round out the data section, is look at DTOs. We're going to create some DTOs. I'll do that next. All right, so back over in our application, I'm just going to kill our running server, Control C, and get rid of this terminal. So yeah, we're going to come on now to DTOs. Now, before we start coding, just a little bit of a sense check by reviewing our architecture. So we've created our model, our platform model. We created our DB context. We have an in-memory database. We will move to SQL Server at some point, and we spent some time creating a repository, which our other classes are going to make heavy use of. But just to round out this kind of section, we're going to now move on to DTOs, data transfer objects. And what are data transfer objects? They're basically external representations of our internal models. And you might be going, why do you want to do that? Well, you don't want to expose your internal models to external consumers. Why not? Well, number one, there might be data in your internal models that you don't want to expose, right? The other thing, which is possibly what's as important, is that as soon as you expose your internal models to external consumers via an API, for example, straight away you're creating a contract with them. And if you then want to start changing your internal models, which is entirely conceivable, and you should be able to do that, you may break the contract with your consumers. And you're basically tying your internal implementation to an external contract, which you absolutely do not want to do. So you need to abstract away your internal data from your external data. And that's all DTOs are. Okay, so they're very valuable, and that's what we're going to do next. All right, so back over in our application, make sure you've closed down any running services or anything like that, any running servers. And I'm going to do Control B to bring back up our directory explorer, and I'm just going to close down these windows here just to make it a bit nicer. And we are going to create yet another folder, so right click new folder, and we're going to call this DTOs. I'm going to get our first DTO, new file, and I'm going to call this platform read dto.cs. Now you might question this and go, what? Don't we just create one DTO? You could, but you're not really going to get the maximum benefit from them. We're going to create quite a few DTOs. In this section, just 2. So the use case is consumers are going to be reading data from us, platform data from our service. So this DTO, the read DTO, is going to be a representation of any data that we want to provide in that context when anybody's reading from us. The other scenario is going to be when somebody wants to create a platform using our service. We're going to provide a view of the data that we expect to be given in that scenario. And it's going to be very slightly different, okay? And that's where the real power of DTOs come in. Anyway, let's get on with this one first. So namespace, platform service, DTOs. And it's just a public class called platform read DTO. It's a very, very, very simple class. And I'm just double checking I'm spelling platform correctly. That looks good. Now what I'm going to do, I'm going to come over to our models folder, into platform, and I'm just going to copy all of our properties. I'm going to paste them in here. Okay. Now I don't mind doing copying and pasting in this instance because I've already typed this code out, and I'm sure you don't want to see me double writing it out again. So let's take a look at these properties and think to ourselves, when somebody's reading data from us, is it conceivable that we would want to give them the ID of our platform object? Yes, we absolutely would. Would we want to give them the name? Yes, we would. Would we want to give them the publisher? This is where it starts going into, well, it depends what the intention of our API is. In this case, we're going to give it to them. And then cost, the reason I put this property in is really to kind of make the point that this could really be an internal bit of data that we don't ever want to expose. So again, if you didn't want to expose that, you would take it out. But for now, I'm just going to leave it in. May take it out later. We'll see how we go. So for the moment, our read DTO is going to be exactly the same as our platform DTO, and that's fine. But what it does mean is that you can change your internal platform model later, and this could remain exactly the same. Fantastic. All right, so that's all looking good. So we're going to create another DTO now. A little bit more interesting, new file. I'm going to call this platform create DTO.cs. Platform create DTO.cs. All right, great. So start with the namespace as usual. Platform service, DTOs. It's a public class called platform create. I'm typing too fast for my capabilities here. Platform create DTO. All right, fantastic. Now what I'm going to do, I'm going to come back over here and I'm just going to copy this again. But this time, let's think about the data that we've got here. So someone's going to create, this is for when somebody's going to, this is specifying the data we want when somebody's going to create a platform with us. The first property there, the ID, do we want them to give us the ID? No, in this case we don't, because we take care of that. Our database takes care of that by creating a primary key for us, and that's where the unique key comes from. So when someone's creating a platform with us, we do not want them to supply the ID as part of the body payload, so we take that out, okay? As for the other stuff, we'll leave that in, okay? Because we do want it. Now, let me just pop back over to the platform read DTO, and I actually took out the data annotations there. I should have mentioned that because it's a read DTO, I don't really feel that we need the data annotations in this case, so I'm just taking them out. For the platform create DTO though, I'm going to leave them in because out the box .NET does some nice data validation stuff with our controller actions. So if somebody doesn't supply one of these properties when they call our controller, .NET will go back with a nice pre-formatted error condition for us, which is really nice. So that's why I'm going to leave it in this case. So in order to use them, control period, and we'll bring in this namespace. All right, and that should clear up our errors, and we'll save that off. So yeah, platform read DTO, it's got all the properties. I'm just going to take out this double spacing, it's kind of annoying me. We've got all the properties that we had in our platform model. We're not using data annotations, but that's okay. And then our platform create, slightly different shape to it. We don't require the ID, but we are using data annotations. Fantastic. So that's our 2 DTOs done for this point in time. Now, at this stage, we've got our model, our platform model, and we have our 2 DTOs, but they're just separate classes. They don't know about each other. There's no way we can map at this point to them, but that's what we're going to do next. And we're going to use a tool called AutoMapper to allow us to map from one to the other. So we'll do that next. All right, so moving on to AutoMapper now, let's just clear down our development environment. And there's a few bits of setup required for AutoMapper. The first thing we should have already done, so over in your CSproj file, just double check that you have this package reference included at the top for AutoMapper. And if not, please add it, otherwise the next bit's not going to work. The next thing we need to do is register AutoMapper for dependency injection. So over in Startup, in our configure services method, we're going to do that here. So making use of our services collection once again, there we are, add AutoMapper at the top. And yeah, that should become a relatively familiar pattern that we're using. You can see it's complaining here because we do actually need to provide a little bit of extra detail inside the parentheses. So add domain, app domain, my apologies, current domain, and then get assemblies. And don't forget the parenthesis at the end there. And we'll save that off. So that's AutoMapper now registered in a dependency injection container so we can use it throughout the rest of our application. Now the final bit of this section is to create what's called a profile. So again, we've got our DTOs, we've got our models, they are not in any way mapped together, and we do that via a profile. So in the root of our project, right click, new folder, we're going to create a folder called profiles. And into that we're going to create a single class called platforms profile. So new file, platforms profile.cs. Okay, and then the usual setup, the namespace of platform service, and this time it's profile, profiles plural, and curly brackets, and then it's just a regular old class, so public class platforms profile. And we're going to inherit from an AutoMapper class called profile. Okay, now this has tripped me up a few times. Our folder is called profiles, our namespace is profiles plural, this class is profiles singular. Okay, it's tripped me up a few times and caused me a few issues, so just make sure you get that correct and bring in the right namespace using AutoMapper. Fantastic, so that's our shell of our class setup. Now, where we create our mappings is actually in the class constructor. So just CTOR to do the shortcut for platforms profile, and tab across, and we just take out the parameters. We don't need any in there. So this is our class constructor, and it's in here that we create our mappings. So let's create our first map, and I'll talk you through about exactly what is happening. And before I do that, let me just do a little annotation, source to target. All right, so we use something called create map, and we specify the source. So think about a scenario where somebody is using our service to read data, consume data from us. Ultimately, that data, the source of it, is in our database. It becomes a model. Well, it is a model, a platform model. That's the source object, and we're going to then map that model to a platform read DTO and give the consumer the read DTO. So the source is the model, platform model, and the target is the read DTO. And that's what the mapping is. Now again, if this is a little bit abstract, when we come on to writing our controller, it will become a lot more obvious when we actually start putting it into practice. But for now, let's create our mapping. So platform, so this is our model, is the source. And let me just bring in the namespace for that before it starts, autocorrect starts driving me mad. So using platform service models, and then our target is platform read DTO. Close off the angular brackets and end with a parenthesis and a semicolon, and we'll just bring in that namespace. So again, just to reiterate, this is servicing our reading scenario. So the source of our data is our platform model, and the target is our platform read DTO. Now, a couple of important points here. Because our platform class and our platform read DTO have properties that are named exactly the same thing, and that's the way we want to map them, we don't need to tell AutoMapper anything else. Hence the name AutoMapper, it does it for us, which is brilliant. When we move through the course, we're going to be creating other classes and other entities where that's not straightforward, and we have to then explicitly tell AutoMapper how to map or not to map between properties, but we don't need to do that yet. The second point is here that we've created a mapping with a source of a platform model to a target of a platform read DTO. Brilliant. If you then had another scenario where you needed the source to be a platform read DTO and the target to be a platform, you have to explicitly add that here. Just because we've created a mapping one way from those two objects doesn't mean that there's an implicit mapping the other way. You've got to explicitly add that, okay? Just those 2 points are pretty important. So just before we finish off, we'll create our last mapping, and this one is for the creation scenario. So again, in this instance, the source of the data is a platform create DTO, because that is what our consumers are giving to us. That is the source of the data, and the target for that ultimately is going to be the creation of a model down in our database, a platform model in our database. So the source is a platform create DTO, and the target is a platform model. Okay, so create map once again, and our source this time is a platform create DTO, and the target is a platform model. Make sure we get that correct. All right, and that's it for now. We will add more mappings in here with some rules as well, actually, but for now, that's all we need to service our current scenarios. So save that off, and the last thing I want to do, just before we move on to working with controllers, is just do a bit of a .NET run, just to make sure everything's running up and building okay. And if it is, we can move on to the next section. And it looks good, so let's move on to controllers. All right, so moving on to our controller now, I'm just going to stop our server from running. I'm going to kill the running terminal. And as usual, I'm going to clear down our previous work that we're doing just to make it look a little bit cleaner. All right, so we already have a controllers folder from when we scaffolded up the application, so we obviously don't need to create that. But right click on that, new file, and we're going to create a file called platforms controller.cs. It's obviously a CS file. Fantastic. And then as usual, we define the namespace of platform service controllers. And then it's just a public class called platforms controller. We're actually going to inherit from something called controller base, which is really a base controller class that's really used for APIs as opposed to full-blown MVC web applications. So controller base. And we will have to bring in namespace, so control period, Microsoft ASP.NET Core MVC controller base. Oh, I selected the wrong option there. I want to, oh, I did it again. Get it right this time. Using, here we go. My eyes were a bit crossed there. Oh, there we go. So we add the using statement at the top, that's what we want. Otherwise it's going to get way too busy. All right, so we're going to create a constructor, so ctor tab. And into this, we are going to work with our repository, and we're going to eventually work with AutoMapper. So let's get going with that. So the first thing we're going to inject in is our platform repository. So what are we asking for? We're asking for an I platform repo. I'll just check that's what we called it. I know we just created it not so long ago, but I just want to make sure I'm giving it the right name. So we're creating one of these, and that will be injected in. And we'll just call that repository. And then we're also going to request an instance of mapper, iMapper, which is our AutoMapper stuff, and we'll just call that mapper. And we'll need to bring in the namespaces for both of these. So using AutoMapper and using, I think I might have, yep, there we are, spelt it wrong, platform, not platform, there we go. So try that again, that's better, okay. Now, as usual, what we want to do is these two parameters are being injected. We want to assign them to private fields, usually denoted by an underscore. So we'll assign repository to underscore repository. There we go. And likewise for mapper. And we'll use these private fields inside our class. And of course they don't exist yet, so control period, and we want to generate a read-only field for each of them. And you can see they are added at the top here. Now this is the kind of very, very standard constructor dependency injection pattern that you're going to see lots and lots throughout this course. Constructor for a class, we'll pass in a number of parameters, and then we'll assign them to private fields, private read-only fields that we then use within that class. Fantastic. Now the other thing we want to do is we want to actually decorate our class with a couple of attributes. The first one is API controller, and that gives us a lot of out-the-box functionality relating to API controllers, and I'll call those out as and when we come on to them, but it's mainly around passing through data via our actions and stuff like that, and yeah, sort of default behaviors that most web APIs will want to adhere to. So it saves us a bit of work. And then we want to also define our route, okay? And this is basically where we can find this API and then subsequent actions. So square brackets, route, open round brackets, and we're going to specify API / and then you can either specify explicitly the name of your controller, so for example platforms, or you can use this kind of wildcard approach where you can just put in square brackets controller, and that will take this portion of the controller's name, everything aside from the word controller, and basically put it in here. So you get the same result. So this route to this controller will be API / platforms. Okay, up to you which way you want to do it. I've seen it being used both ways, either using this way or just actually hard coding it, up to you. All right, fantastic. So now we want to come on to our first action, and in doing this first action, we can actually then test to see whether everything we've done so far has actually worked. So we're going to do an action that just gets all the platforms that have been added to our backend database. So public action result, it's of type IEnumerable. And we're going to have to bring in that namespace, and it's an enumeration of, what is it? Enumeration of platform read Dtos. Okay, and let me just finish this method signature, and I'll just take you through exactly what we're doing here, just in case it doesn't make sense. And we'll call it get platforms. Okay, so we're not passing anything in, we're not passing in an ID in or anything like that. And yeah, that looks okay. And we're going to decorate it with verb http get. There we go. So let's save that off. Now, I think this, I'm surprised, I think I've made a mistake here. We just put this other bracket in and then I'll probably get some complaints. Just finish that off. I'm surprised it's not, there we go. It's not complaining, it's complaining now, thankfully, about the fact that we didn't have IEnumerable or platform read DTO namespaces at the top. So let's bring those in. So control period, systems collections generic, and then platform read DTO. There we go. So basically what this is saying is when you call this action, and it's going to be get action at this route, API platforms, we're going to return an enumeration of our platform read DTO. Not our platform entity, not our platform model, but our platform read DTO, because we've said previously, whenever we're sending data out, we want to send over the read DTO representation of our data. So that's why we're doing that. And then from there, it's actually relatively simple. And we're going to get to a point where we're almost ready to actually see that we've not made any mistakes throughout this whole build process to date. So just to help me debug if it's, if we have any issues, I'm just going to put in a console write line. I have to bring in the system namespace, so control period using system. And I'm just going to say getting platforms. And hopefully we get some platforms, but we will see. All right. So we want to now make use of our repository to actually go into a repository and pull back the platforms that we want. So I'm going to create a variable that will contain the return result set from our repository method. So platform items, and this is going to be an enumeration of platform models that our repository turns back. So we'll make that equal to, and we'll make use of our repository, and then we'll have a look, and we want to get all platforms, and we'll just do that. So that will go into our repository class. Let's come over here. It's going to use this get all platforms signature here, and then in our concrete implementation, it reaches in to our DB context and returns us a list of platform objects. Okay, so we have platform objects in here, but we want to return platform read details. So this is where AutoMapper comes in. We're going to map our models to our read details and return that back. And that might sound rather complex, but it's not really, thanks to AutoMapper. So we're just going to do a return. Okay, so HTTP 200 result, and then we're going to make use of mapper, our injected mapper object. So it's mapper, map, and what are we going to map to? We're going to map to an I enumerable of what? Let me just see if I can get rid of this thing, it's a bit annoying. An I enumerable of platform read details. There we go. And what are we mapping from? So this is what we're mapping to. We're going to map to an enumeration of platform read details. What are we mapping from? We're going to map from this collection here of models. All right, and that should be enough to basically get us at the result that we want. So if we just come back to our profiles and we have a look in here, basically that is going to be making use of this mapping construct here. Now, even though we're using an enumeration, doesn't matter. It's smart enough to know that enumeration or single objects, it will still work okay. So again, AutoMapper, very, very cool thing. So let's save that off. Let's do a control backtick and let's do a .NET run. And hopefully everything should be wired up correctly. I don't think I need to do anything with the platforms control. If we come back over, before we test this, we come back over to the startup class. Let me just move this down. Our controllers have already been added into configure services anyway, so everything should be wired up correctly, and our endpoints are all wired up down here in configure. You can see here we have our controllers mapped through, so should be okay. So the way I'm going to test it, I'm using a tool called Insomnia. If you want to use a web browser or you want to use Postman, Postman's obviously very popular, go for it, doesn't really matter. I like Insomnia because the interface is a little bit cleaner. It's just nicer for making videos. So I've got an empty environment here, and you can download Postman free off the internet. I'll put a link down below. I've got an empty environment, so what I'm going to do, because we're going to do a lot of testing throughout this, believe me, we're going to do a lot of testing in a lot of different environments. So I'm going to create a new folder, and I'm just going to call it local dev. So that's a local development environment, and I'm going to put all my requests for local development in here. And then I'm going to create another folder, and I'm going to call it platform service, because we're going to be testing a platform service and a few other things as well. So local dev platform service, and then we're just going to create a request, new request. I'm just going to go get all platforms. You can obviously call this anything you like, it's just a label really, and it's a get request, so create that. And where are we going to get our stuff from? Well, we're going to, if we come back over to our running application, scroll up a little bit, you'll see that our application is listening on localhost 5001 for HTTPS and 5000 for HTTP. Now, in this video, I'm actually not going to work a lot with HTTPS, which is not something I would usually do, but for various reasons, more especially when we come to Kubernetes, it becomes very, very complex, and it's going to kind of detract us from the core of what we're focusing on. So for the most part, I'm going to be hitting the HTTP endpoints rather than HTTPS. Now that's something I might tidy up in future videos, but for the moment, I don't really feel it's too much of an inhibitor, especially not when we come to running things in Kubernetes. But it does come back to haunt us a little bit later on in the video when we come to using gRPC, but we'll cover that off when we come to it. So just wanted to call that out. Yeah, running on localhost 5000, 5001. For the most part in this video, we're going to just be working with HTTP to keep it simple. Otherwise, we start going down some rabbit holes. So let me just copy that, in fact, and I'll just paste that in. I'll put that in over here. And then we want to put our route in, so it's API platforms, okay? So get request, here's our base URL, and then the route to our action. It's API platforms, which should look familiar to you. Now if we come back over here, it's basically what we specified up here at our class level. If I can find it. No, that's looking in the wrong looking startup. In our platforms controller, we come over here to our class. So our class level, this is our class level route, API platforms. And then we've specified a get. And so the method signature that we're calling from Insomnia will match this method signature here. There's no attributes being passed in or anything like that. So we should get a result back. So let's hit send. And indeed we do. So there we go. We get 200 response back and we get our 3 platforms returned, which should look quite familiar. These are the platforms that were injected into our in-memory database. So that's awesome. We're on the right track. So all we've got to do now is just finish off our last 2 controller actions, and then we're ready to move on to some of the more interesting stuff. All right, cool. So let's come on to finish off our controller. We'll finish it off for this section. We are going to add a lot more into it going through the course, but for now we're going to, just finish off the basics and get our other 2 action results in place. So if, like me, your server's still running, just Control-C to take that down and get rid of the terminal. Don't need startup for the moment, and we're just going to work exclusively within our platforms controller class now. So what I'm going to do is I'm going to get rid of the sidebar, and I just pressed Control and B just to get rid of that, and you can toggle that on and off. We're not going to be moving around any of our files for this last section. We're just going to be working completely in here, so we can give ourselves a bit more breathing room and see exactly what's going on. So the next action I'm going to add in is going to be very similar to this, but this time we're going to request just one platform using an ID. So let's come on and get on and do that. So again, public action result. What are we returning? Rather than an IEnumerable, we're just returning a single platform. Read DTO. That's all. And I'm just going to call that get platform by ID. And then we are going to expect a parameter this time of type integer, and we're going to pass in an ID. Now, when I was talking about this API controller giving us some out-the-box behaviors, this is kind of what I'm talking about here. By defining this ID as part of an input parameter to this action result, basically that will be interpreted automatically when we come over to testing it, and we pass in /2 to relate to one of the IDs of the platforms. That this route will basically be automatically interpreted by this to map to that. Okay, it's kind of nice. You can explicitly tell what you're mapping through from your request, but in this instance, it's all doing this kind of stuff out the box for us. But of course, we do have to specify that it's a HTTP GET. Okay, and then it's actually very similar to this here. So the first thing we're going to do is declare a variable to hold our results. I'm going to call it platform item, singular this time, because we're just looking for an individual item. And again, we'll make use of our repository class, and we did create a method in here called getPlatformsById. Fantastic. And what do we want to pass into it? We want to pass into the value that's been passed in through our URL. Okay, so we're going to attempt to get whatever was passed in. Now, as per sort of REST best practices, if you try to locate a resource, an individual resource, as we're trying to do here, and it's not found, you should return a 404 not found HTTP result set back. Okay, so that's what we're going to do next, or that's the kind of the check we're going to make. So if platform item doesn't equal null, then we have something, that's good, and we're going to return it back. So we'll return it back with an OK. And we're going to do something very, very similar as we did up here. In fact, almost identical. We just don't need to specify that it's enumeration. But let's type out anyway, because it's good practice to get across this stuff, because we're going to use AutoMapper quite a lot. So mapper, map, what we're mapping to. Instead of an enumeration of platform read details, we're just mapping to a singular platform read DTO. And what's our source? It's this platform item. And that's it. Nice and straightforward. So if the platform item returned is not null, great, we do that. Otherwise, we're going to return a not found result, and that will return a HTTP 404 for us. Fantastic. So let's save that off, bring up our command line. Let's do a .NET run. And remember, doing a .NET run also does a build for us as well, as you can see there. But I don't know why I sometimes still like to run a separate build and then do a run. I don't know why, it's just my weird way of thinking. So let's run this one again. Let's take out the 2 and just make sure it's still working. There's no reason why it wouldn't be. Well, it isn't working. What have we done wrong? You've done something wrong here. Let's find out what we've done wrong. And we'll just scroll down a little bit. The request match multiple endpoints. Oh, I know what I've done wrong. So this is actually a really good example of something that we forgot. Well, I forgot to put in. You can see here we've got 2 HTTP GET requests, and it actually wasn't intelligent enough to, I forgot a really important thing. We actually have to specify an additional route in here, because otherwise what that error is saying is we've got 2 HTTP GET requests, which it interprets as being completely identical. It doesn't even get down to the method signature here, even though the method signatures are different. So bit of an omission there. So let me just rectify that. So within our HTTP decoration, let me just do open brackets. And what we're basically doing is we're specifying effectively a route, part of the route that we're looking for. So the way you do that is string, double quotes, curly brackets, ID. So we're saying we are expecting, as part of this GET request, an ID. And as part of that, that is then mapped into this. Yeah, that's my bad. You really forgot to mention that. So yeah, as part of this route here, if we do this, 23 for example, it's going to match this route here. If we take this out, then it's going to match this route here. And it was getting confused because we had no point of differentiation. And where API controller comes in is it automatically maps this value into here. There you go. Early in the morning for me here, I'm not quite woken up yet. Now, the other thing we're actually going to do while we're doing this, I'm actually going to give this a name, and you'll see how this comes into play in the next short while. And I'm just going to give it exactly the same name as the method signature name. Okay, and we actually make use of this a bit later on in our next action result. Okay, cool, there we go. So that should be okay now. So let me run that up again, Control C, and run it up again. And let's see how we're going. So let's come back to Insomnia and let's just run our old request. There we go, back to normal, that's cool. And then we're going to create a new request explicitly for get a individual platform. Okay, there we go. And what I might do is I might just copy this over, and I'm going to paste that in here. And let's have a look at our result set over here. So you can see the in-memory database has automatically added IDs for us. Fantastic. So let's see if we can pull back Kubernetes, since we're going to be working with that next, and put in 3. And indeed it does, it pulls back the individual platform for us, which is all good. Now if we put in some ID that doesn't exist, we'll get a 404 not found, which is exactly what we want, and that kind of adheres to our REST kind of standard practices. Fantastic. Okay, good. So I'm actually quite glad I had that error, honestly I am, because it kind of helps you understand how things work. And that's a really good point. When you make mistakes and when things don't work, that is actually, for me personally, that's when I learn stuff. If everything just goes totally smoothly all the way through, you're going to learn stuff, but not as much as when things go wrong. Okay, so this is a long course. I'm just going to call this out here. This is a long video. You're going to make mistakes. I guarantee it. I guarantee you're going to make typos here. You're going to forget to put things in there and things are not going to work. Don't stress out about that. The code is available on GitHub, and you can, if you want to, you can just kind of overlay that on what you're doing. But what I would suggest you do is try and fix it, because in trying to fix it, you're going to learn a lot more than just listening to me talking and going through the video, all right? So rant over. We're going to move on to our last action result, which is creating a platform using our controller. And then we're going to move on to a bit of Docker and then Kubernetes. All right, so let's come on to creating our third and final controller action in our platforms controller. And it's this controller that we're going to use to create platforms in our backend database. And it's this controller that's going to be the one that we're going to return to and do a lot more work in terms of triggering messaging to other services. So we're not done with this one fully yet, but we're going to get it into a state where we're creating platforms and then we're going to move on to something else, but we will return. So before we do that, let's just do a Control-C to kill the running server, get rid of this, and then we'll move down and we'll create our final action. So again, public action result. And what we're going to return back, we're actually going to return back a platform read DTO. So when you create a platform using the service, part of the REST spec is that you should pass back that resource once it's been created. And so anytime, again, without sounding like a cracked record here, anytime you're returning data back, we're going to use the read DTO. So there we go. Platform read DTO is what we're returning back. We're going to call this method create platform. And what we're going to expect as an input, any ideas? We're going to expect a platform create DTO. There we go. And we'll call it platform. I'll tab that through. So just to go over that again, we're going to return back a platform read DTO, assuming we create one. And what we're passing in, we're passing in a platform create DTO, and that's the DTO we created explicitly for creating platforms. And the only difference really between these two at this point in time is the create DTO doesn't have an ID because our database creates that for us. All right, fantastic. So let me just do our curly brackets, and let's make sure this time we specify the correct, we decorate this with the correct route. So it's going to be a HTTP post this time. And that is all we need to do actually in this occasion, because when we are creating or posting a new platform, we don't actually have to specify an ID. If we were doing an update or something, we would have to do something very similar like we did up here and actually specify that we're expecting like a resource ID in here. But for creating, we're just saying it's a post request. And looking across our entire controller, all of our method signatures are now unique. So this is just a HTTP GET, this is a HTTP GET with an ID, and this is a HTTP POST. So the first thing I want to do is actually make use of AutoMapper. So we're getting passed in a platform create DTO, but our repository works with models, it doesn't work with DTOs. So we're going to have to map our create DTO to a temporary model object that we'll then use to pass into our repository. So let's do that first. So new variable, I'm going to call it platform model, and that's going to be equal to mapper, map. And what are we mapping to? We're mapping to a platform object, a platform class really, not an object. Okay, I'll bring in the namespace for that because I don't think we have that yet, using platform services models, okay. And what are we mapping from? What's our source of our data? Well, it's this here. It's our platform create DTO that was passed in. I'll just put that in here, okay? And we'll round that off with a semicolon. And again, coming back to our API controller decoration here, you're going to probably ask, where is this coming from? Well, we're ultimately, when we come to testing it, we're going to place it in the body of our request. And again, by using this API controller decoration attribute here, this action will kind of look initially to the body request of the request that comes in, and it will just put whatever object it has into here by default. Now you can override that with more explicit behaviors, but again, the default behavior is fine for our purposes. Okay, so we've got a platform model now, hopefully, if our mapper has worked correctly. And if I just do a Control B to bring up my directory listing here and come back into our profiles, you'll see that this is the mapping that's kicking into play. We're taking a platform create DTO as the source, which makes sense, and we're mapping it to a platform. All right, so we're making use of that second AutoMapper mapping here. And then it's quite simple actually. We then make use of our repository and we will do a create platform. And what does that expect? It expects a model, and so we're going to pass in platform model, like so. Fantastic. Now, one thing that we obviously always need to do whenever you make a change or anything like that, we'll need to go back to our repository and we'll need to save changes as well. If you don't do that, if you leave that out, you will have nothing created in the database. So now what we want to do is we want to pass back our successful result if we have one. So in this case, a platform read DTO. As per REST kind of best practices, whenever you create a resource, you should return a HTTP 201 along with the resource that was created and also a URI to that resource, a location to that resource as well. So we're going to do all that in the next few lines of code. But the first thing we need to do then is we need to somehow get a platform read DTO. And so what we're going to do is we're going to use AutoMapper once again, and we're going to map from our model that we've just created back to a read DTO. Okay, so we'll do var platform read DTO equals underscore mapper. What are we mapping to? Oh, we've got map, and what we're mapping to? We're mapping to a platform read DTO. Make sure you get these right. I've got these wrong on occasions and mapped to the wrong objects, and it's caused me some problems down the line, but there you go. That's all part of learning. So that's what we're mapping to. What are we mapping from? We're going to map from platform model. Okay. Just get rid of that space there. Okay, so platform create came in, we mapped it to our model, we put our model into our database, and now we're going to return back the platform read DTO version of that. Now this might all seem a little bit long-winded to you. I've had some feedback, people saying they don't like this kind of decoupling to this extent. Well, that's okay. Personally, I still think this is absolutely the right way you should be doing this, okay? You shouldn't be passing back models directly over the wire. I definitely don't think you should be doing that. So what we want to do next then is we've got a platform read DTO, we want to return it back with a HTTP 201 to our requester. Now this line of code coming up is probably the one that I get the most comments about, going this doesn't make sense, and it's a little bit convoluted, and the Microsoft documentation isn't that great. So I'm going to type it out, and then I'm going to go through and try and explain it, what it's actually doing. It's not really that complicated, but it's a little bit convoluted, and it's not really that intuitive, to be honest with you. Anyway, let's get going. So we're going to return, and we're going to use something called created at route. And so what this effectively does, it returns us HTTP 201 with a route as part of that return. So the first parameter that we're going to pass in is actually the name of basically the route where we can get to our resource. So name of, open brackets, and where is this resource residing? How do we get to that resource? Well, that is why up here we gave this action a name, because this basically is the resource URI. Whenever we create this resource, you can actually then get to it using this action result. So we're going to supply this name, okay, to this here. So this is basically, this first bit is saying this is the route where you can actually then get this created resource, okay? And then we're going to actually basically return back the resource itself. And this is, again, this is something to get rid of this Control B to get rid of that and give us a bit more room. Again, this is a little bit kind of not that nice really, but let me just type it out anyway. So new curly brackets ID equals platform read DTO ID. So this is getting our ID, and then we're actually returning back the platform read DTO as well. And I think I've spelled that wrong. There we go. All right. So basically, we're going to return a 201. We're going to give the route, which is basically this thing here, and then we're effectively generating a new ID, which is basically the resource ID, and then we're passing back the body payload in the response as well. All right, so let's save that off. I think that's all looking okay. Let's do a control backtick. Let's do a .NET run to run that up. And let's wait, that looks okay. And let's come back over to Insomnia, and I'm going to create another request, new request, and this time it's a post request. And we're going to be expecting some JSON as the body. We're going to pass in a create DTO JSON payload, and we'll call that create platform. Fantastic. Now the URI is actually going to be exactly the same as this. Different verb, but same URI, so let's just put that in here. But we are going to supply a JSON body. Now what I'm going to do is I'm going to come over to, let's pick this one here. No, let's pick this one here because I want to get an example payload, and I'm just going to copy one object, okay, just so we have you know, you don't have to bother typing it out and we have the correct format. So I'm copying one object, curly braces to curly braces, and I'm going to paste that in here. Now, let's come back, before I do anything with that, let's come back and do a Control B. Can I do a Control B if we've got the thing running? We can. And we come back to our DTOs. And let's just take a quick look at our platform, create DTO. So what we're expecting to get passed in here is a name, a publisher, and a cost. Okay, no ID. So come back over here and back into Insomnia. We'll take this out. Okay, we don't need that as part of our create payload. There's no ID in here, obviously, because we don't have one yet, but we do need these three attributes here. So let's create a new platform. Let's create Docker, because we're going to be moving on to that next. Who publishes Docker? I'm just going to put Docker. I think that's probably right, might not be that, and the cost is free. So let's send that over. And there we go. We get a 201 created, and we get our resource passed back, and you can see we've got a new ID of 4. If you look over our headers, most importantly, you can see we have a location, and actually it is the URI that we can use to retrieve that resource. And again, that's a really important part of the REST specification, and that was achieved by using, let me come back over to our controller, using this created at route methodology here. Okay, that's what that really gives you. Although it's a bit of a not particularly nice construct, that's what that is basically doing. So that is all looking pretty good. The last thing I'm going to do is actually copy this URI just to check it, and I'm going to paste it into here, into our individual platform. Just check that it works. There we go, 200 okay, and it's returned the right thing. And finally, if we just retrieve all our platforms now, you'll see that we have Docker in there now. Fantastic. So that's basically just a fairly standard, straightforward .NET Core web. I have to stop saying core .NET Web API now, but it's going to form the basis of our platform service going forward, and we're going to add a lot more interesting stuff into it. Cool, so we'll park that there for now, and the next thing we're going to move on to is a bit of a review of Docker. We're going to Dockerize this, run it in a container, before then moving on to possibly the main event, which is getting all this into Kubernetes. All right, so time for a quick review of Docker. Now, we cover everything that you need to know about Docker in this video, but if you want a bit more detail, maybe check out one of my other videos. But let's take a look and do a quick review. So what is Docker? Well, as it says on screen, Docker is a containerization platform, meaning that it enables you to package your applications, in our case, our platform service, into something called an image, and then run those images as containers on any platform that can run Docker. So what does that mean? Well, basically what Docker allows you to do many things, but one of the problems it helps you solve is this idea that you might be running something you develop on your machine and it works brilliant, but then when you come to deploy it onto some other environment, it doesn't work and there's missing dependencies and all that kind of stuff. So what Docker does is it kind of removes that problem by allowing you to package something using Docker into an image. And once you have that image, you can be fairly sure that you can take that image and place it onto anything else that's running Docker and run that image up as a container, and you can be fairly sure it's going to work okay. So it allows for this kind of transferability and this easy deployability of applications, okay? And it's really referred to, or really could be thought of, as application virtualization, which is a nice segue onto the next slide. So what I want to do here is just call out the differences between running a plain old server or PC, running an operating system and running applications, versus virtual machines versus containers. All right, so in the first instance, you've got a PC or a server, it's running an operating system, it's a physical machine, and you just run your applications on that operating system. Fairly straightforward. We then have a virtual machine setup, which is basically operating system virtualization. And in this case, you'll have your host operating system. You'll then have some kind of hypervisor, which will then allow you to run entire virtual machines on that hypervisor, which then have an entire operating system all of their own. So in days gone by, I've run things like VMware or VirtualBox to run a Linux virtual machine on top of my Windows host system. Okay, now that's a perfectly acceptable use case, and virtual machines are still very much used today. Where Docker comes into play And again, this is a very simplified diagram. There's actually more going on here, and there are actually virtual machines involved, but I've taken that away because it was going to complicate the point I'm trying to make. With Docker, or with any containerization platform for that matter, you have your host operating system, you have, in this case, Docker, and then you have your containers running on top of Docker as applications. There's no full operating system involved. Each of these containers has their own view of the host operating system. They don't run on an entire dedicated OS of their own, so they're much more lightweight and much more efficient. But you still get a lot of the benefits with virtual machines in that one of your containers can crash and die or do something terrible. Your other containers are unaffected, okay? So quite a very nice concept and platform, and very much one that lends itself very well to microservices. So I'm sure you're probably starting to think about, okay, you're running up lots of services. It's probably analogous in some way to a running container. And then you can do all sorts of things like scale out your containers horizontally, so you can have multiple instances of the same application running as multiple containers to allow you to deal with extra demand and all that kind of stuff. And we'll do this a bit later. But for now, we're just focusing on plain old Docker. So that's all great and everything, but how do we get our platform service running as Docker? Well, let me take you through that. So the first thing, and the next thing we're actually going to do, is write a Docker file. And that's really just a set of instructions that tells Docker how to take our application, in this case our platform service, and turn it into an image. And again, remember, an image is one of those things that you can distribute somewhere into anything that's running Docker and allow you to run it as a container. So we get a Docker file, along with our application, we run it through the Docker engine, and we end up with an image. Okay, so we're going to do that next. We're going to write a Docker file, we're going to build and create an image, and then going to run up our image as a container, and then finally we're going to push our image up to Docker Hub, because we're going to be making use of Docker Hub a bit later on, but we're going to do all that next. All right, so let's get going and start with our Docker file. So just come over back into our project. Now, if you have anything running in your terminal, just make sure you shut it down before we get going. So in the root of our project, just right click, new file, and we'll call it Docker file. No need for an extension, and you can see by the wee blue whale that VS Code recognizes what it is. So I'm just going to get going and start building up a file. It's actually quite simple, and if you come over to Google and you just type in something like .NET Docker, this first article here, I'm basically just following this, Dockerizing the ASP.NET Core application in Docker, and there's a Docker file down here, which by and large, we're really just going to be following that, to be honest with you. Making some slight changes, but basically that's it. So the first thing we're going to specify is the image that we want to pull down from Docker Hub that we'll use to start our build. So the image is mcr.microsoft.com/.net/SDK. So we want the SDK image, which is a kind of larger image than just the runtime image, which we'll also be making use of. And I'll just sort of specify the build environment name as build environment. And I'm just going to copy this, and I'm just going to push it into Google, and you can see where on Docker Hub that is hosted. So we just go to Google and paste in the image name. I think that should be sufficient. You'll see on Docker Hub that we have the .NET 5 SDK image, and with over 1 billion downloads, so it's been used by quite a few people. Now, if I just come back over to the main landing page for Docker Hub for my area on Docker Hub, you'll see I've got a few images myself that I've pushed up and hosted on Docker Hub. Now, we're going to be pushing up our platform service here, we're going to be pushing up our commands service here as well. It's part of the whole workflow that we're going to be following. So if you haven't done so already, please sign up for a Docker Hub account. I won't tell you how to do that, it's fairly straightforward, but you will definitely need to do that if you want to continue to follow along. But for now, let's get back to our Docker file. And I'm just going to set my working directory. So workdir/app. And then what we're going to do is we're going to copy over the csproj file so that we know what dependencies we actually need to work with in order to build our image. So copy everything from csproj and copy it to our kind of working directory. Okay. And then we want to copy everything else and build it. We copy from source, copy it to our destination, and then we just want to run .NET, publish, C, release. Got that wrong. There we go. Out. And then we want to build our runtime image. So what we're doing here is we are pulling down the .NET SDK image, which we're using to build the main part of our application, but then we want to actually make the image a bit smaller. And this is what I'm talking about when I've said multi-part build. We're now going to pull down the runtime image and finalize our build and just use that to package up our application. We don't need all the SDK stuff as part of our image. So very similar kind of syntax from mcr.microsoft.com against .NET. And this time the image is ASP.NET :5.0. Specify the working directory app. And then we want to copy the output from our build environment from equals build env to app out. And don't forget the trailing period. Get rid of that. Get rid of that. And then we set the entry point. Now this is when our image is run. What actually kicks off, or what do we want to run basically. And so this is where we specify that. So entry point, say .NET, which is what we want to run, and then we actually specify the name of the DLL that we want. In this case, it's platform service.dll. And that should be it. Let me just double check this over. I think that all looks right. So again, just to reiterate, this is the first image we're pulling down, the SDK image. We're creating a working directory. We're copying over the CS proj file. Oh, I've forgotten a line in here. We want to run .NET restore to basically pull down the packages contained in here that we need to build our image. So this is really important. So yes, copy those over, run .NET restore. I don't know why I missed that. We then copy those files over, we then run .NET publish. We then want to build our runtime, our full runtime version without all the SDK gubbins. So we pull down the runtime image, create a working directory, and then we copy the contents of what we built over to that. And then we set the entry point for our image. So when we run our image, that's what gets kicked off. So if you actually come over to the bin directory, you'll see that we have a platform service DLL in there. It's just this thing here, okay, that gets run. All right, so that should be it for our Docker file. Again, if you want more information on this, I've kind of skipped through it quite quickly. Watch one of my other videos. We don't really need to revisit this now, that's it. And we're going to be doing a very similar one for the platform service, but it's literally going to look identical aside from the name of the DLL that we're going to run. So I'll probably just copy and paste it when we come to that point. But that's all we're really going to do with our Docker file. So next we're going to build our image, and you'll see how that works. We're going to run our image. We're then going to stop the running container, and we're going to push something up to Docker Hub. So we'll do all that in the next sections that follow. All right, so we're going to build our image. Now, before we build our image, it's very important that you actually have Docker running. So what I might do is just bring up a command line. Come over here, clear the screen, clear the screen. And if you just type not .NET, I'm going to do that quite frequently, docker -- version, you should see that you have some version of Docker running. Now, I'm running Docker Desktop, so the app is over here. So if you just bring this over onto the screen, let me just make that a bit more manageable so you can see it. Oh my goodness. There we go, that's a bit better. So you can see down here, this is Docker Desktop on Windows. You can see Docker is running down in the bottom left-hand corner. Docker's running, and also Kubernetes is running. So if you go into settings, the cog up here, you'll see a number of options, one for Docker Engine, all that kind of stuff. But Kubernetes, make sure you have that ticked. And that will actually make sure that Kubernetes is running. By default, from memory, it's a long time since I've done it, since I've downloaded Docker Desktop, Kubernetes is not enabled by default. So make sure you enable that and that you see the little whale and the little ship's steering wheel for Kubernetes. So yeah, that's all running. All right, fantastic. So make sure you get that same response whenever you type in Docker at a command line. And yeah, we'll cover Kubernetes a little bit later, but we're just focusing on Docker for now. So what we want to do now is build our platform image. And as I said at the start of the video, I do have a cheat sheet that accompanies this video. You can go to my blog and register there to get a copy of the cheat sheet. So all these commands are in that cheat sheet. So building an image. So making sure that Docker is running, it is. So building an image, it's Docker build. And then we want to tag the build, tag the image with a name basically. And the name that you give it is the name, your username, your Docker Hub username. So mine is binary thistle, and then the name of your service. And I'm going to call it platform service. And from memory, if you put capitalization in here, it won't like it. So make sure everything is lowercase, so platform service. And then the most important thing, now you can specify a version if you want. We're not going to do that. We're just going to not specify a version. And if you don't, then it just tags it as latest, okay? Which is what we want. Most important thing that you'll probably always forget is make sure you put the build context, which is just the dot at the end of that command, okay? You'll probably always forget to do that. I do many, many times. So again, Docker build, and we're going to tag the image with a name, and in this case we want to give it the name platform service, but the syntax you use is the Docker Hub username. And the reason for that is when we push it up to Docker Hub needs to know which account it pushes that image into. So your name here is not going to be binary thistle, that's my name. You're going to have to put your name in, all right? So that all looks good. We just hit run. You'll see what happens. Basically, Docker just runs through the Docker file and it starts executing all the steps, as you can kind of see here. Now, I think I probably have those images locally on my machine, the Microsoft SDK images on my machine. If I didn't, then it would actually go to Docker Hub and pull down a copy of that. So it might take a bit longer. In your case, if you've not done this before, it might take a bit longer to run. It's probably going to be relatively quick for me because I have those images. Now, one thing it will check to see that it's got the latest version of those images. So even in my case, it might download a new copy of the SDK image if the one I have is out of date. But that all looked pretty good. It looked like it built that all right. Now, one thing I will draw your attention to that I use all the time is this Docker plugin for VS Code. So you can go to your extensions and just type in Docker, and it's probably going to be the first one that comes up. I think it's this one here. Yeah, I've got it installed. You can see, you know, it's pretty well used, get high ratings. I really recommend it. So if you're using VS Code, strongly recommend you install that because you can kind of look at your images and stuff like that. So if we come over here and look at our images, and I'll just maybe refresh those, you can see here, there we go. I have this platform service image, binary thistle platform service image with the version latest. Okay, so that's all looking good. So that's building an image, pretty straightforward. So what we're going to do next is run this image up and see what we get. All right, so we've built an image. We have that available, as you can see here again, and we want to run our image as a container. All right, so let me just clear down our Docker file, and I'll come in here and just clear the screen as well. All right, so to run up our image as a container, the command you're after is docker run, and then you don't need to supply this next bit, but I'm going to supply it because if you don't supply this next bit, there's no way of us accessing the server running inside the container. If you run up a container without this, what's called a port mapping, you can't get into it. So what we're doing now is specifying an external port, a port that we're going to use in our Insomnia session to get into our container. It can be anything, as long as it's not running on your machine, and then the internal port that we're going into. Now, there's an awful lot of this port mapping type stuff that we're going to do, not just in Docker, but more especially in Kubernetes. So there's quite a lot of sort of networking-y stuff in here, which might surprise you, but probably shouldn't when you think about the nature of a distributed application. Anyway, digress for the moment. So we're running up our image as a container. So docker run -p for the port mapping, 8080, I'm using that in my case, to 80, which you will need to use. And then we're going to run it in what's called a detached mode. Now, if you don't have to specify this D flag. If you don't, then basically the container output will be displayed in this command line and in this terminal, and you won't be able to use this terminal to type at. I want to retrieve it back and run a few more commands, but it's quite useful sometimes not to run it with the detached flag, and you can actually see some messaging flying through, such as errors or what startup stuff you're getting. But we're going to run it as detached. And then simply, it's just the name of your image. And this can be any valid image name. Obviously, in our case, it's platform service. And in your case, yes, it won't be binary thistle, it'll be whatever your Docker ID is. And in my case, it's obviously binary thistle platform service. And that's it. So again, if you are maybe wanting to pull down a SQL Server image, you could specify the SQL Server image here and run it up and do all sorts of stuff. You'd probably need a slightly different port mapping, but nonetheless, it's the same idea. Docker just goes to Docker Hub and pulls down that image. As we have this locally, Docker Hub in this case will not do that. Hit enter. And what you can see up here straight away, if you're using this plugin, you can see that we now have a container that is running as denoted by this little green play sign, and we get a kind of ID of the container. So a couple other useful commands for you. Docker PS will show you the running containers, and basically we already have one running here, but if you're not using this, you can use the Docker PS command to see what running containers you have. And you'll have this container ID, which is this thing here, which we can reference, copy that, and issue a Docker stop. Give it the container name, container ID, and you'll see that up here, yes, it's been stopped. And if we do a Docker PS again, we have no running containers. Okay, so that's stopping and starting a container. Now, if we do Docker run one more time, what do you think is going to happen? Do you think this is going to run up? Well, let's give it a go. No, that doesn't happen. What happens basically is you're telling Docker to run this image. So it's going to this image again, and it's running up another container. It's not restarting the same container that you had last time. So just be aware of that. Every time you run Docker run, it's basically running up a container. Okay, and again, Docker PS, to get our running containers, it's got a different ID this time. Let's copy that, and let's do a Docker stop. Paste that in, and you'll see that too has stopped. So what if we just want to restart the same container? Well, that is then Docker start. Okay, and then we actually give it the name of the container or the ID of the container that we want to restart. So if we do that, you'll see that the same container restarted. We didn't get another one. Okay, so Docker run to go to an image, run it up. If you keep running that command, it will run up new containers every time. Docker stop to stop it. Docker PS to get a list of running containers, and then Docker start with the container ID to restart an existing container. And that's, other than one other command, which we'll cover in a bit, that is the only, they are the only commands that you really need to work with. Or you can just use this interface here. So you can right click here, for example, and stop it if you want to do that. Okay, so I did mention there is one other command, and it's one command that we're going to be using an awful lot. More than Docker run and Docker stop, we're going to be using this command, Docker push, along with Docker build a heck of a lot throughout the rest of this course. So let's go and do a Docker push, and then we're just about ready to move on to Kubernetes. All right, Docker push. Now, to be honest with you, the command is incredibly simple. There's not really much to it, but what I'm going to do is I'm just going to bring over my Docker Hub page again. Let's come over here. So this is logged into Docker Hub as binary thistle, and you can see I have a few images up here already for other projects, but there is nothing in here that says platform service. That does not exist here at the moment. Okay, so we'll pull that back over, and back over in our command line. And let me actually just clear the screen, and we're going to Docker. Any guesses what the command's going to be? That's right, Docker push, and then it's just the name of our image, binary thistle, and again in your case it's going to be your Docker ID, platform service. Cool. And you can see one of the things it's saying, it's using the default tag latest, which is exactly what we want, and then it's just going to start pushing this container up to Docker Hub. So it depends how fast your upload speeds are on your internet connection. Mine used to be really, really fast, but for some reason it's got really kind of quite bad now, so it takes quite a while. So I'll probably cut the video because I'm sure you don't want to watch me uploading an image, but that's it. It just uploads the image. Now, Docker's quite clever in that images are built up in what are called layers, okay? And so this is going to take a while because we've not uploaded it before, but if I upload it again and I've only made some minor changes, you'll usually see that the upload will be a lot quicker because it's not going to upload everything again. It's only going to upload what's called the affected layer. So it's a lot more efficient. But as this is the first time we're doing it, it's going to take quite a while. So what I might do is I might chop the video here and I'll come back. Won't touch anything else. I'll come back once it's uploaded. But basically, that's pretty much it. But we'll wait for it to be uploaded. We'll check Docker Hub and then we'll move on to Kubernetes. Fantastic, so that looks like that's pushed up now. If we come back over to Docker Hub and if I refresh the page, we should see Binary Thistle Platform Service up there, and we just click on it. Yeah, you can see that we have the latest build up there. We've not really versioned it. Cool, so that's push complete. We're going to be using that an awful lot as we move throughout the rest of the video. But next, there was one thing I actually forgot to do, which was actually when we ran our container, take a look at the container running to make sure that we can get to it using that port mapping. So we'll do that next, just before we move on to Kubernetes, just to show you that that's all working. So we'll do that, yeah, do that now. All right, so back over here, let's just run up let's start one of our containers that we already had. Fantastic, and if you do a Docker PS, see you're running, not PSA, PS. Yeah, you can see it's running and you can see we have this port mapping. So let's come over to Insomnia again. And we've got that here. So we can see we've got our local development environment, the platform service. I am going to create another folder, top level folder. I'm going to call it, although it's technically our local environment, I'm going to call it our Docker environment. And I'm going to create another folder in here. We're probably not going to make too much use of this, but we'll keep it segregated because we might flip back and forward between them, platform service. And then I'm going to create a new request. I'm just going to call it get all platforms. Just a get request, create that. Now what I might do is come over here. I'm just going to duplicate that. Yep, and I'm just going to, no, actually, so we can delete that then. Delete. Yep, click to confirm and just move that into here. Now obviously, we click on this, it's using localhost 5000. We don't want that, we want to use 8080. All right, and let's see what we get. There we go. So that's how we are getting to our Dockerized image rather than directly on, directly when we were running it as .NET Run. Okay, so these are the two differences between the two. And actually, as we move through the video, we're going to have other ways of, because eventually this container is going to be running in Kubernetes, so we're not going to access it in this way either. We're going to access it in two different ways, actually. So it all gets, not complex, but yes, it's quite complex. It can get quite confusing. So that's why I'm being really careful to segregate which environments I'm running where, because it can get a little bit convoluted, let's say that. But yeah, anyway, that's it. The container's running. We can get to it in that way. Now, just before we move on then, what I will do is I'll just stop this container with a Docker stop. I think that's the same one, isn't it? There we go. Stop. All right, great. So that's a bit of a review of Docker, a bit of a crash course on Docker. I think that's enough to get us going. Docker file and some core commands. We're good to go. We'll be using Docker build a lot, and we'll be using Docker push a lot. But now it's time to move on and take a look at what Kubernetes is. All right, so let's move on to talking about Kubernetes. Now, the reason I've got an onion on screen there is not because Kubernetes makes you cry, although it can get quite frustrating from time to time. It's because, well, the way I think about it is very much like the layers of an onion. There's lots of layers involved in Kubernetes. And when I was first learning it, that's kind of how I envisaged it. So, massive subject area, but what is it in a nutshell? Basically, as you saw in the last section, we were running up multiple containers using Docker Desktop to do that. That's obviously fine for development purposes, but when you're moving into a microservices architecture and you're wanting to kind of make sure your containers continue to run, and if they crash that they get restarted, or that you want to scale them out, clearly you're not going to be running around at a command line doing that. So that's where something like Kubernetes comes in. Kubernetes is a container orchestrator. And you know, it's a good name, and the analogy I think fits really well. The Kubernetes is like the conductor of an orchestra that makes sure everything is running as it should, running to time, if you want to put it like that. And again, yes, responsible for making sure things run in the right way, scale out in the right way, all that kind of stuff. And we're going to be working a lot with Kubernetes in this section and the sections going forward, and we're going to tell it how we want it to run things, I guess. So we're going to give it like an end state, an end state that we want it to get to, and Kubernetes will figure out a way of doing that for us. It's pretty cool, actually. Huge subject area. And actually, one of the things I was thinking about when I was making this video was, do we use Kubernetes? Because it can be quite tough, it can be quite a difficult subject area, and I did think about using something like Docker Compose. Docker Compose is, I kind of like to think of it as a kind of a middle ground between Docker and Kubernetes. Docker Compose kind of almost sits in the middle. It allows you to run up multiple containers and network them together. And it's actually a very nice option in development type environments, but production-wise, Kubernetes is really the option that you would be going for. If you're interested in if you're interested in Docker Compose, I've done a couple of videos on Docker Compose to see how that all works. But Kubernetes, it's the main event, and that's what we're going to be using in today's video. So just a little bit more about Kubernetes. I think really the best way of understanding it is to actually start working with it, but I'll give you a bit of background and then we'll go through the architecture of the application we're going to build in Kubernetes next, and that will introduce you to some of the terms and concepts. But again, actually working with this stuff is definitely the best way to learn about it. So it was built originally by Google. It's now in the public domain, or it's now open source, and it's maintained by the Cloud Native Foundation. Often referred to as K8s, simply because there's 8 letters in between the leading K and the trailing S. And I may write Kubernetes as K8s. I'll probably still say Kubernetes though. It's a container orchestrator, huge subject area. So again, in this video, we're going to learn enough to be dangerous. We're going to learn enough as developers to get started and run stuff in Kubernetes, and it will be a fully fledged microservices type deployment. But it is a massive area and we're really only scratching the surface of it. I like to think that there's 2 broad user profiles. Some people may disagree with this assessment, but I think of developers using Kubernetes. So for the most part, that's the audience I'm focused on in this video. As developers, we want to run stuff on Kubernetes, okay? And what sits beneath it and how it's set up, personally, I don't really care too much about that. That's for really, I think, the second kind of category of user, and that's like the DevOps engineer or the administrator or whatever you want to call them, because there is a lot of setup required, and it's people's entire roles just to run Kubernetes and keep it running, okay? I'm not too focused on that, and I'm certainly not going to go into that in today's video, because number 1, I'm not really that interested. Number 2, I don't know that much about it, to be honest with you. I just use Kubernetes as a platform, and that's what I'm focused on today. All right, so let's go through the architecture a bit. Now, when I'm talking about Kubernetes architecture, I'm not talking about the internal architecture of how the Kubernetes system is composed. Again, don't really care, to be honest with you. We'll cover bits of it as we move, maybe little bits of it as we move through the video, but I really don't care how it runs underneath. It's not that interesting to me. I'm talking about how things run on top of it. That's really what I'm referring to as the architecture that we are going to build out throughout the rest of this video. That being said though, I have provided a very, very simplified view of how it kind of runs on top of my local machine in this instance, and how it would run theoretically on something more complex like a cloud environment, something like that, just to give you that context. All right, so let's get started there. So in our case, and I'm sure in your case as well, you're running this on a PC or a laptop or something like that. So I have my bare metal PC on that. I'm running Windows 10 Pro. And just out of interest, I'm also running the Windows subsystem for Linux, which is basically like Linux running on a Windows machine. And the reason I'm running that, a couple of reasons, but the main reason is actually when I run Docker, Docker actually uses the Windows subsystem for Linux to run containers effectively. It uses that part of the system to do that. It doesn't have to. If you're running Windows 10 Pro, you can use the Windows Containerization platform. Can't remember what it's called, but you can use that. That's not available in Windows 10 Home. You have to go down the WSL2 route, but I've gone down that anyway because I think it's actually a nicer option, to be honest with you. So again, got your hardware, in our case it's just a PC, you got your operating system, in my case Windows 10, and then you've got your container runtime, in our case Docker. And then, not strictly correct, but I'm just saying Kubernetes then runs on top of that. So Kubernetes is this platform on which we can build stuff. And again, I'm not going to delve into how Kubernetes is architected internally, not too bothered about that. We'll touch on some concepts, as I said. Now this is really where we come on to talking about the architecture of the application that we are going to build. Now, one point I'll make here is there's a lot of information on this screen, and I do not expect any of you, if this is the first time you've used Kubernetes, to memorize this now and need to, memorize it going into the next section. That's not the reason I'm giving you this information now. The reason I'm giving it to you now is, number one, to start to familiarize you with some of the concepts, not asking you to memorize it. Number two, to give you an end state, because one of the things I found quite overwhelming when I was learning Kubernetes for the first time was all these concepts just kept getting thrown at me. And just when I thought I'd got a handle on it, more stuff kept getting thrown at me. And I was like, oh my God, there's never an end to this. And so the reason I'm giving you the end state architecture is so that you have that end view, that you know that we're working towards an end goal and we can kind of tick off our progress as we move throughout the video. And so we will keep referring to this architecture as we build it up throughout the video so we can see what progress we're making. And in that way, I think you'll kind of understand, number one, the concepts, and number two, that you are making progress and that there is an end in sight. So the first kind of high level object, let's call it that, is this term cluster. So this is a Kubernetes terminology now, and this is kind of what we're going to start focusing on. Docker Desktop is a single cluster system, okay? And multi-cluster systems obviously do exist, but they are kind of quite heavy going. They are like full-on enterprise type setups. We're definitely not going to touch that. I'm definitely not going to touch that. But from our purposes, we're running on a single cluster, and that is Docker Desktop. A little bit more digestible then is this term a node. And again, Docker Desktop, single cluster, single node. And those two terms, I might even do it myself, they kind of almost get used synonymously, not technically correct. Cluster, node. And so within one cluster, you can have multiple nodes running. And for example, if you, I did think about developing this video on something like Google Cloud or Azure, you're probably going to be running on a single cluster, but certainly in the case of Google Cloud, you would be running in a kind of multi-node environment. But again, not really that relevant to the video today. So Docker Desktop, single cluster, single node, okay? But you can have multi-nodes, obviously. Now we're going to start to delve into really what we are building out. We don't have to set up a node, we don't have to set up a cluster, it's just there, okay? That is already there. The fact that we have Kubernetes running, we have a cluster, we have a node. We don't have to do anything with these. And so, to be honest with you, going forward, not really going to refer to them too much after this, so you can kind of almost, not ignore it, but just kind of put it to the back for the moment, okay? But with inside our node, this is really what we are going to be standing up and running. So the first concept really that you're going to have to get your head around, and it's not that complex to be honest with you, is this idea of a pod. Now what is a pod? A pod runs containers. So as in the last section when we're running up containers at the command line, a pod is used to host and run containers. Now a pod, a single pod, can run multiple containers. In this video, we're not doing that. It's one pod, one container, okay? Now a container and a pod are different things, but for the purposes of this video, you could almost use those terms interchangeably. Not technically correct, but I'll forgive you if you do that, and I might do it myself. So pod, container, one-to-one mapping in this case. However, in the real world, you can have multiple containers running in a pod, but we're not doing that today. All right, so the first thing we're going to do is actually take our platform service image and run it in Kubernetes in a pod. First thing we're going to do, and we're going to do that using something called a deployment, but that's for later, okay? So pod is the first level object that we are going to start working with. Now, in the same way as with Docker, we can't actually access that running container now. It's not accessible from within Kubernetes. So what we're going to do next is set up something called a node port. And a node port is what's termed a Kubernetes service. And there's a number of services we're going to work with throughout the rest of the video. Node port is the first one. Node ports are really used only for development purposes. You wouldn't use a node port in a production type environment. So it's really just to allow us to test and get access to our pods, okay, and our containers as well. So it will give us Kubernetes will give us an external port that we will use. It will more than likely begin with it. In fact, it will begin with a 3, and it's usually a 5-digit port number, semi-randomly assigned. Think of it almost like the port 8080 that we used in the Docker example. We'll also have the port mapping, the internal port mapping, in this case, port 80. So external traffic will come in, and it will hit directly our port 80 of our running container in our pod. And it means we can test to make sure that it's all up and running. It's running okay in Kubernetes, and we can access it. So that's the first thing we're going to do. Next thing we're going to do is set up another pod with our command service running in it. Now, obviously, we're going to have to write our command service. That doesn't exist yet, but we're going to write that, build it as an image, push up to Docker Hub, and put it into a pod running in Kubernetes. In order for these two pods to talk to each other, they need to get what's called a cluster IP service. And you can see on here, you have your pod, and then you'll have a cluster IP service for each of the pods that need to communicate to each other. And again, there's this kind of concept of a port mapping, and that will allow our platform service to talk to our command service and vice versa. Next thing we're going to do, the node port, as I said, is really only used in a development context. In production, you would not use a node port. So what we're going to do next is set up yet another pod with something called an Ingress Nginx controller. As it says, an Ingress Nginx container, but it's really an Ingress Nginx controller running as a container. And what that basically is, it's almost like an API type gateway. So I have done a video previously on Envoy as an API gateway. Nginx is on a competing kind of platform that does a similar thing, and we're going to use that in this case to basically act as a gateway for our two services. It's going to run in its own pod. It's going to work in conjunction with something called an Ingress Nginx load balancer, okay, and that's another service. And so external traffic will come in via the load balancer. It will talk to our Ingress Nginx controller, and the Ingress Nginx controller will route directly to our two services. Okay, it won't actually make use of the cluster IP services. They are really just used generally for container to container communication. The Ingress Nginx controller in this case is going to reach out directly to our services. Next thing we're going to do is set up a database, a SQL Server database, because at the moment we're running internal in-memory databases for both our services. So we're going to stand up a separate SQL Server just for use by our platform service. And it's going to have a cluster IP as well, so it can talk to the other services. The other thing it's going to have is access to persistent storage space, because our platform and command services, they can reboot, they don't need to store data, they're stateless. That's fine. SQL Server, it's a database, obviously it can't be stateless, it needs to store data somewhere. So we're going to use something called persistent volume claim to claim some storage on our physical disk. Now that area is starting to go into the domain of the DevOps type guys, the administrator type guys. It's not strictly developer area. Persistent volume claims, that's fine, that's a developer realm, but when you start going further down the food chain and you start talking about persistent volumes and storage classes and then setting up storage, that's starting to go into the realms of the DevOps type guys. Fortunately for us, we can just set up a persistent volume claim and that will do what we need it to do. And it kind of reaches down onto a physical disk. The final pod we're going to set up is our RabbitMQ message bus. And again, cluster IP, and it will allow us to talk to all the pods to talk together within our node. Now, one thing you'll notice here, you'll probably go, where is the SQL Server for our command service? In this video, just for the purposes of saving some time, the command service is going to have its own database, but we're just going to keep it as the in-memory database. Still has its own database, can't stress that enough. It's not using the same database as the platform service, using its own database. We're just going to keep it in memory. And maybe as a bit of homework, once you start to get familiar, you can spin up a second SQL Server just for it. But again, main takeaway, it's not got a SQL Server, but it still has its own data store. Very, very important. And then these cluster IPs, maybe not the best diagram. Basically, it's not saying that the platform SQL Server just talks to the RabbitMQ database, blah, blah, blah. It basically means all these four things can talk together. Okay, they're all chained together, they all talk together. Maybe not the best diagram. But yes, this is our end state, this is what we're going to set up, this is what we're going to build, and as we move through the rest of the video, we're going to refer back to this time and time again to make sure that we are making progress. So with that, I think enough theory. We're now going to move on to creating our first pod in the next section. All right, so back over on our application, just make sure you don't have anything running. And what we're actually going to do is we're going to move out of just working within the platform service project, and we're going to basically work within a kind of more, I suppose you'd call it a solution type context rather than just a project context. So in your command line, if you just come out of the platform service, and so we'll do a directory listing and you'll see that we have the platform service there. And I'm just going to come up one more level and do a listing. Now, all my solution is going to be within this E3 folder here. So what I'm going to do is type code R-E3, and that's going to reopen Visual Studio Code. And we've still got a platform service here, you can see everything in here, but we're now going to create another kind of project level folder. I'll just say yes to that. All right, and that's going to contain our Kubernetes assets, mainly our deployment files. So when you're working with Kubernetes, there's a number of ways you can set things up. You can run things at the command line to deploy pods and do all that kind of stuff, or you can write files, deployment files, and that's the approach we're going to take because it's much more reusable than doing stuff at the command line. So in our in our solution context now, we're going to create a new folder, and I'm just going to call it K8s. Now, as I said in the previous section, K8s is really just related to the Kubernetes stuff that we're going to be writing. So it's not a .NET project or anything like that, it's just going to be a bunch of deployment files. So the first thing, as per our diagram, and if we maybe just pay it a little visit again, if we come back over here, I'll just bring it back up on screen. I'll need to get a more static version of this. Yeah, the first thing we're going to do, actually, yeah, that's actually working okay, is deploy a pod with our platform service in it. That's what we're going to do next, and then we'll come on and do the node port. But for now, that's what we're going to do. So within our K8s folder, right click, new file, and we're going to create a deployment file for our platform service. So we're going to call this platforms-depl.yaml. Okay, so it's a YAML file, as the name would suggest, and depl obviously is just short for deployment. All right, so I think probably the best way to approach this is just to start typing it out and trying as best I can to explain it as I go through. It's a bit long-winded, and there seems to be, you'll probably think there's a bit of repetition in this file, but everything is necessary, unfortunately, and YAML files, yes, are white space sensitive, so just be careful as you work through them. But if you follow along, should be okay. And remember, the code is on GitHub, so you can pull down this file if you do run into problems following along yourself. So the first thing we specify is an API version. So colon and it's apps /v1, and that's just specifying, yeah, the API version that this deployment file is going to use. Under the covers, Kubernetes actually works with basically a REST API essentially to create and destroy its own resources. So that's basically what we're specifying there. What kind is it? Well, it's going to be a deployment. So again, we're deploying something into Kubernetes, and as we work through the course, we'll have different kinds of these files. I don't want to populate it with all that stuff. Next thing is metadata, and we give it a name, and this is really just the name of our deployment. Okay, so we're going to call it platforms-depl for our deployment, basically. And then we come on to our specification, and this is really where we specify our pod effectively. So tab in, and the first thing we're going to specify is the number of replicas. Now, as I said when we were talking about Kubernetes, you can horizontally scale out the number of services that run. So we could have 3 instances of our platform service running if we wanted, and that's what's referred to as a replica. Here we're just going to have a single replica. We're just starting with one, at least to begin with. Now these next, there's going to be 2 bits that follow. Let me just type them out first, and then let me describe them, because they're a wee bit confusing, to be honest with you, but yeah, again, they're mandatory. So the first thing is a selector. And we come down and indent once again, and then we type in match labels, and it's actually getting some help with it. And then app, and we're going to call it platform service. And then we're going to back out again. We're going to stay within our spec, but we're going to be directly under our replicas and our selector tag now. And we're going to define a template. We're going to give it some metadata. Don't forget the colons, tab in. And again, you've got to be really careful with this white space here. And we're going to give it a label or labels. And we're just going to give it a label of app, and again, platform service. We'll just select that from there basically. Now these two things, the selector and the template, kind of work in combination with each other. And really what we're doing within this template, it's within here that we're really defining the pod and the container that we're going to use. And then this selector is basically selecting the template that we're creating. Okay, so it's a wee bit kind of convoluted, but this template stuff is where we're defining what we're deploying, and then the selector is basically selecting it for us as part of the deployment. And then under there, we're going to back out to underneath metadata, so we're still within our template section, but directly under metadata now. And this is where we're going to define our spec. And under spec, tab in, and we're going to specify the containers that we want to run. And we're almost at the end, don't worry, we're almost getting there. And anything within YAML that has this kind of minus sign, that's an array. And you can even see by the name containers, it's plural. You could have multiple containers that we wanted to deploy. But in our case, we're just deploying one. We're going to give it a name of platform service. And what I want to do is just select this and make sure that we have these three things are called exactly the same thing. So the match label, the template app label, and the name of our container are all platform service. And then finally under here, just tab in under the name, we want to define the image. And this is just the Docker image for our service. So image : and then we just specify binary thistle / platforms service, and obviously make sure this name is the same name as the service that we have defined or you have defined. And again, remember, this will be your Docker Hub login ID, and we do actually want to specify latest here. Okay. Now this complaining is just complaining about we're not putting a couple of other things to do with resourcing limits. I'm not going to bother doing that, so I'm going to ignore that kind of warning. Now that's it. That's basically a deployment for a container into a pod. Okay. So if you save that off, we'll find out if we have made any mistakes, but it looks okay for the moment. So again, probably for me, the most confusing thing is this selector thing, but really all it's doing is it's selecting this thing here that we've defined as part of our template. That's really all it's doing. Now we're going to come back in here a bit later, and we're going to define our cluster IP service in here as well. If you remember from the previous architecture diagram, we're not going to put it in yet. We're going to do this all step by step, one step at a time. That's cool. So remember to save off, and yeah, now having defined our deployment file, we're going to actually effectively run it and deploy it into our Kubernetes cluster. All right, so back in our application, we are going to bring up a command prompt. Fantastic. Now, before we do anything else regarding our platform's deployment, what I want to do is just make sure that Kubernetes is running appropriately. Now, I believe I did anyway, bring over Docker Desktop, and I said to check that you have Kubernetes enabled and that it's got the little running instance down here. And that's looking all good. But one of the other things that we rely on as part of Kubernetes, and this is sort of starting to go into the architecture of Kubernetes itself, is basically the command line that we are going to use to drive all of this stuff. And the command line is kubectl, okay? And so if you type kubectl version, this is the command line tool we're going to basically use to issue all our commands. You will see, hopefully, if it's running correctly, you'll see a client version and a server version and all that kind of stuff. Doesn't really matter what the versioning is, just as long as you get something back. That means Kubernetes is up and running and the kubectl command line is all good to go. So let's clear the screen. And again, All these commands, or most of these commands, are in the cheat sheet that I talked about at the start of the video. So let's just do a directory listing where we are. We're in the, oh goodness sake, we are in, oh my goodness. We can see that we've got a platform service, and we can see we've got a K8s folder. So we're going to change into our K8s folder and do a directory listing to make sure that you can see this platform's deployment file. And we're now going to apply that file. And so it's kubectl, apply, f, and then the name of the file. So this is platforms-depl.yaml. And if there's any issues with it, you'll get an error at this point in time, but that looks okay. So we've got a command that comes back saying deployment apps platform depl created. Okay, what does that mean? So if we do kubectl get deployments, because basically we've created a deployment. I'm going to spell kubectl wrong. There we go. You can see here that we have something called platforms depl, 0 containers ready or 0 pods ready, and 1 is up to date. So let's keep an eye on it. But the other thing you can do is see your pods running. So kubectl get pods. Now you're probably starting to see a bit of a pattern emerging here. With this command, you can use kubectl get whatever. So you can get deployments, you can get pods, you can get services. You can see here that we got 1 pod within our cluster now, and it's ready and it's running. So that looks good. Let's just get deployments again, and you can see now that 0, from 0 being ready to 1 being ready, it's all up and running. That looks really good. Okay, so I think if we come over to our Docker plugin, you can actually see here that we have a running container running in Docker, but isn't it supposed to be running in Kubernetes? Well, yes, obviously it is. Kubernetes is orchestrating it, but it still has to run in Docker. Now what I'm going to do is I'm actually just going to delete these 2 containers that we had created in the previous section, because it's just going to get way too busy. All right. Now the other thing I want to do then is come over to our Docker desktop. And if you come over here, it's making itself rather big, and we just go into general. Actually, cancel out this. And we come over into the kind of main window. Actually, to be honest with you though, I actually find the Docker desktop interface can be a wee bit confusing sometimes. So if you go into settings, this is where our settings are, and you cancel to come out of that. This is kind of showing you running stuff. Now, the first thing you'll see is, well, wait a minute, there's actually 2 things running here. How is that possible? Well, this is a pattern that you'll see sort of time and time again. This is actually the running container. And this thing here, as you can see from the name, is actually the pod that's kind of running. So you can click on that, the actual container one, and you can look inside and you can see basically output from our service running in Kubernetes. And it looks very familiar. It's seeding data because we've got using an in-memory database. And you can see here it's listening on port 80, which is basically what we saw when we ran it in Docker as well. All right, so that's all looking really good. So give yourself a round of applause. You've created your first deployment and you've deployed a service into Kubernetes, and it's running and waiting for us to start using it. Fantastic. So in the next section, what we're going to do, we're going to do a little bit more work here just to show you some of the things that Kubernetes can do and how it actually orchestrates services. And then we'll eventually come on to working with our node port. All right, so one of the things I want to show you, and it's one of the things that kind of confused me a little bit about the whole Kubernetes setup, was, okay, what happens, and maybe this is my destructive nature, what happens, here's our running container here, what happens if I delete this? Okay, so let's stop it, and let's delete it. Let's remove it. What happens then? Anything. So if we come back to our command line, and let's do up kubectl get pods, you can see that we've got our pod here, and it's saying 0 of 1 is ready. If we do it again, it's now saying 1 of 1 is ready, and you can see now that a container is running again. We come back over to Docker desktop. You can see that we have the container has come back. We've stopped it, we've destroyed it, but it's just bounced back and come back up. How is that? Well, that is one of the whole points around the Kubernetes. It auto recovers your containers for you. So if a container crashes, for example, something bad happens to it, because we've told Kubernetes as part of our deployment, come back to our file over here, and look at our deployment file. Because we've told it we want a deployment, we want one replica, Kubernetes is going to do everything in its power to ensure that there is one replica of our service running. So even though we explicitly destroyed it there, it still came back and runs again. So you can change that behavior if you want, but the whole point of Kubernetes is that you've told it to do something, you've given it the end state, it will make sure at all times that that end state that you've specified is being adhered to. So that's one of the very, very cool things about it. Now, that's not to say that you cannot destroy things, because that's kind of what I thought originally. You can. So again, if we come back to our command line, you can do something like kubectl. Actually, let's get our pods, get our deployments first. So kubectl, get deployments. And we have a list of deployments, and then we can go kubectl delete deployment, and we'll take its name, and we will delete the deployment. Okay, do a upkey, get deployments. There are no resources found. And if we come back over to our Docker desktop Kubernetes instance, you can see basically it has destroyed everything. We've destroyed the deployment, we've told it to delete the deployment, and there you go, it's taken everything down. All right, so just one other thing, just to show you how easy it is to tell Kubernetes to run 3 instances of our service. We can just change the number of replicas to 3, save that off, upkey, and we'll go back to our apply command. So kubectl apply f platforms depl YAML, and we will hit enter. And clear the screen a wee bit here, and if we do kubectl get pods, you'll see that there are 3 pods. They're not started yet, but Kubernetes now is attempting to start 3 containers for us. And if we keep refreshing this, it will eventually, unless there's an error in our image, it will eventually reflect the fact that we have 3 running containers as part of our cluster. Okay, so you saw how easy that was. So again, the idea is if you're seeing high traffic on one particular service, you can quite easily spawn up 2, 3, 4, however many services, and you can deal with that increased demand. Of course, there are design considerations with the way you've built your service. There may be other things you have to consider, but in our case, it would literally be that easy. So you can see here, we've got 2 containers up and running, and this other one is in this container creating state. So it's still spinning up, and I'm sure eventually you will see all 3 will have started. So unfortunately for those 3 containers, there they are, they're all up and running, and we come back over to our Docker desktop view. You can see that we have our 3 services running, and then we have 3 associated pods, 1 for each platform. And that's a pattern that you're going to see time and time again. You're going to see these pods paired with a service. All right, so no sooner had we spun that up, I'm going to delete it because I don't want three services running. So we'll upkey, and we'll delete deployments platforms depl, and then we'll do get deployments, kubectl get deployments. And we have no resources found, which is correct. And we'll just double check. Yes, it's in the process of deleting. That's cool. So I'm going to come back here before we move on, change that back to 1, save it off, and then for not for the last time, but the last time in this section, we're going to reapply our deployment and get our 1 service up and running. So that's all good. We have a service up and running, but we have no way of accessing it yet. So we're now going to create a node port that will actually give us access to see if we can query this service running in Kubernetes. So we'll do that next. All right, so we want to create a node port now, and a node port is one of a few different types of service that we can create. But just before we do that, just run a kubectl get pods, just to make sure that the pod that we kind of recreated, or the deployment that we reran in the last section with our 1 pod is now up and running. So we have 1 pod running, that's cool. So just make sure you do that before you go any further. So yeah, we want to create a node port now. So if we maybe just come back to our diagram, it's probably worth just taking a quick look. So we've done this now, well done. We're now going to create a node port, and that's going to allow us external access into our service. Now, you'll see on here, we are going to create a node port. We're going to specify this port here, which is just referred to as, well, you'll see in a minute in the file, the port, and this one here, this 80 is the target port. We don't specify this 30,000 port. Kubernetes does that for us. So we specify two ports, this one here and this one here. All right. So back over in our K8s folder, if you right click and do new file, I'm going to call this platforms np srv just to keep it kind of short. So .yaml, don't forget the YAML. So platforms node port dash service .yaml. All right, so I might just pull this down a little bit. And over in our folder, in our file, sorry, we're going to specify an API version again. This time it's just v1 as we're dealing with services. The kind this time is going to be a service. Whoop. I don't really want it to auto-complete it for us, so a service. Again, our deployment was a deployment type. This type is a service type. And we're going to specify some metadata. And this is really just the name that this service will be known as when we kind of work with it at the command line. So I'm just going to call it platform np service -srv. Okay, platform np service srv. Yeah, okay. Some of these names can get a bit unwieldy, so you have to be really careful that you type them in correctly. And then we specify a spec section, tab in, and the type, in this case, is node port. And then we're going to work with our selector. I'm going to specify the app. Now this is where we pop back over to our platform's deployment file and we pick this value here, platform service, okay? So it's basically, it's another selector and this is what we are. We're selecting the same thing. Okay, this node port is going to be working with this platform service. It needs to know where to reach out to. And then we come back and then we specify the ports. So we're going to specify a name. From memory, the name thing is not mandatory, but I'm going to put it in anyway. I'm going to give it the same name as this. I think you need it if you're specifying more than one array of port types. And you can see here, this is an array that we're defining, or array element, should I say, that we're defining. So protocol is just TCP. Port is 80, and again, that's the port on the node port. And then target port is the target, it's the port of the service that we want to talk to. And that should be it. And again, yeah, if you were defining another, set of ports, then you actually do need the name in that case. If you're just defining one, I don't think you need the name, but we'll leave it in anyway. It makes for more descriptive reading anyway. Cool, so we'll save that off. Now, in a very similar way that we did with our deployment, all we need to do is do kubectl, apply, f, and then the name of our file. Now, actually, maybe before we do that, we'll just do well, I can see we're in the folder, but just do a directory listing to make sure that you're there. And yeah, let's go for it. kubectl, apply -f, and then it's just the name of the file that you want to apply. Great, and again, we can see we've got a service created. If you don't see this, you will obviously see an error. Again, the errors, I think I've said this before, maybe I've not. If I haven't, the errors are quite good. They're quite descriptive. They usually get you to the root of the problem if you have made a mistake. So, although it said created, how do we know for sure that it's created? Well, you use kubectl again, get services, and you can see that we have two services here. Now, this one here was actually here by default. It's there already, so we can kind of leave that one for the moment. Don't need to worry too much about that. But this is the one that we have just created. So here's the name, as we specified up here in the metadata, and then you can see that it's a node port, and you can see port 80 is the internal port, and this is the port that we need to use to actually access the service externally. So let's move over to Insomnia again, and I'm going to create another top-level folder, this time for our Kubernetes environment. So a new folder, and I'm just going to call it K8s. Okay, So we've got one for local development, one for Docker, and one for K8s now. And then we're going to create another folder here for platforms. Platform. Let's just keep it consistent. Platform service, let's rename that. Rename. Probably being a little bit pedantic, but want to keep it consistent, otherwise it can get a bit confusing. So platform service, and then we're just going to duplicate this one here. Okay, and we'll move it under here. But unlike, we don't want to use 8080, we want to use that other port that Kubernetes has given us or generated for us, so it's here. So if we just copy that, try that again, so it's 30, 40, 70. And we come over here and put that in here. And yeah, it all looks right. We query, there we go. We have access to our service running in Kubernetes, which I think is very, very cool. So give yourself a round of applause for that. We're making very, very good progress. So basically that is, well, that's not it. Obviously we still have a long way to go, but let's refer back to our diagram to kind of check on progress. So we've now done this, that's fantastic. So really the next thing we want to do in the next section, we're going to concentrate, we're going to go back into writing .NET C# code, and we're going to construct up our command service, and then we're going to do a very similar thing and deploy it in here, and then we're going to get them talking to each other, and then it starts to become much more interesting, because then we're really going into microservices concepts. We talk about how these services can talk to each other synchronously or synchronously or both. So yes, next section we're going to move on to is to construct our command service. All right, so now what we're going to come on to do is create our command service in our kind of solution area. So back over in our, it's not really our project anymore, back over in our solution, just make sure you stop any running services. And let's close this stuff down as well. All right, so make sure that you are in the kind of top level of the solution. In fact, we're going to need a command line. So in the command line, just do a directory listing to make sure that you're in the top level solution area. You can see the platform service and K8s folders. And we're going to scaffold up a new service or commands service. So .NET new, so web API, and the name is command service. Hit enter, and that should go away and scaffold up our command service. Fantastic, and it appears here in our directory listing. So next thing we want to do, I'm just going to get rid of this, is bring up your CS proj file so you can see what package dependencies or package references we have in here, and we're going to add some more in a very similar way as we did with our other service or platform service. So .NET add package, and the first one, again, I'm going to just copy the first one. In fact, I'll probably copy most of them over. Save you watching me typing, is AutoMapper. We're of course going to use AutoMapper here as well, so I think I must have done something wrong. Oh yes. So what I haven't done is change in to the project that we want to be working with. So cd into command service. There we go. So what it was complaining about there was I was trying to add a package reference, and it's complaining that there was no project file basically. So there we go, rookie mistake, and there we go. So we've got AutoMapper added into our CS proj file now. Fantastic. So we're going to add a few package references here. I'm not going to add all the packages that we need. I'll add the ones that we're going to need in the kind of near future. The ones that we'll work with a bit later down the line, I'll pull them in a bit later. So the next one is add package Microsoft Entity Framework Core. And just make sure it's added into the CS proj file. I'll do upkey, and then we need exactly the same, but this time design. And again, this is mostly the same. In fact, it's exactly the same as the platform service as well. Now, I did debate whether to just, skip this, not skip the section, but, not go through all the setup again. But I think it's good practice for you to go through the setup again anyway, and it kind of embeds what we need to do. And it is only one other service, so I think it's probably the right approach. And then we're going to add in memory. Now, as I said previously, I'm not going to work with a SQL Server database for this service, simply just to kind of reduce time a little bit. Working with an in-memory database is fine for the video. If you are moving into a more production environment, yes, you would use SQL Server. But for the moment, I'm just going to use in-memory. That's all. And that's it for the moment. We had the swashbuckle package reference in there. Again, that's for Open API. If I remember, we'll take a quick look at that. But that's it for now. So that's our package references done. Our project is scaffolded up. What I'll probably just do is just remove the stuff that we don't want. So the weather forecast service, we don't want that. And into our controller, we'll take out our controller as well. Whoops, we'll take that out as well. And we'll delete that. Now the other thing we'll actually do is over in properties, in launch settings JSON, if we spin this up, and we will actually spin this up locally, it's using the same ports as our command service 5000 and 5001. And so when we're doing some testing, before we deploy to Kubernetes or even package up in Docker, I'm going to run them both up locally and have them running at the same time, just using the .NET command line. And so obviously we'll get an error if they're both trying to launch on the same port. So I'm just going to change the command service ports, local ports, to 6000. All right, and what we might do, just to make sure it's all wired up correctly, is just do a .NET run, because you never know, there might be some little gremlin in the system that we didn't think about. And that all looks fine, and it's running on port 6000, 6001. It's not going to do much at the moment, because we've taken out our controller and we don't have any models or anything. All right, so we'll close that down. Now in the next section, what we're going to do, what I really want to focus in on, is we're going to create a controller first. We're not going to create models or anything like that. I'm just going to create a very simple controller with a very simple post action endpoint in it. And the point of that is I want to just get our two services talking to each other. That's really the next part of the video. We will eventually come back and we'll add models and we'll add all that kind of stuff in here. But for the moment, all I'm really wanting to do is get our two services talking synchronously to each other using HTTP. We'll do that locally and then we'll do it in Kubernetes. Okay, so that's really the path we're taking next. So in the next section, we're going to create a controller with one action in it that's going to receive a post request from somewhere else. And then we're going to get our platform service to talk to it in a synchronous way. All right, so we'll do that next. All right, so we're going to create a controller in our commands service, simply at this point, just to receive a post request from something else. In this case, it'll be our platform service, just sending something over to us, really just to test synchronous HTTP communications between the services locally, and then we'll do it in Kubernetes. All right, so back over here, I'm just going to close this down, close down the command line and close down launch settings JSON. And over in our command service, if you right click the controllers folder and new file, we're going to create a controller. Now this service is going to end up with two controllers. It's going to end up with a commands controller, as you'd probably expect, but it's also going to have a platforms controller. Why? Basically because this service is going to work with two models. It's going to work with commands and it's going to work with platforms. And the way I've architected this service, basically the platform is really the parent resource of the command resource. So if you think about it logically, you're going to have a list of commands like, you know, .NET run, .NET build. There'll be loads of those and they will relate just to one other resource, the platform. Okay, so when we are using REST, as we are here, to create resources such as platforms and commands, what we should really do is split those out into two different controller actions. So we will have a controller to deal with our platform stuff, very similar to our platform service, and we'll have a controller to deal with our command creation stuff. You'll see how that unfolds a bit later, and I've got a whole section on sort of multi-model REST APIs. But for the moment, again, I just want to focus on getting some comms between the two services. So it might be sound a bit counterintuitive, but the first controller we're going to put in our command service is our platforms controller. Okay, so in controllers, create a file, platforms controller .cs. All right, fantastic. Now let's keep going, but I just want to call your attention to the fact that we are running VS Code with these three projects in here now, and that it can sometimes behave a little bit strangely, but let's see how we go. So namespace this time is going to be commands. Yeah, I think it's doing it already. Commands service. Yeah, and so we're not really getting auto completion at the moment. If you sort of see what's happening, usually if I started typing command service, I would get prompted with the full name of the, of the service for our namespace. But let's, it's very evident how reliant I am on it because I'm so used to that pattern. Let's keep going. Command service.controllers. Okay. And we'll just bring that onto the next line. Okay, and it's a public class. So public class platforms controller. And we're going to inherit from controller base. And we don't have that namespace, so control period. Now, this is what I'm talking about here. I'm doing control period to bring in my list of code suggestions, and nothing is happening, okay? And the reason for that, or I believe the reason for that, is because we're running VS Code, and we're now having it hosting multiple projects. So the kind of IntelliSense stuff appears not to really like that. So what we're probably going to have to do is close down our VS Code session running all these projects and reopen it just with command service, and I'm fairly sure then we'll get our code suggestions. So let me just save that off for the moment. Kill this. Actually, I won't kill it. I'll just bring up a command prompt, and then we'll come up a level, do a directory listing so we can see all our projects, and I'm just going to open code recursively, and I'm just going to open command service itself. Let's do that. Okay, fantastic. And if we come back over to our controller, there we go, it should start complaining, and I'm fairly sure if I put my cursor in there and do a control period, I will get my code suggestions again. So it's just something I've found. I'm not sure if there's any other way around it. There probably is, but for the moment, I'm fine with just running an individual project in our VS Code session. All right, so public class, platforms controller, inheriting from controller base. The next thing we want to do is decorate our class with API controller. As before, it gives us some nice default behaviors, and we're going to create a route again. Okay, so from memory from last time, API, and then you can either put in, not curly brackets, square brackets, you can put in controller. Okay, now you might see a problem straight away here, because we're going to have a route to something called API/platforms. We're also going to have that in our other controller as well. They may go, well, that's not a problem because the rest of the URL is going to be completely different. The IP address or the domain name is going to be different. Correct, that's fine. So we could leave this like this for the moment. However, when we come on to using our API gateway, things get a little bit more complex. So I'm just going to call that out now. I'm going to leave it like that at the moment. This will still work at the moment, but going forward, we are going to have to change this slightly to reflect that this is a slightly different platforms controller from the platforms controller in our other service. In fact, I'm going to put it in now, okay? Because if I forget when we run into issues, it might become a bit problematic. So what I'm going to do, and again, when we move through the rest of the video, this is all kind of hidden. Once we hide all this stuff behind an API gateway, this stuff is hidden. So you're not going to have these horrible URLs that you're going to have to deal with. But just for future proofing, I'm going to put this in. So all I'm doing here is the root is API, and then I'm going to specify that this C really is for our commands. This could be anything, by the way. I'm just putting C in. So API/C to denote our command service, and then the name of the controller. It'll become clearer later on when we move on to the gateway stuff. So bear with me on that. So that's our route. Fantastic. I'm going to create a shell constructor just so it's there, but we're not really going to put anything into it yet. Now we will eventually, like we did with the platform service, inject in AutoMapper and a repository, but we're not doing that yet. Again, in this section, all we're interested in doing is getting an action up and running. All right, so leave a constructor like that for the moment, and then we're going to create our first test action. So it's public action result, and I'm just going to call it test inbound connection. Okay, and it's not going to accept anything really. And all we're going to do is just do a console write line, keep it really simple, bring in the namespace for console using system, console write line, and I'm just going to put something like inbound post at the commands service. Okay, so all we're doing, so we hit this action, we're going to get this printed out to the screen. And I just need to make this decorated with HTTP post. And then finally, you do need to return something back as it's an action result, so we'll just return OK. And I'll put something in here, I don't know, inbound test OK from platforms controller. Quite a few spelling mistakes in there. All right, fantastic. So that probably looks a little bit convoluted. I'll put the trailing semicolon in there, and maybe some of the stuff in here are going, don't quite follow that. That's okay, don't worry, it will become a lot clearer later on. So what I want to do now is just test this, okay? I'm going to test it from Insomnia just to make sure everything's wired up correctly and it's working okay. So into the terminal, make sure you're in command service. We'll do a .NET run. I don't think I'm forgetting anything, but we'll find out. And it should be running again on port 6000. Fantastic. So let's bring up Insomnia, and we're going to close all that down, and we're going to come over to our local development environment, because that's what we're running in. We're going to create a folder under here, new folder, and we're going to call it command service. Okay, and we're going to create a new request. It's going to be a post request. We'll select JSON, and we might pass some JSON over eventually, and we're just going to call this test inbound connection. Okay, create. Fantastic. And what I might do is just come in here, and I'm just going to copy this. Make sure I copy it all. And I'm going to paste it in here. Make that a little bit bigger so you can see it. Now, a couple of things here. The port's going to be different, so it's going to be port 6000, and as per our route, it's going to be API/C platforms. Okay, so back over in our controller, you'll remember this is the route to this controller. Okay, so API/C, and it'll be platforms because we're in our platforms controller. All right, so again, screen's running at quite high magnification, so I'm just going to click send. You get 200 OK, and we get the response back, inbound test from our platforms controller, which looks good. And if we come back over to our running service, you can see that we got this message printed on screen. Cool, so very simple, but really just setting this up to establish that we have an endpoint in our command service. What we need to do now is create a method of calling this from our platform service, so we have that degree of, so we can establish some communication service to service. We'll run that both locally, and then we'll deploy it into Kubernetes. So we'll move back over now to our platform service and write up what we're going to call a synchronous client, effectively, synchronous HTTP client. So we'll do that next. All right, now actually, before we move on to doing any coding, I do appreciate I've been talking about synchronous messaging and asynchronous messaging, and you might be going, what's this guy talking about? So yes, I think it's a good time to talk about this now. I was going to leave it till a bit later when we came on to talking about message buses, but I think since we're starting to do some messaging now, I think it's a good place to actually put these slides in. So yeah, let's talk about synchronous and asynchronous messaging. So what is synchronous messaging? In short, it's basically talking about a request response cycle type setup. Okay, so as a client, I'm going to make a request to our HTTP endpoint in this case, and I'm going to sit there, I'm going to wait until it responds back. Okay, so the requester will wait for a response. This is probably going into maybe a bit too much detail at this stage, but generally speaking, and it's probably quite a controversial statement, and I'm probably going to get lots of hate mail for this one, but generally speaking, services such as our command service and our platform services, when they're servicing requests to external clients such as a web application or Insomnia, those type of external facing services are synchronous. Okay, that's a very common pattern. When you're talking about service to service communication, i.e. within our cluster, for example, and it's just services talking to each other, you can use synchronous communication for sure, and we're going to do that. But for the most part, we, in this video anyway, are going to be using asynchronous communication, and I'll come on to what that is in a bit. That might be a bit of a controversial statement, but yes, for the most part, externally facing services are definitely synchronous. They don't tend to be asynchronous. That's less controversial, all right? Synchronous services usually need to know about each other. So as a requester, I need to go and know exactly, explicitly, I need to request that service for some reason, and I need to know where it is. Now, I put usually in brackets because there are things like service discovery and service meshes and all that kind of stuff where you can maybe have that kind of automatic service type discovery. We're not covering that here today. So for the most part, what I'm saying is if you're making a synchronous request to an endpoint, you need to know where that endpoint is. You may go, well, why is that? Why is there an issue with that? Well, it becomes a bit of a management overhead. If your service is calling another 10 other services, it needs to know exactly where all those 10 other services are in order to call them. And it becomes a bit cumbersome. We're going to be using two forms of synchronous messaging today, HTTP, which we'll come on to doing next, and gRPC. All right. Now, this bit I really wanted to put in because it can get a bit confusing. So I've just said HTTP is a synchronous messaging construct. Cool, and it is, right? So I'm not retracting that. A very good question, it's a question I had initially as well, was hang on, wait a minute, if I've written a controller, which we have done, and I've got some action results in there, I can mark those action results as async. Doesn't that make it an asynchronous messaging construct then? The answer to that is no, and I'll tell you why. So from a messaging perspective, as you can see on screen, say we did tag one of our action results as asynchronous, from a messaging perspective, the method is still synchronous. Any client making a request to that endpoint still has to wait for a response, okay? The async stuff is really all to do with the way that service manages its threads internally. From a client perspective, from a messaging perspective, anybody requesting that service still has to wait for a response, so it's still synchronous messaging. Just to clarify, async in this context, the C# language context, means that the action will not wait for a long-running operation. So say that action result is doing some lengthy database dip, or maybe even calling another service. If it's long-running, what that async keyword means is it's not going to wait, it's not going to maintain hold of its thread while that long-running operation executes. It's going to return the thread back to the thread pool. Okay, so yes, it says here it will hand its thread back to the thread pool where it can be reused. When the long-running operation finishes, it will reacquire a thread and complete, and then respond back to the requester. So all this time, the requester in this scenario has still been sat there waiting for this service to respond back. This whole async construct is purely about thread management internally for that service. Messaging perspective, it's still synchronous though. So yes, as it says there, async in this context is really about thread exhaustion. The requester still has to wait. The call is still synchronous. Okay, so async in this context is about C# language, thread management, nothing to do with messaging. HTTP is still a synchronous, by and large, messaging construct. All right. So synchronous messaging between services can and does occur, and we're going to implement this. So as I said, this is all coming back to this. Do services talk synchronously to each other? We are going to do this. However, it does tend to pair services. It does tend to couple them a little bit, creating a dependency. Now again, in the microservices world, one of the kind of tenets is that you want to try and decouple where possible. You don't want lots of chatty communication between services. They're going to have to talk to each other, and there's a bit of a paradox here, but for the most part, you don't want lots of inter-service communication, and you certainly don't want it in a synchronous fashion, I don't think. And it could lead to something called, additionally, it could lead to something called dependency chain. So let's look at this diagram here. Service A makes a synchronous call to service B. Service B then has to make calls to services C and D, and service D then has to make a synchronous call to service E. So you can imagine if there's delays between any of those request response cycles, or if one even fails, what's going to happen. not a fantastic result. And service A is probably going to be sitting there waiting for a long time. You also have this horrible kind of, the name says all dependency chain where each service needs to know exactly what other service to call. It starts to get a bit cumbersome. You might have heard the term spaghetti programming, maybe not fully applicable in this state, but you get the idea. It becomes a bit of a mess, okay? But nonetheless, we are going to implement it to begin with, and there are scenarios where it's probably the better pattern to use as opposed to using an asynchronous event-based pattern. And we're going to implement that with gRPC a bit later. So I'm not saying you don't use synchronous communication, I'm just saying as a developer, you've got to make that decision about which is the best to use from a service-to-service perspective. All right, so asynchronous messaging. There is no request-response cycle. The requester does not wait. Sounds good, doesn't it? It's more of an event model and, for example, a publish-subscribe type model. Typically used between services, again, might be a controversial statement. There's some people out there that would probably disagree with that, but this is my video and this is what I'm saying, so go with it. Event bus is often used, and again, we're going to be using RabbitMQ much later down the path. We'll introduce RabbitMQ. And services don't really need to know about each other. They just need to know about the bus. So the idea is, as a requester, I just need to talk to the message bus and put something onto the message bus and go, here you go, here's something that other services need to know about, or here's some information that I potentially need. And I just put that onto the message bus, and the message bus sends out these events to any other services that are subscribed to those events on the message bus. Those other services will receive an event, go, oh, okay, I've got this new event, and then will respond back onto the event bus in that kind of fashion. So it's event driven. The event bus kind of sits as an intermediary between services, and it's a publish, subscribe type model, event driven model. And we're going to go into that quite a bit in this video. It does, though, introduce its own range of complexities, and it is actually much more complex than a synchronous request response cycle. It does introduce a lot of other things, that make it more complex. It's not a magic bullet by any means. So then the final slide in this section, and it's a question I wanted to surface here, is, isn't the message bus a monolith? It's this big thing that all these other services are dependent on. To some extent, yes. And it's the same kind of conversation you'll have about API gateways. Is an API gateway basically a monolith? Again, to some extent, yes. But focusing in on the message bus, is it a monolith? Yes, to some extent, yes. Internal comms, if services are reliant on the message bus, internal comms between services would stop working if the message bus went down. However, if you've designed your microservices appropriately, those services should be autonomous enough that they can still deal with external traffic, they can still deal with requests to them and be able to deal with them to some extent, even if they cannot talk to other services internally. So yeah, services will typically still be able to operate and work externally, with some caveats, of course. The message bus, therefore, because it is so important, should be treated as a first-class citizen, similar to the network, physical storage, power, any of that stuff. And so typically, when you're setting up a message bus in a production environment, you'd set it up in a clustered fashion. You would have fault tolerance, you'd have multiple instances all talking to each other, so if one goes down, it's not an issue. And again, that's how RabbitMQ themselves recommend you set up RabbitMQ in Kubernetes using this cluster type approach. We're not going to do that here. It's a bit too complex for this video. It's just an introduction video. So we're just going to set up a single instance of RabbitMQ for our purposes. But generally speaking, in a production environment, you would have this cluster. The other thing I put there is you'd also typically have, a degree of persistence. So if your cluster dies and then it restarts again, it's not lost all the messages that it had in the queue. It should have some degree of the ability to retrieve messages it had in its queue from some persistence layer. That being said, services should also implement some kind of retry policy. So say the message bus goes down, you don't want to just fire messages onto it, and then if the message bus is gone, you've lost that event. The services should be intelligent enough to retry, keep those events queued up and retry when the message bus comes back up. So something you'll hear about often in the microservices world is you aim for smart services. Your endpoint should be intelligent, the pipes should be relatively simple or stupid, as I've put there. Okay, so they're really just there as a transport to get one event from one service to the other. All right. So with that, yeah, again, I just wanted to introduce you to this concept of synchronous messaging. We're going to be talking about it a lot, and asynchronous messaging, we're going to be talking about it a lot. When we come on to asynchronous messaging and RabbitMQ, we'll do a full section on that a bit later. But for now, we're going to move back over to our platform service and implement a synchronous client that will allow us to talk to our command service. So we'll do that next. All right, so back over in our command service. We're not actually going to work in our command service now. We've got everything we need in here for the moment. So I'm just going to close down the running service. Now, I'm going to leave our command service running in this instance of VS Code, and I'm going to bring up a separate instance, a new window, for our platform service, because we're going to be working in there now. So in our new instance of VS Code, I'm going to move into my working directory, season 4, and change into episode 3, and I'll do a quick directory listing to make sure I can see our platform service, and then we're just going to open that in this instance. Cool. All right, so we have our platform service up and running now. So yeah, what we're going to do is create a HTTP client effectively. It's going to issue a post message to our command service. Now this is just a test really, we're not really going to implement too much functionality here. But the idea would be that if we created a new platform in the platform service, that we would want to let our command service know about it, because our command service is somewhat reliant on platform information. And one way we could do that is by sending a HTTP post payload over to our command service, and it could then take that and do with it what it wants. We're going to properly implement that using a message bus type construct. So using an event publisher subscribe type model, we're going to properly implement it doing that. Here, we're not going to fully implement it. All I really want to do here is just make sure that we've got comms working between the two endpoints, more especially when we come to putting it into Kubernetes. This is more actually a Kubernetes thing, really just setting up the networking between our services. And I'm doing this just to test that, help test that. Nonetheless, it's still a valid use case, and we want to make sure that it's all working. So back in our platform service, we're going to create a new folder for our synchronous data services. So new folder, and I'm going to call it sync data services. And we're eventually going to end up with two types of synchronous data service, HTTP that we're doing now and gRPC. But we're going to just focus on HTTP for the moment. So new folder, HTTP. I'll make sure I capitalize H. All right. Now, we're going to make use of something called a HTTP client to make the request. And moreover, we're going to make use of something called a HTTP client factory to basically give us a HTTP client. And then, I've done videos on this before. The main reason we're using HTTP client factory is if you're making multiple requests using HTTP clients, you should be using a factory to do that for you, because it just manages connection safety and all that sort of stuff, and you don't end up with, again, connection exhaustion and all that sort of stuff. So we're going to be using a HTTP client factory, but if you follow along with the code, it should be relatively straightforward. So the first thing we're going to create is an interface, because we are going to use constructor dependency injection, and we're going to inject this client into various places, namely our controller. So we want to allow constructor dependency injection from that perspective. So new file, and we're going to call it I command data client.cs. And then we're going to define namespace, platform service, sync data services.http. Fantastic. And it's just a public interface called I command data client. And we're just going to have one method signature. It's going to be asynchronous, and you'll see why in a moment. So we'll have to bring in the namespace for task in a second. And we're just going to call this send platform to command. Now, we're not really going to do anything with this, but I thought just to kind of make it a bit more of a realistic example, if we come over to our DTOs, the idea is we want to send over a platform that we have created. And we have two DTOs here. We have our platform read DTO with all this information in it, and we have a platform create DTO with this information in it. Now, I'm thinking in this case, when we send a platform over to our command service, we probably actually want to include the ID, our ID, because we probably want to give it a reference, a unique reference to the platform that we've created, so it has that. So I'm going to use the platform read DTO as the message that we pass over, okay? So in here, I'm going to say platform read DTO, and we'll just call that plat. So we're going to bring in a few namespaces here, so control period to bring in platform service DTOs, and we need to bring in threading for this. Okay, great, so that's our interface created. So I'm just going to come on now and create the concrete class. So again, within the HTTP folder, new file, and I'm just going to call this HTTP command data client.cs. Okay, specify the namespace, platform service, sync data services, and as we've typed this in before, you can see it's remembered it, which is cool. And then it's just a public class called HTTP. And I realize I've just spelled that wrong, so let me just rename that. Command data client, yep, so HTTP command data client, and we're going to implement the iCommand data client. So we'll do a control period, implement interface. Fantastic. Now before we actually come on and implement this method here, what I want to do is make use of this HTTP client factory. So in order to do that, we use, once again, constructor dependency injection here. So we're going to create a constructor for our class, and into it we're going to inject a HTTP client. And you'll see how this all ties together when we register this service in our startup class. And we're just going to call that HTTP client. So into here, we're going to get this HTTP client injected, but we do need to bring in the namespace of using system.net HTTP. Fantastic. And again, we need to create a private instance. So I'm going to call underscore HTTP client is equal to HTTP client. And in here, control period to generate a read-only field that we can use throughout the rest of our service, or service method, put it in here, use it in here. Okay, so let's just save that for the moment. And now we're going to come down and actually implement or send platform to command synchronous call. So the first thing I want to do is create a payload effectively that would contain our platform read DTO or information. So I'm going to do a var, call it HTTP content, and it'll be a new string content object. Open parenthesis, I'll just put in the semicolon. And the first thing I'm going to do is I'm going to serialize this object, this platform read DTO. So I'm going to use JSON serializer. I spelled that correct. No, I've not spelled it correct. Serializer. I think that's right. Yeah, so using system text JSON. Now you can see you get two choices here. You could use the older Newtonsoft JSON library. I'm using the Microsoft library moving forward now, okay? And we're just going to serialize the platform object so we can send it over the wire, basically. All right. And in the encoding, bring in the namespace for that, should be system text, there we go, is going to be UTF-8. And then finally, we just need to specify the media type, which is going to be application JSON. Okay, and I'm going to bring that back up onto this line here. Okay, so this string content object is something we're going to send over with our post request. Okay, and it's still complaining because we're not really returning anything as yet. Then we're going to basically make a post async request to our client. So I'm going to do var response equals await. Use our HTTP client, post async, and I'm just going to do a control B to get rid of our sidebar. You can see what's happening. And here we don't have a problem at all because we will solve it, of course, but we need to know where, and again, this is talking about kind of your pairing services to one another. We need to know where to send this post request to. Now we can just hard code the URI of our service in here. okay? But that's not a particularly elegant solution. So what I want to do is I want to move in and put this type of stuff into config, okay? But for the moment, let's just hard code it, and we will eventually come back and put it into config so that it's not hard coded, which is never a great idea. So basically what we want to do, let's come back over to Insomnia. And when we tested our inbound connection in our local environment, this is the URI or URL that we want to send this to. So we'll just copy this in for the moment. Again, I just want to get this up and running and working, but we'll circle back and put this into config. Okay, so paste that in there, and then we need to supply the HTTP content along with this as well. And it's complaining, they wait over it. Okay, so we need to put in async up here. There we go, and that should resolve that. So basically it was complaining that we couldn't call an await method when this method signature wasn't asynchronous itself. Okay, so we're going to post to our endpoint and we're going to provide that HTTP content. Cool, and then all we want to do then is just check that we get a successful or otherwise response back. So if response is success code, then we'll do a console write line, bring in the namespace using system, write line, and we'll just say sync post to command service was okay. Otherwise, console write line, and I might just copy this message here, and we'll say it was not okay. All right, fantastic. So let's save that off. Okay, so we've still got a couple of things to do. We want to bring in configuration rather than hard-coded strings. So what we can do actually is up here in our constructor, where we're injecting in a HTTP client, we can also inject iConfiguration. Big duration, and we'll just call that configuration. Okay, we'll bring in the namespace for that. Now, iConfiguration is one of those lovely objects that gets injected everywhere, basically, or can be injected everywhere, so we don't really have to do too much setup there. The other thing to be really careful of, and I've made this mistake, is that bring in the right namespace for iConfiguration, because AutoMapper also has that too. So make sure it's the Microsoft extensions configuration that you bring up at the top, okay? And then we'll set up a private field, so call it _configuration and make it equal to configuration. And then control period, generate a read-only field. There we go. And we can use this configuration now to inject this in from a config file. So I'm going to copy this and I'm going to do a control B, and we're going to come over to our configuration file. So we have our app settings development JSON configuration file, which seems like a good place in which to put our config for our endpoint from a development perspective. So what I'm going to do is I'm going to come over to here and into our app settings.development JSON. I'm going to create a new parameter in here, and I'm just going to call it command service. And the value, I'm actually just going to make it the kind of base URL for our command service, so we know where to get to it. So we'll save that off in here, and we'll come back to our command service. I'll do a control B to bring this down, and what I'm going to do is I'm going to take this out, and I'm going to make use of string interpolation to inject in that part of our URI into our endpoint here. Now you could put the whole thing, to be honest with you. You could actually put the whole thing in. I'm just putting the server URI, but you could put the whole path in if you wanted, which is entirely up to you. And I'm just going to make use of configuration. So basically, what we get injected in here, configuration, and then just reference the setting that we put in here, which was command service. So just copy that. and put that in here. And make sure you get the forward slash. So basically, this thing here, all the way up to here, is basically going to be a HTTP localhost port 6000, and then the rest of the URI. Now again, you could replace the whole thing if you wanted in here with that. Entirely up to you. In fact, do you know what? Let's do that, because it doesn't really make sense, does it, to just have that little bit. So let's just put that in here like that. That makes more sense, doesn't it? Yeah. Okay, so basically we're just going to put the whole thing in. All right, so that should work now. Actually, no, it won't. There's one thing that we still need to do, and I'll just take this out. I don't know how that got in there, so let's save that off. Now, because we're using this HTTP client factory ultimately, or we're getting a HTTP client injected in, we need to make use of a HTTP client factory in order to do that. So this is the last bit of this section. It has been a bit longer than I had intended, so I do apologize, but Control B, and back over in our startup class, what we want to do in our configure services method is under our repository registration, we're going to make use of our services collection again, and this is where the HTTP client factory gets used. So we're going to add HTTP client, okay? And we're going to specify the interface. So in this case, it's going to be I command data client. So when we ask for an I command data client, we're going to give it a HTTP command data client. So this is us basically, this add HTTP client is making use of a client factory. And so when, let me just bring in the namespaces for these, and both should resolve them as they're in the same namespace. That's correct. So they have resolved. So back over here, when, I'll do a Control B, when our class constructor gets called, we're going to get a HTTP client injected in here that's going to be managed by a HTTP client factory. All right, so that was quite a long section. We need to test this now, so we'll do that in the next video, just to might have a cup of tea now, and then come back and we'll test this and make sure, test it locally, make sure that when we make use of this, and we'll have to put this into our controller in a second, we'll do that in the next video, when we call this service, we can actually send a message down to our command service, but we'll do that in the next video. All right, so still in our platform service, what we want to do is we've created our Synchronous client, our HTTP Synchronous client here. What we want to do is we actually want to be able to use it somewhere. And so where are we going to use it? Where does it make sense to use it? Well, it probably makes sense to use it from our platform's controller. So when somebody runs a HTTP post and we create a platform in our platform service, at that point we want to make a synchronous call, or do we, to our command service to make them aware, hey, we've just created a new command. All right, so we're going to put that code in here, and then we're going to test it. So just do a Control B, just to give us a bit more breathing space. So the first thing we need to do is actually inject in an instance of our command data client into our platform's controller so we can use it. So I'm just going to take a new line for our injected parameters because it's going to get a bit long. So we'll still keep platform repo, we'll still keep AutoMapper, but now what we want to inject in is an I command data client, and we'll just bring in the namespace for that. So using platform services, sync data services HTTP, that's cool. And we'll just call that underscore command data client. And as usual, we need to create a private instance of it. So I'm going to call it underscore command data client equals command data client. There we go. And, oh, hang on. I should just create that. Yeah, there we go. That's right. There we go, that's better. So yeah, make sure the one that you're injecting has not got the underscore and the one that we are creating now has got the underscore. Okay, so generate a read-only field. Again, this pattern should be very, very familiar to you now. And again, coming back over to our startup class, because we've registered this here, we have this available to us in here as well. Okay, so we just come down to our post endpoint. And just before we return back with our created it route statement, I'm going to make a call to platform service at this point. Now, because things could potentially or conceivably go wrong, I'm going to use a try catch block because we don't want some horrific exception if that endpoint is down, for example. So I'm going to make use of the await keyword. I'm going to make use of our command data client. I'm going to send platform to command, and I'm going to pass in platform read DTO that we've got here. Okay. And that should be sufficient for this. And it's going to complain here, but we'll fix it up basically because this is not an asynchronous endpoint. And again, I will stress async in this context has nothing to do with asynchronous messaging. But before we do that, we'll just catch any exceptions. We'll call it EX, and then we'll just do a console write line with something of the nature of, and we'll use string interpolation, so we'll put $sign before the double quotes, and we'll say could not send synchronously. And there may be reasons for that. I don't think I've spelled that correctly, have I? Synchronously. That's right. Doesn't really matter, but for those of you who hate spelling mistakes, it probably is quite annoying if it is wrong. And then we're going to just pass in the message that we get from any exception. Okay, so hopefully this makes sense. So we'll try and send, use our data client to send our platform read DTO to our platform service. If it fails, we'll catch an exception. Now again, this is complaining because it's saying there is no await operator, but that's okay. So we can just put that in here, make it synchronous. But in order to do that, we have to specify it's a task really that's being returned. So task, and then close that off like that, and that should be okay. Not await, async. Okay, there you go. So async, await. And I don't think we have the threading namespace, so we'll bring in using system threading tasks. So this has now made this action result an asynchronous action result because potentially this command here could be long running. But again, to labour the point, from a calling perspective, it's still asynchronous messaging. So let's save that off. Let's bring up our command line. Let's do a .NET build. Looking good. So we'll do a .NET run. And again, just to be, super sort of pedantic, you can see here that, where it should say it here, it usually says it. There we go. The hosting environment is development, okay? So because the hosting environment is development, it will make use of our app settings.development JSON file and pull in the right config for our command service endpoint. And actually, what we might do, I'm just going to stop running, and what I might do is up here in our startup class, what I might do is in configure services, I might just do a bit of an output just to say console write line, and we'll just say, just so we can see this printed to the screen, command service endpoint, and we will make use of our configuration object called configuration in this case. And we'll just specify this. So we'll have this printed out to screen, and because we'll probably do this quite a lot because we're going to be moving between different environments, so it's probably worth just printing out to our console what it thinks the endpoint is. So let's just start that again. There we go. So you saw there what it thought the command service endpoint is. There we go. So this is what it thinks the endpoint is, and indeed that is exactly what we should be using. Seeded data, all good. So that's our platform service up and running. Let's move back to our command service. Let's make sure that's running. Fantastic. And then what we're going to do is we're going to make a platform create request in our platform service, which should then call our command service. All right, so moment of truth. So bring up Insomnia once again. We're in our local development environment and we want to create a platform in our platform service. Okay, so let me just send this over. Looks like it created it. And we'll come over to our messaging, and you can see here within our command service we have an inbound post from our command service. Fantastic. And we come back over to our platform service, we have a message saying the synchronous post to our command service was okay. So that's all working rather nicely. But what I'm going to do, just to illustrate a point, I'm going to come back to our command service and I'm going to stop it. I'm going to kill it. Okay, so that endpoint is no longer there. And I'm going to do the same thing again, and we're going to see what happens. Okay, so we'll create the same thing again. So let's just click send. You can see it's taking time. Still comes back okay because it created the service okay, but you saw that took 2 or 3 seconds. Why did it take 2 or 3 seconds? Well, basically, if we come back to our platform service, you can see we could not send synchronously, no connection was made, blah, 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 which totally makes sense. But you saw how, as a consumer, we were waiting for that, okay? We were waiting for that response to come back. And you imagine there's a chain of those type of things or anything like that. Not a great experience. Nonetheless, we've achieved what we wanted to achieve. And just to recap, it's been quite a long section. We have created a test endpoint in our command service, and we've created a synchronous data client in our platform service that will call this test service in our command service synchronously. Cool, so we've established that that works. What we need to do now is put our platform service into Kubernetes and then wire up these 2 services using cluster IP addresses. So we're going to do that next. All right, so let's just do a quick sense check again of where we're at and what we've done. So we have our platform service running in Kubernetes, and we have our node port set up. We do not yet have our command service running in Kubernetes, but we have it running locally, and we had established connectivity between the 2. That's cool. So in this section, what we want to do is, first of all, get our command service up and running in Kubernetes, and then we're going to create cluster IPs for each of our pods so they can talk to each other. So really the first thing we need to do, the first step of getting our command service into Kubernetes is packaging it as a Docker image and pushing it up to Docker Hub. So we're going to do that now. So let's just make sure we're in the right space. We want to be in our commands service. So we're here, so we're in commands service, and you can see here we're in the right space. So do a quick clear of the screen, and what we want to do is create a Docker file. So in the root of our commands service project, we're going to right click, new file, and I'm going to create a Docker file as we did before with our platform service. Now, all I'm going to do is come back over to our platform service and copy out the config from our platform service Docker file, because it's basically effectively exactly the same, bar one small change. All right, and that's down here, that's the entry point. So rather than it being platform service DLL, it's going to be command service DLL. Now let's just double check. In the bin folder, you want to make sure that the DLL commands service is matched here. It's exactly the same thing. I actually made a mistake in one of the other recordings of this video, and I got this name wrong, and it caused all sorts of issues. So just make sure that you have the right entry point, and we'll save that off. Okay, and then as before, we'll do a Docker build, and we'll tag it with your Docker Hub ID, and then the name of the service, command service. Don't forget the build context at the end. All right, so we'll go away and build that. Should be relatively quick. Fantastic, and then we'll push it up to Docker Hub. So get rid of the build context, get rid of the T, and we'll just type in push, and this will push this up to Docker Hub so that when we create our K8s deployment for our command service, it has an image to go away and pull down. So we'll just let Docker do its thing and push that image up, and then we'll come back and we'll actually test and make sure that our Docker image is actually running as well. I probably should have done that before I pushed it, but we'll wait, we'll let the push finish, and then we'll test and make sure that it actually runs up okay. Now interestingly, you can see here that it's saying layer already exists, so because it is aware of layers or for this image elsewhere, it doesn't have to push the whole thing back up. Okay, so that's pushed up. Now before we do anything else, I should have done this before I pushed it, we're going to do a Docker run. So Docker run, we'll specify an external port mapping to an internal port mapping, which you should be familiar with now. I'm not going to run it in detached mode because I actually want to see the output when we run it. So just the name of the service. Okay, so binary thistle command service. Let's run that up. It's cool. So it's run up okay. It's started on port 80. We're not getting any errors. So that all looks pretty good to me. So what we might do is come over into here and we can see that we have a command service running. So I'm just going to stop that from here. And we get our command prompt back. So that all looks good. So in the next section, what we're going to do is we're going to update our platform's deployment file to include a cluster IP service, and we're going to create an entirely new commands deployment file that also includes a cluster IP service. So we'll do that in the next section. All right, so let's come over to our K8s project. And here we have our existing platforms deployment. Now that's not actually going to change, that's staying exactly the same. But what I do want to do is come underneath here and add in a definition for our cluster IP service. Now you could put this into a separate file if you want. I like to keep it in this instance in the same file, as the two things are really very closely related. All right, so we specify an API version, and this time it's v1. So this will look very similar to the node port stuff that we did a bit earlier. The kind is a service. And then metadata is basically the name of our service, effectively. So we'll specify name, and I'm going to call this platforms cluster IP service. These names get quite long, so you've got to really check your typing. And I guarantee you will make a typo at some point throughout this course. So just be really, really meticulous with your spacing and with the, the naming of your services. And they have to be absolutely exact. If you're one character out, as has happened to me many times, nothing will work. So you've really got to double check. And if you do run into trouble, just download the config file from GitHub and you should be okay. Anyway, so we've specified the name of our cluster IP service, and I'm just going to specify what type it is, and it's of type cluster IP. Capitalize that, and then selector, tab in, app, and we come up here and we actually pick the name of our template, which is platform service in this case. And I'll just make sure I've not copied too much space there. There we go. And I'll paste that in here. Again, you've got to get this stuff absolutely correct. We'll back out and then we'll define our ports. And then it's an array. So we'll give it a name. And again, I'm going to give it the same name, platform service as well. Tab in, protocol is going to be TCP. Port's going to be 80, and target port is also going to be 80. And that's it for now. We will add another port onto this for when we come on to doing gRPC, but for the moment we're just using plain old HTTP, so this should suffice. So our actual deployment hasn't changed yet, and we're adding a new cluster service IP into that. So let's just save that off for the moment. We're not going to apply that yet. And then we're going to create a new deployment for our commands service. So right click in here, new file, and we'll call this commands depl.yaml. Okay, and what I'm doing, I'm going to come in here and I'm going to copy all of this. And I'm just going to do a bit of a replace for our command service. Okay, so let's just work our way down from the top down to the bottom and replace the things that we need to replace. So the first thing we're going to change is the name of our deployment. So rather than it being platforms depl, it's going to be commands. The name of our service is going to be command service. And maybe we just come back over to Docker Hub and we just take a quick look at, just double check the name of our service. So it's command service, not plural, okay? So command service. And I'm going to copy this because I'm going to replace it everywhere. And I'm going to push it in here. I'm going to push it in here. And I'm going to push it in here as well. Okay, so binary thistle command service latest. Let's come down to the cluster IP for this service. And again, we're just going to change this instead of platforms to commands. Cluster IP is okay. And I'm just going to change the selectors to what we already had. There we go. That all looks good. So if I just highlight this, we should have these same things highlighted throughout the rest of the file. And we'll save that off. Okay, that all looks good. Okay, so just to reiterate what we have done, we have built our command service as a Docker image and we have pushed that up to Docker Hub because we need that for our deployment. And we've now updated our platform's deployment to include a cluster IP service, which has not yet been deployed. And we've created an entirely new commands deployment that contains the deployment for our service and also cluster IP. So in the next section, we're going to run both of these deployment files to get everything up and running. But just before we do that, there is one little bit of config we need to pop back into our platform service just before we do that. So we'll do that next. All right, so I was talking about we need to make a bit of a change to our platforms service config. So back over in platform service, we need to know where our command service resides. And this is one of the problems of synchronous data services. If you're doing it this way, you need to know where all the endpoints are. And so we've created a config entry in our app settings development JSON file that tells us where we can find the command service in a development environment. And that's all cool. But when we deploy into Kubernetes, it's an entirely different environment. It actually runs in production. So this bit of config, number one, is not going to get picked up. And even if it did get picked up, it's going to be incorrect anyway because the command service is not going to be running here. It's going to be running somewhere else. All right, so the first thing we need to do is create another settings file just for production, just for our production settings. So I might just clear down a lot of this stuff because it's getting a bit busy. And come back over into the root of our project. I'll just minimize some of this to give us a bit more room. And we're going to create a new app settings file in the root of our project. So new file, app settings.production.json. Okay, and so these are the settings that are only going to get picked up in a production type environment. All right, so we come back over here. I'm just going to copy this. Copy, and I'm going to come over here and create some curly brackets and create this as a top level item. So that's point number one, that's all cool. But where is our command service going to reside in Kubernetes? Well, if we come back over to our K8s folder and we look inside our commands deployment, we have created this cluster IP service for our command service. So again, come back to our architecture diagram because I think it's worth revisiting. Let's come back here. What we are attempting to do is get our two services to talk to each other via their cluster IP services. So really the endpoint from a platform service perspective, the endpoint it needs to reach out to is really the cluster IP service attached to the command service pod. Okay, so the name basically that we need to put in is this here, the name of our service. That is effectively the endpoint our platform service needs to reach out to. So I'm just going to copy that and come back to our platform service. And in our app settings production JSON, I'm just going to replace this here with the cluster IP service of our commands service. And I also need to specify the port. So the name of the cluster IP service, :port, and everything else should remain exactly the same. All right, so again, you know, a little bit kind of convoluted, but there's a lot of config involved in setting all this up. And again, you're probably going to make mistakes along the way. Don't stress if you do. I've made plenty. But the other thing to note here is because I've effectively changed our image now, created some new settings and app settings, Jason, I'm going to have to rebuild our Docker image for our platform service and re-push it back up to Docker Hub. So let's do that now. Let's build it. And let's push it up. So I'm just doing up key, so Docker push binary thistle platform service. And it shouldn't take that long as we've only made a minor change. Now, going forward, you would probably want to extract the settings out of settings file in this way and not have to redeploy images to read in this type of stuff. But again, for this video, I've chosen to do it this way, just in the interests of time. But you can see this probably isn't a particularly efficient way of changing your settings, having to redeploy an image, but that's what we're doing here anyway. So once that's pushed up, what I'm going to then do is we're going to then apply our deployment files, the two files that we've run, and we'll run into another interesting concept when we come to doing that. So there we go, that's pushed up. So I'm going to pause here for a minute and then I'm going to come back and we're going to revisit the two files that we've created, because as yet we've not reapplied them, and then we'll do our final test to make sure that we get our services talking inside Kubernetes. So we'll do that next. All right, so let's just do a quick sense check of where we're at. So let's come back into our K8 project. And I'm going to bring up our command line. I'm just going to clear that down. So the first thing, I want to just, level set on where we're at, because we've done quite a lot of work and it can get confusing. So let's do a kubectl get deployments. Okay, we only have one deployment up and running, which is our platforms deployment. Been deployed, it's all cool, looks good. If you do kubectl get pods, you can see we have one pod up and running, which is again our platform service. So again, we've created these files, but we've not yet applied them. And then the last thing we'll do is we'll do kubectl get services. And you can see here we have this Kubernetes cluster IP, which is already there by default, and we have our node port that we created a few sections ago. All right. So the first thing I want to do is I want to apply our platforms deployment again. So quick directory listing, make sure we can see our platforms deployment file. And we're going to do kubectl apply f and the name of our deployment file. So let's do that now. And let's run that. Okay, now you can see a couple of things here. It's saying that the deployment has remained unchanged. Okay, and that's fair enough, because this part of the file, what's really referring to is the deployment here, the deployment we've actually specified in this file, and that hasn't changed. That's remained exactly the same. But what it has said is we've created this new cluster IP service, which all sounds great. So if we do kubectl get services, you should see we have this platforms cluster IP created, which looks good. But coming back over to our Kubernetes session, and pulling this over here, we have our pod running and we have our platform service running. What hasn't happened by rerunning that deployment file, Kubernetes hasn't gone up to Docker Hub and pulled down the latest version of our image that has our new configuration pointing to our command service. It's not done that. If we just come back over here and go into it, you can see that, it's not restarted, it's not done anything, whatever. So what we need to do is we need to force Kubernetes to refresh this image. Okay, so the way we do that is we come back over here and we'll just do a kubectl get deployments, just to get a list of our deployments again. I spelled that wrong. Yeah, there we go. So we've got our platforms deployment. We want to basically restart that or refresh that. So the way we do that, again, this is all in the cheat sheet, these command lines, kubectl rollout, restart, deployment, and then we just specify the name of the deployment. Okay. And then it says deployment apps platforms depl is restarted. And if we come back over to Kubernetes, we should see some things happening over here. Or Alternatively, rather than doing that, we can just do kubectl get pods. And you can see that we have a container that's running already, but we have this container that's now creating, which is the new container with our new image, with our new config, and it's creating. And eventually this running one, it will terminate once that one has started. So we just have one running now, which is good. And if we come over to Kubernetes and we have a quick look here, you can see one pod has died, and then we come over to our platform service. You can see here, the command service endpoint is here. So it's picked up the right endpoint, certainly, that we've told it to pick up. This is what it will be looking for when we hit the controller. It will then reach out to our platform service. But that won't work at the moment because we don't actually have our commands service deployed. So we'll do that now. And it's relatively straightforward. So back over in K8, let's just clear this out. We'll just do, again, kubectl get deployments. We only have one deployment, so we now want to execute our commands deployment. So again, we'll just do an up key. We want to apply our commands deployment this time. Okay, so kubectl apply -f commands deployment. And you can see this time, we didn't have a commands deployment at all, so it's gone off and created one, and it will pull down the image it has for that. And then it's created a cluster IP service for that as well. Fantastic. So if we do kubectl get services, you'll see we have our two cluster IP services, one for commands and one for platforms, which is good. And then if we do kubectl get deployments, up and running, both are up and running, and we'll do a kubectl get pods to see the health of our pods. And we have two pods up and running, a commands pod and a platforms pod. So that's all looking quite promising. Fantastic. So we'll just come over again to our Kubernetes instance. Let's make this bigger. And you can see we have a pod for platforms, a pod for commands, a platform service, and a command service. And we click on the service, it all looks like it's running okay. So that's looking pretty exciting. So final step here that we want to do is just test that that is working. So we're going to make a call into our platform service, a post request, and we're going to see if we are talking to our command service. So we'll do that next. Fingers crossed it's all wired up correctly and it's all working correctly. So we'll do that. Yeah, we'll do it next. All right, so let's get testing this. So to test, we're going to use Insomnia. So we're going to be testing purely within our K8's environment. And so all we have so far is the ability to get platforms from our platform service. So let's just run that and make sure that's still running okay. That's good, a good start. So what we want to do next is then create a platform in our service running in Kubernetes. So let's come down to our local dev, and I'm just going to copy or duplicate the create platform call, and I'm going to move that into here. Now at the moment we are using a node port, and again we're reliant on this port here in order for that to happen. So let's copy that, and we'll come down to here and we're going to paste that in here. Okay, so hopefully you remember that from when we were looking at node ports. We were just calling a create platform, but we're having to use this node port endpoint. And we'll just, again, we've only got 3 platforms in our platform service, so we're going to create hopefully another one. Now what we expect to see is that number 1, a platform will be created in our platform service. Fantastic. But more importantly, what we want to see in the logs of our command service is that it received that post notification, and if it receives that post notification, then we know that everything is wired up correctly, and we're really quite far down. We've broken the back actually of a lot of the Kubernetes networking stuff, which I appreciate is quite quite voluminous and quite boring. So fingers crossed, let's click send. Looked pretty good, it came back pretty quickly. So looks like we've created a platform in our platform service. Let's just rerun this. Fantastic, we have. And then the last bit we want to test is we want to come over to our Kubernetes session and just pull it over into the screen. And we'll take a quick look at our platform service first, and we should see that it sent some stuff over to, we've done a couple of calls that was getting a platform, so if we move a bit further up, sync post to command service was okay. So it called the command service okay, it didn't get an error, which is fantastic, it's looking pretty good. And then we come into our command service, and you can see here that we got an inbound post from our command service. So it looks like everything is working very well. Now, the only thing you will notice is that we get this warning around HTTPS redirection. So nothing really to worry about, but if we come on into both our services or either of our services, let's pick our command service and come into our startup file. You'll see down here in configure that we have this use HTTPS redirection. That's what's causing that error. Now, one of the things I decided to leave out of this course was introducing HTTPS, I think I've said this already, into our internal Kubernetes cluster. We're not going to use that. So what I might do, just to get rid of those warnings, I might just comment this out. And of course, as soon as we comment it out, it means we've got to redeploy our stuff back up to Docker Hub. But again, I'll leave you to do that in your own time. I'm not going to do it in the video. This is relatively benign at this point in time, so I'm not too bothered about that. So I might do that in between now and the next video. I might push my images back up to Docker Hub. I'm not going to include it here. If you choose not to do that, it's not a big issue. So I'm going to comment it out of our command service, and then I'm going to comment it out of our platform service as well. So over in startup, I'll do that as well. And in between now and the next video, I'm going to build these images and push them back up. And of course, you would have to do the rollout restart thing to get Kubernetes to pull down the latest version, but I'll leave you to do that at your leisure. And if you choose not to, it's not a big deal. It just means that you'll still get those HTTPS redirection warnings. Fantastic. So that's a big milestone that we've got over. What we're going to move on to next is we're going to move away from using the node port, and we're going to move into using a more productionized mechanism to get into our services, and that's when we start talking about the Nginx ingress controller. So we'll start to move on to that next. All right, so let's just do a quick architecture review just to see how we're doing with our Kubernetes build. Let me just find the right, there we go, the right slide. So we have basically got to this stage here where we have a node port, we have our two services running in pods, and we have our cluster IP services wired up so they can talk to each other, which is fantastic. But now we want to stand up what's called an ingress Nginx controller. And as a result of standing that up, we'll also get this load balancer service as well that will allow us to get external traffic in. Now, this is kind of going into more detail about how Kubernetes works. We're going to go through it all step by step, but I'm not going to dwell too much on it, okay? Because we're actually going to be reliant somewhat on an external YAML file that's going to set all this up for us. And really the only thing we're going to end up doing is writing the routing config for this gateway, for this ingress Nginx controller. And the rest of it's kind of taken care of by another GitHub project actually, which we'll take a look at now. So actually that's probably a good segue into that. So let me just come over to Google and let's pull it onto my screen. And if you search for ingress Nginx, be careful because there's a few very similar repositories, but this is the one we want here. So it's GitHub Kubernetes /ingress Nginx. Now, don't worry, we don't need to really do too much with this. If you scroll down to the getting started document, this is really what we want. And this is telling you how we can install this ingress Nginx controller. And we have all these different providers. So if you were running on Google Cloud or something, then you would pick this one, or AWS, you would go with this one. We're using Docker Desktop. So this is all we need. Okay, so we're going to copy this here. You can see the kubectl apply f command that you've been very comfortable using for the last few sections of the video. But this time we're going to specify a URL to where the YAML file exists. So what we might actually do is let's just copy the URL. I can do that properly, copy it, and I'll put it into another browser window, and you can see, and you can probably suggest you take a quick look at the contents of this, but you can see It's pretty big, it's pretty long. I'm glad I don't have to type it out, and I'm sure you're pretty glad you don't have to do it either. But it's still worth going through and having a quick look to make sure you have a sort of understanding of what it's trying to do. But by and large, yes, it sets up this basically an API gateway that we can, route into. So enough of that. I'm going to copy the whole thing now, the whole kubectl apply command. In fact, we can probably just tick this little thing here. That's good enough. And we'll come back over to a command prompt. Let me clear this down. I'll paste this in. And there you go. It's kind of gone through and basically applied everything. So let's take a look and see if we can understand what it's done. So if I bring over my Kubernetes session and go back to the list of running services, you can actually start to see there's a pod here, Ingress Nginx pod here. There's a couple of pods actually, and these will work through for a bit until the deployment has settled down. So some of these things will create, recreate, and then destroy themselves. So let's come back over to our command line. I'll do CLS, and again, we'll take a look. We'll do kubectl get deployments. Now, something kind of strange going on. We can only see the deployments that we have done, our commands deployment and our platforms deployment. What about if we do get pods? Do we have any joy there? Not really. We see our two pods that we have created, our commands pod and our platforms pod, but where's all this Ingress Nginx stuff? Well, again, a bit more of a detailed Kubernetes concept, but Kubernetes works on this concept of namespaces. In a similar way that we've got namespaces for our classes and stuff, Kubernetes works along the same line. So we are working within the default namespace for our project. So we've not really covered that as yet, and I'm not really intend to cover it in too much more detail, but the stuff we've created for Ingress Nginx is in a completely different namespace to our application. So just coming back over to the cheat sheet, you can actually look at all the namespaces that we have. So kubectl get namespace. And you can see here we have default, which is kind of where we're working in, and then we have this, we have these kube namespaces as well, which I'm not really too interested in. And then we have this new Ingress Nginx namespace that's being created as part of what we've just run. So we can look at the pods in that namespace by doing kubectl get pods, and again this is on the cheat sheet, namespace, and then equals the name of the namespace, which in this case is Ingress Nginx. I'll do that. Now I might actually make sure that I put 2 dashes in there. There we go. So that's 2 dashes, not 1 dash. And the cheat sheet is correct. I just was misreading it. And you can see here that we have a couple of, well, one running pod basically, which is now our Ingress Nginx controller. And these two things have basically completed. They're no longer running. And that's what I was talking about with these pods that kind of create themselves and then destroy themselves. So that all looks relatively good. So let's come back to Kubernetes, and you can see here, yeah, we've got a couple of ghosted pods. So I might just get rid of these, remove them. Don't need them. And we've got enough going on our screen without having all this extra stuff running. Okay, cool. So we've got a pod for Ingress Nginx controller, and we have a controller, the actual controller itself, and you can go in and have a look. And it's basically running on Nginx, which is similar to Envoy, which is basically used a lot as a gateway type setup. Fantastic, so that looks good, but at this point in time all we've done is set that gateway up. We might also take a quick look at networking, get services. And you can see in a similar way that we've got the services that we have set up for our namespace, but we could get the namespaces for Ingress Nginx. And I dread to think what it's going to show us, but let's take a quick look. And you can see here we've got a load balancer, which was created. It's another service type, and we have another cluster IP service actually as well that's being used there as well. All right, cool. So again, we don't really need to worry too much about that. That's all been set up for us automatically. What we do need to come on to doing now is to create the routing file that this controller is going to use to route to our two services. So we'll do that next. All right, so back over in our K8s project. So make sure you have your K8s project selected. I'm just going to clear the terminal screen. I'm actually going to get rid of it for the moment. We don't need it just yet. And I'll clear down these other two files. So we're going to create yet another YAML file in here. So right click, new file. And I'm just going to call this ingress-srv.yaml. And this is, again, this is the routing file that the Ingress Nginx controller is going to use to determine how to route to our services. So it's really quite important. All right, so we're going to type all this out. I'm going to go slow. Don't want to make too many mistakes, otherwise it's going to be very, confusing and difficult to debug. So specifying an API version. This time it's slightly different. We want to specify networking.k8s.io/v1. So let me just double check that. API version networking.k8s.io/v1. Perfect. I'm going to specify a kind, and this time it's an ingress. I don't want all that autocomplete stuff, so I'll just type it in. Make sure I type ingress correctly though, so it's an ingress. Oh my goodness, I don't want that. So yeah, kind is ingress as opposed to deployment or whatever. Fantastic. And then we specify some metadata. Again, we will specify a name, and I'm just going to call this ingress SRV, and then some annotations. And we have two. And I tell you what, I might actually copy these in from my notes because they're just going to be very subject to typographical errors. And these are just a couple of helpers really that we're specifying that we want our controller to use. Okay, so it's talking about regular expressions, and yeah, we're using this ingress class for Nginx, which is the gateway that we're using. All right, so again, the code is on GitHub. So again, if you don't fancy typing this out, and I don't want to type it out on the video in case I make a mistake, and then it's just a whole nightmare going back and fault finding. So I've just copied those in. Have a go at typing them out, or you can just go to GitHub and do what I did there and copy them in. Fantastic. So we're going to come back under the main route or indentation layer. So underneath metadata, kind, and API version, we're going to specify the main spec and the rules or routing rules effectively. So indent rules, fantastic, indent again, and this is an array. So the first thing we're going to specify is our host. Now, like a lot of these gateways, they actually require a host name. They don't like localhost usually. They don't like IP addresses usually, and I did a whole video on the Envoy controller. It had the same kind of issue. Well, maybe it's not an issue, it has the same constraint, so you have to specify like a domain name. Now, we just want to really route to our loopback address or local host address. I know they're slightly different, but basically our local machine. But we do need to specify a proper domain name. So I'm just going to specify one here. I'm just going to call it acme.com. And we're going to have to update our hosts file, our local host file, to reflect that acme.com actually redirects to our local address. Okay, so we'll come back and we'll do that in a bit, but just bear with me for the moment. I'll just put that in here. Now you can put anything you like in here. Just remember what you put. If you're following along, I suggest for simplicity, you just put in acme.com like I have done here. All right, under host, we're going to specify it's a HTTP based routing rules. So again, HTTP is directly under host. And then we're going to specify an array of paths. Now this config, it doesn't get much, there's maybe about another 10 lines involved, so don't freak out too much. It's not going to get too much bigger, but it is quite a deep config file, and you have to be, again, I keep saying it, really careful about your indentation, making sure that you've indented correctly, because it can catch you out. So specifying paths, and there I've actually made a mistake myself here, so it's paths like that, and you can see it was actually complaining, so paths is indented under HTTP. Then under that we start to specify the individual paths that we want, so singular path. All right, so the first thing we want to attempt to route to is our platform's controller, a platform service. So the way we do that is just by specifying the route on top of the base URL. So anything on top of acme.com would be, in the case of platforms, would be API platforms. And then we specify a couple of other attributes. Path type is prefix. And then we specify something called the backend, and you can probably guess what that is getting at. Is what service basically are we trying to attach to here. Okay, so the backend, we specify the service, and we specify the name. And the name of the service basically is, if we come over back to our platforms deployment file, it's basically the name of our cluster IP. Okay, so we're going to copy that. So again, platforms deployment file, our cluster IP service, that is the name that we are going to put in here, and that's where we want to kind of direct this backend to. All right, and then port, tab in again, number is 80. Okay, so that's putting in a single route to our platform service at this path on port 80. All right, that all looks correct. So I'm going to create one more path, but this time for our commands service. So I'm actually going to type it out, because sometimes cutting and pasting can be more trouble than it's worth in a YAML file like this. So again, make sure you're specifying your next path as part of this paths array under this minus sign here. So we're going to specify another path, and it will get us used to doing this kind of stuff anyway. So this time the route is API /C. Now again, this is the whole reason I put this C identifier in the route to our command service, because it needs to be different from this, otherwise we're going to run into some issues. So again, platforms, path type, prefix, and then we specify the backend in a very similar kind of way. We tab in, specify the service, we give it the name. This time it's the commands cluster IP service, so we come back over to our commands deployment file and we come down here. We want this name, the name of our cluster IP service. So you can see this stuff is quite horrible, and again, the video I did on Envoy, to be really honest with you, I didn't really enjoy it. And I'm not particularly enjoying this either. I don't really like this stuff, to be really honest with you. For me, it's kind of configuring API gateways. I don't love it, to be honest with you, and it's so subject to error that yeah, it's not my favorite thing, to be really honest with you, but it's a necessary evil in this case. And again, we're specifying port 80. So I think that looks okay. There's no warnings in the actual file itself by the looks of it, so that's all good. I think we're ready to go. So I'm going to save that off, and then all we need to do is just run the kubectl apply command, which we'll do next. But before we do that, I'm going to go into my host file and I'm going to make sure that we have an entry for acme.com, but I'm going to do that in the next video. All right, so we want to update our host file now. Obviously, the host file is in a different location depending whether you're running on Mac, Windows, or Linux. I'm running on Windows, obviously, so I'm going to, browse to that location. I will put a link to where you can find your host file on those two other operating systems, but you can probably, to be honest with you, just Google that yourself. The result is basically the same. So I'm just running, as you know, obviously VS Code, so I'm going to just open my host file from within my K8's project. So file open. Now on Windows anyway, you have to basically open it as an administrator, otherwise it won't let you save the file. Or you can save it as administrator, which is what I'm going to do here. So open file first of all, and the location on Windows is on the C drive. It's in Windows, it's in System 32, drivers, etc, and then there's a few, what look like a few different host files, but it's this first one here, the one that just says hosts, and I don't believe there's an extension, so we just open that up. And we can see here that there's a few entries in here already. Now what I want to do is I want to put in entry for acme.com or whatever you've put in your ingress service file, and I want to just direct it to 127.0.0.1. And you can even see there's some stuff in here that's been put in by Docker Desktop as well to assist with networking. Okay, I'm just going to put this in here, and I'm just going to put in acme.com. So what effect this has is basically whenever we type acme.com into our web browser, it's actually going to look here first before it goes and does any DNS lookup elsewhere. So we're kind of hijacking acme.com. So just remember, of course, that you've done this in your host file, unless there is a site called acme.com that you visit frequently, maybe pick something else. So I'm going to save that, and I'll probably get the warning. So here we go. So it's failed to save, insufficient permissions. So I'm going to retry as admin. And I've just got a pop-up on my other screen saying, do I want to do that? And I've just said yes. Cool, so that should be as good. But what I'm going to do, just because I'm paranoid, is open it up again, just to make sure that that save took. Because I don't want to get through to deploying our changes and then find out that something went wrong. So Windows, System32, drivers, there we go, that's the wrong one, drivers, and etc. And I'm going to open my host file again. And yeah, the change took, so that's fine. So I just want to double check that that is there. All right, cool. So then all we need to do, as we've done many times before, is basically run or apply this ingress SRV file using our very familiar language so far. So just make sure you're in your K8s project folder. We'll do a listing and make sure you can see your ingress SRV YAML file. So again, it's kube ctl apply f, and I'm just going to apply this config. And there we go, we've got this ingress networking K8s IO created, which looks good. So the moment of truth, we want to try and test this now in Insomnia. And again, just coming back to our architecture diagram, I will just show us where we hopefully have gotten to. We want to try this thing here now. So external coming in through this Nginx load balancer, it's going to hit our ingress Nginx controller, and then depending on what route we put in, it's going to route off to either one of those. All right, so fingers crossed, this is a big moment for us. Now, again, what I'm going to do here is, yeah, we're actually running in the K8s environment. So again, yeah, I might want to specify something different here. So what I might do, because this is using the node port stuff, so I want to differentiate that. So I might just rename this and just call it platform service node port, just so I know those are the node port requests, which you may want to continue to use for fault finding purposes. So I'm going to close that down. Actually, these aren't in here, so we just put these in here, that's better. And I'm going to create another folder in here, new folder, I'm going to call it platform service, and I might just call it Nginx, which is really our gateway proper. All right, so I want to copy this or duplicate it, get our platforms and move it up here under this. So instead of routing to localhost 30,407, if we just put in acme.com here, and make sure we spell it correctly, it should route off to our platform service and pull back all our platforms. So drum roll, there we go, fantastic. So we've now set up successfully an ingress Nginx controller. Now, we can't quite test our command service yet because the only controller action we have is that stupid post command. Well, I suppose we could test that really, but I'm not going to do it here. We'll come on and we'll check that when we put in some get actions that we can route through to our command service as well. But I'm fairly confident at this stage, famous last words, that this is looking pretty good. Fantastic. So that's probably most of our networking type stuff done now. We're going to do a few bits of repeated setting up of cluster services and stuff. But by and large, in terms of new concepts, we're done. We're done with new concepts around Kubernetes networking. So it's a good place to be in. So we're going to start to move on to what I think now is a lot of the more interesting stuff. So then the next section, we're going to set up our SQL Server for our platform service along with some persistent storage. And we're going to get all that hooked up. And then beyond that, we're going to move into using RabbitMQ and all that really interesting, exciting stuff. So yeah, we're done in this section. Next section is going to be setting up SQL Server. So yeah, we're going to create our SQL Server now. So let's just check to see where that fits in terms of our Kubernetes architecture. So we've got to this stage now. We just created our Ingress Nginx controller in our last video. And now we're going to set up a dedicated SQL Server just for our platform service. And along with that, we'll create a cluster IP address. Now, something new that we've not encountered yet is another new concept. This is the persistent volume claim. Now, all this is something that we will put into the deployment file for our SQL Server that basically, as the name would suggest, stakes a claim to some physical storage, in this case, on my machine. So just staying on that theme for the moment, if we do a kubectl get storage class, make sure I spell it correctly, we have one storage class. So what's a storage class? Well, there's three concepts really when you're talking about storage. Well, three basic concepts you need to understand. The first one, and really as a developer, the main one you need to understand is the persistent volume claim, which we're going to create. Then you have something called a persistent volume, and then you have this thing called the storage class. So thankfully, all we need to create is the persistent volume claim, and that will use our system defaults, and ultimately we'll use this storage class, which is effectively, in our case for Docker Desktop, just our local file system. If you were using a more enterprise deployment of Kubernetes, say in Google Cloud, you would have to set up all of these things independently, and that's when you start to move into this more administration type role rather than the developer role. As a developer, all I'm really interested in is making a claim to some storage. Other than that, don't really care, to be honest with you. So I'm going to leave it at that, and we're going to move on and create our persistent volume claim in our K8s project. So yeah, in our K8s project, just right click anywhere. I'm going to do a new file, and I'm going to call this local, as it's going to be on our local disk, local pvc.yaml. So local persistent volume claim.yaml. Let me get rid of the terminal for the moment. And API version, and it's going to be v1. Make sure we put the colon in the right space. And the kind this time is a new kind. It's persistent volume claim, and I want to get the persistent volume claim. I don't want to type that, but I don't want all this default stuff. So let's, oh goodness. Actually, I can probably take most of this. I just don't like doing too much auto-generated stuff because it kind of gets a bit lost on everybody. So yeah, let me take this out. That's why I was getting confused. Okay, so API version v1. The kind is persistent volume claim. We are going to have metadata, and we're going to give it a name, and I'm going to name it MSSQL-claim. So Microsoft SQL Server claim. If I can spell claim correctly, that would be useful. And then spec, we're going to specify how this persistent volume claim is made up. So the first thing we need to specify is something called an access mode, or access modes, and it's an array. And I'm going to specify that it's read, write, many. So we want it to read, we want it to write. Then the next thing is our resources. And really this is where we're staking our claim to the storage resources or the persistent resources that we want to use. And it's resources, requests, and then storage. Typing's really starting to suffer now, and I just want 200 megabytes. I don't want a huge, massive disk size, so that should be fine for us. Now, this looks rather sparse, and indeed it is, and you can obviously specify more things in here. But for now, if we just leave it at that, Kubernetes is smart enough just to use the defaults, which will give us access to our local file system. So save that off, and then bring up your command line. We'll just clear this off, and we'll do a listing just to make sure we can see the local PVC file. And then as usual, it's just kubectl, apply f, and then the name of our file. And paste that in there. And you can see here that our persistent volume claim has been created. So if we do a kubectl get PVC, you will see that we have a persistent volume claim created. status is bound, we've got our access mode, which is read and write, we've got our capacity, and we've got our storage class here, which is host path. And if you remember from when we got our storage class, that is what our storage class is, host path. It uses it by default. So that's it really for the persistent volume claim. The next thing we need to set up just before we actually go on and create our SQL Server is SQL Server, when we set it up, will require a system administrator password. Now, again, for a lot of the config I've got in this tutorial, a lot of it is just stored in config files, which is not best practice, but again, in the interest of time, that's what I've done. But here, what I'm going to do, just to show you how you can use something called secrets, I'm going to actually create the SQL Server password as a secret in Kubernetes, and we're going to pull that in via a config file. So it kind of removes this idea that you're actually storing sensitive information in config files, which you generally don't want to do. So we'll do that once, and then we'll move on to actually setting up our SQL Server. All right, so let's just clear the screen here. And what I'm going to do here is I'm actually just going to issue this command, obviously, at our command line. I'm not going to create a file because, again, it would defeat the whole purpose of having something that's secret if you actually put it into a file, because then you just have the same circular reference of bad security. So we're just going to issue this at the command line and not store it anywhere. So it's actually a bit like user secrets. If you've used user secrets with .NET development, it's kind of similar concept to that. In fact, very, very similar to that. So at our command line, we're going to use kubectl, obviously. We're going to create a secret of type generic, and we're going to call it MSSQL. And we'll make use of this MSSQL name in a bit when we actually come on to creating our SQL Server. Then dash from dash literal, and then we specify basically a key value pair for the key and the value. So the key in this case is going to be SA_password, all capitals, and the value is going to be our password. And I'm just going to use, well, you can use whatever you like. I'm going to use this. So let me just check the spelling. I've checked everything is spelled correctly. So kubectl, create secret, generic, MSSQL, -- from literal SA password. That looks good. Okay, so we have our secret created. Fantastic. So we just make sure that we remember these two things here, this name here, and also the key that we defined. So now we're actually going to make use of this when we come on to creating our deployment for our SQL Server. So we'll move on and we'll make use of our secret as well as our persistent volume claim, and then we'll stand up a new instance of SQL Server. All right, so here's the main event of this section. We're going to create a deployment for our SQL Server. So I'm just going to get rid of our terminal because, believe me, we're going to need the room. This is it's actually the longest file that we're going to write, the longest deployment file by a mile that we are going to write. So in our K8s project again, right click, new file, and I'm going to call this MSSQL-plat, as in for our platform service. It's going to be dedicated to that. depl.yaml. All right, so we'll specify an API version of apps v1. And I need to be really careful what I type here because there's a lot of stuff going in, so I'll double check every line as I type. The kind, we've come across this before, is a deployment. And I don't really want that, so I'm going to just type it out, deployment. And the metadata, we're going to supply a name, and that is going to be MSSQL depl. So that's really the name of our deployment. So when you do kubectl get deployments, this is the name that will come up. And if you wanted to destroy this deployment, this is the name that you would refer to. All right, so nothing that we've not seen before. And again, we're going to come on and define the spec. So tab in. We're going to define number of replicas, so 1. And then we're coming on to the usual selector stuff that you've seen quite a few times before. We're going to use some match labels. And then we're going to call our app MSSQL. Just MSSQL. Okay, oh my goodness. Autocorrect. is quite annoying sometimes. Okay, so bring your cursor back under the selector, and we're going to define the template this time. Specify some metadata. You can probably tell I'm not a huge fan of YAML files. The only thing I do like about them is that you can put comments in, which you can't typically do with JSON, so that is their one saving grace. So anyway, template, metadata, labels, app, again, is MS SQL. So you've seen this selector template thing before. Okay, new line, and bring your cursor underneath the metadata, underneath template. Again, be really super careful. I can't really stress it enough. Be super careful about how you type this stuff in, because one mistake and it's game over. So we're going to specify the containers that we want, and again, this is an array. In this case, we are just creating one. So I'm going to give it a name of MS SQL, and then bring the cursor under the name. We're going to specify our image, and this is where we specify the Docker image for our SQL Server. So it's mcr microsoft.com/mssql/server : and I'm going to use the 2017 version of SQL Server, the latest version. Then I'm going to specify some ports, and we're going to specify the default SQL Server port, which some of you may know is 1433. So bring your cursor back underneath the ports, and then we're going to specify some environment variables, and this is where we're going to kind of inject in our secret along with a few other environment variables. So minus sign, we'll give the first one a name of MSSQL PID. Tab in and give that a value of Express. So basically that's saying we want to use the Express version of Microsoft SQL Server as opposed to the developer edition or whatever. And this edition is of course free. So we're going to create another environment variable, give it a name, and this one we'll call accept EULA, and the value is going to be yes. Now that's just accepting the license agreement as per, you know, Microsoft's usual kind of way of doing things. And then we're going to specify one more, and this is where our system administrator or our SA password comes into play. So the name is SA_password. And just as a matter of interest, if you were just running SQL Server, and I've done a few videos on this, if you were just running SQL Server in Docker without using Kubernetes, you actually have to pass in some, well, exactly the same environment variables as part of that. So if you Google SQL Server Docker, you'll actually see some very similar setup required just to run SQL Server as a container. So again, we're just doing that here obviously, but albeit in a Kubernetes deployment. So we're not going to specify an actual literal value, because again, that would negate the whole point of setting up a secret. So we're going to use this thing called value from. And where are we going to get our value from? We're going to get it from a secret key ref. Okay, take a new line, tab in again. What's its name? MSSQL. And again, well, if I bring up my command line, I should be able to, it should still be there, I think. It's basically this thing here, okay? The name that we gave it here. And then the other one is, here's SA password. So again, that's where SA password is coming in. Here's our key here. All right, so that's all that's pulling in. And the key we have to specify here is SA password. Okay, so the name of the environment variable is SA password. The name of the key that we gave it is SA password. Let me just highlight that. That's the same. That's cool. Okay, and that's it for our environment variables. So we need to take a new line, and we need to take our cursor underneath the env. Okay, and here we're going to specify volume mounts. And we're going to give it a mount path, and this is just the mount path of when SQL Server runs. Now we're actually running, this image here is the SQL Server running in Linux, so the mount path is going to be like a Linux-based path, and it's just really going to tell us where our database is going to reside, where our data for our database is going to be. So it's var opt mssql/data, and we'll give it a name of mssqldb. not DV, DB, B for Bravo. All right, almost there. Well, almost there for this part of it. We've still got the networking stuff to go. So we're going to bring our cursor out underneath our containers. So again, Visual Studio Code is quite nice. It does give you the kind of line marker to kind of help you not go too cross-eyed. And I'm just noticing here under volume mounts, I need to bring this back like this, and I need to bring this back like this. That's better. And volume mounts is underneath our env. That's correct. So yeah, this stuff is pretty painful. I will not kid you. I don't particularly love it. Anyway, okay, when I auto-generate it, it's actually doing that for me, but I'm going to leave it like that. Okay, so MSSQLDB is the name of this. And this is really where we're setting up our persistent volume claim. Persistent volume claim name. If I come back over here to our persistent volume claim, it's this thing here. This is the name that we want to, or the claim name that we want to use. So we'll come back over here. Claim name is that, okay? So you'll notice this pattern when you're doing these deployments. You reference other objects that you've created elsewhere, so you just have to make sure that you're creating the right thing. So I think that all looks correct. I mean, obviously when we run it, we'll find out whether it's incorrect or not, but I'm just checking it against my notes to make sure it's correct. Yeah, so I mean, it's kind of done some indentation that I've not used in my notes, but I think it will be okay. I think that should be okay. All right, we'll find out if not. So that's it for defining our SQL Server. You'll be very pleased to hear, but what we want to also do is create a cluster IP address so it can talk to everything else within our cluster. So down here, I'm going to take a new line. Now, as I don't particularly want to do too much more typing, I'm going to copy the cluster IP address spec from one of our other deployment files. So I'm just going to come over to our commands deployment, and I'm going to come down to where we specified the cluster IP address for that, and I'm just going to copy it. Now, obviously, we have to change some settings in it, but that's okay. That's preferable to typing it all out again. So at version v1, the kind is service. The name, we're going to change. And we're going to call it MSSQL cluster IP -srv. So the spec type is cluster IP. The selector, and again, this is where we want to actually select the thing that it's going to network, is basically this here. So we want to copy MSSQL and put that in here twice, basically. So I'll take this out, paste that in. I'll take this out, and I'll paste that in. Protocol is TCP, but the port and target port are both going to be 1433, which again is the default SQL Server port. All right, so that's good. Now, we could leave it at that, but I actually want to be able to access this SQL Server from my desktop. I want to be able to kind of drill into it directly. Now, we can't do that through our Ingress Nginx controller. We could create a node port. I think that would probably work, but there's another service that you can create called a load balancer. We've kind of already sort of seen it with part of the Ingress Nginx stuff. So we're going to actually create a load balancer service, which does similar stuff actually to the node port. It will allow us to actually directly access this. So let's go through and do that. Now, I think I can probably copy this, and we'll just change the relevant bits and pieces as we need to. So again, API version 1, it is a service. We will give it a name of MSSQL load balancer. Now, I don't have this on our architecture diagram. You might go, where is this on the architecture diagram? It's not on there. I deliberately left it off because I didn't want it to become too confusing. And we're actually, when we create a RabbitMQ server, we're going to do something very similar with it as well. We'll create a cluster IP and also a load balancer that we can use to access it. But again, I didn't want to put that on our diagram because it'd get a bit too confusing. Now, you don't have to do this. This is somewhat optional, but I think it's probably going to help us out, to be honest with you. Anyway, back to this. In our spec, we're specifying that it's a type load balancer. The selector is the same, MSSQL. And ports, we don't need to give it a name, so we'll take that out. But we need to put in the fact that this is an array. Oh, Now if we were specifying more than one port, we would need to give it a name, but we don't in this case. So ports, TCP, and again, we'll leave the ports exactly the same. That should work for us, I think. All right, so let's just do a bit of a review. This section is our deployment of our SQL Server. Hopefully we've typed it incorrectly. We'll find out in a minute whether it's not correct. Here's our cluster IP, which you've seen before, and here's this new concept, well, semi-new concept of a load balancer. So I'm going to pause here for a minute, and then we're going to come back and we're going to apply this deployment and see if we can access our SQL Server. All right, the moment of truth. Now make sure you save your file, and we'll bring up our command line again. We'll clear the screen, and I'll maybe move this up a little bit. Do a directory listing to make sure that you can see your MS SQL plat deployment. And again, you should be getting used to this now. kubectl, apply, F, and I'm just going to copy this in. And this is the moment of truth. If we made a mistake, we'll get an error here. Now that all looks good. So certainly the YAML that we've created is syntactically correct. So you can see here, again, you should be getting used to this now. A deployment's been created. We've got a cluster IP service created, and we also have a load balancer created. So let's do a quick clear the screen, and we'll do kubectl get services. And we should see our SQL Server load balancer available to us on localhost, and we should be able to access our SQL Server using one of these ports here. And then we have our cluster IP service, again, internal to our cluster, available on port 1433. Fantastic. And then if we do kubectl get pods, we should see that our SQL Server is still creating. Now it could well be that I don't have the SQL Server images getting pulled down from Docker Hub. So we'll just have to keep an eye on that. And hopefully we don't get any errors and it runs up correctly. Now I've found from my own experience, if anything is wrong with the persistent volume claim or anything like that, and you can't actually mount to the mount point, that's where I've had errors before, and it's caused me a few headaches, but I'm hoping that this gets created correctly. So maybe if I bring up the Kubernetes user interface, we can have a quick look and see what's going on here. So that's the pod running. I'm just waiting to see whether we have a SQL Server running. Not as yet, not as yet. So let's still container creating. So I think it must be doing some stuff in the background. So we're just going to have to wait for this, unfortunately. Let's have a look at that now. Okay, cool. So we have a SQL Server pod up and running. That's looking pretty good. And I'm looking on my other screen here. I've got my Kubernetes kind of user interface up and running, and I can see here that we have SQL Server up and running. That all looks pretty good to me. All right, so what I want to do, quick test, I want to fire up SQL Server Management Studio, and I want to see if I can connect in. So I'm just going to pull that onto the screen here. I'll just resize it, and I'll just connect. And what I want to select is localhost 1433, and I'm going to put in the SA password that we specified. Make sure I type it in correctly. And that's looking pretty good, actually. So we've connected in localhost port 1433, and yeah, we don't have any databases on there yet, which is, yeah, it's looking pretty good. So what I might do, just to test the persistent volume claim is working, although the fact that it's up and running suggests to me that it's working fine. I'm just going to quickly create a test database. It's just, doesn't matter what it is. And then we'll just create that, okay. I'm going to kill that. And then what I'm going to do is we're going to come back over to Kubernetes here, and I'm going to find our, not our pod, I'm going to find our SQL Server container, this one here. And as I've showed you this before, I'm going to kill it. Just delete it. Let's remove it. So it's gone. Now again, there it goes, this one sort of pinging back. As I've said before with Kubernetes, because we've told it via our deployment that we want one running SQL Server, it's going to basically do anything in its power to make sure that that is happening. Looks like we've killed that a few times. Don't think I can kill it anymore. And so what I'm wanting to see is the fact that when that SQL Server bounces back up, that it will be using the same persistent volume claim. Login. Great. And we open this up. And there we go. Our test database is still there. So you saw our container being destroyed and rebooted and all that kind of stuff. And we still have the database that we created. So we can delete this now. We don't actually need that. It was just as a test. Fantastic. So that's good. We've got our SQL Server up and running. We can connect into it externally using this load balancer concept. It should be networked internally. So now what we want to do is we want to actually update our platform service to actually use SQL Server. So we'll do that in the next section. All right, so with our SQL Server now up and running and accessible, which is cool, we're going to turn our attention now to our platform's service, and we're going to set it up so that we can connect to that SQL Server in production in Kubernetes. Now, I think as I mentioned before, when I run this service at the command line, .NET Run, I still want to use the in-memory database. So we're going to have to pick between are we in production, are we in development, and then pick which database we are going to use, or database provider we're going to use. Now, some of you might think that's a bit convoluted. There's various reasons why I made that decision. It's up to you. If you actually want to use SQL Server in development as well, you can absolutely do that. And the way we've set this instance of SQL Server up, as you saw, it's accessible locally as well. But I'm choosing not to do that, and I'll leave it over to you if you want to follow that along. But I suggest if you're following along, you go with what I'm doing here. Anyway, with that being said, the first thing we want to do is create a connection string for production. So with that being said, we're going to come over to our app settings.production.json file, and we're going to add in a connection string that will allow us to connect in to our SQL Server running in Kubernetes. So comma at the end of this attribute here, and then we're going to specify another one called connection strings. Okay, and then take a new line, and then we'll specify, you could specify multiple connection strings here. I'm just going to specify the one that we want. I'm just going to call it platforms con. Doesn't really matter, to be honest with you, as long as it makes sense. So platforms con, platforms connection, and then we specify the connection string. Now this is a connection string for SQL Server. If you were using some other database like Postgres, it would be slightly different, similar but different. The other thing I'll say here is be really, really, really careful that you type everything in absolutely correctly, because this is the type of thing that will cause all sorts of issues if you don't get it absolutely precisely correct. So can't stress that enough. Anyway, I'll do a Control B just to give us a bit more room, and I'll start typing out my connection string. So server equals what? That's the first sort of stumbling block. What is the server we're connecting to? Well, if we come back to our K8s project, K8s, there we go. I'm getting confused, too many projects open. So over in our SQL Server deployment file, here's our deployment of our service, but here is our cluster IP. And again, similar that we've done before, we want the name of our cluster IP service. That is basically what we are connecting into. So come back over here and we'll specify that as our server name, comma, and then the port 1433, then a semicolon. So this is basically our server configuration. We're then going to specify the initial catalog, and that's basically the name of our database. So I'm just going to call that platforms DB. Semicolon again, we're going to specify the user ID, and I'm going to make that equal to the SA account. Now, typically you wouldn't use SA in production. In fact, you wouldn't ever use it at all. Again, just for quickness, I'm deciding to use it. And likewise with password, you wouldn't typically put a password in here, but again, just for quickness, I am going to do that. But calling out is not a great idea. So we produced a secret for our SQL Server, and we read that in from the deployment file. You could do something very similar with this, and you could actually inject environment variables into our platform service. But again, it's kind of taking us away from the core of what we're sort of looking at. So I'm just putting it in here, but yeah, just be aware, it's probably not a fantastic idea to do so. And I'm just going to put a semicolon at the end there. I don't think it matters too much, but I'm just going to do that anyway. So that's our production connection string available. Next thing we want to do is come into our startup class and configure it so that it will work with either the in-memory database, or if it's in production, use SQL Server and use this connection string. So we'll do that next. So still within our platform service project, I'm just going to do a Control B to bring up our directory listing and come over to our startup class, and Control B again to bring it down. Now, as you'll remember, within our configure services method, we already set up a DB context that uses the in-memory database, which we want to retain, but we also want to add one in now for SQL Server, but not use them both at the same time, as that would be rather confusing. So we want to be able to switch between them depending on what environment we're running in. Now, in order to determine what environment we are running in, I need to inject something called a web hosting environment into our startup class up here and get access to the environment that way. So I'm going to do that first. So in our startup class, in our constructor, I'm going to inject in an iWeb host environment. I'm just going to call it env. Now, this is available to us. There's a few things like configuration, like web hosting environment, that are available to be injected into classes at any point in time. We don't have to set them up within configure services, obviously, because that would be a bit of a circular reference. So this is available to be injected, so you don't need to worry about any other setup from that perspective. And then over here, we'll just declare as usual a private field that we will assign our injected instance to. So again, Control period to generate the read-only field, and it puts it down here. Now I'm just going to move these two things up above our class constructor. Don't ask me why, I just think that's where they should sit. That's just my own preference, though. You don't, of course, need to do that. Fantastic. So that gives us access to this env object, where we can now use it to determine whether we're running in production or not. So coming down into configure services, I'm going to create an if statement, and I'm going to make use of our env object, and I'm going to make sure it's an underscore env, and I'm going to determine, is it production? And if so, we want to set up our SQL Server. If not, then we will just use our in-memory database as a bit of a catch-all. All right, fantastic. So all we want to do now in here is set up our DB context that uses SQL Server. Now, what I might do in here is just do a console write line, just so when things are starting up, we can see what is being picked up, and this will come in very, very useful if we start to hit any problems. So I'm just going to say using inmem db. All right, and then likewise, I might actually copy that up here, and I will say using SQL Server. Using SQL Server DB, cool. And then all we need to do is just set up a DB context. So using our services collection again, we're going to add a DB context. DB context, it's going to be exactly the same DB context. So app DB context, fantastic. And likewise, we're going to use some options. You can see it looks incredibly similar to what we've already done for our in-memory stuff. I'm going to tab that in, and I'm going to say OPT. So instead of use in-memory database, I'm going to use SQL Server. And then I'm going to pass in the connection string. If you don't get use SQL Server, you might have to add a namespace by doing Control period and bringing that in if you don't have that already. And then in order to get our connection string, all we have to do in here is make use of our configuration object, configuration, get connection string, and I say this is why you actually wanted to call this thing connection strings and give it that exact name. That allows us to use this get connection string method. And all we need to do is supply the name of the connection string we want to use. So we'll come back over here and we'll copy this in. All right, fantastic. Save that off. So if we're in production, we'll use SQL Server. If we're not, then we'll use the in-memory database. So what I'm going to do, just as a quick test, I'm going to run this now, and it shouldn't make any difference now. Should still be using the in-memory database. Shouldn't get any errors. all looks good. So again, we're using the in-memory database, we're connecting, seeding data, all looks good. Shouldn't really have made any difference at this point in time, which is looking great. So the only other thing that I want to be able to do is apply migrations when our database starts up, if they've not already been run. And I want to do that from within our prepdb class. We're going to have to actually create some migrations, which we will do at our command line. We have to do that anyway. And then the application of those migrations, we can either do at the command line, or we can set up our class to apply those migrations. So I'm going to set up our class to do it, which makes things a little bit more complex, but I think it's probably a slightly better approach. So before we generate any new migrations, what I want to do is I want to come back over to our prepdb class and get it to apply migrations, but only if it's running in production. If you try and apply migrations when something is running in development, and therefore using the in-memory database, it's not going to like that. So we have to again make this kind of determination when we apply migrations that we're only doing it when we're running in a production environment. So we'll do that next. Okay, let's do a Control B and go into our data folder and select prepdb, and Control B again to bring it down. So where I want to actually apply our migrations is when we come to seeding our data. I want to just put it above this section here where we seed data. And I want to be able to determine whether we're in production, in which case we apply migrations, or we don't. So the first thing I want to do is determine if something, and we don't know what that is yet, maybe put a question mark in there. If that's true, then I want to use our context, and I want to access the database, and I want to run migrate, and that will migrate our migrations, which we've not yet created. We still need to actually create and generate our migrations, but assuming we have those, that will run our migrations. So here I want to basically understand whether we are running in production or not. So how do we do that? Well, the quick way I'm going to do it is by coming back to our startup class. And when we call this method here, additionally, I'm going to pass over, again, we have access to this env object here. I'm going to pass over env is production. So if it's production, we're going to get a true here. I'll save that off. It's erroring out, obviously, because that's not what the method signature currently is. So if we come back over here, up to our method signature, which is prep population, we're going to expect it to take in a boolean of prod. Or maybe we call it isProd. Slightly better. So isProd. If it is, obviously it's true, then we want to percolate that down, if that's the right expression to use, down into our seed data method. So we're going to expect that also to take a bool called isProd, and then finally up here, along with passing over our DB context, we're going to pass over our isProd value, and that should hopefully stop everything from erroring out. And then finally down here, we'll just say isProd. So if it's in production, we'll migrate, otherwise we won't do anything at all. Now in here, I'm going to put a console write line just to let us know that we are applying migrations. So I'll say something like applying, or attempting to apply migrations, ... Okay, and we probably should put this in a try catch block, because potentially this is something that could go not quite right. So we will do that. I will say catch an exception, and we will then write out console write line. We'll use string interpolation, and we'll say could not run migrations, and we'll give the reason, so curly brackets, ex message. All right, so I think that's us covered. Now again, I'm going to save that off, come back to our startup class. This is still going to get called. It will be running in development, so I just want to run it again and make sure we've not broken anything. So we shouldn't see applying migrations or anything like that. It should all be totally benign. So we come over here, yeah, we just see seeding data using a memory database, so that's looking good. Hopefully, when we do come to deploy it into Kubernetes, that will kick in and it will apply the migrations. Fantastic. However, there is one thing we still need to do. And I actually forgot to do this, and I had to come back and re-record this. I don't know why I forgot it, but I did forget it. And the thing that I forgot to do was actually generate the migration. So if you've worked with Entity Framework before, you will understand that you have to do a generate migration, and that actually generates a folder within our, if I do a Control B, that generates a folder within our structure called migrations, and it actually has the instructions that we will run against SQL Server in this case. And I didn't do that, I forgot completely about that, and ended up in all sorts of trouble. So we need to do that first. We need to do that now. So we're going to do that in the next section. A little bit convoluted, but we'll get that up and running, and then we're then ready to push this all up to Docker Hub and redeploy our platform service, and fingers crossed everything should be working. But let's generate our migrations next. All right, so we want to generate our migrations now. So the way that you will do that is we come back to our project and do Control backtick. We'll do .NET EF, don't forget the EF, migrations, add, and then you give your migration a name. So we'll call this initial migration and see what we get. Build start, build succeed. We get some horrible looking error. So without going into too much detail, I was expecting that to happen. And the reason that's happening is because Entity Framework Core thinks we're using an in-memory database, and we are in fact using one, and it just doesn't support migration. So we need to basically trick, if you like, our command line into thinking that we're actually using a SQL Server database or some database provider that supports migration. So there's a few things we need to do here, and it's a little bit kind of convoluted. And this is where you might come to the conclusion that you want to use SQL Server in both cases, in both production and in development, because it actually would make this a lot simpler. And all we need to do is just change our config file, which we're going to do. We're going to have to do that anyway as well. So again, this might be an inflection point where you go, I don't like what I've done here. I want to use SQL Server everywhere. That's entirely up to you. But I'm going to keep going with this because, to be honest with you, it's good practice. It's a good bit of learning to understand what we need to do to kind of fake this a little bit. So all I'm going to do is I'm just going to take out or comment out this if statement. And we're not going to even determine whether we're running in production or not. And this, again, this is only to get our migrations up and running. We'll uncomment all this again, don't worry. So at the moment, uncomment that out, we're going to be using a SQL Server. All right, and we'll come down here and I'm going to just comment that out. I don't need this to run. I don't want this to run just yet. So I'm going to save that off as well. Now, the only other thing is it still thinks we are running in a development environment. So it's going to come to development settings and see if we've got a connection string. And in fact, we won't. We've only got one in production, and this will not get read in at all. So we're going to have to come over here and we're going to have to copy this. And we're going to have to put it into our development settings as well. The only thing though is this will not work. This is only for use when we are within the Kubernetes cluster. So we're going to have to change that. Any ideas to what? Localhost. So that should be enough. I'm just going to come back to our startup class and just double check. So we've commented this out. We don't want that to run yet, and we don't want to make that determination. We just want to use SQL Server. All right, so control back tick. We'll do up key, and we'll see what we get now. Fantastic. So that all looked good. We're using SQL Server DB because we forced it to. And what you should see over here is this migrations folder has been created for us. And inside of here, you can see that we actually have our migrations being created. And it's basically just a list of instructions telling SQL Server how to create our tables and all that kind of stuff. So that's cool. We've got that now. So what we can do now is we can roll back the changes that we sort of hacked there. I'm going to use that term. And we can have a attempt now at packaging this up, pushing it up to Docker Hub, and then running it in Kubernetes. And we will see what we get. So again, we're going to go back to this setup here, and yeah, it will run in memory, in development, and it will run SQL Server in production. When it does that, we'll come down to prep population, and it will actually attempt to run these migrations that we've now created and migrate our database. And if it's successful, then we will see the creation of a database in the SQL Server. So getting quite exciting now. So I'm going to pause here for a minute, and then we're going to build this image, push it back up to Docker Hub, and then redeploy our platform service deployment. And we should see everything come together and working as we're expecting. So we'll do that next. All right, so back over in our project, just at our command line, we are going to build our platform service again. So just do a directory listing to make sure you can see the Docker file and make sure you're in the right space. And then as usual, Docker build t your Docker username, name of the service, and then the build context, which is just where we are at. So a period, so platform service. And again, you know, I can't say it again, can't say it more times. Be really, really careful every step of the way that you spell everything absolutely correctly. One small mistake and things won't work. And I absolutely said it before, guarantee you will make mistakes. So, and if you do get problems, it's more than likely going to be some stupid typo somewhere. I've done it plenty of times, so you will not be alone in that if that happens to you. So we'll just let this build. Cool, that looks like it's built okay, and then we're just going to push it up to Docker Hub. So take out the build context, take out the -t, and we'll just put in push, and we'll push it up to Docker Hub. And then the proof of the pudding is going to be we'll do that rolling restart of our deployment, because as far as Kubernetes is concerned, the actual deployment file for our platform service hasn't changed. We've not changed that. We're just going to do a roll restart so it pulls down the latest image, and we'll see what we get. We'll find out at that point whether we've made a mistake. All right, so that's pushed up. Now what I'm going to do is just come over to Docker Hub and just check that it was updated. Now the reason I like to do this is just in case I maybe misspelled the service name and spelt platform wrong, and we had platform service as well as platform service or something silly like that, which I have done before. And then when you do a rolling restart, you're not actually applying the new image down. And then of course you can come over here and you can have a look and see when it was last updated, and it did say a few seconds ago, and we don't have any weird duplicates or anything like that, which looks all good. All right, so with that being done, I think it's time to move on and actually do a roll restart and see if our migrations are applied to our SQL Server running in Kubernetes. And if we get that working, it's another big massive tick. So we'll do that next. So I will just minimize this, and we can do this from any command line actually. We don't need to do it in our K8s project or anything like that. So let's just clear the screen here. Let's just do a kubectl get deployments. And you can see here we have our 3 deployments, which is looking good. And we want to basically refresh, roll, restart this one here. Okay, so as before, we've done this before. And again, just to labour the point, the reason we're not going into our K8s project and doing a kubectl apply is because from a Kubernetes perspective, it doesn't think the deployment's changed. That deployment file stayed exactly the same. So we have to do this roll restart. So kubectl rollout restart deployment, and then we just copy the name of the deployment we want to restart. And it's been restarted. So clear the screen, kubectl get pods, and you can see here we've got this container creating for platforms, so the new container is being created. And we'll just keep an eye on that, and hopefully we don't get any errors. Give it a couple of minutes to find its feet. And unfortunately, we get an error. So that isn't looking too good. So let's come back over here to Kubernetes and let's find the, let me see what we got here. Okay, could not run migrations, login failed for user SA. Okay, that's interesting. So maybe I've done something silly and misspelt the password for our SA account. So let's come back over to our settings in production and let's have a look and see what we have over here. And indeed, I have spelt the password incorrectly, as you will see here, which is really, really annoying. But again, actually, I could have edited this out and pretended it didn't happen, but it's probably going to happen to you. Certainly happened to me. So there should be an exclamation mark on the end of that. Oh my goodness, how frustrating. So we'll save that off. That should be right. Now, we could test this locally, actually, by doing kind of a similar thing to what we did when we generated our migrations and make sure that we can connect in locally. Probably could be a good idea to do that now, but I'm going to be brave, not do that and be a bit foolhardy. So what we'll need to do, and what I'm going to do, is I'm going to kill that deployment because it's a bad deployment. It's not working. So let's do a bit of error management here. So I'm going to do we've already got our, that's our pod. So let's do kubectl get deployments. And we can see we have this deployment and it's just, it's going to be in a bit of distress. So we'll do kubectl delete deployment, and I'm just going to delete this. All right, so that's deleted now. So get our deployments, it's gone. If we get our pods, we have a terminating platforms deployment pod. So that's all good. So that's gone the way of the dodo. So make sure we're still in our platform service. We'll do a directory listing, make sure we have our Docker file. We're going to have to do that whole deployment step again. Now you can automate this, but again, I think when you're learning, I think it's good to go through this pain at least once or twice and you will be very, very sure not to make these mistakes again. So we'll do a build. So Docker build tag, and then it's binary, in my case anyway, binary thistle /platform service. Okay, I'm just going to double check that, make sure I put the build context in. Yet platform service, cool. Let's hit enter. Build that. And that's built, and then we'll just push it up to Docker Hub once again. So let's take out this T and we'll change this to push. All right, we'll push up to Docker Hub again. Now, because we don't have a deployment now, I've destroyed it, we don't have a platforms deployment, we're going to have to go back into our K8s project and we're actually going to have to reapply our deployment, okay? Because there's not one there. So you'll see it being created. So again, there's two distinctions there. If we have a deployment and it's running, you do the rollout restart. If we don't have any deployment, we have to do the application of the deployment. So we'll do that. Fingers crossed this time, we'll see what we get. All right, so that's been pushed up. Now again, I'm going to double check Docker Hub to make sure that it has been pushed up. So let's just refresh that. Fantastic, and we'll come in here and we will see it was updated a few seconds ago. And you can also see the count has been incremented. All right, so we do now need to actually go over to our K8s project. So let me just find that. That's this one here, and do a control backtick, and we'll do a directory listing. And we want to redeploy, yeah, we actually basically want to deploy as if we were doing it for the first time, this deployment here. So again, just to labour the point, kubectl get deployments. We don't have a platforms deployment, so kubectl apply f, and we'll copy, should I say, this file here. Paste that in. And what you'll see is that our cluster IP service is unchanged, which is correct. That was already there, and our platform service deployment wasn't there, so it's being created. Great. So kubectl get deployments. Actually, let's do a get pods because that gives us a bit more detail. So we'll see container creating. And hopefully we don't see that dreaded error. There's nothing worse actually when you see that. It's kind of, your heart sinks a little bit and you think, oh my goodness, what have I done wrong? But it's all part of learning, so it's just part of how things end up being. So we'll check it again, and it's running this time. That is looking good. Let's do it one more time, because I find sometimes it can run. Maybe I spoke too soon, and then it's still running. That's good. So sometimes it can be a bit cheeky. You can do it, get pods, and it's running, and you're all happy. And you just do it again, and it's gone into an error state because it's actually failed. But that looks pretty good. Okay, fantastic. So what we'll do is we'll come over to Kubernetes now. That's not the wrong one. It's Docker Hub. It looks a bit similar. They're using the same color scheme, so that's why I'm getting a bit confused with it. So let me bring that onto the screen here. And we'll do a quick look at the terminal window to see what we get. So here's our platform service deployment. And we can take a quick look at some of the output that we're getting here. We can see, if I scroll up, yep, we're using SQL Server database. We're attempting to apply migrations, all looking good. And then we're seeding data into our database. So looking pretty good, I think. So the proof of the pudding really is to come back over to SQL Server and refresh it. Refresh this. There we go. We've got a platforms DB, and we should have platforms table. If we do a new query, we should have our seeded data in there as well. So just make sure if you're using this tool that you change it to platforms DB up here. And we'll do a select everything from platforms. Great. Indeed we do. That is looking pretty good. And then if we come over to Insomnia, and I'll bring this up, make sure you're using the K8 version. We can do get all platforms, and that's all looking good as well. Now what we might want to do if we want to be really, really brave is we want to do a create platform, but this time we'll just duplicate this. And we'll move this into here, and we will just copy this URI into here, and we will create Docker in our database, and that will be the full proof that everything is working. So that's looking good. We get a 201 created. We'll do a get all platforms from here. It's looking pretty good, and then we'll just come back to our SQL Server Management Studio, and we'll just execute that, and it's there. Quite a long section, but a very worthwhile section. So we've got SQL Server up and running in our cluster now. We have using a persistent volume claim, awesome. And then we have changed our platform service to make use of SQL Server, and it's running in Kubernetes, but to still use an in-memory database when it's running in development. So a little bit of a nuanced setup. Fantastic. So what we are going to come on to doing next is we're going to revisit our commands service, because it's very, very bare bones at the moment. It just basically has that one test endpoint in it. So we're actually going to build that out to be a more fully featured service. You'll probably be quite pleased to hear we're not going to go down the route of provisioning its own SQL Server. We're just going to continue to use an in-memory database for that, because we've covered that already. And maybe as a challenge for yourself or a bit of homework, you can do that. You have all the information now to be able to stand up a SQL Server just for command service, and I'll leave that for you. But yes, in the next section, what we're going to do is revisit our command service and then kind of get it up to speed as a proper service. And then beyond that, we're going to start looking at more interesting messaging between the two services in a proper microservices style. So we'll do that next. Okay, so before we begin coding, let's take a quick look at the endpoints we're going to have to build, stand up in our commands service. Now this conversation is really more a REST conversation as opposed to a microservices conversation. There are some kind of crossover touch points, but for the most part, this really isn't anything really to do with microservices. This is really to do with the fact that our commands service is going to be dealing with two models. A commands model, as you would expect. In fact, let's take a look. A commands model, as you would expect, which will store the command line snippets, but it's also going to have to deal with a platform model. Now, where microservices conversation comes into this, obviously, we are going to spend a lot of time figuring out how to get platforms from our platform service down into our command service, and use this concept of eventual consistency, where We have something created in one service, our platform service, and it's somehow replicated or transmitted or event-driven, whatever, down to other services, in this case, our command service. So that's the microservice problem. Taking that aside for the moment and just looking at this purely from the lens of the command service, the command service is going to eventually have platform data, okay? We will solve that problem. So let's say the command service is going to have platforms and it's also going to have commands, okay? And so what we're really talking about here is how do we enable our command service to work with multi-models? Now, when we talk about just about platforms, a platform you could almost think as the parent resource in this case. And again, our command service is not responsible for creating platforms or anything like that, but what we will allow it to do is allow someone to return the platforms that it is aware of, okay? So that is what we're going to do next pretty much, and we will put that into our existing platform controller. And you'll remember we did create a platform controller with a test endpoint just to test connectivity. So that's fairly straightforward. But the whole point of this section is really saying that a platform is effectively the parent of a command. And maybe putting it another way, a command cannot exist outside a platform without a platform. So as you can see here with these next three endpoints, they're all going to be part of or reside within the commands controller, which we will set up. And probably the most important thing that you'll note here is that the route for all our actions is going to has to contain the resource ID for a valid platform. So for example, taking a look at how we're going to create a command, we cannot create a command without a platform. Hence, we have to provide a resource ID as part of the route when we are creating a command. And the same rules apply for when we are retrieving commands or even retrieving a specific command. We have to do it in reference to a platform. So again, that's it really for this section. It's really just to get you up to speed on the fact that this is how we're going to have to create our commands controller, and it's going to make reference to valid platforms as part of the route. Yeah, so gets you across that, and hopefully it made sense. If not, then we are going to come on to coding next, where hopefully it will become much clearer. So why don't we get started? All right, so we're coming back into some familiar territory now and back into a more coding type structure, which I personally prefer. And we're going to make sure we're in our commands service project. Now you'll remember, it's been a while, fairly basic. In fact, we didn't really do too much with it at all. All we had was this platforms controller where we had a test post-event just to make sure that we could communicate between our services. And that was all we did with it. We don't really have anything else in here. We did, of course, have a Docker file, which we need, and that's not going to change. But other than that, very, very, very basic, even over in our startup class. I don't believe there was too much here. In fact, I didn't even take out the default comments, so I'm just going to do that, which I usually like to do. All right, fantastic. So the first thing we're going to do is create our models. So over in the root of our project, right click, new folder, models. And the first model we're going to create is our platform model. So new file, platform.cs. So we'll create a namespace of command service, and this is models. Fantastic. And we're going to declare a public class called platform. And then we're going to define some properties. So prop, integer, tab across, we'll call this ID. Fantastic. And then prop, we'll call this, we'll give it a type string, and then we'll call it name. And we'll leave it there for the moment. Now what we might actually want to do, and in fact what I might do, is I might put another property in here, an integer, and we'll call it, I don't know, external ID. And that's going to be the primary key of the platform from our platform service, because we might want to keep track of what that is, possibly. So we'll stick a pin in that for the moment, but we'll use that. So this is really a reference to any unique ID that we get given by the platform service. We may want to track that. And of course, we have our own unique database ID, which we'll use kind of internally. That's it for now. The other model we want to create is our command model. So right click in models, new file, and we'll call this command.cs. So namespace, command service, models, and again it's a public class called command. And we'll define a couple of properties on it. First one is an integer, we'll call ID, all good. And then the next one, we'll make a prop. This time it's a string. We'll call this one how to. So how to do a particular activity, such as build a .NET project. Next property, we will have that also as a string. Not a string, and we'll call that command line. And then we'll have a few more properties. It's now an ID, and this one is our platform ID. So this is the kind of foreign key reference back to our platform parent, if you like. And then finally, we'll create a public platform of type platform. I didn't quite do a property there, did I? But never mind, I'll fill it out manually. Now this is basically what's called a navigation property, so it allows us to kind of navigate between commands and platforms by providing a reference to our platform there. Now while I remember, let's jump back over to our platform class, and we want to also, in here, make a reference to the fact that we have a collection, or can have a collection, so we'll use iCollection of command objects. So again, this is navigating the other way, and we'll call that commands get and set, and we'll make that equal to a new list of command objects. All right, so we need to bring in a couple of namespaces and correct our spelling. Collection, using system collections generic. I think that should be enough, yeah. So there we go. And the other thing that we do need to do, which I hadn't done, is we'll need to annotate these attributes as well. So I want to make sure that the string, or the name, sorry, is required. We'll make sure the external ID is also required. And we'll make sure that this is required. And I'll also specify that it's a key, and we'll bring in the namespace for data annotations. And that all looks good, so we'll save that off. And then back over in our commands, likewise, we will make this required. We'll also make it the key. Our how to will be required. As with our command line, it wouldn't be a terribly interesting command if we didn't have a command line snippet in there. And then likewise, our platform ID needs to be required. Okay. And we'll bring in the namespace for that. And that should resolve. Fantastic. So I'll save that off. And we'll do a control backtick, and we'll just do a .NET build just to make sure we didn't introduce any strange errors into here. That all looks pretty good. So in the next section, again, with this service, we're just going to use an in-memory database, but we still need to add a database context. And actually within our DB context, we want to set up we'll specify explicitly some relationships between, or a relationship between our platform model and our commands model as well. Entity Framework does a lot of that for us, but if we want to be really explicit about it to make sure we get the exact behavior you want, then you should set up those behaviors, and we do that within our DB context class. So we'll do that next. All right, so we want to create our DB context now, so let's just get rid of this, and back over in our command service, like we did with the platform service, we're just going to right click, new folder, and we're going to call it data. And in here, we're going to create a new file called appdbcontext.cs. And this is, well, the first bit is exactly the same as we have already done for our platform service. So namespace, command service, data, and we're going to declare a public class called app.dbContext. And it's going to inherit from dbContext. And we'll bring in that namespace with control period. And then curly brackets. We then want to declare a constructor. So CTOR, tab into this, and we want to declare some dbContext options, and of what type, app.dbContext. And we're going to specify some options. Again, exactly as we've already done for our platform service. All good. And then likewise, we're going to do a couple of properties, dbSet, so type dbSet, and it's going to be dbSet of type platform. Let's bring that space in using command service models, and we'll call that platforms. And then we get a second prop. Again, it's a dbSet of type command, and we're going to call that commands. Fantastic. Now, as I said just a little while ago, that should be sufficient, and Entity Framework Core does a pretty good job of wiring up the relationships using its defaults, but just to be on the safe side, I'm going to explicitly declare the relationships between these two entities, because the naming conventions can be a little bit weird when you leave it to Entity Framework Core. So I'm just going to explicitly declare that here. And the way you do that is, yes, within your DB context, but we just need to override a method. So protected, override, what are we overriding? Well, void first of all, and then we're overriding on model creating. And we pass into that a model builder. We'll just call that model builder. And using this model builder, we then specify the relationships we want to declare on our two entities, two models. So entity, first one we're using is platform. And then we just declare the relationships. So we'll say has many. And then we will use a lambda expression. So P goes to P commands. So platform has many commands with one. Again, using a lambda, P goes to P platform. Put the exclamation mark in. And then finally, whoop, has foreign key. Lambda expression again. Platform ID. And we'll finish that off with a semicolon. That all looks pretty good. And then we kind of do the reverse, going the other way from, for our command. So model builder again, specify the entity we're working with, so type command. Fantastic. And then we just specify it has one. And we use a lambda expression again. P goes to P platform with many. So it's kind of the reverse relationship definition effectively. Commands. And then finally has foreign key. P goes to P platform ID. Fantastic. So we can save that off, and I think that all looks pretty good. So again, we'll just do clear the screen here, and we'll do a .NET build just to make sure that's all humming along nicely. And it is fantastic. So we're going to again use the repository pattern here. So in the next bit, the next section, we're going to add a repository. So we'll do that next. All right, so let's close this down. Let's get rid of our DB context, and still within our data folder, we're going to create our repository interface. So right click data, new file. We're going to call this I command repo.cs. Namespace as usual, command service, oh, not models, data. And then we just declare the interface as public. Interface, we'll call it I command repo. So again, because we'll be using a database, we want to specify save changes, which, you know, we always technically have to do. So save changes. And then I'm going to create a number of method signatures here, and there's some that most of them will make sense, and most of them will service those endpoints that I showed you in the slideware, and there's going to be one that wasn't there because it's not actually an endpoint that we're going to expose via our HTTP controllers, but it's something we're going to have to be able to do when we come on to doing the microservice asynchronous messaging, and that is adding platforms into our database, platforms that we're going to get somehow from our platform service. And that's when it really starts to get exciting. So anyway, let's begin. So the first method signature I'm going to declare is a IEnumerable of type platform. A few namespaces to bring here. I'm just going to call it get all platforms. Okay, so that will allow us to get all the platforms from our command service, the ones that it knows about anyway. So let's bring in these namespaces, systems generic, systems collection generic, and our models namespace, fantastic. Next one is going to be a void, and it's going to be called create platform. So again, we are going to eventually need to create platforms in our database, and we will do that generally by getting that data from elsewhere, from our platform service. So yep. It will take a platform object ultimately. And then we need to create this method as well, platform exists, and you'll see how that comes into play a little bit later. And into that we are expecting to pass a platform ID. So basically this is just checking to see whether this given platform ID does exist within our collection of platforms, and we will use this quite a lot actually throughout the rest of the course, and we'll see how that comes into play a bit later. So this stuff is really all about the commands, so I might just actually, you can read the code I suppose, but I might just put platform, sorry, this is all about platforms, not commands. This is platform related stuff, even though it's in our command service, and this next range of methods are really about our commands, and these ones really relate to the endpoints mostly that I showed you on the last slideware. So the first one is going to be an IEnumerable. It's going to be a type command, so it's going to return a list of commands, and we're going to call it get commands for platform. And it's going to expect a platform ID. So we give it a platform ID, and we're going to give it back all the commands that relate to that platform ID. The next one is going to be returning back a single command. We're going to call it get command, and into that we are going to expect a platform ID, but also a command ID. So that's giving us an individual command, if you remember from the routes that we had on the slide. And then last one, possibly the most important, well, as equally important, is void create command. And into that we're going to expect the platform ID of the platform that we want to create the command on, and then a command object called command. And that's our full range of method signatures that this interface needs to provide for us. And if we just come back just over to this slide here, you'll see here that we have most stuff relating to, so we got something that will give us all our platforms, and then these are our three command-based operations here, getting all commands for a platform, getting a single command for a platform, and then creating a command. And the only one that we didn't have on there is this one here, creating a platform, which we do by other more mysterious, more interesting methods. Fantastic. So that's our interface done. We'll move on now to creating an implementation class for our I command repo interface. All right, so we're going to create our concrete implementation class for our command repo interface. So right-click Data, make sure I've selected that, right-click Data, New File, and we'll call this command repo.cs. So namespace, command service.data, and it's just a public class called command repo. And we're going to implement our iCommand repo interface. Fantastic. And so just click in here, control period, implement our interface. Just before we do actually fully implement it, we've only got placeholder stuff here. I'm going to first create a constructor, so CTOR, and I'm going to pass in an app db context. T in there, and we'll call that context. And we will assign that to a private read-only field called _context. Fantastic, and as usual we need to create that, of course, so control period and generate read-only field. Perfect. So let's move down to the bottom and we'll start working our way up the top. Start with the simplest ones first, so save changes. Again, we need to call save changes anytime we add or delete anything from the DB context, and so it actually gets pushed down to the persistence layer. So context, save changes, and we'll return true if the value of save changes is greater than 0. How many things we have affected or impacted. We'll return true. Next one is whether we have a platform existing in our collection. So we'll pass in a platform ID and return either true or false based on whether something exists. So return context again. And this time we're going to look in our platforms collection and we're going to see if we have anything at all in there matching the following criteria. So control period to bring in the link. And so quick lambda expression, so P goes to P and we will look for the ID and see whether it's equivalent to the platform ID that's passed in. And if so, we'll return true. If it doesn't find anything, then we will return false. Next, we want to get all the commands for a particular platform. So we're going to pass in a platform ID and we will return any commands that we have, if any. We could get a null back. That is a valid response. So return _context, this time on our commands. And we will do where, and we'll do another lambda expression. So C goes to C. This time we're looking at the platform ID to see whether it's equivalent to the platform ID pulled in. And if so, you don't need to do this, but I'm going to do it. We're going to order the results by the platform name, just so we have them kind of grouped together. So C goes to C once again, platform name. Not mandatory, but just makes our result set a little bit nicer. Fantastic. Next one, we're going to get an individual command. So we're going to pass in both the platform ID and the command ID. And so we're going to return context, commands, where. And our where clause is a little bit more complex this time. So C goes to C, and the first thing we'll check is the platform ID to see if it's equivalent to the platform ID passed in. But also, so and, we want to check, see if the command ID is the equivalent to the command ID passed in. Now let's do a control B to get rid of our file explorer. And what we want here is the first or default. Okay, we don't want a full result set, we just want a singular command returned back. Next one, get all platforms. This is pretty easy, so we're just going to return back using the context again. Platforms to list. Simple as that. And then slightly more interesting ones, we've got a couple of create methods here. So the first one is creating a platform. So in order to do that, we first want to check to see if the platform object that was passed in, we're going to make sure it's not null. We don't want to try and add a null value to our collection. So if it is null, then we will throw a new argument null exception. And I'll just bring in the system namespace, assuming I spelt that correctly, and amazingly I did. And we'll say name of plat. Okay, so what model are we throwing an exception on? Assuming it's not null, then we will use our context again, and we'll simply go to our platforms collection and add the platform that we've been given. And then finally, probably the most complex method of all, although it's not really that complicated, we are going to add a command. So we're going to get passed in the platform ID, and we are going to expect a command object passed in as well. Now, we're already getting the platform ID from the URI, so if we come back to our list of methods, let me just find the right slide. I just want to show you what I'm talking about. Here we go. So for create a command, this is going to be our route. So we're going to go platforms, platform ID, commands, and we're going to create a command at that route. So we're already getting the platform ID here. So when we actually pass in the command, although the command does need a platform ID, we don't need to specify that in the body of our create or of our post request. That'll become a bit more clear when we create the DTOs for this, but I'm going to do a little bit of code in here that you might go, why are you doing that? But that's basically why. So basically, similarly to the creating platform, if the command passed in is equivalent to null, then we don't want to do that. So I'm just going to copy this rather than typing it. And instead of plat, it's going to be a command. So assuming it's not null, what we then want to do on the command object that's been passed in, you want to set the platform ID equal to the platform ID that we get in the URI. I want to take that out from here. That should be, excuse me, that should be down here. That's why I was getting that warning. So I'm going to go as unreachable code. So yes, just to replay that again, we get a command passed in, but we're not going to have a platform ID at that point. We're already getting it in the URI. So I'm going to assign the platform ID to whatever is in our route. And then finally, context. On our commands collection, I'm going to just simply add that command. Fantastic, and I think that's us done. I think that's the concrete class done. That's all our methods implemented. Looks that way anyway. So I'm just going to do a control backtick, and I'm just going to do a .NET build. Make sure we've not broken anything. That all looks good, fantastic. So that's basically our repository done. What we're going to move on to doing next is creating our DTOs, because then next we're going to move on to fully implementing our controllers. But first we need to get our DTOs in place, and then actually we need to do our mappings as well. So we'll do that next. All right, so we are coming on now to creating our DTOs. So Control B to bring back our Command Explorer, and I'm just going to get rid of these for the moment. Well, not get rid of them, but just clear them down. So in our root of our commands service project, right click and new folder, and we're going to create a folder called DTOs. Now we're not going to create all the DTOs that we need right now. We're going to create the ones that map just to the controller actions that we're going to implement. Okay, there are some other DTOs that we're going to create as we move forward, more related to eventing and all that kind of stuff. But these DTOs, we're just creating the ones we need just to service our controllers. So the first DTO we're going to create, I'm not going to go through what DTOs are again because we've already gone through that. The first one I'm going to create is a platform read DTO. So new file, platform read DTO, not .dto, but platform read DTO.cs. All right, and so namespace, command service, DTOs. And it's super simple. It's a public class called platform read DTO. And we're going to have two properties. Prop, first one is the ID. We want to return back the ID of any platforms that we have. And it's an integer, so that's all nice and easy. And then likewise for our name, assuming I can spell prop correctly, but this time it's a string. Not a sting, a string, and it's a type name. Just going back to our models, just to kind of review, here's our platform model. It's pretty much exactly the same as that. Not quite, but it's got our ID and our name. We're not going to pass back our external ID. We're just passing back our ID and the name. Can of course change that if we so choose to a bit later on, but for the moment that's all we want. Just quickly looking at our command model just before we move on any further. We have an ID, a how-to and a command line, and a platform ID. We actually want to return all of these back via our command read DTO. So back over in DTOs, right click, new file, and we'll call this command read DTO.cs. So namespace, command service, DTOs, and it's just a public class called command read DTO. And let me come back to our platform, and I'm just going to copy these in here, over here. And I'm going to take out the annotations because again it's a read DTO, so I don't really feel we need those. Take these out, and that's fine. So when we are returning a command object back as part of our response, this is what we're going to be passing back. And we're going to save that off. And the only other one that we're going to implement for what we're doing next in our controller is when we want to create a command. So right click DTOs, new file, and it's command create DTO.cs. Namespace, command service, DTOs. Now I appreciate a lot of this stuff is quite boring. We've done it before, but again, it's good practice. We've still not really come on to the really interesting stuff yet, which is when we start using eventing and all that kind of stuff. This is just still pretty much web API, to be really honest with you. But we're almost getting there. So again, command service, it's just going to be a public class called command create DTO. Now, again, thinking when we want to create a command, what are the things that we're going to pass over? What do we want to actually create with? And we've come back to our command class. We have an ID, which again, as you know, we do not want to pass over. Like with our platform service, we're not going to supply the ID, so we don't need to include that. I mentioned already, and again, this is maybe still a little bit confusing, we do need the platform ID, but we're not going to expect that as part of our body payload because we already get given it in our URI. So this is surplus to requirements. Although it's still needed, we don't need to get it as part of our body payload. Otherwise, we'd be duplicating the platform ID, and conceivably the route ID and the ID we pass here could be different, it could be confusing. So we're just not going to allow it to get passed over at all. So all really our command create DTO is going to expect is how to and command line platform IDs passed in the URI. So I'm just going to copy this. Hopefully that made sense, but it will when we come on to actually doing it. And again, because it's a read DTO, I'm going to leave these as required, and we'll bring in the data annotations namespace, and I think we're good. Did we, from memory, let's have a look. No, that's good. We didn't put any other considerations on that. So that's all good, so we'll save that off. So I think that's good. So let's just do a quick build again, just to make sure nothing's broken. I don't think that would break anything. Cool, so again, at this point, all we're trying to do is get our commands service up and running almost just from a web API perspective. We'll do a quick test if we can, and then we're going to move on to the more interesting stuff, which is actually getting these services to properly talk to each other using an event bus, and that is going to be coming up in the section that follows. We're almost there, but next we have to do our controller. So let's move on to that. Now actually, just before we move on, I'm actually forgetting a very important thing, and that is AutoMapper. We have not included AutoMapper yet. Again, remember AutoMapper is the glue that allows us to map between our models and our DTOs, and we've not put that in yet. So first thing I want to check is just to check that we included it in our CSproj file, and we did. So over here, AutoMapper extensions, Microsoft dependency injection, we need that in here. And you will also remember it has to go into our startup class, but I don't believe we have done that yet. No, we haven't. So first things first, we want to add AutoMapper into our configure services method. So under controllers, we're going to access our services collection and we're going to add AutoMapper. And it is there. And again, you'll remember from before, we need to pass in this app domain, current domain, get assemblies, And we'll finish that off. So that allows us to inject AutoMapper in our service. Fantastic. Now this is getting a bit busy now, so I'm going to close all this down. So all it really remains for us to do is actually create the mappings. So again, you'll remember we created a folder for those mappings, or for those profiles, more correctly. So new folder, and we'll call it profiles. Okay, so in the profiles folder, new file, we're going to call our profile commands profile.cs. And its namespace, command service, profiles. Again, be careful with the pluralization of the namespace, profiles, and the AutoMapper class profile that we implement. So public class commands profile, and we're going to implement an AutoMapper class called profile. I'll bring in the AutoMapper namespace. So hopefully you should remember this from last time. And then we just create a constructor called commands profile. We don't accept any parameters, and it's in here that we do our mappings. So just a bit of a refresh, we will specify our source and then our target. Now again, the mappings that we're going to do at the moment are very simple. They just map kind of straight on top of each other, as you will remember from last time. This does get a little bit more complex though. So we will come back in here and update our mappings at some point, but for now, simply create map. And the first one that we want to create is from our platform object to our platform read DTO. So that's when we're giving back platforms from our controller. The source ultimately is a platform model, and the target is a platform read DTO. So I'll just bring in command service models, and I'll bring in the DTO namespace as well. Fantastic. That's our first mapping done. Should make sense. And then the next one, create map, and this is going to be a command, create DTO, and that is ultimately going to be going to a command. Fantastic, and I think that's all we need to do. Oh, and then possibly the third one, create command, or create map, should I say. And the source is going to be a command, and we're going to turn back a command read DTO. So again, likewise, when we're retrieving our command objects, the source is going to be a command, and we're going to be passing back a command read DTO. And that's our three mappings for the moment. And I think this is, yeah, I don't know why that's wrong. There we go, that should be much better. Don't know how that got to be a small p. Anyway, there we go. That's our constructor done. And matching our platform, all good. Yep. Maybe it got it from here. That's interesting. I didn't realize that. You can see here that the name of the file is a small p. And that's maybe where it's getting the name of the constructor. I didn't realize that. I thought it would have got it from the class. Interesting. There we go. Something I learned. So good pickup there anyway. So we'll save that off. That's our commands profile done. So yeah, now we are truly ready to move on to our controllers. All right, so moving on to controllers now. And if we come back over here, you can see that we had a platforms controller already here that we created just to test this inbound connection. Now you can see it's pretty basic. There's enough here to get us going, but we need to obviously expand upon that. Now we did create a constructor. It's not doing very much at the moment. So as usual, what we want to do is inject in a repository so we can use it and a mapper object. So the first thing we're going to inject in is an I command repo repository, and we'll call that repository. No comma, don't know why I put that in. And we also want to inject an I mapper for AutoMapper, and we'll call that mapper. And we'll bring those namespaces in. So using command service data and using AutoMapper. And as usual, we will assign both of those to private read-only fields. So underscore repository equals repository, and underscore mapper equals mapper. And we'll bring in the namespaces for these. Now, before we move any, so read-only field, and same for this, read-only field. Now, before we move any further with this, this will actually fail if we try and run up this class and or run up the application and attempt to hit one of our action endpoints. We're going to get some horrible errors here, and if anybody can tell why, then you're obviously following along very well indeed. The main reason is that we've not registered our iCommander repo in our startup class, in our configure services method, and actually nor have we configured our database context. We've not registered that either. We weren't using any data services from in here when we were testing it before, so we set none of that stuff up in our startup class. So if we come over here, you can see our configure services method is looking pretty bare. We just have our controllers, which was there anyway, and then we did add AutoMapper, but we haven't yet registered our DB context, which we need to do, and we haven't yet registered our repository. So before we go any further, we need to do that. So up here, we'll make use of our services collection again, and we're going to add DB context, and it's going to be an app DB context. There we go. We're going to provide some options. OPT, now I'm just going to get rid of a sidebar for a minute, the directory listing. So lambda expression, if I can type it correctly, OPT goes to use in memory database. And I suspect we need to bring in a namespace for that, so let's do that. Control period to bring in, yep, entity framework core, and then as before we just need to give the in-memory database a name, so I'll just call it anything, doesn't really matter. And again, we're not going to use a SQL server here, and we're not going to distinguish between environments, we're just using the in-memory database just in the interest of time. But again, I've said it before, key point to note is that this service, the command service, does have its own database. Alright, cool, and then finally that's our DB context registered. We now need to register our repository. So let's put it in here actually. So services, add scoped. So we're going to, when anybody requests an I command repo, we're going to give them, should I spell it correctly? We're going to give them a concrete class, which is command repo. And that's it. So yeah, I think that's all in the namespace is there. I think that's right. So let me just do a build, save it first. .NET build. Yeah, that's all good. All right, perfect. So that's all our dependency injection stuff wired up for our data stuff anyway, so we can close that down and we can come back to our controller. So this stuff will now work. So when we ask for one of these, it will get injected in, so that's all good. So we're in our platforms controller at the moment, and let's come back to our slide deck and we'll just have a look at the action that we're going to implement for that. If I can find the right slide, bear with me a second, here we go. So again, we're going to have two controllers within the command service. We're going to have our platforms controller, and that's just going to allow us to get all our platforms. So let's set on doing that first. So it's going to be a HTTP GET request. No routes or anything, it's just going to use the existing route, which as you can see here is API/C and then the name of the controller, which in this case will be platforms. Fantastic. And then it's just a public action result passing back an IEnumerable of what platform read Dtos. And we'll call that get platforms. It will require a couple of namespaces, so systems collections generic and platform read DTO. So command service DTOs. Fantastic. So I'm just going to do a console write line just to give us a wee bit debugging, because I find that quite useful, especially when things go wrong, as you've seen recently. So I'll just say getting platforms from, oh goodness, command service, or command service more correctly. All right, fantastic. So that should just give us a bit of warning that this controller action has actually been hit when we call it. So we then want to get collection of, if there are any, a collection of platforms back using a repository. So I'll create a variable called platform items equals, make use of our repository, and it's just get all platforms. I don't need to pass anything into that. So it's inconceivable this could be null, that's okay. And in fact, it is going to be null for very obvious reasons, which we'll cover in a second. And then we're just going to return back an OK. And we're going to make use of AutoMapper. So we're going to map from our collection of models to a collection of read DTOs. So mapper, map, what do we want to map to? We want to map to an I enumerable of platform read DTOs. And what's our source? Our source is our platform items. And again, that's just making use of one of our mappings in our profile. So that all looks good. Fantastic. So let's give this a go. Let's run this up, .NET Run. And let's come over to Insomnia and test this endpoint. Now it's not going to return anything, it's just going to return an empty set, but I just want to make sure that we've wired everything up correctly and we're not getting any weird issues. So we are running in our local environment. So we're just done a .NET Run. So command service, here's the previous test we did on the inbound connection. In fact, we could probably still test that. And that's working okay. If we come back over here, you can see, yep, we've got an inbound post. So again, we'd expect that to continue to work, but at least we've not introduced any new errors. And so the new thing we want to introduce here is basically a get all commands. So new request, not all commands, sorry, get all platforms. Put space in here, there we go, get request, we'll create that. And I'm just going to copy the URI from here, because it's going to be exactly the same. The only difference is it's a get request, not a post request. Send that over. Great. So we got 200 OK and just an empty array of nothing, because there's nothing there. We've not seeded any data. We didn't create a prep, well, we've got a prep D class from memory, haven't we? So we just come over here, Control C that, get rid of this. Bring up our data folder. No, we don't. I forgot. We didn't actually even create a prep DB class like we did with our platform service where we seeded data and all that kind of stuff. We don't even have one yet. We will in a bit, but for now we don't. So there's nothing there. We just have an empty database with nothing in it. So that's cool for the moment. We'll circle back to this problem with the fact that we have no data for platforms, but for the next part, what we're going to do is we're going to finish off the other action results that we need to put into our commands controller. So we'll do that in the next section. All right, so what we want to do now is create our second controller, our commands controller, that will allow us to service requests for commands. So before we do anything, let's just take a quick review of the endpoints we're going to stand up. So we've done this first one, again, and that was in our platforms controller. I should actually pluralize these, but in our platforms controller, we allowed the ability to pull back all platforms. For the remaining three, that's where our new controller comes in, our commands controller. And you'll see in all three instances, the route is exactly the same, with the exception of the second one, which is an additional parameter, the command ID. But taking that aside, all three of these routes are exactly the same. So this is our kind of controller level routes. Let's just take a quick look. API/C platforms, we're then passing in a platform ID in all cases, it's a mandatory requirement, and then our commands resource. And in this case, we're passing through a command ID. So just try and remember that this is the kind of class level route that we need to put in. So back over in our project, right click on controllers, new file, and we're going to call this controller or commands controller.cs. So namespace, as usual, command service, controllers, it's just a public class called commands controller. And we're going to inherit from controller base. I need to bring that namespace in. Fantastic. Okay, cool. Now, before we come on to doing constructors or anything like that, we want to actually decorate our class with the fact that it is an API controller. Fantastic. And we also want to specify the route. So if we come back to our platforms controller, you can see the route that the class level, or the controller level route was API/C, and then the name of our controller, which in this case was platforms. Over here, we want to do something similar, but coming again, just to refresh your memory, although it wasn't that long ago, we want to have our route as API/C platforms. Now, bear in mind, our controller is our commands controller, so we have to actually write platforms as a string. We need to figure out a way to provide in an attribute, a parameter, platform ID, which we have done before, so it shouldn't be too, in fact, if actually showing you the syntax here, shouldn't be too controversial. And then finally, inheriting the name of our controller. So, back over here, we want to specify the route. And then we just specify the route. So it's API/C/platforms/ an instance where we inject in our platform ID parameter, which will be the resource ID of our given platform, and then finally the name of our controller, which we will use the kind of wildcard syntax, so controller. Okay, so that just picks up this commands portion and puts it in here. So that gives us our class level or our controller level route, which is pretty much the same for all our actions apart from one, where we have to add on an additional parameter. Cool, so before we come on to the action results, let's do our constructor. So CTOR, and as usual, I may just get rid of the stuff at the side here, Control B. As usual, we're going to pass in an I command repo called repository. And we're going to pass in an IMapper object as well, called mapper. And then private read-only fields. So you should definitely, I did tell you we'd be doing a lot of this stuff, and I know it's probably getting a bit laborious, but again, all good practice. Equals mapper. And we'll bring in the namespaces for each of these. Control period. Not namespaces, my apologies. We're going to generate a read-only field. I'm just so used to saying that, bringing in the namespace. So generate a read-only field for both. And we do actually, we do need to bring in the namespace for these. So let's do that. Command service data and using AutoMapper. Fantastic. So namespaces for these, both these things, and private read-only variables for that. Fantastic. So let's come on to our first action result, which is to get back all the commands for a given platform. So it's going to be a HTTP GET. I'm not going to bring up the slide again. I think you've seen that enough. Let me just move this up a little bit. It's going to be a public action result. And what we're going to pass back, we're going to pass back an IEnumerable of what? Of command read DTOs. And we'll call this method get commands for platform. Spell platform correctly. And then we want to pass in the platform ID. Fantastic. So we will get our platform ID from our route up here. So whatever resource or platform ID we pass in, we will get that down here. So bring in the namespaces for IEnumerable, system collections generic, and also for our DTOs. There we go. Now the first thing we want to do, well I want to do anyway, is do a console, bring in the namespace, using system, write line, just to say that we've hit this controller. Again, this is not something you typically do in production, but while we're doing some test code, I think it's useful. So we'll use string interpolation. It will just say hit get commands for platform, and we'll just put the ID in to make sure that's all flowing through correctly. Platform ID. Fantastic. All right. Now we don't want to attempt to get commands for a platform if that platform doesn't exist within our database. So the first thing we're going to do, and I'll do a Control B, and we come back to our repository, is we did put this method in here, platform exists, with passing that platform ID, and that's really exists to just check to see, do we have a relevant platform in our collection? If not, then there's no point in trying to do anything else, and we return back a false or not found or whatever. So we'll make use of that now. So we'll say if, and we make use of our repository, if repository platform exists, we'll pass in the platform ID. And actually, I want to make this a not. So if it doesn't exist, so exclamation mark. So if we get a false back from this, i.e. it doesn't exist, then we will return a not found HTTP 401. And that's it. We won't do anything else there. Assuming that our platform is valid and it does exist, we want to pull back a variable of our commands. So var commands, and this is coming from our repository, and we want to get commands for platform, and that expects a platform ID, so we just pass that through. And we can be fairly sure that we have at least got a valid platform, having done this check up here. And then we just return an OK, 200 response, and we have to map back, so mapper, map, what we're mapping to, and I, enumerable of what, and read Dtos. And what's our source? Our commands. Fantastic. Okay, so that looks good. Now, of course, we can try and test this, but we're just going to get a not found. So let's try it. And again, we're going to get a not found because we have no platforms. But again, that's the problem that you're hopefully starting to see. We have no platforms in our entire service. How are we going to get around that? Well, that's really where we come on to using some nice asynchronous messaging to get some platforms into our controller, into our command service. But nonetheless, we can still test this endpoint to some extent to make sure we get a 404 or 401 is it? I can't remember. 404 not found. 401 is not authorized, that's right. So bring up our command line, we'll make sure everything's saved. We'll do a .NET run. And again, it's always useful to run this stuff intermittently just to make sure that we're not introducing anything weird. So I'm going to just duplicate this one. And I'm going to say get all commands for platform. Okay. And in here, we're going to maintain this is the same API /C / platforms. We'll put in some arbitrary resource ID for our non-existent platform, and then we'll have to amend this on commands. Okay. So yes, we get a 404 not found, which is what we expect as we don't have any platform IDs, but that looks okay. It looks like that's kind of being hit. And if we actually come back over here, you can see here, we had our, again, exactly the reason why I provide this kind of stuff or put stuff in. We did hit our controller correctly with the platform ID of 1, and we just didn't find anything. So that's all looking pretty good. So I'll take a quick pause here for the moment, and then we'll come on and we'll finish off our other 2 action results for this commands controller. And then we'll start to look at what we're going to do about this problem about not having any commands in this service. How are we going to get them in there? So we'll do that next. All right, so let's just kill that. And yeah, we're going to come on and finish off the final 2 action results or endpoints for our commands controller. So the next one we want to write up is basically to pull back an individual command for a given platform. So it's a HTTP GET. I'm not going to bring up the routes again because I'm sure you've seen them enough already, but you'll remember from this one, we need to additionally pass in a command ID as well. So the controller level route takes us so far, but we need to pass in another parameter, which is our command ID. So HTTP GET, open parenthesis, double quotes, and then we just need to specify in our curly brackets command ID as an additional route parameter. That's all right. And then we also, or I'm going to, specify the name of this action result because we'll make reference to this a bit later when we come on to create a command. And this should start to be familiar from when we created platforms in the last service that we built. So I'm going to call it get command for platform. And that's all good. And then it's just a public action result of type command read DTO. We'll just bring back a single command if we find one. And in the name, I'm just going to copy this to make sure it's exactly correct and exactly the same. Don't want to introduce any weird errors into this at this stage. And then I'm going to expect two parameters. So the first one is the platform ID. And the second one is an integer as well, and it's the command ID. I'll select that there. Okay, so platform ID is coming from our controller level route here, and the command ID is coming from our action result level route here. Fantastic. So the first thing we want to do actually is do a very similar, not very similar, an exactly identical check here to make sure that the platform ID exists. And I'm going to also copy this right line as well. So again, platform doesn't exist, there's no point in doing anything else. So I'll just change the name of this. So get command for platform. I'll paste that in here. And we'll pass through the platform ID, and we'll also pass through the command ID, just to help us with a bit of debugging if it comes to that, command ID. Fantastic. So again, you're starting to see the problem that we're going to hit here. We have no way of, at this point in, getting platforms into this particular service. So all these action results, all three of them in fact, are going to just return a 404 not found because we have no platforms. So the problem, and start to think about it, is how are we getting platforms? How should we get platforms into this service? Should we just create another controller action and just allow us to add platforms? We could do that, but we're not going to, because the whole point is we want to actually get our platforms from our platform service in some nice, elegant way, some event-driven, asynchronous way. Anyway, so yeah, let's just finish off this action result before we delve into that too much further. So yeah, we are doing a platform check to see if it exists. If it does exist, that's all well and good. And what we want to then do is return the individual command. So var command equals repository, and we're going to call our get command method this time, and into that we're going to pass our platform ID and also our command ID. Now again, at this point we may or may not have a command. It's entirely valid use case that there is no command there. That's okay. So we need to check that first of all. So we'll say if command is null, then we go no further and we will just return a not found as before. And make sure we put in the double equal signs for equivalency. We're not assigning it, that's cool. And then assuming that's okay, then we just return okay. We do of course have to use mapper. So what are we mapping? Mapper map. What are we mapping to? We're mapping to whatever we are returning, which is a command read DTO. And what's our source? Just the command object that we have up here, which is non-null. Fantastic. So again, that's all looking good. We'll save that off. We'll quickly run it up. Now again, we're just going to hit this first not found condition here, but we can at least see that we get that number one and it's working correctly, and that we're getting both our IDs coming through correctly. So .NET run. And then back over in Insomnia, we will come into our command service under our local dev, and I'm going to duplicate this. I'm going to call it get command for platform. Okay, and it's going to look exactly the same, except we're going to hit on or put on an additional parameter for our command. Still get a 404, which is fine, but what I do want to check to see in our output is that we are hit the controller and we pass through number one for the platform ID and number three for the command ID. So that's about as far as we can take this at this point in time. Cool. So that just leaves the final action result, which is our create command action result. So we'll do that next. All right, so just stop any running services if you have any, and we're back in our command controller, and we're going to write up our third action result. So back down here, pick a new line, and I'm just going to pull this up. So this is a HTTP post this time, and we don't need to specify any additional routes because our controller level route is exactly the one that we want. And again, to labour the point, we have a HTTP get here. It's a different verb, obviously, from HTTP post, so they're hitting the same route, different verbs. It's still unique within the controller, so that's all good. So let's come on to the method signature. So public action result. What are we going to return back? We're going to return back a command read DTO. We're attempting to create a command here. If we do successfully, then we'll pass back the read version of that DTO. So I'll call this create command for platform. And what we're expecting we're expecting again the platform ID and also a command create DTO. I'm just going to call that command DTO. All right, so again, in our route, we're expecting the platform ID, which we are going to get from here. And again, we'll need to perform this same check. And we're also going to expect a command create DTO in our body payload. So again, very similar check. I'm just going to copy this one, in fact. Console write line and our platform check. We'll pop that in here. All I want to do is just change the name of the action result. So hit create command for platform, will pass through the platform ID, perform the check to see if the platform exists. If it doesn't exist, then we return a 404 not found. If it does exist, then we keep going on. So next thing we want to do is create a variable that's going to, not a car, a variable that holds our command model. So var command equals, and we're going to use mapper to map to what type? To a platform, not a platform, a command. We'll need to bring in that namespace using command service model. So yeah, we want to create a command object that's going to hold a command model. And what is the source? The source is going to be our command create DTO here. I'll paste that in here, like so. Fantastic. Now, just a little shout out here, do a control B. You'll remember our command create DTO. We did specify some required parameters. Fantastic. So one of the nice things about using this API controller declaration is that when we hit this action result and we pass in a command create DTO, there's a bit of a validation check using those annotations to make sure that we have those two attributes. You can probably pass in other stuff as well, but this action result will go back with an error if we don't do that. So that's why, number one, it's very nice to annotate create type DTOs, and it's also nice to put in that API controller stuff at the top because you get all that out of the box. Very nice. So we can the point I'm making is we can kind of be sure at this point when we're doing this mapping that we've got a valid object. You could additionally, if you wanted, put this in a try catch block if you wanted to be super careful, but I think we'll be okay for now. Want to keep the code a bit light. So we've got our valid command. We now want to make use of a repository and call create command on it. And we pass forward the platform ID and then the command object itself. And then we always have to call save changes. Otherwise, that will not be pushed down to our persistence layer, in this case, our in-memory database. And then the last thing we need to do, as we've said here, we want to pass back a command read DTO in the body payload, but we also want to pass back the URI, the resource URI, to this resource as well in our headers collection. So that's where this created at route stuff comes in. But before we do that, we want to actually create a read DTO. So var, I'm going to call this command read DTO is equal, we'll use mapper again. You can see how useful AutoMapper is. We're using it all the time. We're going to use it even more going forward. So we want to map to a command read DTO this time. And the source is a model, which is our command that's being created. Now, because we've hit save changes and our model is being created in our database, this command object now has an ID as well. So we have that at this point. So this command read DTO has a valid ID. I'm just going to capitalize the R just to keep things consistent. All right, fantastic. And then finally, we use our created at route command, which again is a little bit convoluted, but nonetheless, you've seen it working before. So created at routes. The first thing we're going to pass in is the name of the endpoint that will host our resource. So in that case, it's name of, and the whole reason we gave this method a name so we can reference it. So we'll copy this and I'll paste it into our name of method here. Fantastic. And I'm just going to take a new line because this is going to get a little bit busy. And tab in, and then we're going to do new platform ID equals platform ID, command ID equals command read DTO ID, and then finally we'll pass back our command read DTO as well. Okay, so as part of the resource, we need to pass back both IDs for both our platform and our command. All right, I think that should be good, and that returns a 201, obviously. Now again, we can't test this right now. We can test it to some extent to see if we hit this. So let's see if we can do that at least. So save off, and then we'll bring up our command line, and we'll do a .NET run. Fantastic, and then we'll bring up Insomnia. Come over here again, and yeah, within our command service and our local dev, we're going to create a new request. So new request, and we're going to call it create command for platform. Great, and that's a post request, and the body will be JSON. So we'll create that off. I'm going to copy the URI from this one here, this request here, because it's going to be exactly the same URI, just a different verb. Fantastic. And then we're going to pass in a command create DTO. So how to, let's say, build a .NET project. And then the other one is command line. And we'll be quite familiar with this now, .NET build. And assuming, you know, platform 1 was the .NET framework. Now I'll just check that the payload I've got here is correct. So back over in our project, let's do a control B, look at our command create DTO, and yeah, we've got two parameters, both required, how to and command line. So that should be okay. Let's send this. We'll get the 404 not found, which is fine, but we'll just come back over here and just check, yeah, that we hit our create command for platform endpoint. Fantastic. So that kind of brings us to the end of this section on building up our commands service. And to be honest with you, it does pretty much most of the things that I want it to do in terms of acting as an API, acting as a service. But the one big missing gap is the fact that there are no platforms in this service. As I said, we could add another action result in here to our platforms controller and allow us to randomly create platforms. That's totally possible, but that would be kind of pointless because our two services are completely then totally independent of each other. And yeah, what's the point in that? So the whole point that we've been building to is that we want to somehow, when someone creates a platform in our platform service, we want to notify our command service that a new platform has been created and add it in to our command service that way. So that is really what we've been building to. We want to use this event-driven messaging architecture to allow us to do that and allow the services to talk to each other in a kind of decoupled way. But nonetheless, there is still a dependency between them. The command service still relies upon the platform service to give it its commands, which is the right thing because the command service is the source of truth. So we're now moving into more exciting territory. So in the next section, we're going to do a quick review of synchronous messaging. We're going to talk a bit about RabbitMQ, and then we're going to stand up RabbitMQ in Kubernetes, and then we're going to add some code into both our services that are going to allow for asynchronous event-driven messaging. So we've been building to this for the last few hours. We're almost there. So in the next section, quick review of messaging, and then onto RabbitMQ. All right, so let's just do a bit of a checkpoint. It's been a while since we've done this overall solution. So we've been looking a lot at the Kubernetes domain. That's cool. And it kind of maps onto this overall solution architecture to some extent, but this is kind of, in my view, the next level up. So let's just do a quick sense check of where we're at. So we've got a platform service up and running to some extent. It's got a SQL Server database, fantastic. We've developed our REST API, and that's pretty much, yeah, that's complete now. The REST-based API is finished. Our internal microservices domain, you could almost map that onto our Kubernetes cluster if you wanted to do that. We have our API gateway, which is our Ingress Nginx controller. We can externally get in and route to these APIs. And again, here's our command service, in-memory database, REST API, which is basically complete. We're not doing any more on that. So this is basically where we're at. And the problem that we were encountering in the last section when we were trying to test our command service was that we have no platforms in there. So what could we do? Well, as we've already kind of done, in a few sections ago, we created a HTTP client in our platform service that posted or could post data to our command service. So one option would be to create another action result in our command service that would allow us to create platforms using HTTP. That is a totally possible solution. And in fact, what we've already done by posting a test message is basically exactly that mechanism. Just we haven't gone that one step further and added a platform to our internal database in our command service, but we could do that. I'm choosing not to do that because, again, we've talked about synchronous messaging, we've talked about dependency chains and all that kind of stuff, and the platform service needing to know about the command service. So we're not going to do that. Instead, as we've discussed, we're going to introduce a message bus. And this means that any service can drop things onto that message bus, and other services can subscribe to that message bus. And so all the services really need to know about is the message bus. They don't need to know about or be aware of any other services. So when we create a platform in the platform service, it's going to publish a message onto the message bus, and it doesn't care who's listening for those messages. It's just putting the information out there. It might be one service, it might be 100, it might be none. Doesn't matter, doesn't care. And then on the command service side, yes, we are going to subscribe for those events. So in the sections coming up, we're going to look at RabbitMQ, what it is, go into a bit more detail about that. And then we're going to stand up a RabbitMQ message bus in Kubernetes, and that will be the end of the Kubernetes stuff. And then finally, we're going to come back to both our services and implement the publisher and the subscriber functionality. So there's still quite a lot to do. And then just to kind of round off, actually, we'll leave the gRPC stuff for the moment. We'll come back to that when we finish this next section. So that's it for now. Now we're going to move on and do a quick overview of what RabbitMQ is, and then we're going to move over to Kubernetes and stand up RabbitMQ in there. So we'll do that next. All right, so let's go on to talk about RabbitMQ, which is going to be our message broker as part of our solution, or message bus. So what is it? Well, it's a message broker or message bus. It accepts and forwards messages, to put it in its simplest form. Messages are sent by producers or publishers, and messages are received by consumers or subscribers. Messages can be stored in the queue, so it has some degree of persistence. We're not going to be using that in our solution, so if our message bus crashes, then we lose all our messages. But in production type environments, you wouldn't do that. You would allow messages to persist in the event of any failures. But yeah, it's one of the benefits of it. So the idea is messages are published onto the queue. If your services are overwhelmed and can't actually service those requests, the message broker acts as a buffer for those messages. And then as and when you bring more services online, they kind of chew through the messages on the queue. Exchanges can be used to add a degree of routing functionality. Now, we're going to be using an exchange, but we're not going to be routing, okay? So I've got a bit on exchanges a bit in the next slide, actually. So just to clarify what we mean by that. Not probably that relevant to this video, but if you're interested, it uses something called AMQP, Advanced Messaging Queuing Protocol, as well as some others now as well. But AMQP is kind of the sort of traditional message queuing protocol. All right, so we'll come on to talking about this concept of an exchange, which again is definitely a RabbitMQ concept. So there are 4 types of exchange that it provides: direct exchange, fan-out exchange, which is the one we're going to be using, a topic exchange, and a header exchange. Now, I'm really going to talk mainly about the first 2. I'll briefly mention the third one, the topic exchange, and I'm not even going to talk about the header exchange. It's way too obscure for my liking, so it's not even worth bothering your time with it. So the direct exchange, so as it says in the bullet points, it delivers messages to queues based on a routing key. So it's ideal for direct or unicast messaging. So you've got your message broker, you have your publisher, so that could be our platform service, you have a consumer, that's a command service, you have this direct exchange, you have the queue. The publisher will publish a message. So I've created a new platform. It will also attach this routing key, which will place it onto the particular queue, and the consumer will then consume off that queue. So we're not going to use this method. This is the one we are going to use. So RabbitMQ is the message broker, our publisher, which is our platform service. There can be many queues. We don't really care. I think there's only going to be one in our example, but you could have a number of queues, just don't care. We've got our fan out exchange. The publisher will publish its message onto the exchange. In this case, I've created a new platform, and the exchange will then fan out to every queue that's bound to that exchange. And then any consumer that's reading from a particular queue will get that message. Okay, and so that is what we want. Okay, and if there's any routing keys attached, doesn't matter, they get ignored. So it's ideal for broadcast type messages, and this is the method that we're going to use. The publisher doesn't care who's listening, it's just throwing it out there. Now again, depending on how you build out your microservices architecture, you might want to use different types of exchange. If you do want to maybe do more direct type messaging, that's entirely up to you. And maybe this fan out exchange isn't maybe the most appropriate use case for something you're building. But for what we're doing, it's the simplest one. It's the one that we want to use. It keeps our pipe simple, stupid, doesn't do anything. It just basically delivers messages. And that's really what we want. And we build the intelligence into our endpoints. And then finally, we come on to this idea of a topic exchange, and it's kind of almost like a cross between the last two exchanges. Basically, the publisher routes messages to one or more queues based on a routing key. So again, you're using this concept of a routing key used for multicast type messaging. And yeah, it's basically, again, it implements different types of publisher subscriber type patterns. All right, so again, I don't want to use routing or anything like that. I want to just use a kind of, broadcast type message. And that's it. So I think all we really need to be aware of is this fan out exchange. That's what we are going to be using. And so next we're going to stand up our RabbitMQ server in Kubernetes. And then after that, we're going to start working back with our services. So let's move on to doing that. All right, so we're going to come on now and deploy our RabbitMQ instance to Kubernetes. Now, maybe before we come on to writing up our deployment file, let's just check in on our architecture, our Kubernetes architecture. And we've come pretty far. We're almost there. In fact, yeah, this is the last thing we need to do. You'll be quite pleased to hear regarding Kubernetes because it's been quite a long road to travel. So yes, we're going to set up a RabbitMQ container with a cluster IP, and not shown on here, we are going to set up a load balancer that will allow us to access the instance externally. Now we're going to use that to look at the actual container itself, but I'm also going to use it to allow our services to connect to it locally from, doing a .NET run. We're going to connect to it that way from our development environment, rather than waiting until we deploy it into Kubernetes, the services that is, and seeing if they connect in and stuff. We're going to do a bit more testing before we do that, unlike what I did with SQL Server. It'll probably save us some time in the long run. Now, the other thing I wanted to say here is we're going to take quite a simple approach to deploying RabbitMQ in Kubernetes. We're going to set up one instance with no persistence. Now, if you go to the RabbitMQ website and you look at how they recommend to deploy RabbitMQ in Kubernetes, they take a very different approach. Now, it's all very well documented, but it's quite a long, detailed process, and it's very much aimed at a production type deployment. And again, for me, it's coming into this realm of, as a developer, I'm probably not going to be wasting too much time. Waste is probably the wrong word, but spending too much time on creating clusters of RabbitMQ message buses and making sure they have persistence. That for me is outside the realm of my personal remit as a developer. Great if you get time to do that stuff, I generally don't. So all I really care about is that, is there a RabbitMQ server there? Yes, there is. And in our case, we will have one. Just be aware, this is not a production quality or production class deployment. But what we're doing, it's totally fine, but just calling that out. So back over in our K8s project, just get that up. We're going to create a new deployment for our RabbitMQ instance. So right click, new file, RabbitMQ. -depl.yaml. Okay, and the API version, let's get started. Version is apps/v1, and double check everything that you are typing in here, because one mistake and it will go critically wrong, do you know what I mean? So kind is deployment. And we'll probably put a lot of stuff in there, so I want to take that out. Deployment, that looks right. Specify the metadata, which is effectively the name of our deployment, and I'm going to call it RabbitMQ-depl. And when you do kubectl get deployments, this is the name that appears. All right, so back to top level, we're going to specify our spec and tab in, and we're going to specify our number of replicas. Here we're going to specify 1. Then come on to the selector stuff, and then tab in for match labels and app, and we're going to call this RabbitMQ. That's all. Take that off. New line, bring your cursor underneath the selector, and we're going to specify our template now, and more metadata. Tab labels, and then app. And it's going to be exactly the same as what we specified here. So let's copy that in, like so. New line, and I'm going to specify a container spec, so put the spec underneath the metadata. It's auto-generated containers, yes, which is correct, name, which is correct. So I'm going to call this RabbitMQ as well. So again, these 3 elements here should all be exactly the same. And then specifying the image, and this time it's RabbitMQ:3-management. And now I'm just going to check the way I've spelt management, because it's a word I frequently spell incorrectly. Now this is just the image that Kubernetes is going to pull down from Docker Hub. The management part relates to a management interface, an optional management interface that we can have. So we're going to pull that image down. And we'll use the management interface just to make sure, number one, that we can access it and it's working, and we'll also see messages dropping on to the message bus as well. And then finally, for our specification of our image, we need to specify 2 ports this time. So ports, tab in, and the first one we want to specify, we'll specify the container port. Get this right, it's 15672. That's the management port that we're going to connect in on. And we need to give it a name. As we have 2 ports, we definitely need to give it a name. So I'm going to call it RabbitMQ-MGMT-port. Come out again, I'm going to specify our second port, and it's a container port again. And this time it's just 5672. So the same as the management port, except it doesn't have the trailing one. And we need to give it a name as well. So I'm going to call it RabbitMQ-MSG for messaging port. And this is the port that our clients, or services should I say, are going to connect in on. This is just for us to access the web interface. So that's why we have 2 ports there. That all looks good, so let's save that off. Now, again, we need to specify a cluster IP for this. So new line, 3 dashes to separate the config. Looking good. So what I'm going to do is I'm going to come over to our SQL Server deployment. I'm going to copy the cluster IP definition. Now, obviously, we need to change it for RabbitMQ, but to save me typing all this again, we're just going to go through it line by line and change the things that we need to change. So API version v1, it's a service. We're going to give it a name, so we do need to change this. So I'm going to change it to RabbitMQ cluster IP service. Coming down to our spec section, the type is cluster IP, the selector we need to change, so we're going to change it to match this value here. I'll copy that down and put it in here. Fantastic. And then we come on to specifying our ports. All right, so I'm going to rename our first port, and this will be our management port. So I'm going to give it the same name as this here. It doesn't need to be, but I think just for clarity, I'm going to give it the same name as that. Protocol is TCP. The port is not 1433, it's going to be 15672, and the target port is also going to be 15672. All right, fantastic. So again, just make sure you get these numbers correct. Very easy to type numbers in wrong and get them in the wrong way. I've done that many times before. Especially with SQL Server, I've often specified the port as 1443 as opposed to 1433. That's caused me no end of problems in my life. So try and avoid stuff like that. And then we do need to specify the second port. So again, we're going to give it a name, and this is for our messaging. So I'm going to copy that as well. Paste that in here. We're going to specify the protocol again. Likewise, it's TCP. And then we specify the port. This time it's 5672. And then the target port is also 5672. So again, I'm just going to highlight this and make sure I get highlights in all the relevant sections. That looks pretty good to me. I think that all looks fine. Fantastic. So save that off. And then the final thing we want to do is create our load balancer. So again, I'm going to come back over to our SQL Server instance, and I'm going to copy the config, and we'll go through it again line by line. Just saves me typing it in again. Saves you typing it in again. So again, API version v1 is a service. Metadata will change the name to RabbitMQ load balancer. The type is a load balancer. The selector, again, we want to change to RabbitMQ. And then we need to specify our ports in the same way. So you can see here we didn't actually name our port for SQL Server simply because we only had one, but this time we do want to give it a name because we have two ports. So I'm going to specify that first. Name. And I'm just going to give it the same name as this management port up here. I'll specify a management port first, copy. Now again, you can see this Kubernetes definition stuff can get really quite long-winded and quite repetitive and all that kind of stuff, but there's not really any getting around it. So this is the last stuff we have to do. So take comfort in that. So 1.5. Unless you enjoy this kind of stuff. Some people like this type of stuff. I personally don't. It's so subject to error. Anyway, so a load balancer, we're specifying our ports. That all looks good. So we've got a name, protocol, port, and a target port. And then finally, we just need to specify the actual messaging port. So we'll give it a name, same name as this. Copy. Protocol is TCP. Port is 5672. And the target port is 5672. Fantastic. So again, just highlight this, make sure we get highlights in relevant areas. I'll highlight this and make sure we get the highlights in all the relevant areas. That looks pretty good to me. All right, so maybe take a quick pause there. We'll save the file, and in the next section, we will run our deployment, see what we get, and then we'll try and connect in and make sure our instance is running. So we'll do that next. All right, now for the moment of truth. So back in our K8s project, let's bring up a command line. Let's just do a quick directory listing so we can see our RabbitMQ deployment file. Let's just do a quick check, because it's been a while. Do a kubectl get deployments. Just to make sure. Don't know what was going through my head there. kubectl get deployments. Okay, everything's running. Let's do a get pods just to make sure everything's okay. Everything's running, everything's looking good. That's all right, fantastic. So clear the screen and the usual kubectl. Apply F, actually I've done it again. Let's do a listing so I can see the file. Yep, okay, so kubectl. Apply -F and then the name of our RabbitMQ deployment file. And this is where we find out if we've done anything wrong. All right, so that looks good. So syntactically, it's all passed. So we've got a new deployment created. We've got two new services created. So let's do kubectl get services. And we should see, that looks horrible on the screen. Let's just pull this over. That's better. Actually, do a control B, that's better. You can see here we have our two RabbitMQ services. So we've got our load balancer And we also have our cluster IP, which is our internal stuff. Fantastic, that looks good. So let's do kubectl get deployments again. We'll see how our deployment's going. So it's saying 0 of 1 is ready. So let's check our pods. So it's doing a container creating. So we'll just sit back and have to wait for that. So I presume Kubernetes is pulling that image down from Docker Hub. So we'll just have to wait and see what happens there. And I'm hoping and assuming and expecting that it should run and start okay. So it's running okay. That's cool. But again, I have fallen into the mistake of assuming everything's okay, and then you do another get pods and you see it's errored out. But that looks okay from my perspective. So let's just come over to Kubernetes and have a quick look. Pull this over and take a look. And we can see that, where is it? There we go. Hiding down here, that we've got a RabbitMQ container. It looks like it's started up quite successfully. Fantastic. So now what we can do is we can, using our load balancer, we can check to see whether we can access the management interface. So let's just bring over web browser using Firefox. Going back to Firefox, actually, I like Firefox. So localhost, and we want to go into our management port. So 15672. Excellent. So we have got a management interface. Now to log in, it's guest and guest. So we just click login, and you can see here we have logged in. It's all looking pretty good. So that's our RabbitMQ service up and running in Kubernetes. What we're now going to come on to do is revisit our platform service and write a publisher service to publish messages onto the message bus. So we'll do that next. All right, so with our RabbitMQ server up and running in Kubernetes, so available to us in our production Kubernetes environment, but also via our load balancer available to us via localhost, we can now move on to updating our platform service. Now, just so we're clear on what we're doing in the next section, or this section, I'll just bring this up again. So we've got all this up and running. We've just stood up our RabbitMQ message bus, and now we're coming on to working with the publisher component of our platform service, asynchronous client to publish messages onto the message bus. So over in our platform service, make sure you have the right project opened up. The first thing we need to do is add the necessary RabbitMQ client packages into our project, because we don't have those yet. So it's .NET, add package, and it's RabbitMQ.client. So we'll add that in, assuming we've typed it incorrectly. I don't think I've typed it in. .NET add package, RabbitMW. There you go, RabbitMQ client, there you go. Again, that's why it's always good to have this up, because you can actually see it being added in. Sometimes I don't necessarily pay attention to the output down here. It didn't really look too much of an error. So yes, definitely added RabbitMQ client in. Excellent, so that's the first thing we need to do. And then the next thing we need to do is we're going to set up some config. So when our platform service starts up, it's going to connect to our RabbitMQ message bus. Now it needs to know where to connect to. So it's going to be one thing in development and it's going to be another thing in production. So we're going to update both our app settings JSON files here. So let's do development first. Let's put a comma at the end of this. And the first attribute we're going to set up is RabbitMQ host. You can call this anything you like. I'm just going to call it RabbitMQ host. And in our development environment, that is going to be localhost. Exactly the same as what we did here. And then the second bit of config you want to provide is the RabbitMQ port. And the port in this case is 5672. That's the message bus port, so 5672. And we'll save that off. And I'll do an Alt, Shift, and F to format our file. Save that again. Fantastic. So I'm going to copy this now, and I'm going to copy it and put it into our production file as well. Now, of course, this is not what we will be using in production. That will not be correct. So in order to get what we need to use, let's come back to our K8 project, into our RabbitMQ deployment file. And as before, we have our cluster IP service here. It is the name of our cluster IP service, acts as the name of the server effectively. So we'll copy that. And you've seen that before with how we've used SQL Server. So again, making sure you're in the right config file in production, we will paste that in like so. So that's our config setup, and we'll read that in obviously when the service starts up. And we've got two different settings for both production and development, which is exactly what we want. So next, what we're going to move on to is we're going to create a new DTO for when a platform gets created in our platform service. We then want to create a DTO for publishing onto the message bus. And you'll see why in a minute, why we have a separate DTO for that scenario. So we'll move on to that next. All right, so let's just review the DTOs that we have. We're still in our platform service and come back to our DTOs. We have two. We have a platform read DTO, which is the DTO we expect back from this service. And again, it's got some kind of domain specific fields like cost and so on and so forth. And also our platform create DTO, which is the one that, we expect when somebody's going to create a platform with us. But we're going to create another one, and we're going to call it platform publish DTO. And the whole point of this DTO is that is the DTO that we're going to put on to the message bus. When a new platform gets created, as far as our service is concerned, our platform service, we're going to publish that information onto the message bus, but we're going to publish it in a very specific format. We're not going to include the cost, for example, and we're going to include an additional attribute. So it's exactly what DTOs are meant for, specific scenarios in relation to how we're moving data around our application. So all will become clear when we come to maybe starting to use it, but as a foundational piece, it's the next thing that we need to do. So in our DTOs folder, make sure you're in the platform project, right click, new file, and I'm going to call this platform published DTO.cs. And then again, we're going to specify a namespace. Back in our platform service, we're in our DTOs folder, and it's just a public class called platform published DTO. So what do we want to publish? What information do we want to publish? And I'll just make sure I've spelled this correctly. Platform. Okay, that's definitely correct. Platform. Yeah, cool. That would have caused me some issues a bit later on. So yeah, platform publish DTO. What information do we want to publish onto the wire? So the first property is going to be our ID, which is an integer. So this will be the ID as far as the platform service is concerned. We're going to publish the name of the service, and we're also going to publish another string, which I'm going to call the event, the specific type of event. And you'll see how that gets used a bit later on, although I'm sure you can probably guess how that's going to be used. Now, with our DTO being created, we now need to come back into AutoMapper, into our AutoMapper's profile, and create another mapping. So the mapping is going to be as follows. Create map. The source this time is going to be a platform read DTO, and we're going to map it to our platform published DTO. And the reason for that is ultimately the trigger for our event is going to be in our controller, in our platform create action. So we create a new action, it gets created. We're going to ultimately create a model in our database. We're also going to pass back the platform read DTO to our consumers, but we're also now going to put a platform publish DTO onto the message bus. So we're going to have already a platform read DTO. We just want to map that onto our platform publish DTO so we can push it out over the wire onto our message bus. So we have that mapping there. All right, fantastic. So I think that's the DTO side of things done. We're now going to move on to actually creating our asynchronous message bus client. So we'll do that in the next section. All right, so back over in our platforms service, let's just close down all this stuff. And we're going to do a little bit of setup. Well, we've done our setup, but we're going to create our interface now. So we're basically going to create a message bus client. But the way I want to build it is, again, we want to use dependency injection. So we're going to have an interface that specifies the methods that our message bus client can perform, and then we're going to build a concrete class to service that interface. So back over in our project, we're going to create a new top level folder. So in the root of the project, new folder, and we're going to call this async data services. So you'll remember we had a synchronous data services with HTTP for our HTTP command. We're now going to create some asynchronous data services for our RabbitMQ message bus. So in here, we're going to create a new file, and I'm going to call it imessagebusclient.cs. And we'll just make sure we spell message bus correct. imessagebusclient. That's cool. All right, so again, this is just our interface. So actually it's going to look very simple. So namespace, and this interface is actually agnostic of RabbitMQ. It doesn't rely on RabbitMQ namespaces or anything like that. So namespace is platform service, and it's now a new namespace, so ASYNC data services. And it's just a public interface called imessagebusclient. And we're going to define a new method, void. Method is going to be called publish new platform. And it's going to expect as an input a platform published DTO. Fantastic. So all we need to do really is bring in the namespace for our DTOs. So again, that's it. That is our interface. So we're going to expect to use this message bus client, and this method is saying that we're going to publish any new platforms onto our message bus. Fantastic. So save that off. And then next, we're going to come on and we're going to implement a concrete implementation using RabbitMQ. Now, fair warning, there's a lot of stuff in this class. This next bit is going to be quite long, and again, it's possibly prone to some error, so we'll need to take it quite slow, quite detailed, and we'll go through and build up step by step. So yes, we'll move on to our concrete message bus implementation class next. All right, so back over in async data services, right click, new file, and we're going to call this message bus client. Fantastic. So let's start building this monster up. It's actually not that big, but it's probably the biggest kind of class we've got in our application. So namespace, platform service, and we're in async data services. Fantastic. And it's a public class called message bus client. And we want to implement imessagebusclient to implement our interface. So control period to implement our interface, and of course it's not fully implemented, it's just a placeholder, but that's okay. And I'm going to do a control B just to give us a bit more room. Now before we actually come on to implementing this method, I want to implement a constructor, a class constructor, and it's within the constructor that we're actually going to set up the connection to our message bus. So CTOR, message bus client, and into this I want to pass an iConfiguration object called configuration, because I want to get access to our config elements that we just specified in one of the previous sections. So let's bring in the namespace for this. And again, be really careful. We don't want AutoMapper configuration. We want Microsoft extensions configuration. So make sure you bring in the right namespace. That has caught me out before. Now again, iConfiguration is one of those things that's just available to us all the time throughout our application, so we don't need to specifically register it in our startup class or anything like that. We just have access to that as a matter of course. So we want to then specify a private read-only field to store or to access our configuration. So underscore configuration equals configuration. We won't bring in the namespace, we will generate a read-only field. Again, you've seen this stuff 100 times already now. Now this is complaining, and I'm just going to do a control B. So I just want to check to see what the issue is here. I think it's because this has got a capital L. Let's see if that makes any difference. That's better. Small things like that can drive you crazy. So I thought maybe the file was named incorrectly, but as you could see, the constructor name didn't match the class name because of a mismatched capitalized L. So just be careful about things like that. It can drive you kind of nutty. All right, fantastic. So that's the first part of our constructor setup, but again, we're only a small part of the way there. So the next thing we want to do within our constructor, again, as I say, this is where we're going to set up our connection to our message bus. We want to set up what's called a connection factory. Now this is a RabbitMQ concept, not dissimilar to a HTTP client factory, similar sort of idea. Allows us to create connections basically to our RabbitMQ instance. So I'm going to create a variable, I'm going to call it factory. I'm going to make it equal to a new connection factory. And we're going to have to bring in a namespace, control period, using RabbitMQ client. So it's a RabbitMQ concept. All right, and then we're going to define what our configuration elements are, what our connection stuff is. So the host name is going to be equal to, we're going to access our configuration instance, and then we're going to specify the name of our configuration element. So control B, and we're going to come down to either one of our files because we've named them the same thing. Now that's a really important point. These have got to be named the same thing. So RabbitMQ host and RabbitMQ host. The values are of course different. So we want to inject in our host value into here. So control B, and we'll paste that in here. That's the first part. Okay. And then we want to specify the port. Now the port value is an integer. Now we have stored our configuration element as a string, not a problem. So let's build it up step by step. So we're going to access our configuration and we're going to access the port element. So we come back over here, we'll copy this, bring it back here and paste that in here. Now I'm just going to move to the end of this. It's getting a bit long, so maybe I take a new line, maybe that's what we do. And I'm just going to put a semicolon at the end there. Now this is not going to work because we are expecting an integer, so what we're going to do is we're going to say int.parse, and then we're going to wrap that in a pair of parentheses. And that should stop erroring out. Fantastic, so let's just save that off. Just do a quick build, just to make sure we're on the right track, because we say we've got a few steps to go in this class and I want to make sure we're not making errors as we move along. So that's all looking pretty good at the moment. Fantastic. So we've got this factory, connection factory object now that we can actually build connections off of. So this next set of stuff we're going to put into a try catch block. So try, because obviously stuff can go quite wrong here. Catch, we'll catch the exception. Call it EX, and then in here, write line, and we'll write out something. We'll use string interpolation, so $, double quotes, put the semicolon at the end, and we'll just say could not connect to the message bus. And we'll put the exception, put a colon there, and put the exception in here so we know kind of what issue we have. And it's more than likely going to be the service isn't available, the RabbitMQ bus isn't available, something of that nature. All right, so we've got a little bit of setup to do now in our try block. So the first thing we actually want to set up is a connection. So what we're going to do is we're going to create a private read-only field called connection. And I'm going to make that equal to a factory, and I'm going to call the create connection method on that. So of course, control period, and we want to generate a private read-only field. We put that up there, and that's added up to the top. So this is our connection now. The next thing we want to do, and again this is RabbitMQ specific, is create something called a channel. So underscore channel. And that's equal to our connection, and we do something called create model. So again, the way RabbitMQ works is kind of, again, it's a bit like Kubernetes, it's multi-layered, there's multiple things we have to set up. We have to set up a connection, we have to set up a channel, and then we have to set up an exchange. So again, just the way it's architected. So again, we'll create another private read-only field for our channel. So generate read-only field. And again, make sure it's being added up here. Next thing we want to do off of our channel is declare an exchange. So we're talking about fan-out exchanges, direct exchanges. This is where we declare our exchange. So exchange declare, and into here, we'll use exchange. We'll give it a name. I'm just going to call it trigger, as we're triggering messages. And then we specify a type. And this is where, make sure you put the colon in, our exchange type. And we specify, you can see the different types here. We specify it's a fan-out exchange. Okay, so we've got a connection. We had to create a channel off of our connection, and now we're now declaring an exchange off of our channel. And at this point, really, we should be pretty much connected to our RabbitMQ instance. But what I'm also going to do, because we might use it at some point on our connection, we're going to subscribe to the connection shutdown event, because we maybe want to do some stuff in there. So we'll subscribe to that event, and I'm just going to call it RabbitMQ _ connection shutdown. Now this doesn't exist yet, so we'll just come outside of our constructor, and down here we will just declare that private void, copy the name, we'll get the object sender. And again, if you've not worked a lot with events before, this is basically an event will be triggered when the connection shuts down, and we can put anything in this method here, basically, when that event triggers. I'm not actually going to put too much in it. In fact, I'm going to put nothing in it for the moment, but we may come back to it at some point. Well, I'll tell you what we will do. We will put in a console write line just to say that our connection has been shut down, just so we're aware that that may have happened, and it helps us debug, doesn't it? So write line, and we'll just say RabbitMQ connection shutdown. Okay, so if you don't want to put this in, you don't really have to. I'm just putting it in just to be a bit more kind of, yeah, it gives us a bit more detail if something does shut down. But at this point, we should be connected to our RabbitMQ instance. So again, I'm going to put console write line, and I'll say connected to message bus. And we'll save that off. Fantastic. Okay, so that's our constructor done. That's basically our connection done. So the next thing we want to move on to, which we will do in a second, is basically create our publish new platform message. So we'll do that next. All right, so on to publishing our platform, actually implementing our main method here. So let's get started. So we'll take out the exception that we've got there. The first thing I want to do is create a message object. And that message object is basically going to be a serialized version of our platform publish DTO. So we're going to use JSON serializer. I want to bring in a namespace for that. So again, use system text JSON. And we're going to call the serialize method. And what are we going to serialize? We're going to serialize our platform publish DTO, because we're going to send it over the wire. And ultimately, we're going to convert it to a byte array. All right. So got that as a string now, basically a serialized string. And then all this method is going to do is going to check to see if our connection is open. And if it's open, then we're going to actually send it. And I'm going to put the send functionality into a separate method. So we'll leave that blank for the moment. Well, I'll tell you what, we'll put our console write line in just to help us with debugging. So console write line, and we will say RabbitMQ connection open, sending message. ... Fantastic. And if the RabbitMQ connection is not open, then we'll do a console write line saying RabbitMQ connection is closed, not sending. Now we could start getting into retries and all that kind of stuff. I'm not going to implement that today. It's just going to take too long, but we'll just write out a message for now to say that we were unable to do that. So we will come back here and we'll put a bit of a to-do in. You still have to actually send the message. Now we could put it in here, but I just feel it's a bit cleaner to pull it into a separate method. So I'm going to make it a private method. Void, I'm going to call it send message. And we're just going to expect a string of message type. Now the other reason I'm doing it this way is that we are exposing this publish new platform as a method on our interface. It's conceivable we're going to have a number of different methods, so publish platform, publish something else, whatever it happens to be. So this send message method, I want it to be generic, reusable by any other methods, and we may just have, you know, a range of other methods that we expose to do other specific things. So that's the other reason I'm kind of pulling it out into its own method. Send message is just totally generic. So I want to now create the body of our message that we're going to send, and it's going to be a byte array effectively. So var body equals encoding, I'll bring in the namespace, system text, and then we'll say UTF-8, get bytes, and then we'll pass in our message. Now while I remember, I'm going to come back up here and I'm actually going to call send message in here, and we're going to pass over our message that we constructed up here, our serialized message, just in case I forget, which I probably will. So that's this method finished, and now we're just going to complete our send message method. Then all we actually have to do now is on our channel, we just need to publish our message. So we'll call the basic publish method. Here we are. And we have to specify the exchange, which we called, when we declared it up here, what did we call it? Trigger. So this is possibly something you'd want to pull into config as well. You don't really like to have magical strings in our code, but anyway, we'll brush over that for the moment. Get rid of this. The next thing we need to specify, which we are going to ignore, is a routing key. Now you'll remember fan out exchanges ignore the routing key anyway, so it's just going to be nothing. Okay, these tooltips can be useful, but they can also be quite annoying. I find sometimes the tooltips appear when you don't want them and they don't appear when you do need them. Next thing is basic properties, and that's just going to be null. We keep getting that, quite annoying. Our body is going to be our body that we've declared here. And that is basically it. Okay, so basic publish, what exchange are we publishing it on? Routing keys are relevant anyway. Basic properties we just set to null, and the body is what we've encoded here. And then really, at that point, we can say console write line. And we'll use string interpolation, and we'll say we have sent, and we'll put in our message here. Fantastic. So that is pretty much it. The only other thing I want to put in is a dispose method. So when our class dies, we clean up anything that's left behind. So public void dispose. I'm just going to do a console write line because I like to understand when these things are happening, and we will say message bus disposed. And we'll just check to see if the channel is open. And if it is, then we will just close the channel off. And then we'll close our connection off as well. Fantastic. So I think that is us done. So let's just do a quick .NET build. And we're all good. Fantastic. Now, before we move on to actually using this now, one last thing I want to do because it's the thing I'm tending to forget at the moment, is we want to come over to our startup class and we want to register for a dependency injection, our iMessage bus interface and the concrete class. So back down in startup, let's get rid of that. Come back up to configure services and let me just get rid of that so we get a bit more room. And after our HTTP client, let's add a registration for our asynchronous client. So this time we're going to add a singleton. And the idea of this is that we're going to use the same connection throughout the rest of our application, So we add a singleton lifetime basically, is why we're doing that. And we'll add an iMessage bus client of type message bus client. All right, and let's just bring in the namespace. Oh, my butterfingers there. So control period, and yeah, using platform service async data services, and that should resolve them both. In fact, it does. Fantastic. So that should be our asynchronous data client setup, which is rather exciting. So now what we want to do is we want to use it from within our controller. So when we create a platform, not only are we going to still send a synchronous message to a platform service, which we're still going to do, we're now going to drop a message onto our message bus. So we're getting towards asynchronous messaging between our services. So we'll do that in the next section. All right, so we're almost at the point, well, we are actually at the point where we can use our message bus client now. So we're going to do a control B, make sure I'm in the right place, and we're going to come back to our controller. So let's do a quick review of our platform's controller. So control B, again, let's come up to the top. So we have our constructor and we're passing in a repository, fine, our mapper, fine, and also our synchronous data client or HTTP data client. And down in our post action result where we're creating a platform, we're doing all our usual create platform stuff, but you'll remember down here, we then actually attempt to send a message to our command service using HTTP. All right, so we're now going to put in another component here. We're going to send a message asynchronously. So back up to our constructor, we're going to add to the things that we are passing in via our constructor using dependency injection. So this time we're going to pass in an iMessage bus client, and that's going to be equal to, it's going to be called message bus client. And we need to put a comma there. And we should bring in the namespace. So yep, using async data services. Fantastic. And then down here, we're going to create a private read-only instance of that. So message bus client equals message bus client. You've seen this 1,000 times before now, and we'll generate a private read-only field. Super. And that's why, of course, we had to, again, I'm just labouring the point, we had to make sure we registered this here. That's something I usually always forget, but we've done it this time. So back down into our create platform method, what I might do, although it's obvious, although you can read it in the code, I might just do a little bit of documentation and say send sync message. And then under here, we're going to send our async message. All right, so again, we'll put it in a try catch block because it's something that could conceivably go wrong, and we'll deal with our catch first. Oh. So we'll catch an exception, EX. I'll do a console outline. I might just copy this here. Saves me typing. And we will just say could not send asynchronously. There we go. So the first thing I want to do in here is create a published DTO. So we created our published DTO. We want to map into, well, we want to create one basically. So we'll call it platform published DTO. And that's equal to mapper. Map. What do we want to map to? We want to map to a platform published DTO. And what is our source? Our source is going to be our platform read DTO that we have up here, hence the mapping that we created. So you could create other mappings. You could conceivably create the mapping from, rather than mapping from a platform read DTO, you could map from the model. That's a possibility as well. Up to you how you want to do it. Now you'll remember, if we just do a Control B, over in our, let's have a look at the DTOs, in our platform publish DTO, we had all this stuff here, fantastic, but we also had this property called event. Now that is not, event is not available as part of our platform read DTO. So we need to explicitly add that in. And that's just to help us identify at the other end what type of message event has been sent out. So platform published DTO, we'll find the event property and we will just make that equal to platform published. Now you would probably want to have a kind of, you would want to document the events that this service emits. In fact, within your entire microservices architecture or application, you would want some kind of documented library of the events that can be expect to be sent and received along with the payloads and all that kind of stuff. I'm trying where possible to keep the payloads as standardized as possible. All right. And then finally, moment of truth, we use our message bus client to publish a new platform, and we just send that one to the wire. Fantastic. So we are almost at a point where we are going to test this. So I'm just going to save that off. And in the next section, we are going to test this. We'll spin up our, and we'll test it locally. We'll spin up our command service locally. We'll spin up our platform service locally. We should see it connect in when we send, see it connect in, and we should see it send a message once and only once we create platforms using the controller. So we'll do that next and we'll see how we go. All right, so let's run up our platform service. So .NET run. Okay, so let's just take a quick look at the output. Shouldn't be anything different from what we've already seen before. So where is it? Yep, so it's using the in-memory database, which is correct. Our command service endpoint is our command service, which isn't running yet, and we've seeded data. Now, a point to really note here is that we're going to run up our command service now locally. For the asynchronous stuff we've just done, that, well, it doesn't need to be there anyway, because again, all it needs to be there is the message bus. So the reason we're running it up is so that the synchronous part of our messaging will still work. And we'll actually shut down our command service as well to see what happens when that is not there and how the synchronous stuff behaves. So we've got our platforms service up and running. Let's come back to our command service. Over here we are. And let's do a .NET run. Fantastic. So again, it's running on localhost 6000, which is good. And then we'll bring up Insomnia. And we will come back to our local development environment, back to our platform service, and we're going to create a platform. Now I might just move this, because we're slightly running out of screen real estate, but let me just do it in Insomnia and we'll see what we get. So let's send this over. So that's cool, we got our 201 created, fantastic. Let's move back over here. So this is our command service, and you can see we still got the inbound post, which is all that we're doing, fantastic. But more interestingly, if you come to our platforms controller, you can see that we connected to our message bus, which is good. Our sync post was okay, obviously, because we just saw it was received by our other service. And then you can see that the RabbitMQ connection was open and we were sending the message. And then finally, we sent the message, we dropped onto the message bus. So that's all looking really rather good. And you can see here, boom, in our RabbitMQ message bus, yes, indeed, there was a message placed on to the bus. Now, off screen, I've got Insomnia. What I'm going to do is I'm just going to rapidly fire some, you can hear me clicking, I'm going to rapidly fire some events in here. And we'll wait for this to catch up and you'll see how that should manifest. So I've just basically blasted a load of commands onto the message bus. So maybe we need to get this to update a bit quicker. Maybe I do a few more. And you'll just see, I've only put a couple on, and you'll see how that compares to what we just blasted on. Holding our breath, there we go. So there's a few more. So that's all looking really rather good. So again, we've dropped stuff asynchronously onto our message bus, our command service is only getting synchronous messages via HTTP. We still have to build in the subscriber. We've not done that yet. But let's come back to our command create service. And you can see here, command service, all the inbound post commands. And I'm going to stop this now. Okay, I'm going to do a Control C. So our endpoint is now down. Synchronous endpoint is now down. Now I'm going to click send, watch what happens. We get a spinner, we're waiting. That is because our platform service is attempting to send a command to a synchronous endpoint, and it has to wait for the message to come back to go either successful or unsuccessful. And there's, I'm sure, a default timeout window that we will wait for. Again, just to demonstrate again, it's waiting. Now you can imagine this whole idea of a dependency chain where you have hundreds potentially of services all doing that, how that could stack up and cause massive delays just because that endpoint is not there. What you will also realize though, as we come back to our message bus, once the synchronous messaging component failed, the asynchronous stuff still went ahead and dropped our asynchronous messages onto the message bus, because that's still there and that's still running. So you can start to see the differences between synchronous messaging being problematic if it's not there, and us just dropping async messages onto the message bus. All right, so that is all looking pretty good. So I think what we should move on to next is we can do one of two things. We can either deploy this into our Kubernetes cluster, which I'm probably not going to do. I think what we do next, because this was successful, is we build up the subscriber in our command service so it can actually receive the events from the message bus. So we'll move on to that in the next section. All right, so let's make sure we are over in our command service, and I'm just going to, before I do anything else, make sure everything else is shut down. Let's just shut that down as well. Okay, so back over in our commands service. Now, I'm going to give you a bit of warning here. This is actually by far and away the most complicated part of the whole video. And that is basically allowing us to, number one, subscribe to the message bus, and then to determine the event on the message bus, and then do something with that event that we've determined. So there's quite a few things that we need to build up here. So we're going to have to add 2 new DTOs to our command service. We're going to have to add the RabbitMQ config to our config file. So we'll do that next, and that's quite straightforward. You've seen that already. We're then going to define what's called the event processor. And the event processor is basically going to determine what type of event did we get. So again, the RabbitMQ pipe is stupid. We're just getting events. So we need to find a way of determining what was this event. Was it a platform published event? Was it a shipping event? You know, there could be a million different events. So the event processor class is really determining what was this event and then doing something with it. And then we're going to write the class that actually connects to the message bus and receives events, because it's dependent on this event processor. So we have to build it up in the order in which they're used. Okay, so there's a lot here. Conceptually seems quite simple, but the implementation, there's a couple of little really gnarly things in here to do with the way dependency injection works, service scopes, service lifetimes, and we're going to be doing some kind of interesting stuff around getting access to our repository. And there's a lot going on here, so you do need to pay attention. All right, so in this section, what we're going to do, just some simple stuff to begin with. We're going to check that we've got the RabbitMQ client library, simple enough, and we're going to create our config, and then we'll move on to the next section. So, commands service, commands CS proj file. Let me just get rid of this for the second. Make sure I'm in here. And yeah, we don't have the RabbitMQ package, so .NET add package. And it's RabbitMQ, keep saying MQ client. All right, simple enough. And there we go, that's added in, very good. And then, like we did with our platform service, we want to add in configuration elements to both our production and development app settings JSON files. So we'll do a Control B, and what I might do is I might select our app settings development JSON, and I might just come over to our platform service, and I might just copy in those files. So here we are, platform controller, platform service should I say, and I'm going to close all this down. And we'll come to our development JSON, and I'm just going to copy these because it's exactly this, connecting into the same message bus. Okay, so I'll copy these over. All right, and I'll paste those in. And doesn't like that. I need to paste it inside here. Paste it in here. That's better. I'll tidy that up by doing an Alt, Shift, and F to format our file. Save that off. Fantastic, and then we'll select our, we've only got an app settings JSON file here. That's interesting. We don't have a production settings file yet, so let's do that. So in the root of our project, right click, new file, and we'll create an app settings.production JSON file. And we will come back to our platforms class, platform service. Get rid of that, go into our production class, and we will just copy this out. Actually, we only need the 2 elements, so copy that, and back over in here, we need to put in a pair of curly brackets, and this is our config for our platform service. So platform service or command service in production. Okay. All right, so command service, we got our development configuration, and we have our production configuration, remembering that it's the RabbitMQ cluster service IP name that we want for production. So that is our sort of basic config setup. Next, we want to move on to doing our DTOs. All right, so we're wanting to create some DTOs now to support receiving platform event messaging down at our command service. So let's just close this down. And we are back in our DTOs folder. So the first DTO we want to create is the platform publish DTO. .cs. So again, we're dropping this DTO onto our message bus from our platform service. We want to take it at the command end and use it and add it ultimately to our database. So namespace is command service DTOs, and then it's just a public class called platform published DTO. And what I might do, just to kind of save a bit of time, is come back to our platform service and just copy these properties over into here, as they should be exactly the same. Fantastic. Now ultimately what we're going to do is we're going to get this, receive this, understand that we've got this, and we want to then create a model in our command service database. So if we could take a quick look at our models, it's the platform model that we want to create, obviously. The ID is taken care of by our database, so we don't need to worry about that. The name we are getting here. We're passing over this additional event property, which our platform doesn't care about, and we're going to use that for other purposes. But we have specified that we do require this external ID property. Now, what that is going to ultimately be is it's going to be the ID of the platform in our platform service. We're going to use that as the kind of unique global identifier. So we're going to have to map between platform publish DTO and platform DTO. Now, unlike previous times where, you know, in the case of name, it's just a straight through exact mapping. AutoMapper can do that for us without any additional config. In this instance, we are going to have to tell AutoMapper that we want to map ID to external ID. And so this is where the AutoMapper stuff starts to get a little bit more interesting. So before we do that though, let's just create our other DTO. And there's one more, it's a very small one. Call it new file, and we're going to call it generic event DTO.cs. And we'll just create a namespace. Namespace. And that's command service DTOs. And it's just a public class called generic event DTO. And it's just got one property, it's a string, and it's just called event. Now I'm not going to go into the details of why we have this just yet. We'll come on to that a bit later, so just stick a pin in that for the moment. And we don't need to use AutoMapper to map this either. That's just something we use a little bit later. But we do need to come back to creating a profile now and a profile mapping that's going to map our platform published DTO and map it to our platform model. So we'll do that in the next section. All right, so let's come down to our profiles folder, and in commands profile, we want to add in a new mapping. So we've seen this before, so create map. What is the source? The source is our platform published DTO. That's what we're going to get over the wire. And we want to map it to our platform object, which all sounds very reasonable. And we'll just close off with a parenthesis. But as I said in the last section, we want to explicitly tell AutoMapper that we want to map the ID of our platform published DTO to the external ID of our source, of our target, sorry, of our destination. So let's do that. So the way you do that is don't put a semicolon here. You come on to the next line if you want to make it look a bit neater. You can have it on the same line as well, obviously. And we do for member. And then we specify lambda expression, destination. So this is where we want to map to. So we say the destination, which is ultimately our platform object, dest, and it knows that our destination is a platform object. So we want to select the external ID property. We then select some options. So OPT goes to OPT, and I'm just going to do a Control B to give us a bit more room. So we can see what's going on here. And then we want to specify on this option, map from. And then what are we mapping from? We're mapping from our source, which is our platform published DTO. And what are we mapping from? We're mapping from ID. Okay, and we'll terminate that with a semicolon. And everything else should map through okay, but that is our explicit rule saying at our destination, which is our platform model, we want the external ID to be mapped from the ID of the source. All right, and we'll save that off. So that's our mapping setup. Now, I'm going to preempt something that I want to do a bit later, and what that is when we come and we receive this platform published object, we have to do a lot of stuff before we get to that, or after we get to that. We want to determine that we want to put this model, this object, into our database. Now, we want to make sure that we're not duplicating the same platform in our database. So we're going to do another repository method to say, given an external ID, do we already have that external ID in our list of models? And if so, then we don't add it. So it's very similar to the platform exists method. This one is just slightly different. We're using the external ID this time. So I'm just going to add that to our repository ahead of time, and then we'll use that a bit later in our event processor class. So we'll do that next. All right, so let's just do a Control B and close this stuff down, and we're going to come back to our repository. We're going to use this a bit later, so I'd rather just get this done ahead of time than do it at the point when we need it. So back over in iCommander repo, we already have this platform exists, and that's checking to see whether we actually have a platform with that URI in our database. We're going to create a very, very similar method. Let's call it platform, well, we'll call it external platform exists. And this is just going to be used to check that we're not going to add additional platforms into our database when we already have it there. Okay, and so we'll say int external platform ID. Fantastic, and we'll get an error now on our concrete class because we've not implemented this, and I'll just pluralize that. So external platform exists, that looks okay, fine. And then we'll come over here and we'll just come up to here and do a control period to implement the interface, and that will put it down here somewhere. Where's it gone? There we are, external platform exists. Now what I might do is find our platform exists method and just copy this because it's going to be very, very similar to that. So in here, we'll paste in return context platforms NA, P goes to P, and this time it's not on the ID, it's on the external ID is equal to the external platform ID. All right, so again, similar concept, we're just going to check to see whether we have that because we do not want to double add more and more platforms if we've already got them, and we're doing that based on the external ID. Fantastic. So just a quick change, and now what we're ready to do is we're going to move on to our event processor class. All right, so on to event processing. So just to give you a quick explanation of what this is, we've got two main bits still to do, and that is the event listener, effectively. We're going to do that later. This one is the event processor. So upon getting an event, which we'll do later, we need to determine what is this event? What is it? Is it a platform published event? Is it something else? So upon determining what the event is, we then want to do something with that. And what we're going to do is we're going to add that platform to our database, assuming we don't already have it in there, hence the last section. So that's ultimately what we're going to do with the event processor. Now, I will call out that we only really have one event that we're interested in our platform. If you had lots more events, then the way I've built this class, you would probably want to decompose it a bit further. But for our purposes, I think it's fine. So back in our command service, let's close everything down. And we're going to create another top level folder called event processing. Now this next bit is actually, there's quite a lot here and there's a few interesting concepts in it, not most especially around dependency injection. It can get a little bit gnarly. Anyway, so we're going to create an interface first, because as always we're going to use sort of dependency injection. So new file, and this is called event, capitalize the E, processor.cs. All right, now this is actually going to look very, very simple, but behind the scenes there's a lot going to be going on here. So namespace command service, event processing. And then it's just a public interface called event processor. That's right. And it's going to have one method called process event, which seems benign enough. And it's going to take a string called message. Very, very generic. So ultimately, we're going to get this message string from our event listener service, which we've yet to build, and it's just going to be our object or event string. So we're going to have to take that string and understand what the heck is this, deserialize it, find what event it is, and then do something with it. So a very benign looking interface, but there's going to be a lot going on behind the scenes. So let's not mess around anymore, let's create it. So new file, still in event processing, and we'll call it event processor.cs. And let's do the easy stuff first. So namespace, command service, event processing, and it's just a public class called event processor. And it's going to implement my event processor. So as usual, let's implement the interface, implement the placeholder, but we're not going to come on to that just yet. Now the first thing I'm actually going to do is I'm going to step outside this class, and in here I'm just going to create a very simple enum. So enum, and we'll call it event type. And this is just listing out our event type. So we're going to have platform published and undetermined. Okay, and that's the only ones we're dealing with. And the reason I'm creating an enum is I don't really like working with magic strings, so this just gives us a bit more structure around the types of events that we can have, and you'll see how this is going to get used in a second. And now just make sure you create that outside the class. All right, so we're coming on now to our class constructor, and again, coming back to the intention of this class, is to take a message, determine what it is, and then we're going to add, if it's a platform published event, we're going to add our platform to our database. So immediately you're going to think, well, that's cool. That's just constructor dependency injection. That's just injecting a repository into this class. Unfortunately, in this case, no, that is not the case. We cannot do that. And the reason is for rather torturous dependency injection reasons. So I did kind of brush over it a bit earlier in the course, but when you register your services in Configure Services, they have what's called a service lifetime. So scoped, transient, or singleton. Now, singleton registered services, they exist for the lifetime of the application, basically. Scoped services, they exist kind of for every kind of session, and then the transient ones, it's every request. So they have different lifetimes. So singleton ones last for the entire length of the application. Fine, you may say. When we come on to creating our listening service, that is going to be created as a singleton service ultimately. It's going to be there for the lifetime of our application. And that service is going to call this service. And in order for that to happen, in order for us to inject this event processor service into our listening service, it too has to have a lifetime the same or greater than the service it's being injected to. So this service is going to have to be a singleton service as well. Fine. If we then try and inject in a repository and ultimately further down the food chain a DB context, those services have been registered with a shorter lifetime, and you can't do that. Freaks out, okay? It's not good practice. So in a long and roundabout way, we cannot inject a repository into the constructor here. We're going to have to inject it, well, we're going to have to create it, a reference to it in another way. So that's what we're going to do here. So coming back to this, probably become a bit more understandable when we actually go through it. So class constructor. So instead of injecting a repository, we're going to inject something called an iService scope factory. And we'll call that scope factory. And the use of the, we'll just go to the thing at the side there, and the use of the term factory, you might start to have some idea of what this may allow you to do, or maybe you don't. And I don't blame you if you don't. But the good news is we can still inject our AutoMapper in, so in the usual way. That's fine. And we'll bring in the namespaces for this, and we'll have to capitalize that. So let's bring this in. Microsoft Extensions Dependency Injection and AutoMapper. All right. I might actually just take this back up onto this line. I don't like using multi-lines unless I really have to. So again, we're going to create some private fields. So scope factory equals scope factory and mapper, or underscore mapper equals mapper. And then we'll create some read-only fields for these here. Read-only fields, and correct that, and bring in a read-only field for that as well. Fantastic. So we'll come on to using the scope factory a little bit later when we actually do have to use a repository, but stick a pin in that for the moment. So the next method I'm going to create in here is in support of our publicly exposed method, which is process event. It's a private method, and basically this is the method that's going to determine what is the event that we got. And ultimately what it's going to use, if we come back to do Control B and we look at our DTO, we look at our platform publish DTO, we are passing through this event attribute here. And we're going to basically look at that and see what that is. And you will remember from, or maybe you don't, from our platform service over in our controller, when we generated our synchronous message, we set that event to this field here, to this string here. So we're basically just going to ultimately look for this string to see and understand whether it's a platform published message. So back over in our command service, let's get rid of that and let's come back to our event processor. So this is a private method, and we'll call it private event type. So it's going to pass back an event type that we defined here. And we're going to call it determine event. Into that, we're passing the string that we get passed through from our, ultimately from our event listener, and we'll call it string notification message. Fantastic. Okay. Then I'll do a console write line. Bring in the namespace for system. And we'll just say something along the lines of determining event. Fantastic. So the first thing we want to do is basically deserialize this string into an object. Okay, so I'm going to create a var, call it event type, and we're going to use our JSON serializer, and we're going to bring the namespace in first before we start to use it. So system text JSON, get rid of that, and we're going to deserialize this time. Now what we're going to deserialize to, well, again, bring this back up, the reason we created this generic event DTO is we're going to deserialize to this, because all we really want to pull out from any message anywhere in our microservices platform is this event property here. So when we deserialize it, we want to deserialize to that. Now, in days gone by, if you're using the JSON, the Newtonsoft JSON library, you could use what's called dynamic deserialization, and that means it kind of does it on the hoof. I didn't like that anyway, because you kind of end up with a non-typed message, which I don't like. So this is typed, using dynamic as non-typed, and it leads you into all sorts of crazy madness, which is not, I don't think, best practice anyway. So long and short of it, we're going to deserialize to a generic event DTO. And what's our source? Source is our notification message. So this is really just to enable us to get at that event attribute. And we'll just bring in the namespace for this. And I think I've spelt it totally wrong. Gen-R-ic. No T. Let's try that. That's much better. Okay, so we have our generic event here. And then all we want to do is just switch on that. So switch. And we'll access our event type and access the event on it. And let's move this up, and then we're just going to do some case statements. Case. And I'm going to come back to our platform service and have a look at what we passed over. I'm just going to copy this. And I'm going to paste that in here. So if our event is that, then of course we can be confident we have a platform published event. And I'm going to do a console write line. And we'll say platform published event detected. And we will simply return back event type of platform published. Fantastic. And that's the only sort of switching we're going to do, so we will just round off with a default, and we'll just write console write line. Whoop. And I'll use this, and I'll actually do that up here as well, because I've been using it all throughout the application. So let's keep it consistent, and we'll say could not determine event type. And we'll just return with that. Oh, actually, we need to return the event type, which will be not platform published. That will get very confusing. Undetermined. There we go. That's great. Fantastic. So again, the whole point of this private method is just to ensure that we can understand what event we got down the wire. And our process event is then literally going to do something. Well, it's going to see what we got back, and it's going to then action it, do something with it. So we'll take a quick pause here because this video's been going on quite long, and we'll come back and we'll finish off our process event and one other method of this class. All right, so let's come back to our process event, and actually just don't forget to save your work just in case something crazy happens. So in process event now, this is kind of our main publicly exposed method. All we want to do is we'll create a variable of event type, and we'll make that equal to determine event, and we'll pass over the message that we get here. So we've kind of, subcontracted the determination of event to this method here. We now have that in our event type, and then simply we just switch on that. So we'll switch on event type, case. So case event type is platform published. Then we want to do something here, and then we'll break. And then we'll just put a default in, and we'll do, well, we don't need to do a console write line because we already kind of had that from here, so we'll just leave it. We'll just break it. Probably a bit redundant, but we'll leave it like that. So what do? We've got a platform published event. We want to actually add it to our database. That is ultimately what we want to do. Now, I would probably, going forward, move out the kind of classes that we use to action our events. Possibly, I'm not sure I would wrap it into our event processor, but I have for this video, and I feel in this instance it's totally okay. So, still within our event processor class, we're going to do one more private method, and I'm going to call it private void add platform. And we're just going to expect in a string, and this is effectively our published platform DTO, but it's still in a string form, so we'll call it platform published message. Okay, now this is where we're going to start using our scope factory to actually get a reference to our repository. So we'll start off with a using statement. Determine or declare a var called scope. Our scope is going to be equal to our scope factory, create scope. All right. So then within here, we're going to create a variable to contain our repository. So we'll just call it repo. And that's going to be equal to our scope, service provider, get required service. And what type of service do we want to get? We want to get an I command repo. Okay, so basically getting a reference to this in this way, as opposed to injecting it through constructor dependency injection. And again, it all comes back to the service lifetime of our repository and this class here. So again, a bit gnarly, but you know, it's definitely useful, and it's going into the more detailed use cases around dependency injection. So the next thing we want to do is not do that. We want to create a variable, and this time we want to essentially deserialize our platform published message into a proper platform published DTO. So var platform published DTO is equal to JSON serializer, deserialize. What do we want to deserialize to? Platform published DTO. And what is the source? Again, this is very similar to the mapping syntax that we use with AutoMapper. We want to deserialize this here. And that's okay, the namespace is already there, so that's cool. So this will then be our platform published DTO. And then finally, we want to try and add this to our database. So I'm going to put this in a try catch block. And so I'll do the catch statement first. And we'll just do a console write line. And we will say, could not add platform to DB. And we will put in our message in here. So EX message. Don't forget the semicolon, which I'm sure you won't at this point. I've been doing quite a lot of coding here. So within our try block, what we want to do is ultimately get a platform model. So multi-stages of converting objects. So var plat equals mapper, not scope factory, mapper. And what we're mapping, we are mapping to a platform. And what are we mapping from? We're mapping from a platform published DTO here, this here, okay. So we'll leave it as is, bring in the namespace for that. And again, semicolon. Great, so we've got our model now. So all we need to do is determine whether we want to add this platform to our database. And that's where this new repository method comes in. So if repo, or if not repo, we'll do external platform exists, and we want to access on our platform object our external ID, and that should have been mapped through. So if it doesn't exist, then we will create it. Otherwise, we will do something else. And in fact, we won't do it. Well, we will. We'll write out a message because we're going down that path, aren't we, of writing console write lines. So we'll do that again. Write line, and we'll just say platform already exists. So we won't bother adding it. Fantastic. And then finally in here, we will do repo, create platform, and we'll pass in our plat object. And then finally, we'll do repo, save changes. Otherwise it will not get added. And I think that is that. That is our event processor class. So, you know, logically it doesn't sound that complicated, but you saw there was some fairly interesting things going on in there. So let's do a .NET build. That's all looking okay. Don't jump the gun. Now the one thing, again, not to forget this, let's put it in. Control B. Over in our startup class, we want to register our event processor interface and our event processor class. So after controllers, we'll put it in there. So using our services collection again, we are going to add singleton this time. And again, the reason we have to do that is because we are going to inject this class into our message bus subscriber class. So add singleton, event processor, and we're going to, let's bring in the namespace, event processing, and then we're going to give them an event processor, like so. All right, fantastic. So we'll save that off. Now what I might just do is I might just run this up, because stuff will often build fine and sometimes it won't run if you've done something wrong with dependency injection. Doing a .NET run really proves it out. So that's all looking good. That's still running up perfectly okay for the moment. So that is looking fantastic. So we're almost there. We're almost there. The next thing we're going to do is now create an asynchronous data service to listen from our command service on the message bus, and then it will use the event processor to add our platform to the database. So we'll do that in the next section. All right, so we are getting towards the end of our message bus stuff, and yeah, I do appreciate it's been a long haul. And the commentary I would want to make here is this is probably the most simple microservices application you could build. It's literally the most, this is literally the simplest one you can build if you're, you know, standing up in something like Kubernetes and using event messaging, and you can see how much work has just been involved in getting it to this stage, and we're still not finished, right? So microservices are really hard, okay? They are hard. They are not an easy thing. They are not a magic bullet. Now, once you have all this stuff set up and you're humming along, and then you're just responsible for building one service, and you've got all your libraries already, you know, all your packages, you're humming along, and you know how to subscribe and you know how to do this, then yeah, writing microservices is quite easy, but the entire setup and learning and the learning curve is big, it's large. So not trivial stuff at all. So let's just clear all this down, make sure we don't have anything running, and we are going to create, I think this, no, it's not. I was going to say it's the final folder within our command service. It's not. We have one more after that as well. But yeah, for now, we are now going to create an asynchronous messaging folder for our subscriber. So ASYNC data services. Okay. And into that, we are just going to create a file, one file called message bus subscriber.cs. Now you're probably going, okay, we've been creating interfaces and concrete classes, Why are we just going straight for an implementation class? That's a great question. The reason is this. This service here is going to have to run in the background. We're going to start it when our service starts, and it's going to be continuously listening on our message bus for events. And so because of that, we have to build it in a slightly different way. We don't use the interface concrete class repository. Again, I did try building it that way, but you get into some very torturous tail chasing around service lifetimes and all that kind of stuff. So this is the simplest way of doing it, and you'll see how it will unfold as we start building it. But yes, we're basically building something called background service, and I'll put some links below that will explain a bit more about background services. But really, yeah, the whole point of it is that it's something that runs in the background. It's a long-running process, ideal for listening for events on a message bus. Now, a lot of this stuff is actually very similar to the client that we built in our platform service. This is the subscriber. A lot of the stuff is very similar to the publisher that we've already built, so it should look quite familiar. So I'm going to kind of go through that stuff quite quickly, and then the more interesting bits I'll call out in a bit more detail. So let's get started. Namespace, and it's command service, and we have to type this in as we've not used it before. So ASYNC data services, and it's a public class. Don't know why I capitalized that. I've not done that before. And we call it message bus subscriber, and it's going to, inherit from something called a background service. We'll bring in the namespace for that. First one here, Microsoft extensions hosting is the one we want. Now you can see straight away it's erroring out. Why is it erroring out? We do a control period, then we need to implement the abstract class. Now this is this thing I was talking about, the long running task. Okay, so it's called execute async, and basically it's within here that we're just going to listen for events ultimately. Okay, that's the whole point of one of these background services. But before we come on to that, I'm going to create a constructor as usual. So ctor message bus subscriber, and we are going to inject iConfiguration, as we want to get access to the configuration elements to know where our RabbitMQ instance is. So iConfiguration, and we'll call that configuration. And then the other one we want to inject in is our event processor, which we took great pains at creating in the last video. All right. So we're just going to bring in the namespaces for this. So event processing, and assuming I've spelt it correctly, Microsoft extensions configuration. Again, please don't bring in the AutoMapper configuration. And I might just put this on a new line as well. And let's get rid of that's better. Looks a little bit neater, doesn't it? Okay, so this is again our class constructor, and as usual, we're going to assign these things to private fields and event processor. Okay, and then we'll just create those. So control period, read only field, and here as well, read only field. Now again, just to kind of labour the point about the event processor, we are injecting the event processor into this class. This class as well is going to be running as a singleton lifetime, so it's okay for us to inject in our event processor. It's a singleton lifetime as well, so it's fine to get injected. We couldn't, however, inject a repository. All right, so I'm going to actually create another method. We could put all our setup and connection stuff in here in our constructor. I'm going to actually just separate it out into a separate method just to keep things a bit more decomposed. But this is basically using the connection factory. You've seen all this stuff before, but we'll just do a private void, and I'll call it initialize. And I'm very conflicted about using Zs, but I'm going to go with the Americanized spelling, even though I don't agree with it. It's an international audience, so maybe it's probably more appropriate. So yeah, we're just going to do our connection into RabbitMQ from here. So you've seen this before, to be honest with you. So the first thing we're going to create is a factory. And that's going to be a new connection factory. And then we just pass in the attributes that we want, and we bring in connection factory actually, so we know what we're dealing with. So it's RabbitMQ client. And we'll specify the host name. And that just equals configuration. And again, you have seen all this before. I will just go back to our config file, either one, because these should be exactly the same name. And we'll just paste those in as before. And while we're at it, I will just come back over and I'll copy this in preparation for pasting it in as well. And I'll get rid of that so we have a bit more room. Okay, so that's our hostname set to that, and then we just set the port equal to _ configuration, and we'll paste this in. Now again, it will complain because it's expecting an integer, so as before, we'll do an int parse. And we'll just round that off here and put the semicolon in, and that should be good. Okay, so that's our factory. We're then going to expect a connection. And that's just going to be equal to our factory create connection. So, and we don't have this as yet, and I think I've put 3 ends in. I'm getting overly excited because we're almost at the end of this. So control period and generate a field. There we go. And you can see it's added up here, private eye connection, all good. And then channel, and that just equals our connection, and we are going to create model. Again, we will generate that as well. It should add up to the top there. Yep, that's all good. And then we declare our exchange off of our channel. So exchange declare. And then here we'll specify the exchange, and we need to use, and in fact we should definitely move this into config, so we're not having it in here, but we'll leave it in there for the moment. So it's the same exchange as the one that we're publishing to, and then the exchange type is a fan out. And then we'll specify something called the queue name. And that just equals, this is slightly different from what you've already seen, queue declare, queue name. And then we want to bind to that, and actually we have to create this first, so generate field. And then on our channel, we do a queue bind to the queue with _ queue name. So it's somewhat dynamic, and we'll just take a new line because there's a few parameters coming up here. And we're going to, again, specify the exchange, which is trigger. And we do have to specify a routing key, which, as I said before, is kind of ignored. And I'll put that in the right place, that would be good. And at this point, we are listening on our message bus, so console right line, to bring in the namespace first, using system, right line, listening on the message bus. listening on the message bud. No, it's bus. Okay. And I'm going to do it anyway because I did it in the last one, so I'm just going to keep it consistent. We're going to subscribe to the connection shutdown method. So connection shutdown plus equals, and we'll say RabbitMQ connection shutdown. And we'll just specify that down here, I think under this, so private void. I'll just copy this. Specify an object sender and shutdown event args E. And I'll just do a console write line just to make us aware if this has been shut down. Connection shutdown. Okay, fantastic. And while we're at it, we'll just do some other housekeeping A-type stuff. We'll do public override void dispose. I also want to put in a check to see if the channel is open. Then channel close. And connection close as well. Fantastic. And then just coming back up to our constructor, I just want to call this initialize method from within our constructor. So we'll do that here just before I forget, because that would be quite annoying if I forgot to do that. So all that leaves us to do really is put in the code in our execute async method, and we're going to do that. This video's been a little bit long, so I'm going to just take a quick pause, and then we're going to come back and finish this off, and then we're almost ready, well, we'll be ready to test asynchronous messaging end-to-end, locally at least, and then we have to deploy up to Kubernetes, but we'll do local testing first. So anyway, next section, we'll finish off the execute async method. All right, so let's come on to finishing off our execute async method. So let's just get rid of this for the moment. Now there's some kind of interesting stuff in here, all really based around this background service concept. So the first thing we want to actually declare is a stopping token. And we'll just throw of cancellation requested. So again, we can request that this method stops by passing in that token into here. Next, some RabbitMQ stuff. We want to declare a consumer. So just to reiterate, we've kind of created a connection, but now we want to actually start consuming events effectively on our message bus. So we'll say var consumer equals new, eventing, basic consumer. We'll bring in the namespace, which is RabbitMQ client events. Let's take out that space. And we are going to pass in the channel that we declared as part of our connection. And then here's the magic. Here's the magic part that you've really been waiting for. So consumer, and then we will go to our received event, and we will subscribe to that event. And into here, we will pass module handle and EA. And you'll see how these are used in a minute. So large kind of lambda function. I'm going to do a console write line, and I'm going to say event received. Okay, so basically if this triggers, it means we have an event on the message bus that we've been listening on. Fantastic. So then I'm going to declare another variable called body, which is the body of a message, and that is going to be equal to the EA body, the EA input that we got here. All right, and then we want to convert this effectively to a string because it's a byte array at the moment. So I'm going to call this var notification message, and we're going to equal that to encoding, bring in the namespace for that, so system text, UTF-8, get string this time, not get bytes, so we're kind of going the other way, and then we'll pass in the body, and we will call the toArray method on that. And then we're going to make use of our event processor from the previous section, and we're going to ask it to process the event for us. And we'll pass in the notification message that we've just kind of converted here. And that will determine what the event is. And then if it's a platform publish event, we'll add that to our database. And don't forget to put a semicolon here. Easily done. So again, we want to keep on consuming. So on the channel, we'll say basic consume. We specify the queue, which is queue name. Oh, that's definitely not right. So the queue. So underscore queue name. Auto acknowledgement. Now this isn't really something I covered, but you can also acknowledge messages. We'll say true. Doesn't really have any impact on what we're doing. And then consumer is the consumer. And then finally, we need to return task, completed task. So this is again really to do with this long running task execution. We will return that at the end and save that off. Now I'm just checking through this. I think that is everything that we needed to do. So initialize, that's creating our connection effectively. This is our long running task, just waiting and listening for events. Our shutdown event is there if we want it, and our dispose method is there as well. So that is all looking good. Let's do a .NET build. Perfect. There's one last thing we need to do. We need to register this for dependency injection. So let's come back over, Control B, Control B to our startup class. And I'll just get rid of this for the moment. Now after our controllers, we're going to add it. And the way you add it, this is where it gets quite interesting, services, and we're going to add what's called a hosted service. And we just pass in the name of our asynchronous listener. So it's message bus. Actually, I can't even, message bus subscriber. Bring that message, bring that namespace in. And we'll just run that out with a pair of parentheses. And that should be good. All right, so very, very exciting now. So unless I've missed something, that should be us ready to test locally. So we will run up our platform service and we'll run up this service and we'll actually see that it should connect in to our local, well, what it thinks is a local version of RabbitMQ, and it's listening, and then we will issue a platform create on our platform service, and we should see the event trickle down, and we should actually see platforms being added to our command service, hence completing the chain of pretty much everything we've been working towards this entire video. So I'm getting quite excited. We'll do that in the next video though. Okay, so the moment of truth, and I can tell you I'm genuinely nervous because there's so much kind of riding on this. So let's first of all come over to our platform service, and let's just do a clear the screen, and we'll do a .NET, let's do a build first. Cool, and then we'll do a .NET run. And again, just double remember, although we've been doing this throughout this course, that platform is running on 5000, but it can run on anything you like really, but just make sure it's running on a different port to our commands service. So platforms service we already knew was working, so that's no surprises. It's now really when we come over to our command service. Fingers crossed here. So let's do a .NET build. I will be so disappointed if this doesn't work. There's building, so let's see what happens when we run it. Straight away, I'm almost crying with joy, I'm happy. Let's see what we've got here. So this is the thing I was really wanting to see. We are listening on the message bus. So by registering our background service in configure services, we are starting that long running task, and it's now listening for events. So That's really good news. Now, what I want to do now is create a platform on our platform service using our friend Insomnia. I'm going to do this off screen, okay, because I want to capture and savor the moment and see what we get down here in our command service. So in 3, 2, 1, I'm going to create a platform in our platform service, and we should get the event down here on our command service. So 3, 2, 1, there we go. Fantastic. So first thing we get is our inbound post event, which we were getting anyway. That's our synchronous event. Next thing we're getting is an event received. So straight away, that's cool. Events are coming down. Then we're determining what event we got, and then we determined that our platform published event was detected. Now, I can't remember what other commentary we put in our event processing class. So let me just come over to event processing and select this. So let's just see when it determined the event, which it's doing here. Platform published event detected. I don't think we got that, did we? No, we did. We did get that. That's cool. And we return that, and then okay, there we go. We forgot to put in, that's a classic one, we forgot to put in add platform. So maybe that's a good thing, because everything else has worked correctly, we just haven't put in our add platform function. I'm just checking to see whether we didn't actually put in so that's quite good. Let's kill this. I'm happy so far, but I want to put in a console write line just when we add a platform. So we'll say platform added. Okay, so let's try that again. So we'll do a .NET run. And in 3, 2, 1, I'm going to create another event. So 3, 2, 1. Don't tell me. I don't think I didn't put in add platform again, did I? I forgot to do that again as well. Oh my God. Right. All right, I'm losing my mind. So let's put that in. You must be watching this and going, what is this guy on? It's been a very long video, so give me a break. So into add platform, we are going to pass over the message. Oh my goodness. All right, there we go. Let's give it third time lucky, as they say. So run. Looking good. And in 3, 2, 1. That's what we want to see. So platform event detected, platform added. That's looking pretty good. So I'm quite happy now. So let's come over to our Insomnia session, and let's come back to our commands service, and let's see if we can get any platforms on that service. And indeed we do. We get Docker. Fantastic. And so Docker's got an ID of 6. So let's just copy that, and let's see if we can create a command for the platform. So let's put in 6 in here, and that's Docker. So let's say, I don't know, push a Docker container to hub, and we'll just say Docker push, and we'll just put name of container, something of container. Fantastic. I might have spelt it wrong, I don't care at this point. Let's send that over, and we get a 201 created. So we have, oh, this is good. I'm so happy at this point in time. It's been a long video. We have created a resource, a command resource with a platform ID of 6. And if we do, let's do a get commands for a platform. So let's do that. Send this over. There we go. So we're requesting all the commands we have for our platform number 6. And that looks like that is working. So if you've been following along this far and you've got the same result as me, congratulations. If you didn't get the same result, then again, we've been doing this step by step. So you should have been checking as you've been going along, and I'm sure you'll be able to find out what the issue is. Things I would personally check are the config settings are the first thing, and then again, just check the code with the code I've got up on GitHub. So that is really Good, I'm very relieved. So the last part of this section is going to be packaging up both our services and pushing them up to Kubernetes, and then we'll do this test in Kubernetes, and we'll do a bit more of an exhaustive testing to make sure everything's working as it is. But at this stage, it's looking pretty good. So we're now in a position where something gets added to platforms, it's event driven down to the command service, and it has the events that our platform event has. But you'll be saying, wait a minute, our platform service already had 3 platforms in it, and all we got was the new platform that we added as part of our event-driven model. That's true. And we're going to come on and solve that in the last section. Once we've deployed to Kubernetes, the last section, we're going to look at resolving that issue. And to do that, we're going to use gRPC. All right, so just before we move on to the last section, which is on gRPC, we do want to rebuild both our services, rebuild their images, and push them up to Docker Hub. So I'm going to begin with the platform service. Make sure you're in the right folder. Quick directory listing to make sure you can see the Docker file. And then, as usual, it's a Docker build -t binary thistle, and then the name of the service, which in this case is platform service. Don't forget the build context, and we will build that up. And we will then push it up to Docker Hub. So I'm just going to take out the -t in the build and just push in platform service. Okay, brilliant. So while that's pushing up, let's come over to our command service. Do a quick directory listing, make sure you're in the command service folder, which we are, and we'll do a Docker build binary thistle, and the name is command service. And just note, make sure I spell it correctly, service. And just note, yeah, this is singular command service. The name of our project is command service. Our service name here is just command service. So we'll rebuild that. That looks good. And then we will push that up as well. So pushing will take a few minutes. So we'll give that, yeah, a couple of minutes. And we'll come back when that's happened, and then we'll restart both services. Okay, so our command service has been rebuilt, and I'll just pop over to platform. That's been, well, not rebuilt, pushed back up. Both of them are now pushed. So quick check on Docker Hub, just to make sure that they have been updated. So I'll just bring that over, and I'll just refresh it. You should see. Okay, so both of these were updated, yeah, a few seconds ago and 1 minute ago, so that is looking pretty good. Fantastic. So what we want to then do is we want to restart both our deployments. So clear the screen here. We'll do a kubectl get deployments. And we already have deployments, so that's why we're not doing the kubectl apply, we're doing the role restart, because we already have these deployments. And again, if we did an apply, kubectl apply deployment file, the deployment file hasn't changed. So again, I've said that a few times already. So let's just redeploy the platform service first. And we'll do a test on that. So kubectl, rollout, restart deployment, and we want to do platforms deployment. So we'll copy that, we'll paste that in, saying it's restarted. So clear the screen, and we'll do a kubectl get pods just to see. So we've got the container creating state, which is fine. So we'll just have to wait for that to create itself. And then what we'll do is we'll create a platform using Insomnia, and we'll see if it drops an event onto the event bus. Just make sure that part of the equation is working, and then we'll redeploy our command service to check that it receives events successfully. I just want to do one leg at a time rather than trying to do everything at the same time. Cool, so that's all running now. That's looking pretty good. So if we come over to Kubernetes, here we are. I'm going to do a sort by started time. So we should see our platform service at the top here. Looking pretty good using SQL Server, applying migrations. We already have data. That's all looking fine. Good. So we'll then pull over RabbitMQ management console so we can take a look at messages going on to the message bus, hopefully. And then the final thing I'll do is I'll just use Insomnia to create a new platform on our platform service. So let me just bring Insomnia onto the screen. The screen's getting a little crowded, but that's okay. So here's our K8s environment. Here's our platform service. I want to just see what platforms we have in here. Now I added a few just while I've been testing offline. We've got a few more platforms in here. That's okay. I want to create a new one. So I'm going to create a new platform. Let's create one called console. I think that's how it's pronounced. It's a service mesh application from the same people that make Terraform. That's all good. So what I'm going to do is I'm going to click send. Okay, and we've got a 201 created. Let me just get all platforms, make sure that was created. Yep, that was created. Good. And over here, we were successful in sending a synchronous post to our command service. We then move on to the asynchronous stuff. So RabbitMQ connection is open, we're sending the message, and we actually did send a message with our attributes onto the message bus. And we can also see down on the message bus that yes, indeed, a message was sent down. So that's excellent. That's our platform service working in production. So I think all we need to do now is just redeploy our command service and see if it receives events. So let's do that now. Now you can do a restart in any terminal. It doesn't have to be within any particular project. So I'm just going to do a clear the screen. I'll do a up key. I want to get all my deployments. So we want to restart the commands deployment now. So I will do up key, and then we'll replace platforms with commands, and that should restart our commands deployment. Okay, and we'll do a get pods, and we'll see that we've got our commands service in the container creating state. So we'll just wait for that to create, and then we'll run a very similar test, and hopefully we should see not only events going on to the event bus, but the event being received in production, and then we can also query that service as well in production. So I'm just going to do a quick check to see how our pods are getting on. Yep, the other one is terminating, which is good. There we go. So we've got all pods, all 4 pods running. That looks good. So what I might do is come back over into Kubernetes. Let's bring that onto the screen. There we go. And the problem here is I have 2 screens and they're running at different sort of magnifications, so the rendering can be a little bit weird. Anyway, let's order by start time. So again, command service is the newest one. So that's really good news. You can see it's listening on the message bus, which is excellent. So it's started up and it's listening. So what I might do is just come back over to Insomnia, and we'll create another platform. So let's create another one of the HashiCorp applications. They do something called Vagrant as well. So let me just move this down a bit. Click send. There we go, looking pretty good. So we got an inbound post from our Synchronous service, which should be working anyway. We also received an event on the event bus. We determined the event. We established it was a platform published event, and we added a platform to our in-memory database. So that all looks like it is working exactly as we would expect. And you can see here that we had that event placed onto the message bus. So looking pretty good. So the only thing that we should really do is add some API calls for our command service. We don't actually have any yet. So in our K8s folder, I'm going to create another folder, and I'm going to say commands service nginx. And we want to, let's see what commands we have. Let's get platforms, that's the one we really want to check. So let's do, actually we can probably copy it from down here. So get all platforms, let's duplicate that. And we'll move it into, move it a bit further up, move it into here. And all we need to do is change the URI. And again, we want to make sure that we put the correct route in. Oh, I copied the wrong thing, I think. No? This must be very painful to watch. Let's copy that. Let's paste it back in here. Okay, and it's API/C get platforms. There we go. So we have our one new platform created in our command service, and of course we don't have the other commands yet because we're only working off an event-based model at the moment, but we will come on, we will rectify that with gRPC. We'll use that to pull down any other commands that way, but that looks pretty good. So maybe what we should do is add a couple of other endpoints in here. Let's create a command. So I will come down here and duplicate this, create command for platform, and we'll just move it up to here, and it will be the same. No, actually it won't be the same, it'll be slightly different. Let's copy this, let's paste this in here, and let's just check what this platform was, 8. So if we come over here, we want to put in 8 and then commands, and that should create a command for that particular, and we'll just leave the same body and it doesn't really matter, but we have created a command there for that particular platform. Good, and we'll just duplicate one more request. Let's get all commands for the platform. Let's just duplicate that just to make sure that's working, and we'll move that up to here as well and move it into the right place. So again, we'll come over here, we'll copy this URL and we'll paste it into here. And I think that's a GET request, so we're getting all commands for this particular platform. There we go, and we've got our one command that we just created. So that is all looking pretty good. I think we can draw a line under Kubernetes stuff really well. Yeah, we can draw a line under the Kubernetes stuff. We don't have to create anything else in there. We can draw a line under event-driven stuff. We are pretty much done with that. Now, obviously, we have just started using an event-driven model. We now have the fabric set up to send events both ways. Well, you'd have to kind of put the client in and the subscriber in each class if you wanted two-way communication, but we've got basically everything we need to work with event-driven models. So that's great. So the last thing, that we want to come on to is we're going to move back to synchronous messaging now, and we're going to address this final problem that, okay, cool, every time a new command is created, we push it down to our command service. Sorry, every time a new platform is created, we push it down to our command service, but we still have the issue where we don't have all the commands. So we're going to solve that in the next section with gRPC. All right, so we move on to the final section of the video, and we're going to be talking about gRPC, and not just talking about it, we're going to develop some gRPC code. But before we move on to that, as it says on the screen, let's discuss what it is and why we should use it, or why would you use it. So first of all, it stands for Google Remote Procedure Call. So obviously created by Google, but it's now again in the public domain in the same way that Kubernetes is as well. It uses the HTTP2 protocol to transport binary messages, and that's quite important. It's, binary messaging. It's designed to be very lightweight and highly performant. I've also put in brackets here because this is something that we're going to discuss in a bit when we come on to implementing it. It does require, or usually does require, the use of HTTPS or TLS, whatever you want to call it, as part of that connection. Now, we are not using HTTPS or TLS internally within our Kubernetes cluster, so that does mean we have to do a little bit of a workaround to get gRPC working, because it is kind of usually reliant on that. It says they are focused for high performance. It relies on something called protocol buffers, or protobuf, which effectively defines the contract between the endpoints. So you use this protobuf file, which defines the service. It defines inputs and outputs. And this protobuf file exists at both endpoints, both the client and the server, and it really forms the contract that both parties have between each other. As you would expect, it's multi-language support, so yeah, we're obviously using C#, but if you have a C# client and a Ruby service, they can talk together using gRPC. And there's language support for most of the main languages out there. It is quite frequently used as a method of service-to-service communication, so you wouldn't typically have a client web browser using gRPC to talk to a service, just given the complexity of the HTTP2 protocol and gRPC itself. So it is used really just internally for service-to-service communication, but it is still a synchronous messaging methodology, if you like. So here's a bit of a diagram. So yeah, we are not implementing this obviously, but yeah, we have as an example, a C# client on the left with the proto file, and then we have a Ruby service on the right, again with the same proto file definition. They talk via HTTP2, and yes, our client has a gRPC stub on the left, and our service has a gRPC server on the right. Now, one of the things with gRPC when we come on to using it within our applications is there is a lot of generated code. So we write a proto file, which is actually relatively simple, very small. As part of the build process, the gRPC library actually builds up a lot of stuff in the background that allows it to work. And then we work with gRPC to actually make calls and receive requests. So we'll see how all that works in the next section. Now, just before we move on to the code, I do want to just come back to our solution architecture and just kind of round it out, because we have been sort of checking in with this as we've moved along. So we are basically at this stage now. We have both our services. We have HTTP communication between the two. We have publisher-subscriber event-driven messaging between the two, both in development and in production. And now finally, what we're wanting to do is introduce gRPC. And our use case is that when the command service starts, we want to use gRPC to reach out to the platform service and retrieve all the platforms that the platform service has. So it gets around this issue of the fact that we only have, at the moment, the event-driven platforms that the command service is aware of. With this gRPC last bit, command service is going to reach out at startup, and pull using gRPC all the platforms down, and it will load the ones that it doesn't already have. So that's our use case, and that's what we're going to implement in the next section. All right, so we'll move on now to implementing our gRPC stuff. And I just want to be clear, because maybe I've not been totally clear about the server and client model here. So in our scenario, the command service is the client, and it reaches out to the platform service, which is in this scenario considered the gRPC server. So at startup, command service is going to reach out and pull down all the platforms that the platform service has. So the server is the platform service, and the client in this scenario is the command service. Now, I also realized I did lie to you in the last section when I said that we had finished all our Kubernetes stuff. That was in fact a lie, not an intentional lie, an unintentional one. I just simply forgot that there was one small piece of config that we have left to do. And it's very, very small, so you don't need to worry too much about it. And it's really just an addition to some existing config that we have. And for those of you keen of eye, you'll actually see on screen here the addition that we still have to make. And that is around, really, our cluster IP service and the fact that it needs to provide a port called 666. And what is that port? Well, I'm just using the number 666. It can be absolutely anything you like. I'm just using it as a little bit of a dark humoured joke, mainly because it took me a while to get this stuff working. And what we need to use it for, I did mention that gRPC uses HTTP2 with TLS, effectively HTTPS. Now, we don't have HTTPS running in our cluster, and it was one of the things I decided to leave out because there's quite a lot involved. Number one, to get it up and running in a cluster, and number two, there's a lot of opinions that you don't really need HTTPS inside your cluster because it's kind of an internal domain. You would terminate TLS at the Ingress Nginx gateway. So certainly from your web browsers to your services up to the gateway, yep, use HTTPS, absolutely 100%. Inside your cluster, there's differing opinions. Some opinions even suggest you don't even need to use it. So it's why I decided to leave it out. There's a lot of work involved to get it set up and generating certificates, even development certificates, so I've left it out. So with that being said, that left us with a scenario where we're not using HTTPS, we're not using TLS therefore, and so gRPC needs that little bit of extra config in order for us to tell it that we only use HTTP2 protocol without TLS. So in order to do that, we need to do some configuration on the Kestrel web server running on the platform service, which is our server. And then we tell our client endpoint to connect in to a specific port, in this case 666, that we allocate, that is just running HTTP2 without TLS. When a client connects to a server using gRPC, there's a negotiation that happens and they will use the highest level of security available on that connection. And so if we don't explicitly say there is no TLS, it will attempt to use TLS as a connectivity method and it will fail because we just don't have it set up to work correctly. So it's a little bit of a workaround, but in some ways it's not a workaround, because if you don't want to use HTTPS in your cluster, you would have to do something like this anyway. So that's what we have to do to get it all working, simply because we don't have HTTPS running in our cluster. So a very small bit of config in Kubernetes, so we'll do that next. And then we'll move on to configuring the Kestrel web server, which we'll do via config. And then we're ready really to move on properly to the gRPC stuff. But this is a bit of networking stuff that caught me out. So we need to get it done and out of the way. So back over in our K8s project and back in our platform's deployment YAML file. All we need to do is add another port to our cluster IP service. So the actual deployment does not change. This stuff does not change. All we need to do is add another port. So in the file, underneath ports, we'll add another array element. We'll give it a name. You need to give it a name, and we'll call it platform gRPC. And we will give it a protocol, which is just TCP. And we'll give it a port. Now this port number can be anything you like. If you don't feel comfortable using 666 for various reasons, you don't need to use it. You can use anything else you like. I'm just using that, given my sense of humor. And then target port is also 666. And that's it. Save that off, and then we need to basically apply this deployment file. So it's not a rolling restart because our actual file has changed. So we need to apply it. Again, I keep laboring that point of difference. So we'll do a quick, let's get our services. So kubectl get services, just to have a look, and I'll just move this over, that looks horrible. And you can see here our platform's cluster IP service, excuse me, is just running on port 80. So we want to additionally add our port 666. So to do that, let's do a directory listing and get the name of our file. There we go. And we'll do a kubectl apply f, name of our file. Make sure I pick the right one. Copy that down, paste that, and what you'll see is that our deployment itself is unchanged, which is correct. We didn't change any of that, but we did change the cluster IP configuration, and we can see that it has a configured status. So if we do get services one more time, you should see now on our platform's cluster IP service, we have this additional port that it's listening on. Fantastic. So I'll just pause here for a minute, and then we'll move over into our platform service project, and we'll do our Kestrel configuration, and then we're ready to move on to actually using gRPC. All right, so back in our platform service, and we only need to do this in the platform service. We don't need to do it in the command service, the client. We only need to do it in the server side of things. And the other thing I'll mention is this is a configuration for when we're running in Kubernetes. When we are running locally, doing a .NET run, HTTP is supported, so we can actually, you don't have to worry about this, it will just work. All right, so what we want to do is, I'll just get rid of this for the moment, and I'll close down all these files because it's taking up a bit of room. And we want to come into our production, our app settings production file. Okay, and this one here. So again, make sure you're in platform service, app settings production JSON, and we want to add in some configuration into here. And so we'll add it under our RabbitMQ stuff, so comma. And we're going to nest some attributes in here. So as you can see here, VS Code is kindly providing some defaults. So it's the Kestrel web server we're wanting to work with here. So I'll bring this onto a new line. We then want to specify endpoints. You can go, it's actually giving us some help here. Within endpoints, we want to specify a label, effectively. So the first one is going to be gRPC, and then I'm going to provide some more curly brackets. So let me just bring these onto new lines. My eyes cross slightly when things aren't indented properly. So gRPC. We then want to specify protocols, and then we want to specify for this HTTP2. Now that just allows us to use HTTP2 with no TLS. And then we provide a URL. And again, it's a production URL. So this is basically the URL that the server is going to be running on. So it's going to be HTTP, not PS, so make sure it's HTTP. And what is the server that we're running on? Well, we've come back again into our K8s folder project, and we come down to the name of basically our cluster IP. So in production, this is the URL of the server that it's going to be running on. So we copy that, come back to our platforms file, platforms project, we paste that in, and we put 666 on there as well as the running port. Okay, so just go through that again. We're configuring the Kestrel web server. We're configuring a number of endpoints. That looks a wee bit weird, so I'll take a new line. We're calling this endpoint gRPC. This can be anything. And then inside this particular bit of config, we're specifying the HTTP2 protocol and the specific URL that we want. Now we need to actually now explicitly specify as well just the web API or the HTTP endpoint for our HTTP services, which have been running on port 80 thus far. And so that's all we're going to do. We're just going to specify that it's running on port 80. So again, protocols, this time we're going to select HTTP1. And then finally the URL. As before, I'm just going to copy this up to the colon, exactly the same. Paste that in, and it's port 80 this time. All right, so that all looks good. I'm just going to bring these commas up here. Make it a bit consistent. That looks a bit better, doesn't it? Yep. This must be quite painful to watch. In fact, if I do an Alt-Shift-F, yeah, that does it for us. There we go. So Alt-Shift-F auto formats it for us instead of me clicking about like an idiot. So yeah, we've got two endpoints. One, this is basically what we already have, and this is the new one that Kestrel will now listen on, and we're telling it just use HTTP2 without TLS. So we'll save that off. Fantastic, and that will only be applied in production. Now I do want to just check, come into launch settings JSON, I do want to check that we're still using, yep, so we're still using HTTPS 501 in local development mode, but I'm doing .NET Run, that's fine. And I might just come in quickly while I remember in our command service, just double check in properties as well, check launch settings JSON, and again, we're running HTTPS there with the local development certificate, so that is all fine. All right, so a little bit of faffing around there. That's a bit of networking stuff that caught me out when I started deploying this into production, but we should be good to go now. So in the next section, what we're going to do is we're going to move on to more interesting, actual proper gRPC stuff, and we're going to specify our proto file. And our proto file basically specifies what the service is and what the shape of the data is. And then we'll do some build that actually auto-generates a lot of code in the background that we don't actually alter, but is auto-generated from this proto file. So we'll do that next. All right, so before we actually even get started with coding, we do need to add some package references to both our services, to both our platform and our command service. So let's come back to our platform service first, as it's slightly simpler, would you believe? It is the server in this scenario, but we only have to add one package here. So bring up your command line, and I might get rid of our sidebar, Control B, and I'm going to do a .NET add package, and the one we want is gRPC ASP.NET Core, and that's the only package that we need for our server. Okay, so again, our platform service is acting as a server in this scenario, so that is the only one we need there, so that's cool. Then let's move over while we remember, otherwise I will probably forget. Let's move back over to our command service project. Now this is acting as the client. Now, surprisingly, or maybe not surprisingly, we need to add quite a few package references in here to support gRPC from a client perspective. So we'll just add those in one by one, clear the screen, and so the .NET add package, and the first one we'll add is gRPC tools. Okay, and that's added that in here. The next one we want to add, I'll just do an up key, add package, gRPC .NET .client. And that's added that in as well. And then the last one is a Google package, is Google.protobuf, which is protocol buffers. Fine, so those are the three packages you need in the client: Google Protobuf, gRPC.NET Client, and gRPC Tools. Fantastic. So we've got everything we need from a configuration perspective. Now let's move on to constructing our proto file. All right, so we want to come on now and create our proto file in our project. So just close this stuff down. And yes, in our platform service, we're going to create another top level folder called Protos. So new folder, call it Protos. And then I'm going to create my file, and I'm going to call it platforms.proto. Like so. All right, get rid of the terminal, and let me do a Control B to give us a bit more space. So it's in here that we define our contract effectively and what will get passed between server and client. So some syntax setup. It's kind of similar to the stuff we did with Kubernetes, specifying API versions, but this time we specify the proto version, so proto version 3, semicolon, and then we specify the C# namespace, which, let me just double check, so Control B, we'll just pick any class at random, and it's just the top level namespace, so in this case platform service. So we'll copy that into here, and we'll put that in here like that. Okay, fantastic. So yep, that's just kind of general setup stuff. So the proto file applies to this namespace, and that will be used later when we do some building and code gets generated. So proto file will consist of the data, the messages that gets passed in and back from our services, and that's the other thing. We define our remote procedure call services in here. So I'm going to define the messaging first, and you do so by using the message keyword. So the first thing I'm going to specify is our input. So again, just to reiterate, this service is going to allow our client, our command service, to retrieve all platforms. So what input does it supply? It doesn't actually need to supply anything. So we still have to specify an input. So I'm going to call it get all request, and it's just empty. Okay. And then what do we give back? Well, we're going to give back a load of platforms, assuming some exist, which hopefully they do, but that's what we're going to give back. So what we're going to specify now is effectively the platform model, the structure of that. So I'm going to call it gRPC platform model. And you can almost think of this almost as analogous to a platform model definition, a C# model definition. It's almost the same as that, really. I'll just come back up here and do our curly brackets. Now, we're going to effectively now specify the properties of our model. Now, you define them in a protobuf file in a slightly different way. We specify the data type. And the first one I'm going to define is the platform ID. So I'm just going to call it platform ID in this instance. And I'm going to make it equal to 1. Now, your first question, if you've not done this stuff before, is why are you making it equal to 1? The 1 in this case is not a value of platform ID. The 1 in this case is a position number. So for every property you define, you've got to define its position. It's just how protobuf files are defined. So that's it. And again, bear in mind, the messaging between services is totally in binary. So again, it's all part of that encoding process, which personally I'm not going to get that involved in. The next one we're going to specify is the name. It's a string. and we're going to make its position equal to 2. So you can kind of see a bit of a pattern emerging here, and then finally we'll pass over another string, which is the publisher. And no guesses as to what position we're going to give it. We're going to give it position 3. So to be honest with you, this actually isn't the data that we pass back. We want to pass back multiple, potentially multiple platforms. So in order to specify that, we have to specify one more message, and we're going to call it platform response. And this is actually what we pass back. And we want to pass back many of these, multiple of these. So the way you do that is the repeated keyword, and then the name of the model that's being repeated. And then we just give it a name, platform. And we have to again specify a position ID in that message payload. Okay, so if you've not done it before, maybe it appears a little bit strange. I guess, you know, it's not fair maybe to say it's strange. It's just if you've not done it before, it's probably not that familiar to you. But the most important takeaway here is we're going to be referring to this kind of as our model, our main platform model object, and we're actually going to be doing some AutoMapper stuff with this eventually. Now, something to really call out, which I find, again, a bit counterintuitive for me, is when we build this project, the gRPC package will actually create code for us, and it will actually create a model, a gRPC platform C# model for us. That doesn't exist as yet, okay? It exists here in this format, but it doesn't exist as a referenceable C# model. It will eventually when we do our build. But there's a few steps we need to do before we even get to that. So we're not quite finished the proto file though. We need to specify the actual service itself. So our client is going to call this service to get back these platforms. So we define that by defining service, and I'm going to call it gRPC platform brackets, and then the remote procedure call itself is going to be get all platforms. And then we supply the inputs. So this is basically this is the procedure call here that we're defining, the method if you want to call it that. So what are we inputting to that? We're inputting this. We're expecting that as an input, which is basically just an empty object, it's nothing. And what do we return? We return this platform response, which is a repeated array of models, or collection of models, however you want to term it. And we put it in parentheses like that. So that's our platform's proto file done. Let's just save that off. And again, this is the contract between our server and our client. And we're going to copy this file eventually over into our command service as well. It's going to have exactly the same copy of this so it knows how to talk to our server. Great, but we're not quite done with our setup. We need to add something to our CS proj file so that when we do our build process, we get some code generated. We then need to define our actual our synchronous data service that makes use of gRPC, and then we need to update our startup class to pull all this together. So there's still quite a bit to do, just setting up our server, and then we'll come on and effectively repeat the same thing in our client. But next, let's update our platform service CS proj file, and then we'll move on to actually defining our service. All right, so let's go over to our CS proj file, and we need to specify a new item group. All right, and I'll just copy that, and I will terminate that off, or paste that in, and we'll terminate that. Usually, I found usually this kind of helps you and auto-completes a wee bit for you, but maybe it's not being that helpful today. Anyway, so what we want to define within our item group is something called protobuf, and this is basically telling our project where it can find a gRPC protobuf file. So protobuf 1f include equals, and it's just a path to our protobuf file. So platforms.proto. And then the other thing we want to specify in here is whether our platform service is running as a server or a client. And as you know, we're running as a server in this instance. So we just say gRPC services equals server. Terminate that like so. So let's save that off. So yeah, again, this is really just saying we can find our platform's proto file, and when we do a .NET build, we're going to get some automatic code generation going on, which can take a bit of getting used to. I don't personally like it, actually, but it's how it works, and I understand that's why it has to work like that, but I don't really like code being generated on my behalf. But anyway, that's how it works. So let's give that a go then. So control backtick, and we'll do a .NET build. Okay, and all being well, that builds up. So what should have happened if we come into our OBJ folder, into debug, you'll see we have this protos file, and then in here we have our generated code, and you can see by the code window over here, it's quite voluminous code. Okay, there's quite a lot going on here, and that gets generated for us every time we build our project. So you don't touch that code, that's just done for you. And you know, fair play, all you really need to specify is this protobuf file, and the rest gets taken care of. But just be aware that there is that auto code generation going on. And if you haven't done a build and you try to access this class, for example, you'll have some trouble with it. But that is there now, having generated it. All right, fantastic. So that's us just set up the protobuf stuff. What we actually need to do now is create a synchronous data service that is going to act as our server effectively for our platform service. So we'll do that next. All right, so back over in our platform service, let's just clear this stuff down. We are going to come back into our sync data services. So you'll remember that we had defined some HTTP sync data services. We now want to create another folder under sync data service called gRPC. I'll capitalize the G. All right, and into here we're going to create our server, basically, our gRPC server. So right click, new file. I'm going to call this gRPC platform service .cs. All right, so namespace as usual, namespace platform service, sync data services, and then we're going to add gRPC onto that because it's newly created. So it's a public class called gRPC platform service, and then we're going to inherit from gRPC platform base. And coming into our protos file, you'll see that that looks familiar. Okay, that is our service, the name of our service that we are kind of inheriting from. Now, we got autocomplete there because we'd already built our code. If you hadn't built our code prior to writing this, you wouldn't get that, probably not, unless you've got the automatic build stuff going on. So again, just be aware of that. All right, now ultimately, we are going to be making use of our repository because we're wanting to go into a repository, get all our platforms, and then pass back this protobuf class. What's it called? Platforms response class. So we come back into platforms response, we are wanting to pass that back, basically. So you're probably starting to think, okay, we're going into a repository, we're going to pull out some platform models, we're going to be passing back this gRPC model type. We need to map those, and indeed we do need to map them. So just before we complete our service, I'm going to come back over to our profiles folder, into our AutoMapper profiles, and I'm going to create one final profile in here. So create map. What is the source? The source is going to be our platform model. So we're going into a repository, we're pulling out platform models. Okay, what are we mapping to? What is our destination? Our destination is gRPC platform model. Okay, so back over in our protos file, it's this here. This is what we're mapping to. Okay, so we have to map our attributes effectively. Now, the only one really that we need to map is this one here, because I've called it platform ID here, whereas in our model, it's just coming back as ID. So let's do that now. So we've seen this before. So for member, destination, so what we're mapping to. So this is the gRPC platform model. we are mapping to platform ID. Now you can see here that the code generator has changed platform ID into the standard C# capitalization. So we get capital P, capital ID. You'll remember in here, it was all, well, it was different case. All right, so it's done that for us. So we're now working with our C# type class, the generated class. So we want to map to platform ID. What do we want to map from? The source. So OPT, let me just get rid of the sidebar there. So OPT goes to OPT. What do we want to map from? Well, in our source, src goes to src, and this is a bit long-winded, then it's our ID. So our platform is our source. We want to map the ID of our platform to the destination, which is the platform ID of our destination. Now that's all we should have to specify because the other names are similar, but just to be totally complete, I just want to do the other mappings for the other attributes just in case we get caught out. We shouldn't need to do that though because they are basically the same. So in our destination, we've got a name. What do we want to map to? We want to map to name. Okay, so really don't really need to do this, but because we've only got a few, I'm just putting it in just for like complete safety, just in case we run into any issues. But these last two shouldn't be necessary. We should be able to run without them. Okay, this is the first one. The first one is the only one we really need to do. And don't forget, semicolon. So again, that is the last mapping, AutoMapper mapping we're going to have to do. So we're mapping our platform to our gRPC model. So going back over here, let's finish off our class, our platform service. So I'm going to do a constructor. And into our constructor, I'm going to pass our repository. So iPlatform repo. I'm going to call it repository. And we're all going to pass in a mapper object as well called mapper. And we'll assign those. Actually, let's bring in the namespaces for these. So data service and AutoMapper. Fantastic. And so pos underscore repository equals repository and underscore mapper equals mapper. We'll generate read-only fields for those as usual. So that means we now have access to our mapper and also our repository. So you've seen this 1,000 times before. And then we come on to actually exposing the method that is going to allow us to return our platforms back via gRPC. So public override synchronous, so task. And what are we returning back? We're returning back platforms response. So again, in here, we are returning this back. Okay, that is what we are returning back. And again, our platform's response is an array of these. Okay, so it's not the most intuitive thing, to be really honest with you, and you're maybe scratching your head a little bit. I really don't blame you, but bear with it. It does all work. So we're going to call this method getAllPlatforms, and then we're going to specify getAllRequest. Request, again, that is this thing here. And finally, we have to specify this other thing here called server call context. And we'll just bring in the namespace for that, gRPC core. That's a gRPC specific thing that we have to specify in this method. All right. So task, I think we need to bring in the namespace for threading. Yep, that's all good. So this is just complaining because we've not returned anything back yet. So I'm going to create a new platform response object. I'm going to call it response equals new platform response. And then we're going to use our repository to populate another variable, platforms, with a bunch of platform models if we have any. So I've seen this before, using a repository gets all platforms. All right. And then we want to basically add each of our response models, each of our platforms, to this platform response object. So I'm going to do that via a for each loop. So for each variable, call it platform, in platforms, so for each model in our platforms collection, on a response object, which is this platform response object here, platform add, and then we're going to use mapper, increasingly becoming my favorite tool. And what are we mapping to? We're mapping to a gRPC platform model. And what is our source? Our source is plat. All right. And then finally, we return task from result here, response. And that should be our service good to go. So we'll save that off. So yeah, basically we're making use of a repository, we're making use of our mapper through constructor dependency injection, and we are returning back a platform response object, which again comes from here. And we're basically doing that by using AutoMapper to populate that collection using a for each loop. All right, so that's our last use of AutoMapper in this service anyway. It's served us very well, and yeah, we're basically almost at the end of defining the server related stuff for gRPC. All that we need to do now in this next bit is come back into our startup class and actually register this service for dependency injection. We also need to specify, actually we need to specify it as an endpoint, not dependency injection. We do need to register gRPC more globally for dependency injection, and then we specify this as an endpoint in our configure method. So we'll do that next. All right, so almost there with our server. So let's bring up our directory browser, and I'm going to come into startup. Let me just go to this other stuff and close that down. And in configure services, we do need to register gRPC for dependency injection. So services add gRPC. That's it. We don't take those out. We don't need to do anything else. Let's save that off. All right, but what we do need to do, which is a bit more kind of involved, is we do need to specify the service that we've just defined, the server that we've just defined as an endpoint, which kind of makes sense, I think. So under our controllers mapping, we need to specify endpoints again. And this time we're going to map gRPC service. And what service are we going to map? Well, the service that we just created. So let me just bring that up, and we are referring to this service here, our gRPC platform service. So I'm just going to copy that and paste that into here. So, and we need to bring in a namespace for that. So using platform service sync data services gRPC. Fantastic. Now this next bit is optional, and I'm going to put it in just for completeness. Now this is what this allows us to do. This allows us to serve up the proto file to a client, and they can then use it and understand what the contract is. So you don't need to do this bit, but I'm just going to do it for completeness. So endpoints map get, and I'm going to specify a path, and I'm going to say protos platforms.proto. And we'll say async, sync, context, pair of curly brackets, let's put in our semicolon. And in here, we're going to await context response, not request, response. Write async. Bring in that, and then we will do system IO file. I might actually take this out and just have file. I'll bring in the context using system IO, that's better. Read all text, and then we'll just specify what we're wanting to read, which is protos folder platforms.proto. So again, Don't need to do that. We're just adding another endpoint to serve up our contract, which is probably good practice. All right, so let's do a .NET build. All good. Let's do a .NET run. All good. So again, not really doing much at the moment. We do need to move on to doing our client to make requests to this to see if this all actually works. But the fact it's not crashing or doing anything horrible at that, I think we're probably in quite a good place. So now we're going to move on to writing our client in our commands service. Do that next. All right, so we have just completed the gRPC stuff from the perspective of our platform service. So we'll just stop that running if you had it running. And now it's time to move over to our command service, which is our client. So we're going to do a lot of the same stuff, but there are going to be some differences as well. Now, just make sure before you continue on that you added these 3 packages to the csproj file in the commands service. All right, so the next thing we want to do is we want to add some config. So when the commands service starts up, we want to tell it where to go to retrieve our list of platforms. So we need a destination basically. So we'll need one for development and we'll need one for production. So it's just really the URI of the endpoint of our platform service endpoint. So over in our command service, I'll close all this down. And we'll go into app settings development JSON first. So along with all our other development endpoint config, we will create one last piece of config and we'll call it gRPC platform. And we'll give it a value of our platform service endpoint. So HTTPS. Now note that I'm using HTTPS in our local development environment. That is supported. So localhost port 5001, and that means we don't need any additional config. That will all just work out the box. Fantastic. So I'm going to copy this and then come over to production settings. And this is where we want to target our production endpoint. Now, as we have already gone through, we cannot use HTTPS. And then we just need to find the endpoint of our production server. And so as before, let's just come back to our K8s project, come back to our platforms deployment file, and you'll see again, this is the name of our server. So we'll copy that, cluster service IP, and we'll bring it back over here and we'll put that in here. And then the only other thing we have to put in is the port, or gRPC port, which in my case is 666. So when this starts in production, this is the endpoint we'll try and target. And when it starts in development, we'll just access our local host on HTTPS. And note that this is HTTP. Make sure that you put that as HTTP. Fantastic. So that's it for the sort of configuration setup for our client. Next thing we'll do is we'll just copy the proto file over from our platform service into our client service. So we'll do that next. All right, so let's just close this down and we will create a folder in the root of our command service project. So right click, new folder, and we'll call it protos as before. And then rather than, well, what we'll do is we'll create a file and then we'll just copy the contents over. So new file, and we'll call it platforms.proto. And then we'll come back to our platform service, get rid of that, and find our protos folder, platforms proto, and we'll just copy all of this. It's exactly the same. And we'll bring it back over and paste it in here. Fantastic, so we'll save that off. Now, like with our platforms project, you will remember we had to put a line in here to define where gRPC can find any proto files. So I'm going to copy that as well out of our platform service csproj. I'm going to copy that. And back over in platforms, sorry, back over in commands, I'm going to paste it in here. Now, the one thing that we will need to change is this. It's not running as a server. it is running as a client, which shouldn't really surprise you, but everything else remains the same. The route or the path to our proto file is exactly the same. So let's save that off. All right, let's do a .NET build. Let's go back to our console, back to our terminal, should I say. Clear that and do a .NET build. And everything looks okay, that's cool. All right, so with that done, all we really want to say is a few more things we need to do, but the next thing we're going to do is actually build our client service that's going to be called to call our server endpoint. So we'll do that next. All right, so back over in our command service, we're going to create our client, our synchronous client, to connect in and make a call to our remote procedure call over on our server. So back in our project, we're going to create one more root folder called sync data services, because again, gRPC is a synchronous data service. Now, we're not creating any more other than gRPC, but just to keep it consistent, I'm going to do a new folder and create gRPC. Just in case you wanted to add a HTTP client here as well to make other calls, we'll just structure it in a consistent way. So we're going to create an interface first. So in the gRPC folder, right click, new file, and we're going to call this platform data client.cs. So the namespace, command service, sync data services, gRPC. And it's just a public interface called platform data client. And what we're going to get it to return, we're just going to get it to return an IEnumerable of platform objects. And we'll call it return all platforms. So we'll ultimately run this at startup. So let's just bring in our few namespaces. So we'll bring in, I think I've spelt that wrong. Yeah, it's better. It didn't look quite right to the eye, so there we go. And we'll bring in our models as well. Fantastic. So you're probably starting to think, okay, we're going to be using a gRPC client to ultimately return a list of platform models. So you're probably starting to think we need to use AutoMapper. We do, but we'll come on to that in a bit. But for now, this is sufficient for the moment. So we now want to create a concrete class. So right click the gRPC folder, new file, and we're going to call this platform data client.cs. I'll get rid of this and I'll give us a bit more space here. So namespace, command service, sync data services, gRPC, and it's a public class called platform data client. At least I think that's what we called it. Let me just double check. Platform data client, yes, that's fine. And that's going to inherit from our interface. So cursor in there, implement interface. But before we do that, we're going to create a constructor. And into that, we're going to pass iConfiguration, as we'll read in the endpoint from our configuration file. And we'll call that configuration. And we're also going to read in a mapper object, as usual. So let's bring in those namespaces using AutoMapper and make sure you use Microsoft extensions configuration. And then we'll assign those to private read-only fields, so underscore config configuration and underscore mapper. Oh, goodness. Equals mapper. And we'll just generate those read-only fields. Fantastic. Okay. And so really all we need to do is come on and flesh out this method here. But before we do that, I think it's probably worth doing the AutoMapper stuff now. So let's just come back over to our profiles folder. And we're going to put a new profile in here. Right, so under here, we're going to create another map. And we're going to define the source. Now, what is the source in this case? The source in this case is a gRPC platform model. Now, you'll remember if we come back over to our Protos file, in here, this is basically the source, because we're going to be getting these, albeit an enumeration, we're going to be getting these from our endpoint. And so we need to map it to our platform model as we specified here, platform. So let me just bring in the namespace for that using platform service. And we need to do some mappings. So let's just come back again to here. We're going to be bringing over our platform ID, our name and our publisher. So I'm probably not going to bother with the publisher because from memory, I don't think we're even storing that in this service, so it's irrelevant. The name will map over, but that should map automatically. But this here, the platform ID, we want to map it to the external ID of our platform model. So we need to set up some mappings. So don't forget the parenthesis, and we'll come on to a new line, and we'll have to do this for member type stuff. So same thing as we've done before, specifying the destination. So the destination is on our platform object, so here, external ID. So it's actually very similar to what we've already done up here. And put the comma in the right place. So OPT goes to OPT. And what are we mapping from? We're mapping from our source. And I've got that completely wrong, so let's put that around the right way. What we're mapping from our source. And it's platform ID. Now again, like with the other mappings we did in the platform service, we probably don't need to do this next mapping, but I'm going to do it anyway. So for member, we'll copy this and we'll just change the values. I'm going to map over the name value, but that should auto map. So we're saying the name destination on our platform model, we're going to map to the name from our source. The only reason I'm doing this, I'm double checking it, is because we're using gRPC and I just want to be doubly confident that we're mapping everything through that we want to map through. Now the other thing I want to do is I want to do an ignore. So for our destination method, dest commands, I just want to ignore that. Now I think it would be ignored anyway, but again, I just want to be explicit in the fact that we are ignoring any mapping of command objects or a command collection. So I'm just going to go ignore. So we don't, AutoMapper doesn't even attempt to do anything from that. So I think, to be honest with you, this is the only thing we really need to do by way of mapping. This other stuff is probably not necessary, but I'm doing it just to be doubly sure. So we'll save that off. That's our AutoMapper stuff done. And I think that is all our AutoMapper stuff for the whole project now finished. We're really coming to the end of things now. So back over to our platform data client, we've got our mappings in place now, so we can now finish off this method here. So let's get rid of this. And I'm just going to do a console, bring in the namespace using system write line. And we're just going to say calling gRPC service. And what we might do, we'll actually name the service just so we can kind of see what it is we think we're calling. So curly brackets, and we'll use configuration. And then we'll bring back the config item. So let me just go and pull that out. Oh, keep doing Control V instead of Control B. So let's come back to one of our config files. This is the value we want here. So let's copy that into here. All right. And we'll just end that like that. So I think that should be okay. Cool. Again, just helps us with debugging a little bit. So we now have to set a few things up in order to talk to our endpoints. So the first thing we need to set up is a channel. And again, this is a different channel concept to the one from RabbitMQ. So we declare a gRPC channel. Bring in the namespace for that. Using gRPC net client for address. And then we specify our endpoint, and it's actually exactly the same as this. We're just pulling in the endpoint. So I'll paste that in there, that's so. And I don't think we need that. There we go, that looks better. There we go. Fantastic, and then we need to declare a client. And that's equal to new gRPC platform. Bring in the namespace for that. Platform service. So again, all this stuff will only work if you've built the solution and it's built the code behind for the proto files. So gRPC platform and gRPC platform client, and then we pass in the channel like that. And then we want to declare our request, which is basically an empty object really. So that's equal to new get all request, which again is basically, we come back over here, is just this thing here. Okay, so it's not nothing, but it's, yeah, sort of nothing almost. All right, so then we're ready to actually make our call to get all platforms. So we'll put that in a try catch block. I'll move this up a bit, and we'll do the catch first, so that's usually easier to declare. So same as usual, exception EX, we'll do a console write line. I'll make it $sign at front. We'll say could not call gRPC server, and we'll put the exception in here. Right, and semicolon. Then finally within our try block we want to get a reply equal to client get all platforms. And we pass in the kind of dummy request. I'll just fix that up. Reply. Okay. And then finally we want to return mapper map. What do we want to map to? An enumerable of platforms. And what is the source? The source is a reply dot platform. And that should be the client done. And we actually should probably put, it was complaining we're not returning something for everything, so we'll just return a null in here. And that should resolve the errors there. That's it. So the client's relatively simple. We're just putting in our configuration object, a mapper object, set up a channel, set up a client, dummy request, and then we just make the request as so. So it's not that complicated. All right, so that's it, almost at a point where we're done. All that remains to be done is calling this at startup. So what we're going to do is we're going to create a prepDB class, a static prepDB class like we did with our platform service. We don't have one here yet. We'll quickly knock that up just to keep it consistent, and then we'll call this service from within there, and we'll seed in the platform data that we get from this method, and that's us, we're done. Well, and then we have to deploy to production, but if this all works locally, then I'm fairly confident, given what we've done so far, it should work okay in production. So we'll come on to doing the last real bit of coding, which is the prepDB class, to retrieve this information from our server. All right, so still within our command service. In fact, before we come on to doing the prepDB stuff, let's just do a .NET build, just to make sure we are all still working okay. Great, and actually, before we even come on to doing prepDB, the one thing I did forget, and I keep forgetting, we need to register for dependency injection our interface and our concrete class because we're going to inject or get a reference to those anyway within our prepDB class. So let's just do that now. So let's close all this down. Let's come into our startup class. Let me get rid of my terminal. And let's come into configure services. And we'll just put that after this. So services, we're going to add a scoped lifetime. And we're going to pull in, or we're going to say that an I platform data service will give us a platform data service. Let's just pull in the namespace. I think I probably, yeah, platform data service. That looks okay. Must be something wrong. Platform data client, not service. Been a long video, getting confused at the end of it. So yes, it's our client, isn't it? Of course. So let's try that again. And yeah, there we are. These both should resolve now. Great. So let's just do a .NET build again. Let's do a .NET run, in fact, just to make sure we're all looking okay. Yeah, that's all looking fine. Fantastic. So yes, now last class of the whole project is our prepDB class that was going to call our gRPC client code. So let's just close that down. Let's minimize that. And then in our data folder, right click, new file, prepdb.cs. All right, so namespace, command service, data, and it's a public static class called prepdb. Fantastic. And we're going to create a private public method. Not a private public method. That makes absolutely no sense. A public void public static method. Public static void, and we're going to call it prep population. And we're going to inject an iApplication builder into that. Called application builder. We'll pull in that namespace. And we'll use that ultimately to get a service scope again, because again, we can't use constructor dependency injection because it is a static class. So we'll create a service scope. And we'll equal to application builder, application services, create scope. And we'll need to bring in the namespace for create scope. There we go. So we want to get our client, our gRPC client. So gRPC client equals service scope, service provider, get service. And what do we want to get? We want to get an I platform data client. And that's what we just created from the last section. So let's bring in the namespace. Fantastic. And then we want to basically get a collection of platforms. So we'll create a platforms collection and make that equal to gRPC client. And then we will call return all platforms. And then, like our other prepDB class in our platform service, we're going to create a private static void method called seed data. Into that, we're going to expect an I command repo. We'll call that repo. And we're going to expect an I enumerable of platform objects, which is basically a result set from the method, the prep population method. We'll call that platforms. All right, so I just want to make sure that we have that namespace. So systems collection is generic, and then bring in our platform. Actually, you want to do that using a using statement. There we go. And so then we're going to call this method from in here before we finish seed data. We're going to call seed data use our service scope again, service provider, get service, and we're going to get an iCommander repo, and then we're going to pass in our platforms from here. Okay, and I forgot to put the parenthesis on the end there. Okay, that should resolve. Fantastic. So again, yeah, into our seed data method, we're passing a repository. We're just getting that from our service scope again, and we'll pass through our platforms, which we retrieved from here. And then finally, we want to push the data into our database. So console write line, bring in the namespace, and we'll just say seeding new platforms. Fingers are getting tired after all the typing, so almost there, the last for each loop. So we're going to say for each platform in our collection, we're going to do a check. So we're going to say if not underscore repo, not underscore, so used to saying underscore repo, external platform exists, plat, external ID. So if we don't have it, then we will add the platform to our database. So we'll say console write line. Actually, we won't bother with a console write line in here. We'll just use repo, create platform, and pass in the platform object. So this just means we're not duplicating platforms or ones that we already have, using the platform service ID as the kind of global key. And then irrespective, we'll just save changes. So we may or may not add anything, doesn't matter. We'll just call save changes. Fantastic. All right, so yeah, all then that remains to be done is we just need to come over to our startup class, and we need to call our prepdb, or call our prep population method off our prepdb class. So prepdb, prep population, and we just need to pass through our app instance as so. So that is it. That is it, assuming we haven't made any errors. So .NET build to build it up. Looks good. So good quick pause here. We've done quite a bit of coding here. So in the next section, we're going to run both of these up locally, and we're going to test to see if our gRPC stuff actually works. And then we'll take it from there. All right, so on to testing our gRPC stuff. So let us come back over to our platform service. Here we are. And through the screen, we'll do a .NET run. So we're using a memory database, everything's looking pretty good. So we're not really going to do anything with this now. Let's just check to see, it should have data in its repository, in its database. So into our platform service, we'll do get all platforms, send, and we have all our platforms there, the 3 platforms. Now, what we want to do is run up our commands service, and it should start up. It should use gRPC to pull those same commands into its repository. And if that does work, then we know it has worked correctly. So let's do a .NET run. So looks pretty good. So it's listening on the event bus, which we want it to do. It's calling the gRPC service at HTTPS port 5001, and it looks like it's seeding that data into its database. So if we come over here to our command service and we get all platforms, we get the 3 platforms that we had in our platform service. So using gRPC to get that data, which is very, very good news. And then just to kind of labor the point, if we come back to our platform service and we create a new platform, and then we come back to our command service and get all platforms, we have that platform as well delivered via our event bus So the two services are now completely in sync, and we're using synchronous messaging and asynchronous messaging to achieve that. And really, although this was a very simple example, you saw how much work went into creating it, but fundamentally those techniques that we have used here are then usable in much, much more complex setups. So it's a good foundation on which to move forward. So very pleased with that, glad that all worked. All we have to do now, and it could be a little bit of a sticking point, is we need to repackage or rebuild both our images, push them up to Docker Hub, and then restart our deployment in Kubernetes. Now, we did have that unique config stuff that we put in because we're not using HTTPS within Kubernetes, so that might cause a sticking point. Shouldn't do, should work okay, but that's our last thing that we need to do. So let's just finish this off and get that done, do a quick test, and then we can all go home. So we'll do that next. All right, the moment of truth. Let's just stop all our local running services just to give us a clean slate. And let's start with our platform service. So yes, what we want to do is we want to rebuild the image. So do a directory listing, make sure you're in the platform service folder, make sure you can see your Docker file. And we'll do Docker build. Platform service, don't forget the build context. So let's just do that. Oh yeah, I forgot to tag it. After all this time, there you go. I think it's the first time I've made that mistake. We didn't tag it. So Docker build -t and then the name of the service. Don't want to make any stupid mistakes at this point in the game. All right, it should build relatively quickly, but because we've added some newer code in, it might take a bit longer to build. It builds, again, builds the images in layers, and we've added quite a bit of code, so it's probably updating a few more layers than it would have done if we'd made only some minor changes. So it's probably pulling in all the gRPC stuff, actually. That's probably why it's taking a bit longer. So let's just let that do its thing. All right, that's built. So up key, and we'll just push this up to Docker Hub. Push. All right, we'll just let that push up. And in the meantime, let's come over, I just want to wait, yeah. In the meantime, let's come over to our command service, and we'll do a directory listing. Make sure you're in the commands service, and we'll do a Docker build. Don't forget the T this time, binary thistle, and it's command service, and don't forget the build context. So let's just check that's correct. Binary thistle command service, fantastic. Let's rebuild that. Fantastic, an up key, and we'll just push up to Docker Hub. And then as usual, once both of these things have pushed, we will check Docker Hub to make sure that both our images were actually pushed up and we hadn't made any mistakes, and that we have the latest images up there. So I might just wait for that to happen, and we'll come back and double check Docker Hub. All right, so that's our platform service pushed up. Let's see how our command service is doing. It's still running along, so we'll just wait for that to finish as well. All right, so that's our command service finished. Our platform service should have finished as well. Indeed it has, fantastic. So let's just come over to Docker Hub. We'll do a quick refresh. And hopefully we should see a few seconds ago, a minute ago, that makes sense to me, fine. So they look like they have been pushed up successfully, and we haven't got any other images, misspelled images or anything. That's good. So last thing, we're going to do a kubectl rollout restart, and then we will make a, well, we'll see actually almost immediately when the command service starts up whether the gRPC stuff was successful. So we'll do that next. All right, so let's come back to our platform service. I think we're already there. Yeah, we're already there. Let's clear the screen. So yeah, we want to just get our deployment. So kubectl get deployment. And we basically just want to restart our platform's deployment. So kubectl rollout restart deployment. And we want to restart this deployment here. So that's restarted, so we'll do kubectl get pods. And we'll see that the container is creating. I've opened a beer at this stage, so I'm fairly confident it's going to work. Let's do another get pods, still creating. Again, and you can see that the old pod is terminating, so that shouldn't take too long to terminate. So let's bring Kubernetes back over. We'll order by start time. So our platform service should be the first one that started. I just want to make sure that everything's looking sort of okay. Yep, it's looking all right. There's nothing too concerning there. And actually, one thing we can see is that it's listening on port 666 as well, which is good news. So we're on port 80 for our HTTP traffic, and it is listening on 666 for gRPC, so that's looking pretty good. Now, maybe before we do anything else with our other service, I just want to make sure that we can still call our endpoint. So let's just say, not in our command service, in our platform service, get all platforms. Yeah, we have all our platforms there. It's all still working fine. Fantastic. So, moment of truth, real moment of truth. Let's clear the screen, get our deployments again, and we want to restart our commands deployment. So upkey, rollout restart, and this time it's commands, and we'll restart that. We'll do get pods, and we should see container creating, and again, shouldn't take too long, and at this point, when it starts up, should use gRPC to pull down all the platforms that we have running in our platform service. So fingers crossed, we'll see how it goes. Let's just check our pods again. Okay, so our old pod is terminating, it's gone, that's looking good. Let's just do, okay, it's all running up. So that's a really good sign. We're not seeing it erroring out, which is obviously a good sign. So let's sort by start time again, and it's our command service at the top. And we should see here, calling the gRPC service, seeding new platforms. I think that looks good. So let's come back to our production queries and get all platforms from our commands service. And indeed, it did. It pulled down all of our platforms. Fantastic. So with that incredibly long video, we have finished and we've deployed everything to production running in Kubernetes. So if you followed this far, thank you for following this far. It's been a very, very long video. Now, I do have some final thoughts on a bit of a review of what we've done. Just go back through reviewing what we have done, and there are some final thoughts on things that we could do to move this forward even more. The things I left out that I would maybe include the next time. So quick pause, I'll finish my beer, and then we'll come back and we'll talk about those things before wrapping up. All right, so here's just some final thoughts from myself on how I would move forward if I was to revisit this course or add some more material into it. As you're, I'm sure, very aware, it was a very long course, a very long video, but we didn't cover everything. I mean, you're probably never going to cover everything, but there's some things that I would probably introduce if I was going to extend it going forward, and this is just my thoughts at this point in time. So the first thing I would like to look at is HTTPS, TLS, whatever you want to call it. I don't like ignoring that at any point in time, so I would definitely want to at least revisit it in more detail and make a more of a considered assessment of whether we would want to use it within our Kubernetes cluster or not. We didn't, obviously, and that may still be the case, but I'd probably want to focus in on that a little more and at least provide some options for introducing HTTPS into a Kubernetes cluster. I'd probably want to revisit the event processor. It was just one big kind of massive class, so I think that could be a bit more elegant, and I'd probably think about re-architecting that, but for our purposes it was fine. Possibly a more elaborate use case. Our use case was very, very simple, which I think for this video was the right approach. It didn't detract us from what we really needed to focus on, but going forward I think a more elaborate business-focused use case would be probably beneficial, because you then have to start really thinking about how eventing works. And this kind of feeds into the point above, really. So that might drive a more elegant eventing system. And then the last one, service discovery. So that means that services can discover each other without having to have hard-coded endpoints, which I think is a really nice concept. And it might also address some of the issues that I called out with synchronous messaging. Some of them anyway, not all of them. So something I possibly would look at introducing into another course going forward. I'm sure there's other things, but those were my top 4. Other than that, thank you for watching. If you liked the video, give it a like. If you haven't done so already, please think about subscribing. But until I make my next video, stay safe, and I'll see you next time.